Hi, welcome to this Java tutorial. In this part, we will learn programming fundamentals using C language. If you're already familiar with C programming, you can skip this part and start learning Java onwards. Here is the list of topics that we will learn in this part. First, we see the meaning of what is a programming language, followed by the meaning of what is a program. We'll then understand different concepts such as compilation, compiler, execution, source code, object code, variables, data types, variable declarations, functions, the different parts of a function, calling a function, passing values to a function, returning value from a function, called function and calling function. Conditional statements such as if statement, switch statement, loops such as while loop, for loop, do while loop. We'll end up this part by learning the concept of arrays. All these concepts are explained clearly with hands-on programming examples. Now, let's begin with the word programming language first. A programming language is a set of few English words, some predefined rules, which are together called as syntax. We use programming languages to develop or to write software programs. As an example, you can see the list of reserved words used by C language, C++, and Java. Now you can see a list of few programming language names on screen. We have C language, C++, Java, C#, and Python. Apart from these programming languages, there are so many other programming languages available. Now let's see the meaning of the word program. A program is a set of instructions which we use to tell the computer to perform a specific task. For example, calculating simple interest, we write the program to calculate the income tax. However, programming languages are not limited to writing simple programs that calculate income tax or simple interest or area of a circle, nothing as such. We can use programming languages to develop any complex programs. The first program when we learn any programming language is called as the Hello World program. And the Hello World program in C language looks something like this one. When we execute this program, it prints the text Hello World on the computer's output screen. Don't get confused by trying to understand the meaning of what is displayed in this program on the screen. By the end of this chapter, you will get a very clear understanding and meaning of this entire program. The first program, that is the Hello World program in C++, looks like this. And the Hello World program of Java looks like this. The motto of this tutorial is about Java, and therefore we are not going to learn the meaning of this program in this part and also in this tutorial. However, we'll learn the meaning of this program by the end of this part. And when we learn Java, we understand the meaning of this program clearly. Now, once the program is written or developed, in order to execute it, we need to perform few steps. To execute this program, we have to translate this program, which is written in English and understandable by humans. The computer's operating system cannot understand human understandable language. Therefore, we need to translate the human understandable program into a language that the computer's operating system can understand. This conversion of human understandable code into machine understandable code is called compilation. Code means program. Human readable code is called source code. Computer readable code is called object code. In order to perform the compilation, we make use of some pre-written program called compiler. Compilers are written and developed by expert programmers. Now that you understood the meaning of compilation and compiler, you can see the explanation in the below mentioned image. First of all, we type the program using any text editor such as Notepad or something else. We store or we save the program in the computer's hard drive with some name such as hello.c. And after the program is developed or written, we provide this program to the compiler, which is a pre-written program that we previously understood. The compiler reads this human understandable program and then produces the operating system understandable equivalent code. And this code is technically called as object code. And the file extension to the object code is .obj. Don't get confused with the words source code and object code. We have already understood. Source code means that the program humans can understand. Object code means the program that the computer's operating system can understand. Once the object code is generated, that is, once the program is compiled, we then need to execute it. When we execute this program, what happens is the operating system loads the program into the computer's memory and delivers these instructions to the computer's hardware, that is the CPU, which then executes the program. And this is the compilation execution process of the C language and C++ program. However, the execution process, the compilation and execution process of Java program involves one more extra step. That is, when we compile a Java program, instead of getting the object code, we get something called as byte code. Okay, this byte code is not understandable by any operating system. Therefore, it has to be translated into a language that a particular operating system can understand. To translate byte code into object code, we use a software called as JVM. JVM stands for Java Virtual Machine. And once the object code is produced, it is then executed by the operating system, such as Windows, Linux, or whatever. However, we will understand the clear details of this image when we start learning Java. Now let's proceed and see the steps of downloading and installing the C language software. To use the C language, to work with C language, we have to download the C language software, and there are a variety of options available. The option that we use in our learning is something called as mingw software. Now open your browser to download the C language. We then search for something called as mingw w64 install. When you select this one, please locate something called a link which contains something like this one, mingw w64 install.exe. Now, when you click on this one, it takes us to the download page, and in the next few seconds, it starts downloading, and the file will be downloaded. We are prompted for where it has to get downloaded. Still in download process. Let me go back and then click this one again. So it starts in the next few seconds. Right, so it is asking where to download this file. I'm creating a folder on the desktop. Let's say the folder name mingw, and inside this folder, I want to download this file. Okay, and once the file is downloaded, you see here in the lower left corner of the browser, the file is downloaded. You can open this show in folder option. From here, you can double click this file and keep clicking the next button wherever applicable. You click the next button, and then it starts asking us this permission, next button. And here it is asking us the folder where this software has to get installed. Now, by default, it has chosen C program files x86 mingw. I probably take the default one. Otherwise, let me create one more folder, browse. And then let me go to this PC and then C drive, Windows C drive. I'm creating a new folder, check here. And the folder name mingw. Okay, now I'm clicking OK there. And then I select this folder. And now you see here, the C language software is installed in this folder. Now, let me click the next button. And it takes a few minutes. You have to be patient here. Please hold on until the time the download is finished. And after the download is finished, it starts installing. Depending upon your internet speed, the download will be completed fast or slow. Okay, before installing, it first downloads the required software from the internet. Okay, now let's wait until this downloading and installation process is completed. And now the download process is completed. We should click the next button to continue the installation process. Now click the finish button. Now the software is installed. We shall go and check if it is there in C drive, computer C drive. It is Ming folder. Right? It is Ming W here. Now you see we have the folder Ming W32, inside which there is another folder BIN bin folder. Please make a note of this one. Okay, here, let's say we make use of the file or software command called as GCC. This command we use to compile and execute the C program. Of course, not for execution, for compilation. Okay, so that's how it looks like. So let's move on to this folder. You copy here. Now you type the command here, and then it opens the command prompt, and you can please watch here. C drive, Ming GW32 bin folder. Now you can see GCC hyphen version. You see, it prints you the version number GCC, and this is the version number 8.1. The GCC command is used to compile a C program. For example, I'll demonstrate that how do we do that. Now please watch one important point here. This command is available in this folder bin. For example, if I move to the C drive, watch here what I'm typing, CD and then reverse slash. When I press enter, now you please watch here. I'm currently located into root drive of the computer's C drive. Okay, now here if I type GCC and I press enter, this command won't work. This command won't work. Okay, when I press enter, this command won't work because this command GCC is not available in the root drive, computer's root drive. It is available in the bin folder, which is available in this folder, which is in turn available in this folder. In order to run this GCC command from here or from any other folder, we have to do something called as path setting. Now let's understand that step. Understanding and setting path variable. Path is an operating system level variable. It doesn't belong to C language or Java or C++. It is specific to operating system. It is not related to any programming language. And the operating system uses this path variable to find the folder location or the folder path of the executable commands of various programming languages or various programming softwares. For example, C language, Paintbrush, Notepad, and all that stuff. You watch here, for example, I'm going to this command window. Now I'm typing Notepad, and then when I press enter, the Notepad is executed from within the C drive here. So this Notepad command can be executed not only from this portion. I can, let's say, let me cd Ming W. When I press here, from here also I can type Notepad and then press enter. Now, if you look at the difference, I can execute and open the Notepad software program from C root drive or from any other folder, not just in one location. In a similar way, if you want to work with C language commands, first of all, we have to instruct the operating system the folder path of that GCC command that we have demonstrated now. So let's go ahead and do that. So what we do is, it is in this, I'm once again coming from the beginning, Windows C drive, Ming W, and from Ming W32, and from here open the bin folder. Now inside this folder, we have this all the commands. Now select this one, copy this, okay. Now once this is copied, we need to paste this folder path in the path setting. So, you press the window key and then advanced system settings. You type advanced system settings. And when you click this one, we are taken to this screen, system properties and advanced tab. Now in here, we click this environment variables. Now we have something called path. When you click this path, click edit. Now we have a list of path declarations already set here. Now to this existing list, we have to add the folder path of the GCC command. Now if you notice here for Java, I have already set. Okay, however, I will demonstrate Java download, install and path setting process in the Java tutorial part. Okay, this is the existing path of this one, mingw. I'm deleting that. Now I'm clicking new here and then I'm pasting it there. So now if you look at this one, mingw32 bin, this is the location where we have the GCC command available. Now we click OK all the places and then quit this window. Now let me close this window, and if you check here, now we should be able to execute the GCC command from any location, not just from the bin location as we have previously seen. However, this time also it won't work because we have to close and reopen a fresh command window after we change the path setting in the Windows environment variables. So therefore, I'm closing this window and then I'm opening the command window once again. Press the window key on your computer keyboard and then you can type CMD. The command prompt window gets open and this is the place. Now you see we are currently in a folder users and then my name folder, that is Ravita Dekonda. Now here I can type the command GCC and then I press enter. It will, of course, this is the command is working. The error is not related to inability to work with this command. You may check this one, GCC ---- version. When you press enter, now the command works. Okay, now that's it. We have seen how to download and install the C language software. Now let's move on and see the first program in the section. Setting the path for C language. This has been just now completed. Now let's see compiling. First of all, we see the C program. How do we type it? How do we compile and execute it? We'll also see the process of typing the Java program, compiling and executing. The file name to the hello world program is usually hello and the file extension of the respective software. And for example, since if we work with C language, we save the file using hello.c. And if it is a Java programming language, we save the file using hello.java. However, the file extension is a strict convention and the file name is your own choice. Of course, there are certain rules in naming the files in Java that we will understand when we start learning Java. So let's go ahead and see the process of typing the C program, then compiling it and then executing it. So what I'm doing is I'm first of all going to my computer's Explorer window, and then in the C drive, I'm creating a new folder. Let's say C programs folder is what I'm typing in here. Now inside this one, I want to save my programs. Now let me go to the command window. From here, I go to CD reverse / and then press enter. Now here I want to move to my folder CD space C-programs. In this folder, I want to type my programs. Now I'm clearing the screen by pressing CLS. Okay, the screen is cleared. And then I want to create a new program. What I'm doing is Notepad. I'm opening the Notepad in order to type my C program. Notepad space hello.c. Now here the Notepad command opens the Notepad software with a fresh Notepad window, and it opens that window with this file. However, this file does not exist. Therefore, the Notepad software will ask us whether we want this file to be created or not. Now, what happens when I press enter? Please understand and observe. Okay. Now, when I press enter, you see here, cannot find the hello.c file. Do you want to create a new file? Now, you see the untitled title displayed here. When I click yes, the file will be created. and this untitled becomes hello.c, or this is how it becomes hello. Okay, now what I do is I type the program there. This one we call it as include statement. Please do not try to get confused. stdio.h. I will explain these details in a few minutes. Now this is what I have to type here, and then void main, and here I'm typing something called as printf. Let's say hello world. Maybe I give a space in here. Okay, printf my first C program. Whatever you want, you can type as many print commands as required. Okay, now this file I have to save it. Control S, I've saved it. I can minimize or close this window. Now let's say I want to compile this program. To compile this program, we use the command that we have already discussed, gcc. To this command, we have to, this is the compiler as we previously seen in the compiler slide, gcc followed by the hello.c, the file name to be compiled. The code inside this file, if you remember, we call it as source code. Okay, so and then I press enter here. It will produce a file with the name a.exe. Currently, we just have hello.c file. Okay, for example, you see here the list of files that are available in this folder, that is dir, and when you press enter, the dir command displays the list of files and folders that are available in the current folder. The current folder is c-prog. When I press enter, we just have only one file, that is hello.c. I'm once again clearing the screen. If you notice CLS, and then I'm pressing enter key. Now the screen is cleared. Now I want to compile the program. So I make use of the GCC command, GCC, and then space, the name of the C program that I want to compile, GCC space hello.c. And when I press enter key, if there are no mistakes in the program that I have typed, okay, this file will be successfully compiled. The compiled file is named as a.exe, executable file. We previously understood hello.c produces hello.obj, and that obj file is again converted into one additional file called as executable file. By default, it produces a file called a.exe. Now, when I press the, when I type the dir command now to see what files are available, you see we have a file called as a.exe. Now, once again, I'm clearing the screen for the sake of convenience. Okay, the screen is cleared. Now, I type the file name of the exe file, executable file. Exe means executable. So when I type the file name of the executable file and then press enter key, it will execute the program. Okay. However, if you want your own name to be given to the executable file, we can do that one also. So what I'm doing is I'm clearing the screen one more time. GCC space and file name to be compiled, the program file name to be compiled, hello.c, and then -o or -o. O means options. In this case, the options, what I want to do is hello.exe. Now, these two parts instruct the compiler to generate a file called hello.exe instead of a.exe. Now, when I press enter, we will now have hello.exe also, apart from the already existing a.exe. Now, let's go ahead and see that dir, and then when I press enter key, you can see it here. We have hello.c. By default, in the previous compilation, it had produced a.exe. But now, when we compile the program for the second time, we have mentioned the file name of the exe file to be specifically of choice. Now, if I want to execute that, I simply type hello and then press enter, then the program is executed. So this is how we download and install the C language software, set the path setting, and then we develop the programs, compile and execute. This is only an introductory part. after we finish the programming fundamentals part, you will get a clear understanding of this entire program. For now, please try to understand at a high level. I'm explaining the lines of the program. The first line we call it as include statement, and the include statement contains something called as stdio.h. H means header file. Stdio means standard input output. Standard input output dot header file. Hash include means altogether this statement tells the compiler to include the content of the programs which are already available in this file into this new program. This is the existing programs, list of existing programs that are installed when we install the C language software, as discussed in the previous steps. When we install that, all the header files are included. This header file contains the pre-written programs in C language. Okay, for example, this file contains this printf and an additional software and additional functions called as scanf and some more other details. Okay, and this part we'll understand in the next few minutes, and this part also we'll understand in the next few minutes. At a high level, to understand this entire part, we call it as main function, and this part we call it as printf function. That is the print function. The print function is used to print something on the computer's output screen. Okay, this is the high level explanation. The detailed explanation will be explained in the next few minutes. Okay, now that is the Hello World C program. In a similar model, let us see how do we type and execute the Java program. However, we are not going to see the download and installation of Java software here. We will see that in the Java tutorial part section. Okay, now what I'm doing is I'm closing this file and then creating one more folder. I'm going to my computer's C drive, and here I'm creating a new folder. Let's say Java-program folder. Okay, now the Java has already been installed. As I told you just now, I'm not going to demonstrate in the programming fundamental section, because the motto of this one is about the programming fundamentals using C language, not using Java. Once we start learning Java, there you can see the steps of downloading, installing, and path setting for Java. Now, let me go back to the command prompt, press the window key, and then open the command window by typing the cmd and then press enter here. And then let's say cd / or reverse slash and then press enter here. Now clear screen, and then I want to switch to my folder, that is cd java-prog folder name. Right now here I want to create a new Java program, notepad hello.java. Please remember, due to some rules and requirements which I'll explain later, Java file name and class name should be same. I'll explain those details later. Do not worry about that. Okay, now it will ask me. Now I'm typing the Java program. Please, I'm not explaining this. Please try to understand. Just demonstrating how do we type and compile and execute a Java program. Okay, so I'm just typing. I explain all these details very clearly in the Java tutorial part. Public static void main, and then I type something called string args, and then here I type the print command. In Java is little different than the print command in C and C++. The print command in Java is something called as System.out.println, and the print command in C language is printf, and the print command in C++ is actually they are not commands, they are functions. The print command in C++ is something called as cout. Okay, now let me say hello world, and then probably I'll type one more print command, print statement, that is System.out.println my first Java program. Okay, and that said, let me save this file and then save. I can close or minimize this one. To compile a Java, as I explained you, there are two steps. One step is extra when we compile and execute a Java program. First of all, let me show you the list of files in this program, in this directory. That is, I type the dir command and press enter. Now you see we got hello.java. There is a single file. But when we compile this one, we get one additional file called as .class file, as we previously understood in the compilation explanation slide. Now let me type. To compile a Java program, we make use of one Java command named as javac. Okay, please remember, for this one to work, we have to set the path in Windows operating system variable or any other operating system. The path has already been set. As I told you, I am not explaining the download install process of the Java, because this part of the video, we are learning programming fundamentals using C language. I'll explain these details in the Java part, javac, and then the file name which contains the Java program, the file name which contains the Java program. And then when we press enter, if there are no typing mistakes in the program is successfully compiled. And after the successful compilation, it produces one extra file called as hello.class. Now, when I press enter, you see we get the hello.class file generated. Now, let me clear the screen and say dir. This command will show you hello.class file here. So the code that is in this particular file, we call it as byte code. We will understand the meaning of byte code once again when we start learning Java topic. Now, let me clear the screen, and then to execute the Java program, we make use of a command called as Java. There are two commands for compiling and executing Java programs. The first one is javac, used to compile the program. The second one is just Java. C is not there. This one is for executing the program. To execute the Java program, we make use of the Java command, and then we type the name of the .class file that was produced as a part of the successful compilation. Now, when I press this one, please make a note. This has to be same as if as it is typed inside the Java program. It should not be small or mixed case. Now, when I press enter, we should be able to see the output. My hello world, my first Java program. And this is how we develop a C program and C++ program, compile and execute. Now let's understand the concept of keywords, or otherwise called as reserved words. Every programming language comes with certain pre-reserved words, certain set of reserved words, which are called as keywords or reserved words. And the ones which are common to C, C++, and Java are displayed on screen, like integer, char, float, void, if, for, and so on. Apart from these list of reserved words, which are common to C, C++, and Java, Java has its own set of additional keywords which are not displayed here. We will understand those set of keywords reserved by Java specifically apart from these ones when we start talking about Java. Now let's see the concept of something called as comments. Comments are those pieces of text which are used to describe the purpose of certain lines of program, certain lines of statements in our program. And there are two types of comments mostly in almost every programming language. The first one is called as a single line comment, which begins with a double slash, after which we type in the comment descriptive text about our program, the purpose of a particular piece of code. And the second one is called multi-line comment. The comment can spread across more than one line, and it is enclosed between slash star and then star slash. Whatever you type in between these two symbols is considered as a multi-line comment, and the comments are not considered or compiled and executed by they're ignored by the compiler. Now let's talk about something called as variables. Variables are names that point to memory locations in computer's memory, that is the random access memory. The computer's memory is divided into individual blocks called as memory cells, and the variable names point to these memory block cells, right? As an example, we have X is a variable, Y is a variable, S1 is a variable, S2 is a variable. All these four variables are pointing to different memory cells. And the variables are used to read and to store values into these memory locations. As an example, if you look at this code snippet, x equal to 10 stores the value 10 into the memory location pointed by x. Similarly, y equal to 20 stores the value 20 into the memory location pointed by y. And in a similar way, s1 equal to hello and s2 equal to Java, these two statements store the values hello and Java into the memory locations pointed by the variable names s1 and s2 respectively. Now let's understand the concept of data type. Data type is a classification which tells which type of data a particular variable holds in memory. For example, x is holding 10 and y is holding 20. S1 and S2 are holding strings there. So there are different types of data type words available in the programming languages. The most fundamental data types in C language, C++, and Java are called as int, char, and float. Int means we can store the numbers such as 10, 12, 15, and all. Char means we can store the single characters such as A, B, C, or we can store the symbols such as @ symbol, star symbol. Float means we can store the numbers such as 10.12. Now, variable declaration is a way of telling the variable's data type and name. That means before using any variable such as x and y, we have to first of all declare a variable. While declaring a variable, we have to instruct the compiler about the name of the variable as well as what type of data type it belongs to. So the syntax to declare in a variable in C, C++, Java is same. You can see the syntax here. We have data type followed by the name of the variable. As an example, we have few variable declaration statements displayed on screen. We have x and y, which belong to int data type. And we have ch1 and ch2, which belong to char data type. Similarly, we have two variables of float data type called as radius and area. X and y can be used to store the values such as 10, 12, 15. ch1 and ch2 can be used to store a single alphabet or a single symbol such as A, B, C, or otherwise $, otherwise star symbol. Okay, now the variables radius and area are used to store the numbers such as 10.1 to 51.6 and so on. Now, in order to declare variables, before declaring the variable names, we have to follow certain rules. And we have the rule something like this one. A variable name can contain alphabets, digits, and the special symbols $, and underscore. A variable name can start with an alphabet or a $, or an underscore. A variable name cannot start with a digit, or it cannot be a language reserved word such as int, for, etc. Now let's understand the concept of operators. Operators are those symbols which are used to perform specific operations such as addition, subtraction. Every programming language comes with certain set of category of operators, and the most common category of operators in almost every programming language is displayed here. We have arithmetic operators, relational operators, increment and decrement operators, logical operators, and assignment operators. However, apart from this category, every language has its own additional set of language category operators. Now, the first category is arithmetic operators, which are used to perform arithmetic operations such as addition, subtraction. Now, the operators of the arithmetic operators are plus, minus. Star symbol is used for performing multiplication, and slash symbol is used to perform division, and the percentile symbol is used to perform the division, but to get the result, that is the remainder. As an example, you can see here you are using a plus sign for addition, minus sign for subtraction, star for multiplication, and slash symbol for division where we are getting quotient, and the percentile symbol where we get the result, that is the remainder of these two operations. This is the division operation. And then we have the relational operators such as double equal symbol, which is used to check whether two values are same or not. Double equal symbol, we call it as double equal symbol. This is a relational operator. And the second symbol, if you look at here, we have the exclamatory mark. In programming vocabulary, we call it as negation. And this one is called not equal to sign, not equal to symbol. And we have greater than symbol, less than operator, greater than or equivalent operator, less than or equal operator. And the examples are displayed here. Next, we have something called as the arithmetic operators, assignment operators. Assignment operators are a combination of plus equal, minus equal, star equal, and so on. Okay, for example, if you want to write this statement I equal to I plus 2, we can shorten this piece of statement into this model, that is I plus equal to 2, which is expanded into this one automatically. Similarly, we have this model for all other operators. I minus equal to 2 is same as writing I equal to I minus 2. In the similar model, I star equal to 2 is same as writing I equal to I plus 2, and so on. The next set of operators are called the logical operators, which are double ampersand symbol, which we call it as AND, and we read it as AND. And similarly, double pipeline symbol, which we read it as OR. And here, this is the negation symbol that we have previously understood. The logical operators are used to combine more than one expression. As an example, you see here, we are combining 5 greater than 2. We read this one as AND 2 greater than 1. In this case, 5 greater than 2 is correct and 2 greater than 1 is correct. If both the expressions result to true, then the final output results to true. And here 5 greater than 2 or 1 greater than 2. But in this case, only the first one is correct. The second one is incorrect, but we still get true because at least one expression results to true. And the third one, 5 not equal to true, the 5 not equal to 2 is correct. Therefore, we get the result as true. And then we have the increment and decrement operators, which are called as 2 plus signs with no space in between and 2 minus signs with no space in between. As an example, if we write I plus plus, it is same as writing I equals to I plus 1. Similarly, if we write I minus minus, it is same as writing I equal to I minus 1. Okay, and this is the increment and decrement operators are used to increase or decrease the value of a given variable by 1 unit, not more than that. We can place the increment and decrement operators on either side of the value, on either side of the variable. If we place the increment decrement operators after the variable name, then we call them as post increment and post decrement. There is a slight difference in the output. Similarly, if you place the increment decrement operators before the variable name, then we call them as pre-increment or pre-decrement operators. Now, let's understand the summary of the operators as previously understood. We have the operator type, operators, and an example list is given. We will now understand the concept of functions in programming. A program is divided into logical parts called as functions, where each function performs a specific task. For example, let's consider we have a C program whose file name is circle.c. In circle.c, we have two divisions, two logical partitions, such as area and circumference. Each partition is called as a function. The area function calculates and prints the area of circle in the output. Similarly, the circumference function calculates and prints the circumference of the circle. So this is one example where a program is divided into logical partitions called as functions. We will understand more details about functions in the next few minutes. Another example where a program is divided into functions is shopping cart.c. In shopping cart application, we have different functions, different divisions. As an example case, we have calculate discounted price is one logical partition, that is one function, and this is another function, calculate cart total. The calculate discounted price function, what it does is it calculates the final price of a product after applying the discount for a given product actual price. Similarly, the calculate cart total, what it does is it sums up the price of all the products that are purchased and prints the cart total bill in the final output. Altogether, we have two functions and the one program has two functions. Now let's go ahead and see something called as types of functions. There are two types of functions in almost every programming language. The first one is built-in function and the second one is user defined function. Built-in functions are those which come ready-made when we install particular programming language software. For example, if we download and install C language, it comes with a lot of ready-made functions that are built into the software. Similarly, if we download and install C++ or Java or Python, whatever language we download and install, during the installation, it comes and shipped with ready-made functions which are called as built-in functions. Now let's see the couple of built-in function names in C language and Java. The couple of built-in function names among from many functions are printf and scanf. The printf function is used to print something onto the computer's output screen, whereas the scanf function is used to read some data from the keyboard. Similarly, in Java, the println function and the next line function are used to print and read from the keyboard. Please be noted that in Java, functions are called as methods. So println is a method. Next line is a method in Java. Now coming to user defined functions. User means programmer. The programmer defined functions are called user defined functions. There is no specific name for the programmer defined function. Whatever name we want, we can assign to them. Example, we have discount function, area function, interest function. That's about types of functions. Now let's move on and see the functionality of printf and scanf in C language. The printf function is used to print something onto the computer's output screen. And this is the example code snippet to demonstrate that. We type the function name printf, and inside the brackets, within the double quotation symbol, we type whatever we want to get printed on the computer's output screen. And after this one, so the first statement prints the output hello world. In the second statement, we declared a variable int I equal to 10, wherein the value 10 is assigned to the variable I in the memory location. And after that, we have printed the value of I in such a way that it prints I equals to 10. In this particular situation, this %d is called as conversion character, and D stands for decimal integer. The purpose of this conversion character is to pick the value of this particular variable mentioned after the double quotations, convert it into decimal integer, and print it in place of %d. Altogether, the output of this so-called statement is it prints I equals to 10. There are so many conversion characters available in C language. The most popularly used three conversion characters are %c, which stands for character data type, %d, which stands for decimal integer, %f, which stands for floating point conversion character. That is about the printf function. And the next one is the scanf function. It is used to read the input from the keyboard. For example, we want to take the capture input from the keyboard. We want to ask the user, please enter the value for first number, please enter the value for the second number, and so on. In those kind of situations, we can make use of the scanf function. So how do we do that is something like this one. First, we declare a variable integer I, and then we are prompting the user. So when this statement is executed, it prompts the user to enter the value for the I. Now, when this statement is printed, when the computer encounters the scanf function, please ignore the typing mistake there. When the computer encounters the scanf function, what happens is it does not execute this statement. It passes here until the time we input the value to the variable I. And when we provide the value from the keyboard 10, 20, whatever it is, that value 20 is picked and stored into the address of I. Here, ampersand symbol means address of I. And then we have printed it in the final output. So let's see the code examples for these two functions, printf and scanf. Now let's go to the command prompt. Press the window key, go to the command prompt. And from here, let's go to the root drive cd/ and then cd c-program, and then press enter here. Now I want to develop this program that is read two integers and print their sum. So let me do that. Notepad, and then what I want to do is sum.c. Okay. Now what I'm doing is I'm including something called as stdio.h. As I explained previously in a short discussion, the stdio.h is called as standard input output.h. Now here what I do is void main, and then inside the main function, we will understand the purpose of the main function, the meaning of the main function in the next few minutes very clearly. Also, we'll understand the different parts of a function such as void and these curly braces and these brackets, everything very clearly in the next few minutes. Now let's declare two variables, x comma y. And then what I'm doing is printf. I'm then asking the user, enter the values for x and y. And then what I'm doing is scanf function. And here, 1 percentile d for each variable, percentile d for x, another percentile d for y, and then comma, close the double quotations there, and then comma, address of x, comma, address of y. So this is how we capture the input from the user. So whenever the computer encounters this scanf statement, it does not continue the execution until it receives the values for the number of variables that we have mentioned there. In this particular case, we have mentioned two variables, so it waits for until two values input from the keyboard. And after this one is successfully executed, we want to print the sum. So printf, let's say percentile, let's say sum is equal to percentile d, and then inside the bracket symbol x plus y is what I'm typing in here. Now that's all. The program is now completed. I am saving it from the file menu. Once the program is saved, either I can minimize or close it depending upon the requirement. So what I want to do is to compile the program first. GCC, and then what should we type? Sum.c. And to give the final output file name, our own choice name, then we should go for -o and then sum. And then I press enter. If there are no mistakes, it compiles well and produces a file called sum.exe. Now, if I type dir and see the number of files available in this one, this was the previous case where we first understood the first program, and this is the latest program that we compiled and it produced the sum.exe. Now let me clear the screen in here. Now let me execute that sum and then press enter. Please remember, in order to execute the program, we should type the name of the executable file that is produced and hit enter key. When we hit enter key, the program is loaded into memory by the operating system and it passes the instructions to the computer's hardware, and the CPU executes the instructions one by one. Now, when I press enter key, it starts asking us the values. Enter the values for x and y. If you notice here, the computer did not execute the next statement until we provide the values. So I say 10 for the first one and 20, give a space, and then 20 for the second one, and I press enter. What happens is the value 10 is captured and stored into the address of I due to this particular part of the program. Okay, before storing it into the address of I, what it does is it converts into the decimal integer using the conversion character. Similarly, the second case. So this is how it works. After that is one, then it executes this statement. It prints sum is equal to percentile d. In place of percentile d, it prints the addition of this whatever we supply. So there should be a match between the number of conversion characters and the variable names or the calculations, whatever is supplied here. So for this percentile d, this is the value to be printed. For this percentile d, this is the variable name to be stored in. For this percentile d, this is the variable name to be stored in. So that's about the printf and scanf function example. Now let me press enter key. Now let's see the output. Sum is equal to 30. Similarly, let's go ahead and see the second program as per the agenda. Read radius and print area. In this case, we have to take the floating point variable declaration. Now let's go ahead and do that. Coming to the program, I'm closing this file. So I come to the command prompt. I'm clearing the screen. Then what I'm doing is notepad area.c. When I press enter, we get this one. Again, press OK there. And then we have to type something called as hash include stdio.h. And here we have to type void main. I'm telling many times, please do not bother about void main and all. In the next few minutes, we'll understand the details very clearly. So what I'm taking is float. Let's say radius is equal to something like 2.0 or 2.3, whatever we want. And then area is equal to, let's say 0.0, because it is a floating point, we are using the decimal values there. And then what I want to do is calculate the area. Area is equal to 3.14 multiplied by radius, again multiplied by radius, once again pi r square. I can take this one multiplied by pi r squared. If you want, we can take this 3.14 also in a separate variable for more readability and clarity. Float pi is equal to 3.14. Okay, this pi is a fixed value. It does not change continuously here and there, and the values which doesn't change once assigned, they are called as constants. I'll talk about that in Java language. Okay, for now I'm not considering those things. And usually constants are typed in uppercase characters. So let me do that. And then what I'm doing is pi is equal to 3.14, area equals to this one. And then what I want to do is printf, and here what I'm doing is radius is equal to percentile f, comma, and then what is that? Area is equal to percentile f, and then double quotations close, comma. For the value to be printed in place of this percentile f, we have to provide the radius variable name. Okay, after the first comma. So what I do is radius variable should be given, and then give another comma. In place of this percentile f, we want to print the value of the area variable. So here I'm giving area, and that's it. So this is how the program works. Now I'm saving the file and then coming back to the console window, and then let me compile this one, gcc area.c -o, and the file name, final output file name I want is area. Okay, and then when I press enter, if there are no mistakes, we get the screen clear. Now I'm cleaning the screen, and then to execute the program, if you all remember, we have to type the executable file name and then press enter. We got radius is equal to 2.0, area equals to 12.56. And this is how we use the printf and scanf functions in C language. Now let's understand the different parts of a function. The first one is function name. Every function is defined a meaningful name. In this example, we have two different functions, and the name of the first function we defined is area, and the name of the second function we defined is circumference. Next to the function name, we declare a couple of brackets, which are called as parentheses. And the parentheses, inside the parentheses, we can declare variables, which are called as function parameters, regarding which we'll understand in the next few slides. And the next one is the function body. The function body is that part of the function whose code is that is enclosed in between the opening and closing flower brackets of the function. And the next one is the function parameters. As discussed just now, these are the variables which are declared inside the parenthesis of the function. The parameters of a function are used to receive and store the values that are sent as input to this function from a different function. We'll understand passing values and reading input to the function in the next few minutes. And the next one is the return statement. The return statement is used to send the value that is computed by a function to a different function within the same program. For example, in this case, the return statement return followed by the variable name k, it returns the value that is stored in k to a different function that belongs to the same program, or depending upon that situation, to a different program also. In the second example, return a, this statement returns the value stored in the variable a to a different function. The next one is the return type. Just before the function name, we declare a data type, which is called as return data type, or simply called as return type. Return type or return data type represents the name of that data type whose value is being returned by the function. For example, in this case, the return statement is returning k. K belongs to int data type. Therefore, the return type of the sum function is int. Similarly, in the second case, the second function, the area function, is returning a. A belongs to float data type. Therefore, the return type of the area function is called float here. There are situations where a function does not return a value to a different function. In that case, the return type is void. Now, let's understand the meaning and purpose of the main function. Main is a special function in almost every programming language. As usual, it is a special function in C, C++, and Java as well. The operating system begins the program execution with the main function and ends the program execution with the main function. Consider we have a program called test.c and it has two functions. The first one is the main function and the second one is the test function. If we compile and execute this program, what happens is the operating system reads the main function into the memory, reads and loads the main function into the memory. And after it is loaded into the memory, it starts executing the code that is there inside the main function step by step from the beginning of the main function. So it starts from here and keeps on executing all the statements one by one. And when this statement is executed, we get the output printed on the screen. And after this one, the operating system moves to this part. And after this one, the main function is removed from memory, if you notice it here. The operating system does not execute the test function or any other function that is a part of this program. In order for the test function or any other similar function to get executed, we need to perform something called as a function call. A function call is the name of one function which is placed as one of the statements in other function. Consider we have this program with main function and test function. And in this case, we have two different functions. And then what happens is we mention the name of the test function inside the main function as one of the statements. And this particular statement, which contains the name of test function inside the main function as one of the statements, is called as the function call. The function call is followed by the parenthesis. Now, let's understand the execution flow of this program. When we execute this program, what happens is the operating system first starts and loads the main function into memory and then starts executing the statements inside the main function step by step. So first it executes the printf function and the output is printed on screen something like this. And when the operating system jumps to the next statement, which represents a function call, what happens is the operating system jumps the execution control flow from this place to the actual code of the test function, something like this. It then loads the test function into memory. You can watch it in the diagram here. And then it starts executing the statements of the test function one by one. So here it executes this one, and you can look at here in the output, we get learn clearly printed in here. And after this statement is completed, it goes to the end function, and both the functions are removed from memory. So that is the meaning of the function call. A function call represents the name of one function which is placed as one of the statements in other function. When a function call is encountered, the operating system jumps the execution flow from the current portion to the name of that function which is called. Now let's see the hands-on code examples that demonstrate the concept of the function call. So let me open the command prompt from the start menu, cmd, and then from the command prompt, I open this command prompt. And then let me move to the root directory, cd, and then /. And then let me move to the folder c-programs, and then clear screen. Here I want to create a new program. The file name is test.c. and then the file is created, and the first one is include stdio.h, and then I want to declare the main test function void test here, and then after that I want to declare the main function void main. Then what I do is print the test, let's say printf hello world, and then something like this one. And after that, I want to define the test function. Let's say here, I say printf, and then learn clearly, something like this one. And then after that, I want to save this file. And then let's try to compile and see the program without a function call. And if we execute this program as per the previous understanding, the output should be up to hello world. It should not print the learn clearly output because we have not made a call to the test function from inside the main function. So when we execute this program, we just get this output. Let's see that. And after that, we'll see the meaning of the function call in practice. So let's say GCC, then test.c -o, and then test. When I press enter, the file will be compiled. Now clear screen, and then test to execute the program, and then we see that. So as we discussed, it did not print learn clearly. So let's go ahead and make a call to the test after the print one. So let's say test, and then, so if you remember comments, this is a single line comment. This is a function call to the test function. This is a function call to the test function. I'm saving this file. I'm once again compiling and executing this program. GCC test.c -o, and then test, and then press enter. Now clear screen. This time we should get the output printed for both the print commands, hello world and then learn clearly. If you want the output to be printed on the next line, one of the options available in C, C++, and Java is something called as escape sequence. So prior to the letter L, I'm giving a reverse slash followed by the lowercase n. Okay, so lowercase n. This combination of reverse slash and lowercase n, we call this one as escape sequence, which is a special character. It has some special meaning. Whenever the computer encounters this one, instead of printing /n in the output, it pushes the cursor to the next line called as new line, right? So now let me save this one and come back and compile and execute again. GCC test.c -o, and then test. Now if I execute that, we see the output printed in the next line, something like this one, right? So there is a space after n, so that's the reason we got the output space. Now let's try to add the call to test before the print function, the first one. Now here also we are doing the same thing, file and save. And again, what I'm doing is GCC test -c and then -o, and then test. When you compile this program, this is successfully compiled. This time, if you notice here, when the main is first loaded, it encounters this statement. So therefore, it jumps the execution flow from this part to this part. It first of all prints learn clearly. And after this one is completed, it goes back to the main function and prints this one. And again, it encounters one more time function called to the test function. Therefore, it again jumps to test, and then it prints this one and again comes back to this portion. So this is to let you know that we can make a function call any number of times depending upon the requirement. Now GCC test.c and then -o, and then test. Now press enter, you get this one. Now let me execute the output, test, and then press enter. You see learn clearly is first called, and here we have not used the /n, therefore we got the output something like that. So probably we do that one as well. I give a /n here, file save, and then come here, clear screen. Now GCC test.c -o, and then test, and then press enter. Now clear screen and then test. You see the output is printed something like this one. Right. So therefore, this is to note that if we call a function any number of times, that those number of times the code inside that function is printed. Right. So let's add one more function to the same program, void greet, and then inside this function, what I'm doing is let's say printf welcome to learn clearly. Okay, and then this is the greeting, and then we have to declare that function void greet on top of the function declarations. Now this greet function will not be executed as we just now discussed because we did not make a call. So let's first of all give a /n there, and then let's make a call to the greet function from inside the test function. That from inside the test function, let's say greet something like this one. So what will happen now is because the test function is executed twice, Every time the test function is executed, it makes a call to the greet function. So therefore, this is executed. Now, what will be the output? Can you please guess that? So first of all, it loads the main function, comes here and prints learn clearly. And after it prints learn clearly, it jumps to the greet function and prints welcome to learn clearly. And from here, it jumps back to this place. And from here, it jumps back to this place and it prints hello world. And after that, it again comes to test function, again loads the test function, this one and this one and this one and so on. Now let me save the program, file save, and then execute the program, gcc, then test.c-o followed by test. And when I press enter, now let me execute the program. You see learn clearly, welcome to learn clearly. This is inside the greet function. It went back to the main function here, and this is test again called. It's again called from the greet function. Now let's see the next example, math.c, to demonstrate the function call, compiling and executing. After that, we'll see the circle.c as well. So let me create a new program, notepad, let's say math.c. And then first I will add the include statement. And please be noted, the include statement is not compulsory depending upon the compiler we use. For example, there is a compiler called Turbo C++ compiler. If we use that one, include statement is automatic. We don't have to separately write the include statement. So that's it. Let me declare the sum function, void sum, and then semicolon, and then void main function. And then inside the main function, let's say I'm typing some text there. Let's say this is main function. And after that, I go to the sum function declaration definition, void sum. And here, what I do is, let's say I want to type some code here, integer I equals to 10, comma j equals to 20, comma k equals to 0. And then what I do is k equals to I plus j. And then printf, I say sum is equal to percentile d, comma k. This is one way, or if you want, we can change it something like this one in a different way. You can watch here. Printf percentile d, you can say the sum of percentile d and percentile d is percentile d, and then close this double quotes, put a comma here, and this is the value of I and value of j and value of k. So what we do is I, comma j, comma k. This is how we do that. Even if you want, you can ignore the variable k. There are so many things that we can solve the problems using programming in multiple ways. However, we are learning the programming fundamentals. We are not learning the logic development in this particular part of the video. Okay, now we have printed the sum of two numbers using two different approaches. Now this is the case. Now what I'm doing is I want to make a call to the sum function from inside the main function. You watch here. So this statement makes a call to the sum function. Okay, now that's it. Now file save. Similarly, we can add as many functions as we want depending upon the problem statement that we are developing the program for. Okay, we can add sum, we can add product, multiplication, different kinds of functions. There is no limit. Okay, depending upon your problem statement, you are free to add as many functions as required. So for now, I have taken only one function, that is sum. Now let me compile this program. GCC, I have already saved it, I think. If not saved, I'll save it one more time. GCC math.c and followed by -o, and then math, and then press enter. Let me see if it is saved or not. So math and then press enter, the main function. And I forgot to mention the slash new line, this one. So that's the reason it is coming like this one. So let me go ahead and add a new line there. So here I give /n. here also I give a /n, and here also I give a /n. This is the optional, depending upon the requirement we give it. So let me compile it one more time. GCC math.c-o, and then let's say math once again, overwrite the existing file, and I press enter. The file is compiled. Now I type the math file name, which is the name of the executable file. When I press enter, you see this is the main function, sum equal to 30. The sum of 10 and 20 is 30. So as I told you, there are different ways to solve one problem using programming. Everyone thinks in a different way. This is called that we call it as algorithmic and logic improvement. So however, we are not learning those concepts in this video. Now let me close this one and clear the screen. Let me move on to the next code example, that is circle.c, compiling and executing. So to do that, I guess you all know how to do that. Creating a new program, notepad, let's say circle.c, and then I begin with hash include, and then stdio.h, and then I want to declare the let's say area function, and then semicolon. I want to declare one more function, that is circumference. Please ignore typing mistakes. Okay, now I want to go for the main function, and inside the main function this time I don't want to print any output. I just want to make a call to the area function as well as the circumference function. Now let me declare the code for the area function. What I'm doing in here is float, let's say radius is equal to 2.0, and then area is equal to 0.0. And then what I want to do is printf area /n area of circle is equal to %f, comma, and then here I have to provide the formula for that. Inside the bracket symbol, we have to provide that if we are using any computation to signal the priority of execution. Whatever is there inside the bracket symbol, parenthesis symbol, is given first priority for execution. You can even nest brackets, and like that. And the innermost parenthesis is executed first, and from the innermost to outermost, the sequence of execution is followed. Now, what I'm doing here is this is area, right? Pi r square. So pi means 3.14, as we know, multiplied by radius, multiplied by radius. So here we are not even taking the making use of the area variable. So therefore I can even delete that area variable. So I'm going ahead and deleting this area variable. I just have the radius available. Similarly, I want to declare the circumference function as a separate function, void circumference, and then inside the code of this circumference also I want to take the radius one more time. Okay, for each function we have to take a variable of its own because the variables declared in one function are not visible to other function. That is called a local variable. Now let me say this time 3.5 or something, and then printf. Once again I use a /n, and here what I'm doing is circumference is equal to %f, and then double quotes, and then put a comma. I believe you remember we have to use parenthesis here, and the next parenthesis is for the printf function. This one is for printf function. Now here what we have to do, 2 multiplied by 3.14, which is the pi value, and then star, and then radius. So this is how we are calculating the area of the circle as well as the circumference of the circle. The next step what we have to do is make a call to area as well as circumference from inside the main function. Let's see that. Let me call this one area, and then let me call this one circumference. Okay, and this is how it works. Now let's go ahead and see if there is any compilation failure. Fix that and come back and compile it again. So how do I do that? I compile this one, circle.c, and circle.c-o, and then circle is how, this is how we do that. Now luckily there are no typing mistakes and no errors. Now let me execute the program by typing the file name, that is circle, and I press enter. We got the area of circle equal to something, circumference is equal to something, and this is how it works. Now let's understand the next topic called as passing values to function call. Now look at this screen. We have the main function and sum function. From within the main function, we are making a call to the sum function. While making a function call to the sum function, we are passing two values within the parentheses, that is 10 and 20. The 10 is received and stored in the variable I inside the parameter I in the sum function, and similarly 20 is captured and stored inside the parameter j that is declared inside the function definition of sum. And from here on, the execution is as usual. So let's see how it works. So when this program is executed, a function call, what happens? The operating system jumps to this one, and then I and j become the variable declarations inside the function sum, and 10 and 20 are stored in I and j. And then it starts with k, and then it goes to k equals to I plus j, then k becomes 30, and then it prints this one. So that's the meaning of passing values to a function call. Now let's go ahead and see the function parameters and code examples. First of all, let's see circle.c, as well as after that we'll see math.c. Now let me go to the command prompt once again. Let's say cd root drive, then clear screen, and then cd space c hyphen program. From here, we already have those two files such as math.c and circle.c. Let me open those. Let me delete math.c and then delete circle.c. Both of them are now deleted. Now screen cleared. Now let me open a fresh math.c file, something like this one. So first of all, I want to include the stdio.h, the header file. And then I want to declare the sum function with two parameters, int, int. Okay, it again depends on compiler to compiler. We just mention int, int. Sometimes depending on the compiler, we mention int I, int j. So let's see, if it doesn't work. Let me come back and put it here. And then what I want to do is define the main function. Now inside the main function, this time I don't want to do anything like printing or something. I want to just print the function call. Make a call to the sum function. Now void sum, and in here int I, int j. And then what I want to do is I simply want to print, let's say I want to take int k equal to 0, and then k equal to I plus j, and then printf, then let's say sum equals to percentile d, then comma, and then let me print k in place of that percentile d. Now that's it. Let me go to the main function and make a function call to sum, let's say while passing. So this is a function call, to which we are passing two values, 10 and 20. As I told you just now, this depends upon compiler to compiler. Okay, now let me say if the compiler doesn't accept this one, I have to use I, j here. Okay, now let's say something like this one. Usually it is optional, but let me give a try. Let's say int file save. Now let me go to the compiler, and then gcc, and then math.c followed by -o, and again the file name of the executable file. And when I press enter, let's say it has compiled. Now let me execute this one. We got sum is equal to 30. Now once again, let me try the variable names as well. Int I, int j. Now file save. I have saved it once again. Maybe I give the values different this time. Let's say 5 or 3, 5 or something. File save. This time let me try the compilation one more time. As I told you, it depends on compiler to compiler. gcc math.c and then -o and then math, and I press enter. It has taken this one too. Now let me execute that. math and I press enter, sum equal to 8. And this is how we pass the values. Let's go ahead and see the next program of passing values to a function, that is circle.c. Let me go there. Notepad of circle.c, and then let me go there. First of all, what is the first step? Include stdio.h, and then I want to go for, let's say, area, and here I want to pass something called as radius. Okay, as I told you, this one is optional depending upon the compiler that we make use of. Now here what I'm doing is void main. Inside the main function, I'm not going to print anything, just I want to make a call to the area function. So void area and then float radius, something like this one. Now inside this one, I just want to print the radius directly, printf, area directly. Let's say /n area equal to %f and then comma, and a parenthesis for that. What we have to do is let's say 2 pi r. So this is pi and then radius that has come from the main function, and then again radius, something like this one, and then that's it. So let me call it this one from inside the main function, area of 2.3 or whatever the value we want, and then file save. And when this function is, when this program is executed, first this one is executed and this one is executed, and then what happens is this 2.3 gets and hits and stored into this radius variable, and this statement is executed, after which the output is printed. The program terminates after executing this statement. Now let me save this one, file save, and then clear screen, gcc circle.c-o, and then circle, and I press enter, and then I say circle. We got the output area equal to something like that. Let's understand the concept of returning value from a function. Let's consider this code example test.c, which has two functions, function main and function sum. And the function sum has two parameters, that is I and j, which are of integer data type. And if you notice here, the function main is making a call to function sum and then passing two values, that is 10 and 20. This 10 and 20 are captured and stored into variables I and j, and then computed and stored. Their addition is computed and stored in the variable k inside the function sum. Now let's see the execution of this program, how it looks like. So first, the operating system starts the execution from the main function, from the beginning of the main function. It then declares the variable x, and it looks like something like this one when the statement int x is executed. Strictly speaking, it stores some unknown value inside this one, which is technically called as garbage value. And after this statement is executed, when the operating system encounters a function called to sum, it jumps the program execution flow from the main function to the sum function, as we previously learned in the previous slides. And then what happens is it jumps the program flow to the function sum and then declares I and j. And then what happens is this 10 and 20 gets stored inside I and j. And after that, the code inside the sum function is executed. And if you see the step-by-step understanding, if this one, when this one is executed, what happens is we get a variable k, and the k is initialized to value 0. And when the next statement k equal to I plus j is executed, k's value 0 is now replaced with the value 30, which is nothing but the addition of I and j. And after this one is done, what happens is the operating system jumps to the next statement, which is called the return statement. As we previously learned, the return statement causes the value of whatever is mentioned here carried back to some other parts of the function. In this particular case, that some other part is nothing but the main function. So when this statement is executed, please watch it here, how it happens, something like this one. This k sends the value, the return statement sends the value k to the main function, and the sum function call is now replaced with something like this one, x equal to k. Please watch this one. And when this one happens, you can see that x receives the 30 the value 30 from the sum function. Also, please note the return data type of the function sum is int in this case, because the data type of k is int. Therefore, the return type has to be int. And this is the meaning of returning a value from the function. Now let's go ahead and see the, and here we have printed after x is executed, we are now printed sum is equal to x. Okay, and then sum is printed as 30. This is output printed something like this. Now let's go ahead and see the hands-on code example of returning value from a function with two examples, sum.c as well as circle.c. Now let me open the command prompt, and then once again, let me go to the root drive and then cd c-prog program folder. Now here I want to create a new new file. Let me delete sum.c if it is already there. Sum.c, it is deleted, and then delete circle.c if it is already there. Now clear screen. Now let me create a new file that is sum.c. Now inside the sum.c, the first step is include stdio.h, and then I want to declare the sum function with two parameters, int, int. And please be noted, this time we are returning a value from the sum function. Therefore, the return type has to be integer in our example case, as per the understanding in the previous slides explanation. Now let me go ahead and print the type in the code for the main function. The main function is here, and then currently we have let's say int x, and then what happens is x is equal to sum of 10, 20. So this particular piece of highlighted code, we programmatically read it as sum of 10, 20. And then what I want to do is printf, and then let's say sum equal to, and then percentile d comma x, and that's about the main function. Now let me type in the code for the sum function, int I comma int j, and then what I want to do is I want to take one variable inside the function sum and put it a 0 value inside that, and then later I want to take ik equal to I plus j, and then instead of printing the output from inside the sum itself, and here is the statement that is returning a value to the main function. And please be noted, few programming languages and few compilers support something called as dynamic initialization, wherein in place of 0 we can directly add I plus j here itself. But this feature depends from programming language to programming language, as well as compiler to compiler. Okay, this is just an information to let you note it, and that's it. And once this one is done, let me save this file, file save, and then let me compile and execute this program. So gcc sum.c -o, and then followed by the executable file extension, that is sum. Now clear screen and then sum. That's how it works. Now we go ahead and close this file, exit, and then let me create another program, notepad circle.c. Now in the circle.c, similar to that one, hash include stdio.h, and then what I want to do is for example, I want to declare the area function here. Area is equal to float of, let's say, radius, and then I want to declare a semicolon. From here I want to declare the main function. Inside the main function, currently let it be empty, and then from here declare the area function, and let's take the radius as the parameter. And then what we do is we can directly return, instead of storing, calculating this and that, let's say return let's say 3.14 multiplied by radius, and then multiplied by radius again. That's all. As simple as that. In this case, we don't have more than one statement. This is also a possible and programmatically legal code. And then what we do in this case is float area equal to 0.0 in the initial case, and then area is equal to let's say I say a here instead of confusion. So let's say a, and then a equals to area. We are making a call to the area function and then passing 2.3 and then semicolon, and then printf, we are making area equal to percentile f comma a, and this is how I'm explaining doing this program. Now let's go ahead and compile and see the results. So gcc, let's say circle.c, gcc circle.c, and hyphen o followed by, let's say, circle, and then press enter. Now clear screen, and then if I type this program, you get that one. So that is about returning value from a function. When you return a value from a function, the value is received and stored in a variable inside the function that makes a call to the target function. Now that is completed. Now let's go ahead and see one more topic called as called function and calling function. This is very important, called function and calling function. Let's say we have these two functions inside the program test.c. The main function is making a call to the sum function. Therefore, we refer the main function as the calling function. And similarly, the sum function is being called by the main function. Therefore, we refer the sum function as the called function. And that's about the concept of functions and different aspects related to function, passing values to a function, returning values from a function, calling function and called function, and many other topics have been discussed. Okay, now let's move on and learn something called as control statements inside programming fundamentals topic. Control statements are those which control the execution flow of the program, and depending upon the condition that we mentioned, they make the program flow jump from one place to other place. There are two types of control statements, two categories of control statements, which are used to conditionally execute the code, and the other one is to repeatedly execute the code. Now, when it comes to conditionally execute code, there are two models available. The first one is called the if statement, and the second one we call it as switch statement. Similarly, when it comes to repeatedly executing code category of control statements, there is something called loops. We'll see all these topics one by one with clear understanding, as well as with hands-on code examples, as we have been doing so far, understanding the concepts and then learning the hands-on code examples demonstration. Now let's go ahead and see the if statement first. The if statement is used to conditionally execute certain block of code. There are different possible syntaxes available to the if statement. Now you see the syntax here. We use the if keyword followed by the parenthesis. Inside the parenthesis, we provide one condition. And if this condition becomes true, only then the code inside the if statement is executed. As an example, you see if I greater than j, only then this printf command is executed, printf statement is executed. Similarly, if price greater than 100, then discount becomes 5%, something like this one. So that is called if statement. Now let's go ahead and see the hands-on code examples to the basic if statement. As I explained just now, there are more elaborated syntaxes available to the if statement. This one, what we are currently looking at and learning is the basic if statement. Now let's go ahead and see the big number.c and discount.c program. So let me go back to the command prompt. Now let's say notepad if1.c, and then I press enter, something like this one. Now here I'm making use of the include statement as the regular statement that we have to make use of. Please remember, I told you earlier, the hash include stdio.h is optional depending upon which type of compiler we make use of. There is a C compiler called as Turbo C++. If we make use of that compiler, it is not compulsory to include the statement hash include stdio.h. Now let me go to the main function. I'm typing the main function. Inside the main function, I'm taking two variables, int I equal to 10, comma j equal to, let's say, 5. And then what I'm doing is, if I greater than j, then I want to execute the output something like this one, printf percentile d, sorry, let me say printf I is greater than j, something like that, anything, whatever you want. That's all. This is called as a simple if statement, which contains only one if statement, one condition, and that's all. It does not contain what if I is not greater than j. That is a part of another if statement syntax called as the else block. We'll see that in the next few minutes. Now, as of now, we will save this program, compile and execute that. Now let me go ahead and then gcc if1.c and then -o and then if1. Now press enter. It is compiled, and let me execute this one, if1, and then press enter. I is greater than j, because 10 is greater than j. If you remember, this is one of the operators categories that we learned in the beginning of this programming fundamentals part. Now let me change the values to reverse. Let's say this is 5 and this is 10. Okay, now file save, and if I compile and execute this one, let's say gcc if1.c and then -o and then if1, and when I press enter, it is again compiled. This is compiled, but this time the program does not print the output because the condition mentioned inside the if condition is false. So therefore the statement inside the if condition is not executed. This is not executed. So that is the basic if statement. Now let me close this file and let's move on to the next example as we are talking about. This is discount.c. Now let me go to the command prompt, and what I'm doing is creating one more program, notepad discount.c. Now inside this program, as usual, let's add the include statement stdio.h. Now inside this one, I want to add the main function, and inside the main function, let me take some variable. Let's say product underscore price is equal to, let's say, 150. And then what I want to do is, discount is, initial discount is currently 0, and let's say I want to say if product underscore price, if it is greater than 150. Please watch the condition carefully. The value of the product underscore price is currently 150, and the condition here is 150 is not greater than. In such case, what we have to do is greater than or equivalent. We have to use greater than followed by equal sign operator. And then I want to say discount is equal to, let's say, 5%, for example. And after this one, what I want to do is printf discount is equal to percentile d comma discount. So if you all remember the meaning of the print command, up to here it prints the text discount equal to as it is, but in place of this percentile d, this stands for decimal integer, as we previously understood. In place of this percentile d, it prints the value of discount. Now when we execute this program, what happens is, if the condition meets to true, in our example it is true, if the condition meets to true, the execution flow is taken into inside the if condition, and the discount variable's value is changed to 5 from 0. Now let me go ahead and compile this program. Let me come back to the command prompt. Now gcc, let's say discount.c. When I press enter, then let me compile it one more time by supplying the executable file name -o is equal to discount, let's say discount. Now when I execute this one like discount, I get the output as 5. Now if I remove the equal sign, the condition fails because 150 is not greater than 150. Therefore this will not be entered, and the value of the discount variable is not changed. It remains 0, which is the initial value. Now let me save this file and compile, execute one more time. Okay, so gcc, let's say discount.c. -o and then discount, and then it is compiled. Now if I want to execute this one, discount and then press enter, it is something like this one. Now let's understand the next syntax of the if statement. In this syntax, what happens is we provide an else part. What if the given condition inside the if statement fails? In this case, the operating system jumps the execution flow to the else part in case the condition mentioned inside the if condition fails. As an example, if you see if a greater than b, it enters the if block, but if it fails, it goes to the else block. Similarly, if price is greater than 100, the discount becomes 5%, else the discount is 3%. Now let's go ahead and see the hands-on code example of if-else statement. Let me go ahead and delete the existing programs. For example, delete if1.c and similarly delete discount.c. Now I want to create a new file, notepad if else 1.c, and inside this program I want to first of all add the include statement stdio.h, and then the main function. And first I want to take a variable a equal to 10 and then variable b equal to, let's say, 5. And then what I want to do is inside the if condition, if a greater than b, and then here I want to type the actual code that has to get executed. Let's say print f, that is a inside the parenthesis, let me give %d, a is greater, and then comma a. And just in case if this one fails, I want to go to the else part, let's say else. And here what I want to do is print f and then %d, let's say this is b, and inside the brackets let me say %d and then is greater, and here I say b. Okay, and that's it about the if else first example. Generally speaking, as one of the best practice, we generally use the opening curly brackets on the same line and else part here. This is as a best practice. This is not a rule, and something like this one. And that's it. This is saved. Let me compile and execute if else 1 gcc if else 1.c -o and then if else 1 and then press enter. No problem. Now let me execute that if else 1 and press enter. Okay, a is greater. Now let me go ahead and change the values in reverse. I say this time 5 and this time this one as 10, file and then save. Now it goes to else part because a fails, the condition inside the if statement fails, and therefore it jumps into the else block. Let's say gcc if else 1.c -o followed by the final output file name if else 1, and when I press enter, the code is compiled. Now let me execute that if else 1 and then press enter. We get b is greater. Okay, this time b is 10. Previously a was 10. Now this time b is 10. Now let's go ahead and close this file and open one more new file, that is discount.c. Now let me create one more file, notepad discount.c, and inside this file let me start typing the include statement stdio.h and then void main. And then what I want to do is, as I told you, one of the best practices, we generally place the opening curly bracket on the same line. It is not a rule, it is one of the best practices. Now what I'm taking is integer price is equal to 100 comma discount. Initially the discount is equal to 0. Now let me go for the if statement. If price greater than or equivalent to 100, now let's say discount is equal to let's say discount is equal to, let's say 5%, else block, and then what we do is discount is equal to, let's say, some 3%. Now after the else part, we print the discount value. So printf price is equal to percentile d, comma, and then discount is equal to percentile d, and we have two percentile d's. The first one is price and comma, and the second one is discount. Please be noted, each percentile d, each conversion character should be provided with a matching variable name, where the variable's value is picked and converted into the specific format specifier here, that is percentile d in this case is decimal integer, and here price value is picked and converted into decimal integer and displayed in place of the percentile d. Similarly, the discount value is printed in place of the percentile d for the second case. Now let me save this file. So here the price is greater than or equal to 100. This condition becomes true. Therefore, we get the discount as 5%. This is 100 and this is 5 for the first run. Now let us go and see the compilation and execution process. GCC discount.c -o and then discount. Okay. Now what happens is it is compiled. Now if I execute that, fatal error, no input files. Sorry, it is not GCC. I have to type discount. Now you see price is equal to 100, discount is equal to, let's say, 5. Now if I change this one to some 90 or something, discount, the if condition fails, and therefore it jumps into the else part and the discount becomes 3. And here we should get 3 this time. Now file save. Let me go here. Once again compile discount.c -o and then discount, something like this. Now let's run this code. You see discount is equal to 3 because price is equal to 90. And this is how we make use of the if else state. Let's now understand the next possible syntax of the if statement, which is called as if else if ladder. And the syntax looks something like this one. We first provide the condition number 1. If this condition is satisfied, the execution flow jumps into this block and the rest of the if statement is ignored. Just in case if the condition fails here, the execution flow jumps to the next part of the if statement, which is nothing but the else if, one more condition. And if this condition is satisfied, the execution flow jumps to this part and the remaining part of the if statement is ignored. And this way it keeps on checking multiple if else if statements until it finds the right match. If no condition is matched, it ignores all the statements. As an example, you can see we have the price being tested for the value 1000. If the price is 1000, we want to set the discount to 10. But if the price is less than 1000, but if it is greater than 500, we want to set the discount to 5%. Otherwise, we want to set the discount to 3%. So this is how the else if structure works. Now let's see the hands-on code example of this else if. Now let me delete the discount program if it is already there, discount.c. Now I want to create a fresh program once again. So let me say notepad discount.c. Now the very first step we actually do is include statement stdio.h and then void main function. And then what we want to do is take the price part here, integer price is equal to, let's say, 1000, comma, discount is equal to, initially, let's say the discount to 0. And then depending upon the value of the price variable, we want to set the discount as we just now understood. Now what I want to do is type in the code for price, that is a if else if ladder. If price is greater than or let's say equivalent, if price is greater than or equivalent to 1000, I want to set the discount to some 10% as we just now understood. Now otherwise, else if the price is greater less than 1000, but if it is greater than 500, price greater than or equivalent to 500, then we want to set the discount to some 5%. Discount is equal to some 5%. else we want to set the discount to no more condition checking. We want to set the discount to just 3%, just in case if it is less than 500, that's all, the discount goes to 3%. So that's how the else if structure is developed. Now let's print the details. Printf, let's say price is equal to percentile D, and then comma, then I want to say discount is equal to percentile D, comma, price, comma, discount, and then that's it. Now let me save this file and let's go ahead and compile and execute this program. Let's say GCC discount.c -o and then discount and then press enter. The file will be compiled if there are no mistakes. I think, yeah, it is now compiled. Let me execute by typing the file name, that is discount. When I press enter, we got 1000. The discount is 10. Now let's go ahead to the program and then change the price to some 999. Let's see how it works. 999. And then save this one. And again, I want to compile GCC discount.c -o, and then the final output file name is discount. And then this is compiled. Now let me execute this program once again. This time we got the discount as 5%. Let's go ahead and change the discount price to less than 500. Maybe I say 499 or 499, sorry. Now save this one and then come here. Once again, we need to compile it. GCC discount.c -o, and then the final output file name. Now, once again, if I execute this program, discount, we get the output 499. It is discount is equal to 3%. And this way, the if-else if ladder can be used in a situation where we want to check multiple conditions one after other. If the first one fails, we want to check the second one. The second one fails, we want to check for the third one, and so on. And that's about the if statement, which is one of the categories of the control statements. Let's now understand the next type of the control statement, which is called the switch statement. The switch statement provides an alternative syntax to if-else if ladder structure, and the syntax looks something like this. We make use of the switch keyword followed by the flower brackets. And next to the switch keyword, inside the parenthesis, we provide an expression such as a variable name or any other method call or something. If the value of this variable or the condition mentioned inside the parenthesis, if it matches with the case 1's value, then these statements are executed. And then this break statement causes the switch block to be skipped, the rest of the switch block to be skipped. And just in case this value is not matched with the value that is mentioned inside the condition, the execution flow jumps to the second possible case and then checks this. If this one matches, these statements are executed, and the break statement here causes this switch statement to be skipped, with the next part of the switch statement to be skipped, and so on. If none of these values match with the value that is mentioned in the condition, then what happens is the default portion of the switch statement is executed. And for the default, the break statement is optional. And of course, the default statement itself is also optional, right? So as an example, you see here, we have the variable I declared to value I, 5. And then we are trying to check the value of this variable I against a few set of values. Switch I, and then if the value of this variable, if it is 1 or 2 or 3 or 4 or 5, if it is in any of these values, this statement is printed in the output. And this break statement causes the switch block to be, rest of the switch block to be ignored. If the value of variable I is not among this 1, 2, 3, 4, 5, then the execution flow jumps to the second possible case, that is case 6 or 7. If in case the value is 6 or 7, if this one is printed, and this break statement causes the remaining switch statement to be skipped. If the value is not 1, 2, 3, 4, 5, 6, 7, then it goes to the default and then prints the default print output. And that's how the switch statement works. Let's go ahead and see the example for the switch statement, the same thing. So let me create a new program. notepad print day.c, and inside this program what I want to do is include stdio.h and then start the main function. Now inside the main function, let me take the variable name, let's say int day equal to, let's say 1 for example, and then switch day. Instead of taking I have taken the variable name as day there, nothing wrong. So let's say case 1 colon, case 2 colon sign, and then case 3 colon sign, case 4 colon sign, and then case 5 colon sign. If it is 1, 2, 3, 4, 5, 1 or 2 or 3 or 4 or 5, then let's say it's a working day. Let's print the text as working day. And then just for the sake of understanding, let's print the day also. Day is equal to, let's say we print the text something like this one. So day equal to percentile D, and it is a working day, something like this. We'll print it. So for the sake of percentile D, we have to give that day, something like this one. And then we should not forget the break statement. If we forget the break statement, what happens is the execution flow continues with the next part of the case statements. So it is important that we should not forget it. And then case 6 as well as case 7, let's say we want to print the similar output, but it's a weekend. Let's print it as weekend. Day equal to percentile D, it's a weekend. Okay, it's a weekend. Let me correct it to lowercase. It's a weekend, and then none of them are there. Let's take it as default. Let's say printf. I will paste it, no, rather, let's say break statement is not compulsory to the default block, and then so day equal to and invalid day. So that's how it works. Let's go ahead and give a try to execute this program and see the output. So the default value, the first value that what we mentioned is 1 there. Let me minimize, and then now to compile this one, gcc print day.c -o, and then we want to give the executable file name as print day, and then let's see how it works. Now it is compiled. Let's clear the screen and then execute that one. Let's say print day. So we got a day equal to 1, and it's a working day. Now let's try to change the value of the day variable to 3 or something else and save and compile it again. I've changed it to 3. Now let me go ahead, and every time we modify the code, we have to compile it again. Okay, so gcc print day.c -o print day, and then press enter, and then let's say print day, and let's say it is 3, it's printed. Now let me give the value to some 6 or 7. So file, again save, okay, and clear screen. Again I want to compile that, compiled, and again I want to execute that. So it's a weekend, and then let's give invalid days such as 9 or 10. Again I have to save it, then clear the screen, and again compile it once again, and then I want to execute that. So that is how the switch statement works. Okay, so let me switch to the next topic. That's about the control statements, conditional control statements, which are used to execute a given block of code only if a given condition matches true. Now let's move on to the next category of the control statements, which are called as loops. Loops are those control statements which are used to execute repeatedly execute a given block of code as long as their condition is some given condition is true. There are 3 different loops available in almost every programming language. They are while loop, for loop, and do while loop, right? So, and this is the syntax to work with the while loop. So this is, we use the while keyword, and inside the brackets or the parenthesis, we declare some condition. As long as this condition results to true, this block of statements that are mentioned inside the curly brackets of the while loop are executed continuously. As an example, you can see first we declared the value of I to 1, and inside the while condition, we mentioned I less than or equivalent to 5. We want to print the value of I. So the current value of I, which is 1, is printed, and then the execution, then after this one, the value of I is incremented by 1 unit. So it is incremented, it gets to 2, and again the condition is checked. 2 less than or equivalent to 5, and this results to true. Once again, the execution flow jumps inside the while loop, and it prints the current value of the I. This time it is 2, and it prints 2, and so on. And when I is currently 5, if it is incremented to 5 plus 1, this becomes 6. And when the condition is checked here, 6 less than or equivalent to 5 becomes false. Therefore, this part is not executed, and the loop terminates from the value 6 onwards. Similarly, this is another example where we want to compute the sum of the first 5 numbers. So while I is less than or equivalent to 5, we want to keep on adding the current value of the variable I to the variable sum. Let's see these examples in the next few slides with the execution flow demonstrated. Now that's how it works. Now let's see these examples. So 5 numbers.c. We'll see how this one works in the slide itself, and after that we'll see the hands-on code examples. Now let's say, so if initially I equals to 1, and the execution jumps to the while loop. So 1 is less than or equal to 5. This results to true. Therefore, the execution flow jumps to inside the while loop, and it prints the current value of I. This is 1. And after that, the execution flow jumps to I equal to I plus 1. That means the current value of I is incremented to 1 unit. And after that, what happens is the execution flow again jumps to the while loop. You see here, this is now 2 less than or equivalent to 5. This is true, and it goes inside. And when this statement is executed, we get the current value of I is printed, which is 2 now. And then current value of I is incremented to 3, and it keeps on something like this one. It keeps on going every time the value is printed. Now it is 5, and 5 less than or equivalent to 5, it goes inside and then goes here. Now current value of I is incremented to 6, and then this condition 6 less than or equivalent to 5, this fails there, and it is not printed, and the loop is exited from that part. This is how the loop works in programming, not only in C language, it's almost same in almost every programming language. Okay, now let's move on and see the execution flow of 5 numbers sum.c. Now initially we have I equal to 1 and sum equal to 0, and the loop begins from here. So 1 is less than or equivalent to 5. So therefore it enters inside the while loop. Then what happens is existing sum is 0. It is added with existing value of I, that is 1. So sum becomes 1. And then what happens is I is incremented to 2. And then it goes here 2 less than or equal to 5. This is true. Therefore, again it enters into the inside the while loop. The existing sum is added with the current value of I, that is 1 plus 2 becomes 3. And it keeps on something like this. Okay, this is how it works, and somewhere it breaks when the value becomes 6, somewhere, and then after that the while loop is exited, this sum variable is printed, something like that. So that's about the printing the sum of the first 5 numbers. Another example is something called as Fibonacci series. A Fibonacci series is something wherein the current term is equal to the sum of the previous two terms. So consider we have these variables a equal to 0, b equal to 1, c equal to 0, I equal to 3, something like this one. All the values of the current values of the variables a0, b1, c0, current value of I. Now c equals to a plus b. When this statement is executed, please watch a change in the variable c. This is a plus b, 0 plus 1 has now become 1. And then what happens is we are printing the output printf percentile d and percentile d. For A, we are printing 0. For B, we are printing 1. And then we are starting the loop execution. So I less than or equivalent to 10. So here current value of I is 3. 3 is less than or equivalent to 10. So the condition is true. Therefore, it enters inside the while loop and it prints the current value of C. The current value of C is 1. It has printed the value 1 there. And then it is shuffling the values. We are shuffling the values. A equal to B, because the current value of A is earlier A was 0. Now we are assigning B to A. Then and after that B equal to C. It is again same. Now C equal to A plus B. Now please watch. The current value of C is 1. When I say C equal to A plus B, this is 1 plus 1. Then C becomes 2 here. Okay, C becomes 2 here. Then current value of I is 3. I'm incrementing it to 4. You see here. And then again it starts with the loop. 4 less than or equivalent to 10. It again jumps inside the loop. It prints the current value of C, which is 2 now. And this way it keeps on going and it continues the loop as long as the value of I is less than or equal to 10. And this is how the output is printed. Now, maybe I explained this program little faster than usual, but that's okay. You can play these examples at a lower speed if you're not conversant or comfortable. Now let's go ahead and see the hands-on examples of these three things, which are 5 numbers and all that stuff. So let's say notepad, let's say 5 numbers.c, and then I want to type in the program include stdio.h and then void main. Now what I want to do is declare a variable I, integer I equal to 1, while I less than or equivalent to 5. I want to print the current value of I, printf, and then %d. I want to give one space and then I want to print I there. And after that, I want to increase the value of I to I plus 1 and then semicolon, file, save, and let's go ahead and see the output. Now clear screen. I want to compile it. GCC 5 numbers sum.c. What is that? GCC 5 numbers sum.c -o and then 5 sum. What is the file name? What is that? This file name is 5 numbers.c. The file name is 5 numbers.c. GCC 5 numbers.c and then -o 5 num. Oh, still not there. dir 5 star. What is the file? Oh, it is saved as .txt file. So I want to change this one to, okay, rename of 5 numbers.c.txt, then 5 numbers.c. Please watch here. This is the rename command that changes the name of this file from .txt extension to .c extension, file extension. And then the system cannot find this path. What is happening wrong here? Let me close all these files. Okay, dir 5 star. Let's say, okay, rename 5 numbers .c.txt and then 5 numbers.c. What happened? The system cannot find the file specified. There is a space, I guess. This is one space. One space is there. Oh my God. Maybe I'll delete that 5 numbers star, and then that makes faster. Notepad 5 numbers.c. Okay, something wrong in the command. Include stdio.h and then void main, and then let's say integer I equal to 1, while I less than or equivalent to 5. I want to begin the while loop, and inside the while loop we want to print the current value of b, then a space followed by that we print, and then we want to say I equal to I plus 1. Since we are learning the programming fundamentals, I'm not using the shortcut code wherever applicable. I'm using the most basic style of programming. So for example, instead of typing this one as a separate line, I can just say I++, the increment operator, if you remember, which I explained in the initial parts of this programming fundamentals video. So this is one way we can do that. And alternatively, what we can do is here itself, we can use it as a post increment operator. This one also works well. Okay, however, let's see the basic approach and then try to understand the different approach. So I equal to I+1 semicolon file and then save. Now let's say, let me check the file exists this time, dir 5 star. So the 5numbers.c exists this time. Now clear screen. Now gcc 5numbers.c 5num. I want to give it as -o and then 5num and then press enter. That is compiled. Now let's type 5num. Please note the executable file name that I have mentioned is 5num. So we should always type the executable file name, but not the C program source code file name. Right. So when I press enter, we get the output 1, 2, 3, 4, 5. So as an example, let's try to change this program to I++. Okay. And then semicolon, file save. So we'll compile it one more time. Every time we modify the program, we have to compile it. So I'm compiling it again, and then it prints the same output, something like this one. So we even can do something like I++ here itself directly, file and then save, and then let's again compile it. So after compiling it, we again get the same output. So that is how it works. Let's say we forgot to increment the value of this variable. We have just set it printf %di. So what happens is the current value of I always be less than or equivalent to 5, and the program execution flow will be inside the while loop continuously. And this kind of situation, we call it as infinite loop. So let me try this one. So I is not incremented, if you notice here. So let me try this one. So let's say GCC and then what is that? 5numbers.c and then -o 5number, something like this one. Now, if I execute 5numbers, you see how it looks like. So it is continuously printing the current value of I, and this kind of situation, we call it as infinite loop. So to stop this one, we need to press the key combination Control key and then C. Press and hold down the Control key and then press C. Okay, the key C, and then that is terminated. So that's the about infinite loop. So please always change the value of the variable that is used in the while condition. Now, if you want, we can take the loop in reverse also. Let me take the current value of I to 10, and the condition has now to be changed. How do we change that is, while I greater than or equivalent to 1, this time we want to decrement the value, but not increment the value. I minus minus, file save. I have saved it. Now you want to change it. Let me compile it again. GCC 5 number. Of course, we have used the loop for 10 numbers. That's not a big deal. Okay, -o, once again 5num, and then I press enter there. Then if I save it as run it as 5. Now we got the loop, numbers printed in reverse order, because the initial value that we have chosen for the variable I is 10, and the condition is little reverse this time. Instead of asking it less than or equivalent to certain number, this time we have asked it to check if it is greater than or equivalent to certain number, and therefore after that we have printed and then decreased the existing value by 1 unit. So that's about the 5numbers.c. Now let's move on and see the another program, that is 5numbers_sum. Instead of printing the 5 numbers, we want to print the sum of the first 5 numbers. Let's say notepad 5sum.c, and it's almost the same program. Include stdio.h, and then what I want to do is begin with the main method. Now inside the main method, we want to take two variables this time, integer I equal to 1 and the current value, the initial value of the variable sum. And then what we want to do is while I less than or equivalent to 5 or 10, whatever the requirement is about, here inside the while loop, what we want to do is sum is equal to sum plus I. And then this one we have already understood in the slides how it works, isn't it? So here then I plus plus is something like this one. So I plus plus is something like this one, semicolon, file save. And after the while loop, outside the while loop, we have to print the value of sum. So printf, let's say sum is equal to percentile D and then comma the variable sum. So otherwise, you want more elaborated and clean descriptive output, value of sum after, let's say, after while loop completion, value of sum after while loop completion. And then let's say I want to print this statement before the while loop as well, value of sum before while loop completion. Okay, before while loop completion. So this prints the current value of sum, that is 0, and this prints the current value of sum, that is after while loop is executed. For example, it prints 15. Let's go ahead and save and compile this program and execute and see the output. So for example, I say gcc 5 sum dot c and I say 5 sum hyphen o and then 5 sum, and this is how it looks like. And let me execute this program. Let's say 5 sum, something like this one. So value of sum before while loop completion is equal to 0. I forgot to mention the slash new line as I told you in the previous example. So I want to put a slash new line there. Let's say slash n. Okay, now file save. This space is not required though. Let me compile and execute one more time. This is compiled and this is executed. So value of sum before while loop completion is 0 and value of sum after while loop completion is 15. And this is how it works. So there are so many approaches to solve a programming problem that is called algorithm and logic development programs. However, we are not learning different logic related problem statements here. So as a small improvement to this statement, what I can do is these two statements can be shortened into one single statement. You can watch it here. So what I can do is instead of writing this one as like this one, I can say sum is equal to sum plus I plus plus. So because this is the post increment operator, what actually happens is, first of all, this portion of the statement is executed. And after this one is completed, the computer executes this portion of the statement. That means this is a 2-in-1 statement. We can even more shorten this one with the help of the assignment operators. If you remember that we learned in the beginning stage, that is sum is equal to sum plus I plus plus. Instead of writing that one, we can say sum plus is equal to I plus plus. So it is also same as the same thing, right? So same as the previous code. Now let me change the increment value to 6 or 10, for example, file and save. And then let me come back to the console, compile it again, and then execute it. So this is 55 this time. So as I told you just now, there are multiple ways to solve one problem. Everyone's thinking is different. Different people have different ideas, and the smarter you develop the program, the more efficient the program is executed. So that's how it works. So that's about working with 5 numbers sum. Let's move ahead and see the next program called as Fibonacci series. So notepad Fibonacci.c, and then inside this one, what I want to start type in the program, include stdio.h, and then start typing the main method. And inside the main method, we want to take the variables such as int a equal to 0, or let's say b equal to 0, comma, I equal to, we want to begin from this one, c equal to 0, and that's it. So what we want to do is, first of all, we want to say c equal to a plus b. We'll do that later. So first of all, let's print a and b, printf, and then say percentile d space percentile d, this is A comma B, and this is all. As I told you, different people do programming with different approaches. There is no fixed way of solving a problem using programming. So here we are printing 0 and 1, and then we are assigning A plus B to C. And then what we want to do is, while I less than or equivalent to 10, so we want to print 10 series of Fibonacci numbers. So what I want to do is, inside this one printf, I want to say, let's say percentile D, maybe I give one space there after this one, and then percentile D, then a space, and then comma C. This one has already been explained in the slides, how the flow executes, right? So then what I want to do is, A equal to B, we want to shuffle the values. We want to give the current value of B to A, and we want to give the current value of is B equal to C. So B equal to C, something like this one. Okay, B equal to C, and then C is equal to A plus B. C is equal to A plus B, and that's all. We want to increment I to 1 unit, and that's all. So file save. Then I want to execute this program. It's a GCC Fibonacci. Oh, once again, this file problem has come. Let me select this entire text, copy, file, save, file, exit. So I want to create a notepad fib.c, and then I proceed there and file save. So now I want to compile GCC fib.c -o and then fib, and I press enter. And if I type this one, something is incorrect. So current value of B equal to what is printed there. I think in place of 0, it has to be 1 there. File save. Now let me compile and execute. GCC fib.c and then fib. So this is how we get the Fibonacci series printed. So there are multiple ways to solve a problem using programming. Okay, as I told you a few times already. So that's it. Now let's understand the next topic, that is the break statement. The break statement is used to exit from the middle of a loop based on some condition. In order to understand this statement, let's consider one problem statement wherein we want to check whether a given number such as 25 or some other number is a prime number. In order to check whether a given number is prime or not, we need to perform the modulo operation and check whether the remainder is 0, starting from 2 to the given number minus divided by 2, such as 25 mod 2, 25 mod 3, and so on. During this entire process, if we find at least one remainder 0, then what we do is we change this temporary variable from 0 to non-zero to indicate that there is one factor. So what we do is we begin with 2 and we check this is non-zero. Then we go to the next one. We again check this is non-zero. So the temp variable is not changed. We again check this is non-zero. Temp variable is not changed, and so on. And now we get it. When we perform the modulo operation with 25 and 5, we get the remainder as 0. Therefore, we need not continue with the division process until the last number. And also we change the temporary variable from 0 to non-zero, such as 1, 2, whatever we want. And then we terminate the loop from this point. So here in such part, we use the break statement. So let's go ahead and see the code snippet with hands-on example of loop. The for loop is another kind of loop, as we have already noticed. There are 3 types of loops in almost every programming language: while loop, for loop, and do while loop. Now we are currently discussing the for loop, and the syntax of the for loop is something like this one. We use the for keyword, and inside the brackets or parentheses of the for, we have 3 parts. The part 1 is called initialization, and then after initialization part, there is a semicolon. As an example, you can say we initialize the value of the variable that is used to check the loop iteration condition. So I equal to 1. And the second part is called test expression or condition. So this is the syntax. As an example, you can see I less than or equivalent to 10. And if this condition is true, what happens is the execution flow jumps inside the for loop and all the statements are executed. And after the statements are executed, the execution flow jumps to the third part of the for loop, something like this one, incrementing or decrementing or something else. As an example, we have I++. And after I is incremented or decremented, it again goes and checks the value for I, whether it is less than or equivalent to 10. And if the condition is true, it executes these statements. Okay, so it is almost equal to the while loop, and it's just a choice whether you want to make use of while loop or for loop. Okay, now this is an example. You see, for I equal to 1, I less than or equal to 10, and then I++, printing I, and this is printing sum, and this is Fibonacci. All these three programs that we understood previously using while loop can now be written using the for loop. Let's go ahead and see these programs in hands-on. Okay, so 10 numbers. Let's take 10 numbers this time. Now let's say notepad for loop 1.c, and then I begin the program, include stdio.h, then void main, and inside the main method, main function, what I want to do is integer I equal to 0. Now for loop is started here, the curly parenthesis. For I equal to 0, sorry, I equal to 1, I less than or equivalent to 10, and then I++. Now this curly brackets belong to the for loop. If there is only single statement that we want to execute as a part of the for loop or while loop or if statement, whatever it is, we don't need these curly brackets. However, it is a good practice to make use of them. Now I want to print the current value of I, %d, and print a space after each number. The current value of I want to print is something like this one. Now file, save, that's all. This prints the first 10 numbers. Now let's say clear screen. It is gcc for loop 1.c -o and then for loop, something like this one. Now let me execute the program. I type for loop and then I press enter. I get the output. This is how we make use of the for loop as an alternative to the while loop. Now let's go ahead and see the next program in the example case, 10 numbers sum.c. So what I do is I create one more program. Before that, let me close this existing program. So what is that? Notepad for sum.c, and then what I want to do is type in the program, include stdio.h, and then void main, and inside the main function we start typing the program, int I equal to 0, and then comma sum equal to 0. And then what I want to do is for I equal to 1, I less than or equivalent to 10, I++, and inside the curly brackets I can just type sum is equal to sum plus I. If you remember in the previous examples while talking about the while loop, I said this can be shortened to sum is equal to sum plus I. Sum is equal to sum, let's say sum plus equal to I, something like this one. Okay, so there is no statement as such. In this case, what we can do is in I++, we can put a comma, then we can say sum is equal to sum plus I, something like this one we can do. This also works, and we can ignore this part of the program. As I told you many times up to already, there is no single rule that we have to develop the program only using one style of approach. We have different solutions available for a problem to be solved. So because we are learning the fundamentals of programming, I am not using all shortcut approaches to solve one problem statement. After the for loop closing curly bracket, we have to print the value of the sum. So printf, I say %d, let's say sum is equal to sum is equal to percentile D, and then put a comma there and then print the sum. So this is the variable name, and these are all the case sensitive. Now let me save and execute this one. Let's say GCC for sum dot C and then hyphen O and then for sum, and then press enter. Now let me execute this program for sum. Now you see sum is equal to 55. That is how it works. Now let me close this program. Now clear the screen and let's go on. I'm leaving it to you to do this Fibonacci program, either looking at this slide or do it yourself. Okay, that's about the for loop, and let's move on to the next type of the loop, that is called the do while loop. The do while loop, the syntax is something like this one. We have the do keyword followed by the opening and closing curly brackets, and the body of the loop is in between these curly brackets, and we make use of the while condition after the closing curly bracket and something like this one, and we have a semicolon here. Now, as an example, this is something like this one. We can print the first 10 numbers. We can print the sum of the first 10 numbers. It's almost same. Okay. Now, let's do the program something like this. So let's go ahead. Let's say notepad do while 1.c. Now, let me type in this program, include stdio.h and then void main. And here, what we want to do is integer I equal to, let's say 1, and that's all for now. Do, and the curly bracket open, while I less than or equivalent to 10. And then what I want to do is printf percentile D, comma I. And I want to give one space after each print. So one space, because I'm not using the slash new line, that is slash and escape sequence. And then I want to go for I increment here itself. The difference between do while loop and the other two loops, that is the while and for loop, is the do while loop is executed at least one time, because before the first execution, there is no condition to be tested. So that is the difference between the do while loop and the other two loops, while and for loop. You have to make a note of this one if you're a beginner to programming. So that is how it works. Now let me save this file, and I think almost correct. Let me compile and execute. Clear screen, gcc do while.c and then hyphen o, and then I want to give the file name, executable file name as do while, and then press enter. Now do while and then press enter, we got this output. Similarly, we can do the other programs. Let's say I want to close this program, control A, control C. I want to close this program. I want to say one more do while sum, notepad, okay, do while sum dot c, do while sum dot c, something like this one. So I want to take one extra variable here, that is sum equals to 0, and then instead of printing here, what I want to do is sum plus is equal to I plus plus. I already told you earlier, and after the while, we want to print the sum here. So something like this one, percentile D, comma, let's say sum. I want to print sum is equal to percentile D, comma, and then let's say sum I want to print here. File save, and I hope you are able to understand, because these programs were already explained using while loop. I am not explaining line by line. Okay, now let's say gcc do while sum dot c and then hyphen o, and then do while sum, and then press enter. Then do while sum, if you type, we get 55 again. So similarly, you can also do the what do you say, the Fibonacci numbers, okay, Fibonacci series using do while loop by looking at the while loop example. And that's about working with the control statements such as if statement, switch statement, and loops such as while loop, for loop, and do while loop. Now let's move on and understand the next topic called arrays. An array is a collection of continuous memory cells that share a common name. So let's say these are the continuous memory cells all these memory cells, that is, which are nothing but variables, which all share together one single. In a normal case, all the memory cells, all variables have different names such as I, J, K. But in case of arrays, all the memory cells, all variables share the common name, that is called array. And then array element index, with for each element inside the array, we have some index. The programming index the programming language uses index, and the index starts from 0 and ends with number of elements minus 1. Element means each memory cell that belongs to each variable that belongs to an array is called element. For each element there is an index. So we have 0, 1, 2, 3, 4 here. So array element index is used to read or to write data into a particular element. For example, the name of this example array is scores, which has 5 elements. Now, if you want to store some value into the 0th element, or if you want to store some value into the 4th element, we need the index, and therefore we use the array element index for that. So the syntax for reading, we'll understand that in the next. So here, declaring an array is something like this one: data type and followed by the array name and then size. Okay, example, int scores of 5. We read it as scores of 5. We read it as areas of 3. Please note, I have highlighted this with C language, the example and syntax that belongs to the C language, because the syntax in working with arrays is different in Java than that of the syntax in working with arrays in C language and C++. So when we talk about arrays in Java, we can understand the syntax that is specific to Java arrays. Now, currently, let's focus on the C language syntax and example. Now, as you're able to see, we have data type followed by the array name followed by the square brackets, inside which we are mentioning this size, means how many elements we want, we mention in the size place. So as an example, we have integer scores of 5. This one, the first statement will create something like this one. Similarly, we are declaring one more array. The name of the array is here areas, to store the areas of 3 different circles. Maybe this is the size that represents 3. So in the first case, the array indices start from 0 and run through 4, and here it starts from 0 and run through to 0, 1, 2, and here we have 0, 1, 2, 3, 4. That's about declaring an array in C language, as well as syntax and example. Initializing array means providing the values to the elements that are a part of the array during the declaration. And the syntax you see here: data type, array name, and the size. And inside the flower brackets or curly brackets, whatever you want to call it as, we give first value, second value, and so on. As an example, you see integer scores of 5 is equal to, we have provided the values for 5 elements, some values such as 56, 34, and so on. So that's about initializing an array. Now, this is reading and writing data from array elements to array elements. The syntax here is array name, and inside the square brackets, we give the index of the element to which we want to assign the value, or from which we want to read the value. So as an example, scores of 0. Please recall, we read this statement as scores of 0, scores of 1, areas of 0, areas of 1, something like this one. So the first statement stores the value 10 into the array element 0 with an index 0 of the scores array. Similarly, the second statement stores the value 20 into the array element with the index 1 of the scores array, and the other two statements store the values 4.5 and 6.5 into the 0th and first index of the areas array. So that's about initializing arrays and reading, writing from arrays. Now let's see the hands-on code examples of these two programs. So let me go to the command line and then create a notepad scores.c. And here I want to start typing the program, include stdio.h and then void main. And here, let's say I want to say something like integer scores of 5 equal to, let's say I want to say something like this one. Let's say some values I'm giving input there. Okay, something like this one. 1, 2, 3, 4, 5. That's there. It's completed. Now you see printf, let's say percentile d is equal to, oh, let's say I want to print scores of some second element, index 2, but the element is 3. Don't get confused. Because the indexing starts from 0, 2 means the third element, 0, 1, 2. So we get output 56 now. Now file save, and let me go to the compilation. Let's say gcc scores.c, and then -o, and then let's say scores, and then press enter. So main function, something is missing. Percentile d, this is a comma, it's not an equal to sign, comma there. Okay, file save, and then let's say gcc scores.c, and then -o, and then scores, and then we compile it. If you execute this scores file, you get 56. That is the element number 3, index number 2, as I told you. If you want to change the value of the second index, let's see this one. Scores of 2 equal to, let's say 100. I'm changing 56 to 100. After changing, I'm printing this value. Copy this one and I paste it here. Okay, value of scores of 2 after changing. Okay, we can say after changing, I can say something like this one. So let's see the compilation now. Compile and then execute. Value of scores of 2 after changing is 100. Because I have not used the /n here, we're getting the output printed on the same line, /n, something like this one. Okay, so that's about this one. We can develop so many programs to understand the logic and algorithms. However, the purpose of this tutorial is give an overview of programming fundamentals using C language. Okay, logic and algorithm development, there are so many programs to learn that we can learn, that cannot be, there is no limit for that. Okay, so that's about scores.c. And similarly, we get a copy paste of this one as areas.c. Let me open one fresh program, notepad areas.c. And inside this one, what I want to do is something like this one. So instead of integer, I want to take this one as float. And then I want to take this one as areas. This time I want to make the size as this one. So let's say 2.0, and then I want to take it as 3.5, and then I want to take it as 5.6 or something. And here we want to print areas of 2, the element with the index 2, but the actual element is the third element. We get 5.6 in this case. I'm not using these two print commands, file and then save. Now let me go ahead and compile this areas.c. gcc areas.c -o, and then areas is something what I'm doing in here. Okay, there is something wrong. One comma is extra here. So this is 3.5, and this is done. Now that is completed. Now let's take compilation once again. It is compiled. Now areas, and then press enter. Okay, we have printed this is 0, this is 1, and this is 2. So this is percentile d is the correction here. If you remember, to print the floating point values, we have to use the percentile f. So I make it as f there. D means decimal integer, and that's the reason we got the incorrect output. Now let me compile it one more time. Okay, compile it, and then I print it there. I got 5.60. So if you try to use an index that is not there, let's say the index is 8, file save. Now let me compile and check if it compiles or not. Actually, it compiles. Okay, you see here it is compiled. and then we get this one, we get some unpredictable output. In case of Java, when we start learning Java, we need to understand one point here. In case of Java, if we use an array index that is beyond the size, this statement results in one problem statement called as array index out of bounds exception. However, when we talk about arrays in Java, we will see that code example live in action. And that's about the programming fundamentals using C language, guys. As I told you, this is not an in-depth C language training. This is only an overview of the programming fundamentals that we learned using C language. There is no limit to learn the problem statements and programs. We can learn it as many as we want. And each problem has a different, multiple solutions. Different people develop different programming or logic and solution. Okay, thank you for watching this and keep continuing with the Java part. We'll meet in Java part. Thank you. So in this part, we'll start learning the Java programming, being in this part, especially introduction to Java and various topics related to introduction. So we'll first see what is Java and what is Java used for, followed by the different software editions that Java offers. And then we'll see Java version history, downloading and installing Java, understanding and setting path, followed by the meaning of JDK, JVM, JRE, JDK tools. We'll see the steps of developing the first program, compiling the first program, and executing the first program. And then we'll understand the meaning of native code and bytecode, followed by the Java features, keywords, operators, and understanding the concept of IDEs, as well as downloading and installing the Eclipse software IDE. And then we'll see the concepts such as creating a new project in Eclipse, executing the Java program in Eclipse, etc. Followed by the data types and sizes in Java, variable types and their naming rules. And then we'll see the control statements such as if statements, loops, etc. We'll then see the structure of a Java program, followed by the concepts of class and object in Java. And then we'll understand the naming conventions that are used to name a class, object, variable, and all that stuff. We'll then see the concept of static and non-static in Java with the differences and meaning as well as examples. After that, we'll see the details about System.out.println command statement, which is used to print something onto the computer's output screen, followed by the reason why the main method is public and why the main method is static. So let's get started with what is Java first. Java is a high-level object-oriented programming language, and it is used to develop different kinds of applications such as desktop applications and web applications and embedded systems. Desktop applications are those which are executed locally in a desktop or a laptop computer. These applications don't require an internet connection. Examples of desktop applications include retail stores billing systems, hospitals data entry systems, school data entry systems, and similar ones. Web applications are those which are executed on a remote computer, which is technically called as a web server. And the applications, when executed on a remote computer, produce the results which are sent across the internet to our target devices such as desktop, mobile phones, or any other gadgets. Examples of web applications include online shopping applications, ticket booking applications, banking applications, etc. Embedded systems are those applications which are embedded in electronic devices such as ATMs, gaming devices, and printers. Now let's see the different software editions that are offered by Java. Java is available in 3 different editions called as Java Standard Edition, Java Enterprise Edition, and Java Micro Edition. The Java Standard Edition is used to develop the desktop applications. Enterprise Edition is used to develop the web applications as well as enterprise applications. More advanced web applications are called as enterprise applications. Micro Edition is used to develop embedded systems. Now let's see the Java version history. The first version of Java Standard Edition JDK 1.0 was released during the year 1996. And as of this recording, March 2021, JDK 16 was the latest edition. However, even though the latest version of JDK is 16, most applications are currently still using JDK 8 to JDK 12. In this tutorial, we'll make use of the JDK 8 as it is the most commonly used version of Java. Now let's go ahead and see the steps of downloading and installing Java. In order to download Java, we'll search for something called as Java Standard Edition 8 or JDK 8 download in search engine. Java SC8 download. And when you search for this one, we are provided with the search links, something like Java Standard Edition Development Kit 8. And this is the link that is offered from the oracle.com. In order to download the JDK software from oracle.com, you need to register with the Oracle website. The registration is a simple process. And when you click this link, we are taken to the download page, which provides a list of downloadable files for respective operating systems, different operating systems such as Linux 64-bit, Linux 32-bit, and so on. My operating system is Windows 64-bit, and therefore I'm going and selecting this particular option. JDK 8, U stands for update and 301, update 301. Now, when I click on this download link, it will ask me to accept the agreement license and this one, license agreement, and then click the download button. When we click the download button, we are taken to the login page. If you don't already have an account with oracle.com, you need to sign up first. You need to register yourself with oracle.com in order to download this software. So I'm providing my details and then getting the download done. Now, once the sign-in details are provided and click the sign-in button, provided the credentials are correct, it takes us to the download page and it will prompt us where do we want the software to be downloaded. I'm selecting desktop, and on the desktop, I'm creating a new folder, JDK 8 download file. Some folder name I'm mentioning. And in this folder, I want to save this downloaded file. And then the download starts. So the download is started. It's almost downloaded. Depending upon your internet speed, it downloads fast or slow. So in my case, it's downloaded very fast. And now let me minimize this window, and then let's go for the JDK 8 download file. So this is the folder in which we have downloaded the software. Now what I want to do is, in order to install JDK software, we first need to download, and then we double click this file. And the installation process takes a few minutes. Now it is asking us for the permission, and then click yes here. Now click the next button here. So it takes a few minutes. Now, please try to watch here. Install2 is the folder path where Java is being installed. So by default, it installs Java in program files of the C drive, and it creates a folder called Java, under which it again creates one more nested folder with the folder name JDK and the version details such as 1.8, 1.9, and so on. If you don't want JDK to be installed in this particular folder, you can click the change button and locate the folder into which you want to install the JDK. However, it is recommended to keep the defaults as it is. And now we click the next button. When we click the next button, it starts the installation process. So the installation process is going on. It takes a few minutes. Now here, after it installs JDK, it installs one more part of the Java software, one more component we call it as, that is called as the Java runtime environment. So it is also installed into the almost same location, C drive, program files, Java, JRE, and then version number. Now we click the next button here. It again installs the JRE. earlier it installed something called as JDK. We'll see the details of what is the meaning and difference between JDK, JRE, and other topics in the next few minutes. So it is currently installing JRE. Now the software installation is completed. Let's click the close button. Now to check the software installation, whether it is successfully done or not, we need to open the Computers Explorer and then go to C drive, Windows C drive. If you remember, the JDK software, it got installed into the program files folder. Inside the program files, there is a Java folder. And inside the Java folder, we have two folders. The first one is JDK followed by the version number. And the second one is JRE followed by the version number. We'll see the details about JDK, JRE, and other topics in the next few minutes. JDK stands for Java Development Kit and JRE stands for Java Runtime Environment. And the commands to use to execute, to compile and execute the Java programs are located in a folder, bin folder, which is inside this JDK folder. So let's open this folder and we see the bin folder. The bin folder contains many commands. All these commands which are stored in the bin folder are technically called as JDK tools. And the most popular commands are JavaC and Java, which are used to compile a Java program and execute a Java program. Apart from that, there are so many other tools which are used for different requirements. For the beginner level, those are not at all required. Okay, and the most commonly used one more tool is called JAR, the JAR tool, which is used to compress the Java software application. Because when we develop Java applications, all the programs are compiled into something called as .class files, which are then compressed into a zip file, which is technically called as a jar file. In order to create a jar file and in order to extract a jar file, we make use of the jar tool. However, we are not going to see the jar tool right in the beginning stage. Depending upon the situation, we can see that. As I told you just now, the JavaC command and Java command are used to compile and execute. We'll see those steps in them. Now, let's say we are currently in this folder. Now, let me put here. So you see C program files, Java, JDK. And in this particular folder, if you type the command prompts, let's say you, excuse me, you type the CMD, we open the command prompt from this folder. So we get the command prompt. So it's getting loaded. Yeah, it's taking some time. So here is the command prompt. Inside the command prompt, we are currently in which folder? Please watch. We are in the bin folder. So all the commands such as JavaC, Java, etc. are available in this folder. So that means we can check whether Java is successfully installed or not. Java space and then we can type version, Java hyphen version. Sorry, Java space dash version. So when you say it prints us Java version, that is 1.8.0_301. This is the version number that is currently installed. So if you get this output of Java version command in this particular folder, that means the Java software is successfully installed in your computer. But please be noted, in order to compile a Java program, we use one more tool called JavaC. And when we type and press the enter key, it shows a screen full of options that we can use with that. However, we'll see the details. Now, let's understand the next topic called as understanding and setting the path variable. Path is an operating system variable, and it is used by the operating system to find the folder locations of various executable commands of various softwares, such as JavaC command, Java command in case of Java software, Notepad command in case of Notepad software, and so on. In order to understand this sentence, let's go back to our Java bin folder in the command prompt. We already know that this is the folder in which we have the commands related to Java software, which are used to execute and to compile and execute Java programs. That means if I want to compile a Java program, I have to make use of the Java C command. And when I press enter, the command works well. The command works well because we are currently in the bin folder. Now imagine I want to execute this command in a different folder. What I'm trying to say here is I want to move to the root drive of the C drive. So root directory of the C drive, something like this. Now by typing this cd and then reverse slash, I move to C drive, root directory of the C drive, computer's hard drive. Now, if I type the Java C command here, the command will not be executed. Why? Because the Java C command is not available in the root directory of the C drive. It is available in the bin directory of the Java installation path. So we need to instruct the operating system that if we type the Java C command from any folder, not just from the bin folder, if we execute the Java C command from any folder, it has to get successfully working. So we need to tell the operating system to pick this Java C command from this particular folder, even though that command is not available in this root drive or some other location. We do this by adding this folder path such as bin to the operating system's level path variable. Now let me copy this one. Okay, so let's go to the folder structure. So go to the C drive and then program files. Now inside the program files, Java is located here. In Java folder, we have JDK, and in JDK, we have bin. Now let me copy this one. And then we have to paste this path in settings variable. So operating system settings variable. You press the window key and then go to advanced system settings. You type advanced system settings and click this button. And then you open this environment variables option. Now here you see something called as the path variable. Click on here and then click edit button. Now here you see a list of path variable, a list of folder paths already set related to other softwares. Now when you click the new button, we want to add our Java path here. Okay, we can add the Java path here. See, please try to understand the path variable is not related to Java. It is a general topic related to operating system. It is applicable to almost any software that is installed on the computer. Now, if you see here, we have pasted C program files, Java, JDK version number followed by the bin folder as one of the settings in the environment variables. Now we click OK all around and then we click that. Now, if you type Java C command, it should work from here also. However, it will still not work now also because after changing the path variable details, we have to quit and reopen this window. So I type the exit button and then I press the command window key and then command prompt cmd. And then from here, now we can type the Java C command from anywhere. Now you see, I typed the Java C command from a folder named after my name, Ravi Tatikunda. So earlier it wasn't working, but it's working from any folder now because we had set the path. So that's the meaning of setting path. So that's about setting path for executing Java software commands. Okay, now let's go ahead to the next topic, JDK, JVM, JRE, and JDK tools. So the details are now understood step by step. JDK stands for Java Development Kit. JRE stands for Java Runtime Environment. JVM stands for Java Virtual Machine. JDK tools are the software commands stored inside the bin folder. As we just now understood, example commands are Java C command, which is used to compile, Java command, which is used to execute, jar command, which is used to compress and uncompress the Java software, and other tools as well. So that's about the introduction to JDK, JRE, JVM, JDK tools. Now let's see these details, this topic in detail. So Java Development Kit is a composite package of different other software such as JRE and JDK tools. For example, JDK is composed of JDK tools as well as JRE. And then JRE is again composed of something called as the Java Virtual Machine as well as the Java libraries. Java libraries means the built-in programs that belong to Java, which are installed during the Java software installation. Example built-in programs are available in java.lang package, java.util package, java.input-output package. Not only these three, there are so many other built-in packages available. All those packages belong to this Java libraries category. And the Java virtual machine is that part of the JRA which is responsible for loading the Java programs into memory and executing them. We'll see those details in the next few minutes in the later parts of this tutorial as we move on to the respective topics. JDK tools are those commands which are used to execute Java related software programs such as compiling and executing. We already understood just now. So that's about the Java development kit. It contains JRE and JDK tools. JRE in turn contains Java virtual machine and Java libraries. Now let's move on and see the steps of developing the first program and compiling it and executing. We can type the Java programs in a plain text editor such as Notepad or Notepad++, or we can use the advanced editors such as Visual Studio Code or any IDEs such as Eclipse, IntelliJ, and STS. So as a first program, we make use of the Notepad, and once we understand the meaning and details about what is an IDE and how to download and install IDE, we start working with Eclipse IDE from the next program onwards. For now, let's open the Notepad and start typing the first program. We'll see how it works. So to do that, first of all, what I'm going to do is I'm going to my computer's Explorer, and inside the Explorer in the C drive, what I'm doing is I'm creating a new folder. The folder name, let's say Java-prog, Java program, something like this one. So this folder is currently empty. Inside the command prompt, what I want to do is I want to switch to that folder. So currently I'm here. I'm clearing the screen by typing the CLS command. Now the screen is cleared. Next step, what I want to do is CD and then reverse slash, the backslash. And when I press enter, I'm taken to the root drive of the C drive, root directory of the C drive. And from here, what I want to do is I want to move to that Java programming folder. So now we are currently in this folder, Java-programming folder. Here, I want to create a new Notepad file. What I do is Notepad space, let's say hello.java. So the file extension to Java programs is .java. And this is called the class name. We'll understand the details very clearly one by one. So don't get confused or don't be in a hurry. Okay, so what I do is I now press enter. It will now open the new Notepad file. It's not getting activated. Something stuck. Yes. So now you see it's asking us cannot find the hello.java file, and it's asking us, do you want to create a new file? I click yes button there. Now it creates a file. In the upper left corner of the Notepad, you can watch the file name hello is mentioned. Okay, however, I'm not going to explain the details of the program. We'll understand all the details very clearly in depth, step by step in the next few slides in the parts. For now, I'm typing the program, just okay, public class hello. And here I'm typing one method, public static void main string args, and then the statements to print some output on the screen, System.out.println Java programming language. And probably we can add as many print commands as you require. System.out.println welcome to Learn Clearly YouTube channel. Okay, whatever you want, you can type. So as many statements as required. On now saving this file. Once the file is saved, what I'm doing is compiling the program. In order to compile the program, we use a command called as javac. Watch here, the javac command. And to this command, we provide the file name with the file extension .java. As an example, it is displayed here, javac welcome.java. But the program name I have chosen is hello.java. So no problem. What I will do is I type javac space hello.java. So come back here. Now Java C hello.java. And if there are no mistakes, the program compiles well, and we get one more file generated. The Java C compiler generates one more file with a file extension hello.class. Now let me compile that. So this is successfully compiled. There are no typing mistakes or programming mistakes. Now I say dir, that is the directory command, which is used to list out the files available in the current folder. Now you see we have two files available. This is the file that we have developed, or the program is written in which, and then this is the file that is automatically produced by the Java C compiler. So this the code inside this file, we call it as byte code. In the next few minutes, we'll understand that. Now I clear the screen by typing CLS. Now let's go to the next thing, executing a Java program. To execute a Java program, we use the Java command, and the syntax is Java space, the name of the class which contains the main method. Example, Java space welcome. However, in our example case, what I'm doing is the name of the class is hello. I type Java space hello. And when I press enter, it will print us the output, whatever is mentioned in the code. And please be noted, the class name that we mentioned here, it is case sensitive, and it should match with the class name exactly as we mentioned inside the program. If this one is capital letter, then we have to type with the capital letter. For example, if we type the same spelling but incorrect case, let's say Java, and I type everything in lowercase, it doesn't execute. That is case sensitive. We'll understand the details in few minutes. A lot of topics need to be understood before understanding the details of the public static void main and public class hello. All these things will be very clearly understood in the next few minutes. Okay, so please be patient. Now let me save this file, and that is completed. However, you want to check one more thing. I want to type complete capital letters also. It doesn't work. It has to be exactly the same class name with the same spelling and the same case that we typed inside the program. So that's about compiling and typing the first program, compiling and executing the first program. Let's move on to the topic of native code. Native code is the code that is produced when we compile a program developed using programming languages such as C and C++. Okay, so that is called object code, and object code is native to a particular operating system. Therefore, object code is called as native code. So object code is native to a particular operating system. That means if we generate object code to Windows operating system and try to execute it in Linux operating system, for example, it won't work there, because the Linux operating system does not understand the language that is understandable by Windows, and vice versa. So that is the trouble with the non-platform independent programming languages like C and C++. So that's the meaning of the native code. Now let's understand the concept of byte code. So the native code is generated something like this. We have a C program, something like this one, and we use a C compiler, and it produces a file called hello.obj, which contains the object code. Now the next thing is the byte code. Byte code, the code that is produced when we compile a Java program, is called byte code. We have just now seen, isn't it? So this code that is available in the .class file, dir, and you see here, we have a file called hello.class. So the code, the program that is available inside this one, we call it as byte code. You can see I type the command type space hello.class. The type command is not related to Java, please. It is an MS-DOS command. Okay, don't get confused. This command is used to display the contents of specific file, whatever we type here. It can be used to type the content of any file, not just the .class file. So here, when I type the command type space hello.class file, it displays the content inside the .class file, and you can see here. So this is called the .class. This is called the byte code. Okay, so you can see the slide here. Byte code is the one that is produced when we compile a Java program. And please try to understand, byte code is not understandable by any operating system. Neither Windows understands it, nor Linux understands it, or some other operating system understands it. So before execution, the byte code has to be translated into the native code that a specific operating system can understand. The native code is sometimes called as byte object code also. So as an example, we have hello.java file, something like this one, which is called the source code. And we use the Java C compiler to compile the Java program, and then it produces a .class file which contains the byte code. This byte code is not understandable by any operating system and has to be translated into a language that a particular operating system can understand. That is, in other words, this one has to be translated into native code that a particular operating system can understand. In order to translate the byte code into native code, the translation of byte code to native code is done by something called as the Java virtual machine. Now let's understand the Java features. Java provides different features such as object-oriented, platform-independent, simple, robust, and multi-threaded. Apart from this, there are so many other features as well. Object-oriented is a feature in which Java supports the object-oriented programming principles such as encapsulation, inheritance, polymorphism, and abstraction. Platform independency means the Java code runs on any operating system if we have the JRE installed. What does this mean? We have a Java program, something like hello.java. We compile it and this .class file is produced. Then we can take this .class file to any computer with any operating system and then execute in that computers with any operating system, provided we have the JRE installed inside that. Because internally JRE contains the Java virtual machine, which will take care of converting the .class file into the object code or native code. We had previously understood the details of what is JVM and JRE in the slides. So that is the meaning of the platform independency. That means we can compile the Java program in any one operating system and carry that .class file and execute it in any other operating system, in any platform. Okay, that is the meaning of the platform independency. Java is simple, provided we know any programming language, like simple to learn if we know C or C++ programming. Java is robust. It strictly checks the data type safety. For example, let me demonstrate this robustness feature. Before I explain the data types, let me demonstrate that. So let me open the notepad hello.java file. Now you see here, for example, I type some more code here. Let's say long x is equal to 10, and then let's say int y equal to 0. And then what I do is y equal to x. Please try to understand here, long is a wider data type and int is a narrow data type. I am assigning a wider data type to a narrow data type with a proper downcasting, something like this one. Usually we do downcasting, isn't it? But now I am not doing this one. Now, without doing proper casting, I'm trying to compile this program. Java compiler breaks this statement, and that is called robustness. Java is strict in checking the type checks. So for example, if I save the program, file and then save, and then I try to compile the program, Java C, and then hello.java, then what happens is it shows the compilation failure. So the same statement does not show an error in case of C and C++. So that is the difference between Java and C++, C and C++. This is one of the main advantages when you talk about work with Java, because the errors are caught in the early stages during the compilation itself. Okay, so that's how the meaning of the Java robustness. And Java is multi-threaded in that it provides the features to develop multi-threaded applications. Later, as a part of this tutorial, we'll see the detailed understanding concepts of multi-threading with code examples also. So far, we are done with the Java features, and let's move on to something called as Java keywords. So there are so many keywords. Nevertheless, we can find out the list here. So many features are there, keywords. Java has so many keywords available. And the next one is Java operators. Operators, as usual, we have arithmetic operators, relational operators, increment and decrement operators, logical operators, and so on. So these are the arithmetic operators, relational operators, increment and decrement operators, logical operators, and then assignment operators. Here we have increment and decrement operators. Now let's understand the concept of IDE. IDE stands for Integrated Development Environment, and it is a software that fastens the application development by providing various features such as auto-completion, debugging, and packaging. Auto-completion means, for example, we want to type the System.out.println statement. We need not type the entire full statement. We can use the keyboard shortcuts that will automatically generate the System.out.println statement. This is just an example, but IDE provides so many other facilities. We can easily debug the application, and we can package the application by simple mouse clicks. The most popular IDEs for Java application development available in the market are many, but the most popular ones are Eclipse, IntelliJ, and STS. Now let's go ahead and see the downloading and installing process of Eclipse software. So let's go to the browser and then search for Eclipse JEE download for Windows or something. So Eclipse is available for Java Standard Edition separately and Java Enterprise Edition separately. So if you download Eclipse for Java Standard Edition, in that one, you cannot develop the applications that require the Java Enterprise Edition features. So it is always recommended that you download Eclipse for Java Enterprise Edition, and depending upon your operating system, you can go for the relevant download options. Now I'm clicking the first option you see here, eclipse.org website. From here, I'm clicking this one. So when this page is loaded, I want to scroll down and locate for old versions of Eclipse, because if I select the latest version, chances are there that these Eclipse versions make use of latest JDK versions such as Java 16 and all. So just to prevent confusion and the feature support, I want to scroll down and I want to download this version named as Neon. When I click on this one, now it opens up a page from wherein we can download this one. So Neon, let's say one package. I click on this one, and then I select this Windows 64 option. Now it is asking us where to download the file. I want to just download it directly on desktop. Because it is a zip file, I can just click the save button. In the next few minutes, it finishes the downloading process. So it is downloading fast, nothing to make waited. So now the download is completed. You can check on the desktop. We have the download zip file here. Now we can extract this one, right click, and then let me extract onto the desktop on the same folder. So once it is extracted, we can open the folder structure and start working with Eclipse. So before start working with Eclipse, let's understand few basic concepts related to Eclipse, such as what is a project, what is a workspace, and all that stuff. Now this is extracted. You can see it here. We have it here. Now when we open this folder, we have one more folder inside that is Eclipse folder. And inside this folder, you can see one Eclipse icon is there. This is the file that we use to launch Eclipse. I double click on that and it is getting open. Please remember one point. In order to work with Eclipse, we should have JDK installed in the system. Okay, so for the first time, it takes a couple of minutes delay in order to load all the required libraries into memory. Now, while it gets loaded, let's move on and try to understand few concepts here. So that is the downloading and installing process. And we just now understood we need to have a Java installed in the system in order to work with Eclipse. Now, working with Eclipse, to understand few concepts are there. First thing is a project in Eclipse. Project is a collection of various files such as .java files, HTML files, XML files, and then JavaScript files, CSS files, and many different kinds of files. Depending upon the type of the project we work with, Eclipse provides different types of projects. For example, it provides a project type called as Java project, wherein we use that to develop the Java Standard Edition applications. And if you want to develop advanced topic related Java projects in Eclipse, we have to choose a different type of project available in Eclipse. Now you see when Eclipse is launched, it is asking us something like select a directory as workspace. So you can watch this sentence. Eclipse uses the workspace directory to store its preferences and development artifacts. Artifact means the code files that we type and generate. That's called artifact. Now by default, it is choosing the workspace folder by the from the users folder. You see users and the username followed by the workspace. So if you want, we can change this one by clicking the browse button. I'm changing it, and then I scroll up to the desktop. On the desktop, I want to create a brand new folder, and the folder name, let's say Java tutorial workspace, Java tutorial workspace folder. Now I click OK there, and now I think something incorrect, not this one. So I go to Java tutorial workspace. This one I want to select it. Now you can see C drive uses the username, that's my name, Ravi Tatikonda, desktop, and then Java tutorial workspace is selected there. And if we want, we can give a tick mark here that Eclipse will not prompt us again to select a workspace every time we open it. Now I click on this OK button, it starts loading Eclipse. Now let's come back here and then see, let it get open. So it is taking few seconds. Now this is the first time screen when Eclipse is launched for the first time. When we maximize that, you can see this is the welcome screen. And this is the point to notice that Eclipse is available for both Java Enterprise Edition and Java Java Standard Edition. But we have downloaded Eclipse for Java Enterprise Edition. That means we can use this Eclipse to develop both Java Standard Edition applications as well as Java Enterprise Edition applications, whichever is required. Now let me close this one. And before start working with this one, let's move on and try to understand. A project is a collection of various files, and Eclipse provides different types of projects as we previously understood in the previous 2 minutes. Now, let's say the project types that Eclipse offers, the most fundamental project type is something called as Java project, wherein we develop the Java Standard Edition applications. And the other types of projects are many available. A couple of them are something called as the Maven project and the Dynamic Web project. However, these are not required for the beginner level developer. Once we understand the complete Java Standard Edition, then we can learn these additional topics. So the next topic in Eclipse is something called as a workspace. A workspace is a folder in which all projects are stored. We have just now noticed the meaning of workspace, and then creating a new folder to store our projects just now. Now let's move on and see the steps of creating a new Java project, and then creating a class inside that, and then executing that program. So the first step in working with Eclipse after we launch it is to create a project. So let's go ahead and see. And please try to watch the different parts of this screen that is displayed on open Eclipse. The upper left corner, you see the currently active workspace folder name in which our projects are stored. And next to the workspace, there is something displayed called as Java EE, which means Eclipse has currently displayed the editor screen options, which are compatible with Java Enterprise Edition. We can switch to some other options available. And this display or this layout of the screen is called perspective. For example, look at the upper right corner. There is one icon, open perspective, adjacent to something called as quick access. When you click on this one, it allows us to switch to different perspective. A perspective is the layout and arrangement of Eclipse windows, different windows inside Eclipse environment. Currently, Java Enterprise Edition perspective is active. We want to switch to Java perspective. When we click OK button, please watch in the upper left corner. It will now display Java instead of Java Enterprise Edition. Because we are learning the Java Standard Edition as of now, let's make the Java as the perspective, active perspective. When I click OK, please watch. Now it is changed to Java. And not only this one, few other options are also changed internally. Let's not bother about these things. Now let's go ahead and create a new project, that is the new Java project. To create a Java project or to do anything in Eclipse, we have more than one option available. Now for now, let's create a new Java project from the file menu, file, new, and then Java project. Now when we create a new Java project, we are prompted to type the project name. Let's say I type demo hyphen project hyphen one, let's say project one. And by default, it has chosen the execution environment, the Java Standard Edition 1.8. In certain situations, we want to change the versions, we can change it here. Right now, we can click the next button here, and again, we can click the finish button here. And this is what now we are done with project creation, creating a Java project. We are done. Please try to understand a project is a collection of different kinds of files. Okay. Now, when I expand this one, we have the SRC folder. We call it as source code folder. And we also have the Java runtime environment, the Java built-in library attached to this project. These are all the built-in libraries, built-in programs in Java. Now, let's say we want to create a new class. Let's create a new class. So inside the project, right click here and then go to new option. And from there, we can select the class option. When we click the class option, we are again prompted with the class name. We will deal about the topic called packages at the respective time. Currently, do not bother about the package topic. Now, here is the class name that we have to type. Let's say I type welcome or something else. And then this is the class name. Eclipse will automatically create a class for us. And then we have something called which method stubs would you like to create. Eclipse provides us with different options available. For now, if we give a tick mark here, public static void main, the main method is automatically generated and added inside the welcome class. Now let me click the finish button. Okay. Now this is how Eclipse automatically generates a class. You can check it here. We can double click on this window, the welcome.java file name, that will maximize the screen. Now this is how. Say, for example, we have not selected a tick mark while creating the new class, and we still want to get the main method automatically generated. So let's do that now. So in the SRC, I'm creating one more class. Let's say class here, and then I'm typing the class name hello. This time I am not selecting the main method. That means main method is not added now automatically. We just have the class declaration. Again, double click, it will maximize and restore. Now here, we want to automatically add the main method. So what I do is I press the, I type the keys M and then A. And after that, we press the key combination control and then space. When we press control space, we get a few options available. Main method. You come here and you can select this one. The main method is generated something like this one. So here, this is how it looks like. And if you want to type the output system dot, you see here as I keep on typing, this is some bug in Eclipse. So as I keep on typing, it gives us suggestions that we can automatically choose from. Okay, something like this one, System.out.println, something like this one. So as a shortcut, we need not type the complete System.out.println hands-on. We can go for the shortcut available. What we need to do is we type the letters SYSO, and then we press control space, and then we press enter. It will be automatically generated for us. So that's how we can automatically generate the main method and the System.out.println command. Let's say Hello and welcome to Java tutorial, and then let's say by learn clearly. So here we learn complete Java step by step in depth with real world examples, live hands-on coding, no ready-made code uploaded into Eclipse and then explanation is done on that, nothing as such. Now this is completed. Once the program is developed, we can, in order to execute this program, so we can right click on this one and then locate an option called as run as, and from here we click this option Java application, run as Java application. And then when we click on this option, the compilation is automatically done in the background as we keep on typing. When I click on this one, it executes the program. You see, and we get the output displayed in a window called as console window. Hello and welcome to Java programming. Here, this is one. We can maximize this window if we want. We can double click and again restore this window. So this is how we need not make use of the Java C command and Java command to compile and execute. What happens is, as we keep on typing, Eclipse automatically compiles. For example, you see here, if I erase this semicolon here and then save it, Eclipse automatically compiles it, and it shows the compilation failure with the red color underline there. And if I put the mouse pointer at that place, it says the description of the problem. Syntax error, insert semicolon to complete the statement. That means as we keep on typing, Eclipse automatically compiles, and if there is any mistake, it stops compiling and it displays the errors in that particular part. So that's about creating a new project and a class in Eclipse. Please remember one point. There are multiple ways to do one particular step in one particular activity in Eclipse. It's not compulsory that we have to go for right click. We have multiple options available. We have file menu, new menu, and so on. We have the keyboard and toolbar options available. Multiple options are there. To run the project, we can go to the let's say we have the run button available. We can use the right click button and run as. Multiple options are available. Right. So let's go ahead to the next point. Let me close this Eclipse folder, and let me close this browser window as well. Now come back to this tutorial. Now let's move on and try to understand data types in Java. There are 8 primitive data types in Java, which are byte, short, int, long, and then float, double, char, and boolean. The first 4 are used to store the numbers such as 10, 15, 13, 14. Okay, and the float and double are used to store the numbers such as 15.6, 35.6, something like that. And the character data type is used to store a single alphabet or a single character, such as an alphabet or a single digit or a special symbol such as $sign or an underscore, something like that. And the Boolean data type is specific to Java, which is not available in C language. This is used to store the values like true and false, whichever. And the Boolean data type supports only 2 possible values, that is true or otherwise false. And they are spelled in lowercase, complete lowercase without double quotes. Now, each data type variable in any programming language occupies a certain predefined number of memory cells in the computer's memory. So here, when it comes to Java, the variables of the specific data types occupied are mentioned here. The variables of byte data type occupy 1 byte, and the variables of short data type occupy 2 bytes, and so on. And people who are from C and C++ or any other programming language, please be noticed that the character data type in Java, it occupies 2 bytes. In case of C language, it occupies only 1 byte. Okay, and also in C language, the int data type occupies 2 bytes, and in C language, this is we have something called as unsigned data types, which are not available in Java. These are the 8 primitive data types in Java. And when it comes to Boolean data type variables, the number of bytes that it occupies is vendor specific. The meaning of the word vendor specific is it depends on the JDK product that we have downloaded from the specific company or a website. For example, we have the JDK downloaded in our case from oracle.com, and JDK is also available for download from other companies' websites as well. So depending upon which company's website we have downloaded the JDK, the number of memory bytes occupied by the Boolean data type is specific to that particular JDK downloaded product. So that's the meaning of the word vendor specific. Now let's move on and see the control statements. Control statements are nothing but if statements and loops, as in any programming language. If you are beginner to programming languages, you are required to watch this video from the first minute, wherein I have explained the programming fundamentals using C language, which includes all the required necessary topics that you can understand Java clearly. So the control statements, I'm not teaching the control statements here. I'm directly explaining a few examples here. So first of all, let's understand these examples in Java. Largest of two numbers example using Java programming. However, you may already know these things in C language. Now we are learning with Java. So here I'm creating a new class. In the new class, let's say I'm big number dot c, big number, not dot c, I'm sorry, big number. It is a Java file. When I click the finish button, it gets us the new class generated. And I put the cursor inside the mouse inside the curly brackets. You please watch, wherever we click, the cursor is activated there. So what I'm doing is I'm clicking the cursor mouse there and I get the cursor activated there. Now I am generating the main method automatically. Main method MA and then control space and then MAI and then the main method and then press enter. Now I want to take two numbers, integer I equal to 10, comma j equal to 20, and then I want to check if I greater than j. Then what I want to do is SYSO, then control space. I want to say I then plus sign is big number. I is big number, something like this one. So this is kind of a concatenation symbol in Java. So first of all, the value of the variable I is printed in the output. For example, in our example, it is 10. 10 and then the 10 is attached to this output text. 10, altogether the output is 10 is big number, just in case if this if condition becomes true. And then we want to go for an else part, and then you watch here SYSO and then control space and you press enter, we get this one J and then plus space is big number. Something like this. We develop the programs in Eclipse. We first create a project and followed by that we create new class and then we continue doing the programs. Now, if there are any compilation failures, we get the red lines then and there itself. For example, this here we got the red line. I put the semicolon there. For example, I delete the double quotation symbol. We got the red line there. So we no need to compile manually by using the Java C command, or we no need to execute the program manually by using the Java command. Now, once the program is ready, we can right click here and then go to run as option and then Java application. We got 20 is big number, something like this one. So that's how the first program is completed. Temperature example, you can let me go and create a new class here, right click and then new class here. Now I say temperature, the class name is temperature. And then let's say this is about only for demonstrating programs using Java. If you already know, you can skip this section. Now, the main method, something like this one. I want to select the main method here. In the main method, what I want to do is I want to take the temperature as a double variable, double, and then let's say temperature is equal to, let's say, some 33 or something, and then 33.00, something like this one. Now, if temperature is greater than 30, I want to print it's very hot, something like that. It's very hot or something like that. And then let's say else I want to print it's moderate. It's moderate. Okay, something like this one. This is a temperature example. Right click and then run as Java application. Of course, we are in the beginning stage of Java programming where we are learning the control statements. Once we finish the basics topics, we can switch to classes and object, wherein we learn real world programs. Okay, this is only to learn the syntax and semantics of the language. Okay, next we'll talk about the day of the week example. Let's say I want to create one more class, new class, and in here I want to say day of week, something like this one. Here I say the main method. Okay, and then the main method, I say the main method and then I want to take day, integer day is equal to, let's say, some 5. I can go for the switch statement or an else if ladder depending upon my requirement. So switch day, I'm taking this one here, case 1, and then let's say case 1 and case 2 and so on. Case 2, okay, case 3, and then case 4, and then case 5. Let's say I want to print it's a working day. It's a working day. And then I want to break this switch statement. And just in case, I want to copy this, okay, and then paste it here. And I want to go for 6 and 7. Let's say it's a weekend, something like this one. Weekend. I once again remind you people, this is the fundamental topic. However, to the beginners, it is required. If you're already familiar with the programming fundamental topics using Java, you can skip to the advanced topics such as class, object, inheritance, polymorphism, and all that stuff. Okay, so now let's say default, some system.out.println invalid day, something like this one. Now we can save this one, Control S, and then right click and then run as Java application. We get the day, it's a working day. So that's about day of the week. It can be done using switch statement or else if ladder, whatever. So ternary operator, largest of two numbers. I believe all of you know the ternary operator. Now let me do that. So let's say new class here. In the new class, ternary large number, for example, and I generate the main method here. And here, when I generate the main method, I say I want to take int I equal to 10, and then comma j equal to 20, and then I want to take int k is equal to, if I greater than j, then k equal to I, else k equal to j, something like this one. And then I want to print k as the output. So k is the output. Now let me run this code. Let's say this is how it works. We get this one. We shuffle this to 30, for example, and then we should now get the output as 30. Right, so that's the ternary operator. That's about the if statement hands-on example. Now let's move on to the as I'm telling one more time, if you're familiar with this programming fundamentals using Java, you can skip to the advanced part wherever you want, classes, object, encapsulation, exception handling, because this is a complete tutorial right from the programming fundamentals to the advanced topics such as collections in Java. So you are free to switch to whichever topic you want. And let me move to the next one, loops, hands-on code examples. First of all, let's develop this program. Print the first 10 numbers example. So for the sake of practice and revision, this time I'm creating one more project, demo-project2. I'm going to the file menu, new, and then Java project, and I'm giving the project name as demo-project-2. And inside this project, the execution environment is the default one, that is Java Standard Edition 1.8. I'm clicking the next button, and again I'm clicking the finish button there. Now the project is created. We want to create a new class there. In the source menu, right click and then go to the new class option. And from here I want to let's say 10, what is the program name? 10 numbers. Okay, we want to print the first 10 numbers, and this is the class name. And here I want to generate the main method, and that is the main method is generated here. Now inside here I want to go for a variable declaration such as int I equal to 1, and then while I less than or equivalent to 10, I want to print this one, and then print I. Then I want to give one space, and then in the next statement I want to go for I++. Okay, that's how it works. Space is not required. Okay, we instead of printing use print ln, we make use of the print command. The difference between print ln and print command is that the print command continues its output with the already available output on the screen on the same line instead of printing the output on a different line. So this is how the printing the 10 numbers. Okay, so these are all simple programs. I'm reminding you people, you can skip to the advanced parts if you want. Okay, this is and then we go for the Fibonacci series. Let me go to the one more class, right click here and then go to the new class here. I say Fibonacci numbers. This is Fibonacci is okay, that is okay. Now I'm creating a new main method there. I'm creating a new main method there. So I want to take the initial values int a equal to 1 comma b equal to 1 comma c equal to 0 initially, and then let's say I equal to 2, or let's say I begin with 3. And then what I want to do is c equal to a plus b. I'm not explaining the Fibonacci series, the flow here. If you want the explanation of this logic, you can watch my programming fundamentals portion of this video, which is in the beginning part of this video tutorial. Okay, this tutorial starts from the programming fundamentals, where I explained the complete fundamentals related to programming, like what is a program, compilation, and all that stuff. If you want the explanation of how this logic works, you can watch that particular part in the programming fundamentals video. Now, c is equal to a plus b, and then what I want to do is initially I want to print something called, let's say I want to print a, and then give a space, and then I want to give a space and then print b. I printed a and b, and then I also printed c there. Okay, if you remember, the plus sign that we use inside the System.out.println is for concatenation purpose, right? So here System.out. This prints 1 plus 1 and 1, and then 2, this is printed here. And once the 2 is printed, what I want to do is, while I less than or equivalent to 2, equivalent to 10, what I do is we print, let's say, we shuffle the values something like a equal to b, and then b equal to c, and then c is equal to again a plus b, something like this one. So instead of printing c here, there is small correction. So I don't print c here, I'll up to here, and then here I print System.out.print, and then I print c here. Before c I print one space. Okay, one space is printed, and that's how it works. Now let's go ahead and increment the variable I plus plus, something like this one. Now let me run this program. It should print 1 1 2 3 5, something like that. So this is the Fibonacci series. Let's move on to the next example, factorial program. Let's do that using I'm doing all the programs using while loop. It is up to you. You can do it in any other loop like for loop and something else. However, even if you're already familiar with these programming fundamentals using other programming language, I recommend you people to definitely develop all these programs hands-on and practice the programs, so that you get experience in programming with Java, like creating a class and other stuff. So what is the current program we are talking about? Factorial. So I say factorial program, and this is a class which is there. Now here I want to create a main method, and then in the main method, what I want to do is I want to take int x is equal to 5, and then I want to take int sum is equal to 0, or otherwise I say int fact is equal to initially 1. And then what I do is for int I equal to 1, I less than or equivalent to x, instead of taking it as x, I'm taking it as number. Okay, this is number, and then I select I plus plus, and then what I do is fact star is equal to I. Fact star is equal to I, and that's all. After this one, we can print the factorial. So factorial is equal to, and then plus I say fact, and that's all, right? So let's go ahead and see the factorial of 5. It should print 120. That's how we can use the simple programs in Java. Please do not take it light. Okay, practice is very much important. As I'm telling you many times, if you're already familiar with these programming fundamental programs such as factorial, Fibonacci series, you can jump to the required parts such as class, object, encapsulation, inheritance, and whatever topic you want, because this is a complete Java course right from the programming fundamentals up to the collections, which is an advanced topic in the Java Standard Edition. Now let's move on and try to see the next example displayed on screen, prime number example. So let's go ahead and create a new class. Okay, now I'm creating a new class here, new class, and in here I'm typing the class name as prime, and then I want to generate the main method again, MA, and then MAI, and then the main method here. I want to take the number that I want to check whether it is prime or not, something like this one, and then temp is equal to, this time I want to take a Boolean data type. Let's say the variable I equals to 2. And then in case of C language, we usually take the temporary variable as an integer, wherein we store 0 as false and 1 as true. Now I'm taking Boolean as temp here. Temp is equal to, let's say by default, it takes a false value, or in some of the circumstances, I'm taking true here. Now what we do is while I less than number, and then we want to check that, for example, if number mod I double equal to 0, or if number mod double equal to 0, let me take this Boolean as false, for example. If number mod temp is equal to true, and then we want to exit the loop, and after this one, I am taking I incremented here. Now after this one, if temp double equal to true, temp double equal to true, then there is a factor. Then I want to say that number and then space is not a prime number. A number is not a prime number. Else part, what I want to do is System.out.println here number, then plus sign is a prime number. Say this is a little fast explanation, I think, but you can slow down the speed in YouTube as you have controls there. So because few people don't like slow teaching, and then that's the reason I'm going a little fast. 25 is not a prime number. Let me run this one, let's say 13, and then save here, and then right click and then run as Java application. This is 13 is a prime number, and that's it. That's the prime number example. Let's go ahead and see the pyramid of stars example. Okay, I'm creating one more new class here, new class, and then let's say pyramid, and then inside this program, I want to generate a main method. Okay, the main method. So I want to print for int I equal to 0, I less than, okay, I less than, let's say 5 lines, I plus plus. Okay, in Java and C++, inside the for loop, we can declare a variable. If you are new to this syntax, don't get confused, which is not possible in C language. Okay, we can declare variables inside the for loop itself, and the variable's life is up to the life of the for loop. Okay, after the for loop is completed, that variable is deleted from memory. It dies from the memory. It's no more accessible after the loop in which it is declared. So this is the outer loop. That means this indicates we want 5 lines of output. And then what we do is for int j is equal to, let's say 0, and then j less than or equivalent to I times. So for example, if I current value of I is 0, then we well, let me take it as 1 and less than or equivalent to 5. And here also I'll take it as 1 and less than or equal to then j plus plus. So this is how, and then what I do is I want to print System.out.println, and then I want to print one star symbol there. Okay, and then that's it. So this star is continuously printed the number of times the j loop iterates. The how many times the j loop iterates depends upon the current value of I. For example, if the current value of I is 1, then this only one star is printed. After that, this loop terminates. Okay, every time j is reinitialized to 1, and then after the inner for loop, we have to make one print command here, empty print command. This prints the slash n here. Please watch carefully here. I have used just print command, and here I have used a println. Now let me run this code example and demonstrate the output, how it looks like. So this is how it looks like. However, if you need further more detailed explanation of how this program works, you can mention in the comments box. We can understand that explanation. Okay, so that's about the programming fundamental examples such as if statements and hands-on examples called if statement and loops. Okay, now let's understand the next topic. Now let's understand the structure of a Java program. A Java program contains one or more classes where each class is a collection of variables and methods. However, a more advanced usage of a class contains constants, nested classes, and interfaces. This is not for the beginner level usage. A class is called as a user-defined data type. What it means is that when we declare a class, we are defining a new data type, and a class acts as a blueprint for creating objects. We shall understand the details of what is an object, how to create an object, etc. in the next few minutes. Now let's go ahead and see the concept of a class, about its syntax and example. A class is declared using the class keyword followed by the class name, and all the members of the class go inside the opening and closing curly brackets, such as variables, methods, etc. These are the variable declarations go here, and the method declarations go here. As an example, you can see the calculator class declared here. This is the class name, and it has two variables. It has two methods. Now let's see the concept of something called as naming conventions used for declaring classes, variables, and methods. Classes and interfaces are typed in Pascal case. The meaning of Pascal case is the first letter in each word is typed in capital letters. It is not at all a rule, please. It is just a convention. Meaning of convention is a best practice. As an example, you can see few details mentioned here, few class names and interface names. In case of employee details, E and D are the first letters are typed capital letters, and it is the same across all other examples. The concept of interfaces is totally different. We will learn interfaces in the right time. For now, please ignore the word interfaces. Now let's see the naming convention used for variables and methods. I repeat once again, method means function in Java. Right? Variables and methods are typed in camel case. In the meaning of camel case is the first word is typed in lowercase, and the second word onwards, the remaining words, for each word, the first letter is typed in capital case, that is the Pascal case. As an example, you can see the variable names and method names displayed on screen. In the first case, employee number, EMP is typed in lowercase, N is typed in capital case. And EMP first name, the first word is typed in complete lowercase, and the second and the second and the third words, the first letter is typed in Pascal case, something like that. Similarly, you can see the method names print account details, print customer details, find average salary. In all the cases, the first word is typed in complete lowercase. Second word onwards, they are typed in Pascal case. Once again, to say this is just a convention, it is a best practice. It is not at all a rule. However, it is recommended that you follow the conventions. Now let's go ahead and see the class declaration hands-on code examples. And before starting the hands-on code examples for these ones, please be noted that we are currently not seeing the output of this one. We are just declaring the class, because these examples will be continued with the next topic. And then after completing the next topic, we'll see the output. So let's go ahead and start creating the classes. So let me go to Eclipse and create a new Java project. Let's say the project name is demo-project number 3, and then I click the finish button. Now inside this project, I want to create a new class. Let's say the class name is calculator. And inside the calculator class, let me declare a couple of variables, such as integer a equal to 10, then integer b equal to 20. Depending upon the requirement, we can declare the variables or we can omit them. It is not a rule to declare them compulsory. So public void sum, and please try to forget the word public for some time until the time we reach the topic. And inside the method sum, I am declaring I'm printing the output. Sum is equal to, and then here I'm using the plus sign, and then a plus b, something like this one. And then I want to copy and paste this method and rename it to subtract. Let's say this is subtract, and then let's say a minus b, something difference or whatever you want to type. Let's say this is a minus b. As I told you just now, we are not going to see the output of this program right now, because this is a carry forwarded example where we will add something more to this topic in when we talk about objects creation and calling the variables and methods of an object. So let this class declarations be like this until the time we finish the objects. Now let's go ahead and see the next class declaration, circle class. I'm closing this one and then creating a new class, right click, and then creating a new class. And the class name I'm talking about is circle. This time I'm not making use of any variable declarations because I don't want them. I'm just making use of the methods declaration, public void area. And this area method takes one input parameter, which is of double data type. Let's say it is radius. And here I want to print the area inside the println command. Area is equal to, and then put a plus sign and parenthesis. And inside this parenthesis, I want to type the calculation of the area of the circle. So to calculate the area of the circle, what we use is pi r square, 3.14, which is pi value, and then radius, and then multiplied by radius. I repeat once again, we are not getting the output in this part. In the next few minutes after completing the topic of objects, we'll see the output of these class declarations and methods. So instead of typing this 3.14 manually, we can make use of some built-in class called as math.py. However, because I did not teach this particular topic right now, I'm not making use of that math.py variable here. I'm directly making use of 3.14 manually. Now I copy this and method and paste it, and then let me go to this circumference. Let's say this one as circumference. And then here also I'm getting radius. So here I'm typing the circumference, and then I say 2 multiplied by 3.14 multiplied by this one. And that's all we are done with the circle class declaration. It just has two methods. There are no variables required in this case. That's the reason we did not declare the variables. Now let's go ahead and see the next class declaration example, discounted price class. Let's go ahead and let me close this one. I create one more class, new class here. And here I type the discounted price, the class name. You can type any name of your choice then. Now this class contains one single method, public void calculate and print discounted price. Calculate and print discounted price. Okay, and then this one takes double actual price and then double discount percent. Are you all able to notice that I'm following the naming conventions such as Pascal case and camel case for declaring variables and methods? I think you are following. Okay, so this is how the method is declared. Now inside this method, we want to calculate the logic to calculate the discounted price. Let's say discount is equal to double discount is equal to, what do you say, actual price, and then multiplied by discount percent by 100. So then we get the discount stored into this variable, and then after that discount double discount price after discount. Okay, price after discount is equal to actual price minus discount, whatever is calculated in the previous step. And then we type here System.out.println actual price is equal to, then a plus sign, then the actual price. See, when you are working with Eclipse, you need not type the complete spelling. You type the first few characters such as ACT, and then press the Control space keyboard combination that will give you the suggestions. And from there, you can select and press Enter key there. Actual price is printed. And similarly, we want to print the discount applied is equal to something like this one. I say discount is this one, and discount applied is equal to this one. And then we want to get a price after discount. Price after discount is equal to, and then a plus sign, and then here we give price after discount. So this is about the discounted price calculator example. Now let's see the net salary calculator class example declaration. So we come here, create a new class, and let's say the class name is net salary calculator. And then inside this one, we'll take few variables. It is not a rule to take variables or to omit variables. It's just depends upon the situation and requirement. Now let's say I want to declare a few variables here. Double gross salary is equal to, let's say, some 10,000, and then double income tax is equal to, let's say, some 500, and then double insurance is equal to, let's say, some 300, and then double PF is equal to, let's say, some 200. Okay, 200.00 everywhere. Let me give a double value, and then here double value, and then semicolon. Now this is done. Let's take a method here, public void calculate net salary, and this method does not take any parameter, just for the sake of demonstrating different ways of doing programming. Now calculate, spelling mistake, calculate net salary. Calculate net salary. Now let's say double net salary is equal to, let's say, gross salary minus deductions, or income tax plus, let's say, insurance plus PF. That's all about this one. So we better take this one into deductions variable. Double deductions is equal to this one, we take and put it here. That makes more readable. So gross salary minus deductions, and that's all. Now let's print the details here. What is that? Gross salary is equal to and then put a plus sign for concatenation. And here, let's say this is the gross salary, and let's say the second one is print command once again, and here deductions is equal to plus sign, and then deductions. And what is the next one? The net salary. Just a plain calculation, not strict rules about the salary calculations. Net salary is equal to net salary. And this is how we develop the program class declaration for calculating net salary. And that is completed. Let's move on and see the next example, the bank account class. So let me close this class and then create one more class, new class, and the class name, let's say, bank account. Now inside this class, let me declare account number. Let's say integer account number, and let's say double account balance. Let's say account balance is equal to, let's say, some 10,000.0, and then account number is equal to some 1, 2, 3, 4. And now we'll add a couple of methods here, public void withdraw, and here let's say integer, let's say double, what's say amount to be withdrawn, let's say amount. And then here what we do is let's say account balance is equal to account balance minus amount, something like this one. And then let's go for deposit, and then double amount to be deposited. And then we say account balance is equal to account balance plus amount that is added from the method parameter that is coming from here. So this is how it works. Just in case this method, we need to add extra condition. If the amount that is to be withdrawn is greater than this one, then we can do that. If what we can do is, if amount that is being withdrawn is greater than the account balance, then what we can do is we can just say System.out.println insufficient balance, insufficient account balance, okay, cannot withdraw. Okay, then we just return from here, the control will go back. That's all. So just in case we provide some 15,000 that is more than this 10,000, this condition gets true, and then this is printed and the control is returned back to the calling program. and this will not be deducted. Just in case this is fail, only then the amount will be deducted. That's about this one. And we also want to give some method like public void show account balance. Show account balance is equal to something like this one. Here we want to print the account balance for account number, account balance for account number. Let's say we give the details like this one. Let's say System.out.println account number is equal to plus account number variable that is declared at the beginning of the class variable declarations. And then what we do is system dot and then account, we can type the full name. For example, account balance is equal to plus account balance. And to improve it more, what we can do is let's say we withdraw successful for the amount of plus amount that has been withdrawn. Similarly, we can say this statement copied and pasted to the deposit, this one. Let's say deposit successful or something, deposit successful or something. That's all. We can keep on adding. See, this is all depending upon the requirement. We can keep on adding as much code as we want. This is about the bank account class, which has the deposit method, show account balance method, and other stuff, right? So something like this one. That's about the class declaration hands-on code examples. We'll continue with the next topic. Now let's understand the concept of objects in Java. An object is an instance of a class. In more simple words, an object is a variable whose data type is the name of a class. In order to work with objects, we need to perform two steps. Step number 1 is declare an object reference, and step number 2 is create the object. The syntax and example for declaring an object reference is something like this one. We have the class name and object reference. And the example looks something like this one. Calculator is the name of the class. C1 is the object reference. When object declaration statement, that is, when this statement is executed, space is not allocated to the members of the object C1, which are declared in the calculator class. That means when this statement is executed, C1 is null. Object heap means the memory location in Java in which objects are stored. And the syntax and example for step number 2, that is creating an object, is something like this one. Object reference is equal to new operator followed by the class name to which the object reference belongs and the parenthesis. This class name followed by the parenthesis is called as constructor. The topic related to constructors is different from the current topic. So we'll understand the concept of the constructors in the relevant time. As an example, C1 is the object reference and new C1 is equal to new calculator, that is the constructor declared here. When the statement containing the new operator is executed, that is, when object creation statement is executed, space is allocated to the members of the object C1, which are declared in the calculator class. In other words, when this entire statement is executed, it can be understood something like this one. The space is allocated to the variables A and B as well as to the methods sum and subtract. Strictly speaking, the methods are located in a space called as method area in Java memory model. However, this is for the sake of simple understanding to demonstrate when the object creation statement is executed, memory is allocated, space is allocated to the variables as well as methods that belong to an object which are declared in the specific class. Now let's go ahead and see the syntax of how do we make use of the members that belong to an object. The syntax is object reference dot variable name is equal to value, or otherwise object reference dot method, and if there are any arguments that we need to pass. Example, C1 dot A equal to 10, C1 dot B equal to 20, where A and B are the variables that are declared in the class to which the object C1 belongs. Similarly, we are making a call to the sum method and subtract method on the object C1. So this is the Now let's see the hands-on code examples for working with objects such as declaring object reference, creating objects, as well as accessing the members of objects. So this is the list of examples that we will continue with, for which all these classes were earlier declared. Now let's go ahead to the project. Now open this class project and expand the src folder. And inside the default package, we will see the code. Now, the concept of packages is different. We will understand it separately. We are still in the beginning of classes and objects. We'll understand concepts in the right time, package concepts in the right time. Now, let me create a new class for circle objects. Okay, I'm creating a new class. Now, inside this one, I'm mentioning class name as, let's say, calculator object demonstration. Now inside this class, I want the main method. So how do we generate the main method? We type the keyboard shortcut and then control space. Now what is the first one? Syntax, if you remember, class name followed by object reference name and then semicolon. This is the syntax. Example, calculator and then C1. Okay, this is step number 1. The step number 2 is equal to is this one. New, let me type the syntax if you want a revision kind of thing. Object reference is equal to new keyword followed by the class name and then this constructor. So example, C1 is equal to new calculator, control space. You can type the control space and that will automatically generate. So this is how we have declared object reference and created objects. Now what we do is we access the members of the object. So here there is a shortcut. That means we can declare these two lines in one single statement. Watch here. The syntax is something like this one. Class name object reference name is equal to new and then class name and then the constructor, something like this one. So the example to the above declared statement is something like this one. Calculator C1 equal to new calculator. So declaring an object and creating an object in one single step. Okay, so this is how we do that. Now, after the object is created, space is allocated to the variables of the object C1, which are declared inside the calculator class. What are the members that are declared in the calculator class? You see here, we have the calculator class. There are two members, so two variables and two methods. Please remember, not every variable and method that is declared inside a class is allocated. Only for non-static variables, non-static methods, the memory is allocated that belong to an object. We will clearly understand something called as static versus non-static in the next few minutes. For now, please try to understand the members that belong to an object are only non-static members that are declared inside a class. Now, once the object is created, we want to get the variables and methods of that object. For example, C1 dot A equal to, let's say 10, I want to say, and then C1 dot B equal to 20. And then I want to make a call to the methods on C1. This is object reference name, that is of C1 dot sum and then C1 dot subtract. So if you remember the syntax is object name dot and the variable name or the method name that the object has. Okay, so in our example case, object C1 has two variables and two methods. Okay, now when we right click and then execute this program, so before executing you have to save the program. I'm continuously saving the changes every time I'm typing the program. So I'm right clicking on this program and then go to the run as option and then run as Java application. Then we get the output. So sum equals to 30 and subtract is equal to -10, right? So that is done. Let's go ahead and see the next example of the object that is circle class. Now let me go here and create one more class, new class, followed by the class name circle object demo. You can give any name to your classes. Okay, now the main method, and when the main method is generated, so main method, and inside the main method, what is the syntax? Circle C1 is equal to new circle, and then I remember there are no variables that I declared inside the circle class. It just has a couple of methods directly, area method as well as the circumference method. So directly call the methods on the object C1. C1 dot, what is the method name? Area, and let's give the input radius as 2.4 or something. And similarly, let's execute the circumference method on the object C1, that is this one, let's say some 3.2 or something, and that's all, right? So let me save this and execute the program. We got the output, area is equal to something, and that's how it works. So this code, this particular statement will go and execute this line of code that is declared inside the circle class, and similarly, this line of statement that is declared inside the circle class. So I hope you are able to understand. Just in case if you feel this one little fast, you can, as usual, you can reduce the speed of playing in. Okay. Now let's go ahead and see the next example of creating and working with objects, discounted price class. Now let me create a class, new class, right click there and then new class. Now in the new class, let me say discounted price object demo. As I told you, you can give any meaningful class name. It is not compulsory that you have to give the same class names. Now let me click the finish button, and as usual, I want to get the main method here. Okay, the main method is now generated. Now I want to create the discounted price class object. Discounted price, I think discounted price is not there. Do you have it or not? Okay, there is a small correction, it seems, in the class name while I created this one. So right click on the class name here and then go to what do you say, refactor. Okay, and then rename, and here you can correct it, discounted price, and then press enter. It will make changes wherever applicable. Now we can make use of that one. So discounted price, dp1 equal to new discounted price. Control space, please, everywhere, wherever applicable. You can just keep pressing the keyboard combination, control space, and then that will automatically fill the auto completion. Now dp1 dot calculate discounted price. Let's say actual price, let's say some 100, or let's say some 250 or something. Actual price is 250, and let's say some 5% is the discount. Now let's save this program and execute this one. Now let me right click this one, run as Java application. Actual price is 250, and discount applied is 12.5, that is 5% of 250, and price after discount is something like this one. Okay, you can drag this window here, you can watch it here, right? So something like this one. Let's create one more object. You see here, discount price, dp1 equal to new discounted price. This is the second object that we are creating now. And then dp2 dot dp, it's not dp1 here, sorry for that, dp2 dot calculate discounted price, let's say some 300, and let's say the discount percentage, let's give it to 4 or something, and then let's save this one. Right click here and then go to run as Java application. We got the two prices. This is the second one, this is the first one. So this is how we create objects and access the members of the object. Now let's go ahead and see the net salary calculator class. Now let's see, let me create one more class to demonstrate the object creation. Right click here and then go to new option and then select the class option. Now here I want to create the class name as net salary calculator object demo. I think you are able to understand the naming standards. Class names are typed in Pascal case. Okay, now this is the class name, and then what I want to do is generate the main method, and inside the main method I want to create the class netsal nets control space. Okay, and then ns1 is equal to new net salary calculator, and then what we want to do is ns1 dot let's say we want to, we have already declared the values to the gross salary, income tax, and all that stuff. However, okay, let me just directly calculate the net salary. Now let's say right click here and then go to the Java application. So now we get gross salary as 10,000, deductions as 1,000, net salary as 9,000. However, if you want to change the values of the gross salary and other deductions, we can do that. Okay, now this is actually done using something called as getters and setters. We'll understand that particular getters and setters in a special topic called as encapsulation. Until then, we'll use it directly here. ns1 dot gross salary is equal to some 15,000, and then ns1 net salary 1 dot, let's say, not let's take a fresh object instead of working on existing object. Net salary calculator ns2 equals to new net salary calculator, and then ns2 dot gross salary is equal to, let's say, some 15,000, ns2 dot income tax, let's say some 900, and then ns2 dot insurance is equal to, let's say, some 600, and then ns2 dot pf is equal to, let's say, some 300, right? And after that, let's calculate the net salary using this ns2 dot net salary. I hope you are able to understand. If there is anything not clear, you can please mention in the comment box. I will reply to your comment. Now right click here and then run as, we get the net salary. So this is for the first one. Let's give one break command here. So let's say after this one, so I give one break command here, System.out.println. Now let me run here the program again, and that's all. You see here, where is that calculation? This is printed at the bottom. So 1 second, it has to go here, right? Control S. Now let me run this program. You see we got this one, this is ns1 and this is ns2. Now let's go ahead and see the next example, bank account class. So let me close this one. Okay, now create a new class, right click here, new class, and the class name, let's say bank account object demo, bank account object demo, right? So let me create the main method first, main method, and then here I want to create the bank account object. You see here BA and then control space and then press enter. Bank account B1 equal to new bank account, and then I want to make a call to B1 dot, let's say currently I want to show the existing balance. You watch here, you want to show the existing balance. So what I do is let's say System.out.println, now printing default account balance or something, some message, and then we are now going to perform deductions. Now depositing, and then B1 dot deposit, and the deposit amount, let's say some 1,200, and that's all. Now let's say System.out.println, what we have to do is now withdrawing, sorry, it's a text, now withdrawing, and then B1 dot withdraw, and let's say we withdraw some 2,000, and that's it. Now let's go ahead and see the output here. So the default is 10,000, account number 10,000, and after depositing 10,000, deposit successful. We did not get the after depositing, we again call this one, please. What is that? Show account balance. We should call the show account balance one more time here. After depositing, we'll call here. Let's say, sorry, not this one. Let's say B1 dot show account balance, and then I say /n, and here also after withdrawing, show account balance. So we are showing the account balance at 3 different times. The initial time when we did not perform anything like deposit or withdraw, and after depositing one time we called it, and after withdrawing we called it one more time. Now let me run this code. Now run as Java application. Now you see here the initial balance is 10,000, and now depositing it is 11,200, and after from 11,200 we have withdrawn some 2000 amount, and then it became 9200 for the account. Now let's understand a next topic called as nullifying an object. Nullifying an object means declaring an object reference with something called as null. As an example, you can see C1 is equal to null. When this statement is executed, what happens is the link between the object reference C1 and its actual object that is located in memory is disconnected. To understand this concept, let's understand this image. When we create an object C1 is equal to new calculator, there is a connection established between the object reference C1, and C1 has access to this object via this pointer. So this pointer demonstrated here using the arrow pointer is removed when we say C1 is equal to null, and then this object becomes inaccessible. So this object is no more accessible, and therefore the memory occupied by this object is released by the JVM by a process called as garbage collection. Garbage collection is a process in which the Java virtual machine releases the memory of unused objects or nullified objects which are no more accessible. Thereby, it increases the memory available for the next set of objects which are created. That's about nullifying an object. Now let's move on and see something called as static and non-static members of a class. If we declare any member of a class such as a variable or a method using static keyword, then we call them as static members. Example, there can be static variables, static methods, static blocks, static nested classes, and many other types of the static members can be declared inside a class. You can see the example of this statement. Let's say we have a class called test. The class test has two members, I and the method hello. I is a variable, hello is a method. Both of them are declared using the static keyword, if you notice. So these are called as static variables and static methods. And the next topic is non-static members. If we don't use a static keyword while declaring variables, methods, then we call them as non-static members. As an example, within the same test class, you can see here, we have the variable j and the method world, which are declared without using the static prefix here. So that's the difference between the syntax of static versus non-static members of a class. Now let's go ahead and see the syntax to use the static members. Now we have these two members, right? So how do we make use of these things? Let's see. So this is a static variable and static method. This is a non-static variable and the non-static method. Now, how do we access the variable I or the method hello, which are static? That means, how do we store the value inside I, or how do we execute the method hello of the class test, which are both declared as static? So the syntax is something like this one. We make use of the class name and a dot symbol followed by the static member name. So this static member name can be a variable such as I or a method such as hello. As an example, you can see here, test.I equal to 100. This one stores 100 into the variable I, and test. Now let's see the hands-on code example for the static members of a class. Let's say we have this class test and these two members which are static, the variable I and hello. Let's go ahead and see the example. Let me create a new class here. Let's say the class name as test, or maybe I give static test. Now inside this class, what I want to do is declare a static variable such as static int I, and then static method such as static void hello, and then something, the print message hello from the static method. Okay, something like this one. Now here inside the same class, I'll probably add one main method, or more clearly we can declare, that's okay, main method. Now inside this one, what we do is, what is the syntax? If you remember, class name dot static, this one, right? So static test dot I equal to 100, and then static test dot hello, or static test dot hello, the method being executed. Now you want to print that static test dot I. So you see here, we are using the class name dot static variable name, And once again, class name dot static method name, and here also static class name dot static variable name. So whether it is a variable or a method or something else, the syntax is always class name and dot symbol followed by the variable name or method name, whatever it is. And let me execute this one. Right click and then execute this one. So this is executed and we got the output. And please note one point: if you declare any variable such as any method or variable, so any member of a class such as variable or method, such as using static keyword, what happens is there will always be only one copy of a static member inside a class, in spite of how many objects are available in loaded into memory created to that class. Okay, now let me go and explain the next topic. Syntax to use the non-static members. The syntax to use the non-static members. In our example case, the non-static members are J and world. J is a variable, world is a method. So the syntax is like object reference dot non-static member name. And example, you can see test t1 is equal to new test. First of all, we have to create an object, and then t1 dot j. T1 is the object reference. If you look at the syntax, t1 dot non-static member name is j equal to 20 and t1 dot world. Now that's about the syntax and example to use the non-static members of a class. Now let's go ahead and see the example code snippet for the non-static. Okay, and let me create a new class. Let's say new class, and let's say non-static test. So here I will declare two variables, variable and method. Integer j, void let's say world, or anything you can use, that's okay. System.out.println hello from non-static method, something like this one. Now here I generate the main method. The main method, first of all, I want to create an object. T1 is equal to new test, and then T1 dot it's T1, sorry, it's not a test, it is non-static test. Non-static test T1 equals to new non-static test, and then T1 dot j equal to, let's say, some 200, and T1 dot world, and then we want to print it system.out.println T1 dot j, something like this one. Okay, now let me execute this one. Right click and then run as Java application. This file is executed. Non-static members will be there in memory, one copy for each object. For example, if I copy and paste this these 3 lines of, let's say I copy and paste these 3 lines one more time and change the object name to T2 wherever applicable. Now I have created 2 objects. So because we have 2 objects available in memory, there are 2 copies of the variable j and 2 copies of the method world, that is non-static, that belongs to each object. If you create 10 objects, there will be 10 copies of non-static members of a variable. When it comes to static members, there will always be only one copy loaded into memory, which is a static member. Okay, whether we have 0 objects or 1 object or many objects, there will always be only one copy loaded into memory. That is the conceptual difference between non-static and static, and the syntax difference with hands-on code example has already been explained. Now let's move on and see the topic called as system.out.println. What is the detailed understanding of this system.out.println? Okay, so to understand this one, we need to understand couple of built-in classes in Java. The first one, we call it as the print stream class. The print stream is one of the many built-in classes in Java. Built-in classes means the classes that are available, that are installed when we install Java. So here the print stream is one among the many built-in classes. It has so many methods. One of the methods of the print stream class is something called as the println. Now please watch here. PrintStream class has many methods. One method is something called as println, which is a non-static method. So the syntax to use this non-static method is using an object reference, if you remember. So we have print stream out is equal to new print stream. This out out is the object reference. Okay, now what we do is using this object reference, we execute this non-static method out.println. You see the syntax object name dot non-static method name. So that is how the syntax is used. Now let's understand one more class called the system class. The system is again one more built-in class in Java. As I told you, there are so many built-in classes, and the system is another class. The system class has an object of the print stream class inside it. You see here, out is an object of the class print stream inside the class system. But if you notice here, object out is not a non-static member. It is a static member of the system class. So how do we access the static members? You know the syntax, right? Class name dot static member name. The object out is a static member. If you look here, system is the class name. Dot out is the static member name. So class name dot static member name. And altogether, if you look here, system.out is the class name dot static member name. Out.println is the object name dot non-static member name. And altogether, if you say system.out.println is equal to system.out plus out.println. And this is how system.out.println is a statement that we use to print something onto the computer's output screen. Now let's understand the reason why the main method has to be declared public. In order to understand why the main method has to be declared public, we first need to have an understanding of the concept of packages in Java. However, we will understand the packages in more detail at a later time. For now, let's understand the concept of packages at a high level. A package is a group of related classes which are placed together in one folder, and packages are created using the package keyword and package statement. Consider we have this package statement package P1. When this statement is executed, it creates a folder named as P1. And similarly, package statement P2, when this one is executed, it creates a package called as P2. And let us consider these blue colored boxes as the boundary of the packages, the folders. And let's say both the packages P1 and P2 have a few set of classes declared inside them. Now you say we have class A and class B that belong to package P1 and class C belong to package P2. If we want to make use of any class or any method of one class, one package outside that package in a different class. For example, if you watch here, the greet method of class A is used inside the test method of class C, which is in a different package. In order to use such kind of code, the so-called greet method has to be declared public. Okay, if something is declared as non-public, that is not visible outside the boundary of the specific package. So in the current situation, the greet method is public. Therefore, this public greet method can be accessed and used outside the package P1. Okay, and if you look here, we are using here a.greet. We are using the class name dot the method name because greet is a static method. And because it is public, it is visible and accessible outside the boundary of the package P1. Just in case if the public keyword is not declared to the greet method, the visibility of greet method is restricted to the boundary of the package P1. For example, let us consider the public keyword is not there for declaring the greet method, then this will not work. A.greet will not work. Okay, in this context, now let's understand any non-public member of one package are not visible outside the package. Now you see here, if main method is non-public, then it is not visible to JVM. Consider we have the hello world class, and just in case hello world class is executed in a separate package and JVM is being executed in a separate package, both are being executed in different packages. So if this main method is non-public, JVM cannot execute the main method. So therefore, it is required that the main method has to be made public, so that the public method is visible and accessible for the JVM to execute the code. If you remember, Java code is loaded and executed into memory by the Java virtual machine. And that's the reason main method has to be public. Now let's understand the reason why the main method has to be declared static. If main method is non-static, JVM cannot load it because non-static members require an object to access them. When JVM loads the class hello into memory, it cannot find any object in order to execute the main method if it is non-static, because non-static methods, non-static variables, they are executed using the object name dot method name or variable name. But if it is non-static, we require an object, but there is no object of the class hello available in memory. So therefore, in order for the JVM to execute the main method without the object of the class hello being available, we should make the main method as static. If main method is made declared as static, JVM can execute the main method even though there is no object available, by using the syntax class name dot method name. And therefore, the main method has to be declared static method. Now let's move ahead and understand the basics of Java memory model. Java memory model is a big subject. However, we are not learning all those topics here in detail. Okay, the three fundamental partitions of the Java memory model are stack, heap, and method area. Stack is a place where local variables are stored, that we will understand in the next 2 to 3 minutes. And heap is a place where instance variables are stored, and method area is a place where the method code is loaded into memory as well as the static variables are stored. We will understand the details of the types of variables in the next 2 minutes. Types of variables. There are three different categories of variables or types of variables in Java: local variables, instance variables, and class variables. Local variables are those which are declared inside the methods. They are not created unless assigned, and they are stored on the memory location stack. For example, this is a class test, and inside the method we have declared two variables. The variables, if we declare them inside the method, they are called as the local variables. Local variables are stored on the stack part of the Java memory model, right? In this case, we have two local variables which are declared inside the method sum. And one more point, local variables are not created unless assigned. What does this statement mean? This means the memory to the local variables is not allocated unless we assign a value to them. Let's go ahead and see this in action. For example, I create a new class here, new class, local var test, local variable test, and inside this one I declare the main method. And inside the main method, if you declare a variable in any method, then it is a local variable. So if you look here, this variable is called the local variable because we have declared this method inside the method, declared this variable inside the method. Now we cannot print this one. You watch here, System.out.println. We cannot print it because you see we got a red line there, compilation error. The local variable I may not have been initialized, which means the value for I does not exist in memory. So I better demonstrate this one in the command prompt in the notepad. I'm opening the command prompt and then cd // and then cd Java program folder. Now I'll create one Java program, notepad local var test dot Java, and inside this one I create a class, public class local var test, and inside this one what I do is public static void main, and then string args something like this one. And then what happens is I declare a local variable, and then System.out.println, and then I'm saving this file. Then I want to compile it. How do I compile that? Java C, let's say local var test.java, and then this won't get compiled because variable I does not exist in memory. Only the name is registered with the compiler. The meaning of this statement, if you look at here, local variables are not created unless we assign a value to them. That means memory is not allocated. That variable does not become into existence in memory if you don't put a value to that. So let me give a value, some 10, 0, something like that. Let's say 10. Now, when the value is assigned, memory is allocated, and this variable I comes into existence in memory, and this can be printed. Now, let me demonstrate that. File, save. Now, I'll compile this program, clear screen, Java C, let's say local var test.java. Now it is compiled. Now let's say local var test, I'm executing that. We got the output 10. So that is the meaning of this statement. Local variables are not created unless assigned a value. Now let's talk about the next type of the variables, instance variables. These variables are declared outside the methods without the static keyword, without using the static keyword. They are loaded in memory when an object is created. They are stored on the object heap. This is called the object heap. Any variable which is declared outside the method, as an example, you can see this is the class test, and we have these two variables declared outside the method. They are not declared inside the method. And also one more point to notice here is we did not make use of this static keyword. If you notice here, declared outside methods without static keyword, and they are loaded into memory when an object is created. As you know, when we create an object, non-static variables and non-static methods that belong to an object, and whatever variable we create, they are stored on the memory partition called as object heap. That's over. And then class variables, these are also called as static variables, the variables which are declared outside the methods, but by making use of this static keyword. This is a small difference between the static variables or class variables as well as the instance variables. Now, the static variables are loaded into memory when their .class file is loaded, and they are stored in a memory partition called as the method area. This is the place where the static variables are loaded into memory. Please don't get confused. The class variable and static variable both are interchangeably used. Now that's how it works. Now you see here class test is there. Now this time variables I and j are declared using the static keyword. The variables I, j in this particular example are called as class variables. We can also call them with a different name called as static variables. These are located in memory in something called as method area. And that's about the types of variables in Java. Let's move on see the hands-on code examples. Now let's go here. So local variable has already been seen. Now let me take you to the Eclipse. Now what I do is instance variable test. I say new class, and the new class, what I do is instance var test. Now here what I do is I declare instance variables, means the variables declared inside the class, outside the methods, integer j, without using the static keyword. Please recollect the statements that we learned just a couple of minutes ago. This is without static keyword. These are called instance variables, and these variables are loaded into memory when we create an object of this particular class. What I'm doing now is creating the main method, and inside the main method, what I'm doing is creating an object of the instance var test class. How do we create a class object? So instance var test, let's say instance var test, let's say object 1 is equal to new instance var test. Now when this statement is executed, what happens is object called as ob1 is created, and these two variables belonging to that belong to the object ob1 are loaded into memory, and these variables will get zeros into their zeros as their values. Now if you print the values, you see here System.out.println ob1.i and then System.out.println ob1.j. Okay, so these are now printed. Now let me run this code, run as Java application. So there are errors. Okay, let me fix the error in the other program, the local variable test. Let me give it as 10 something. Now the error is solved in that other project. Now let me run this one. We'll get the output as 0. That's how it works. That's about the local variable. Instance variable. Local variable, we have already seen the example. Now let me create one more class to demonstrate the static variable. So static var test, and this is how. And this is, we don't need any object creation for this one, because as I explained just now, static variables are loaded into memory when the .class file in which they are declared. When this .class file static var test is loaded into memory, these variables are loaded into memory. So we can straight away print them without creating an object. For example, watch here. What I'm doing is System.out.println. I'm not creating any object if you notice here. So let's say static where test is there, dot I, and then you remember, right? Static means a class name dot variable name or class name dot method name. So this is something like this one. Please try to understand when we execute a program, what happens is the Java virtual machine loads the compiled dot class file. If you remember, when we compile a Java program, we get a dot class file generated. And when we execute a program, what happens is the JVM loads the dot class file of whatever name it is. And the dot class file, when the dot class file is loaded, during that time, all the static variables, static methods that belong to the dot class file are loaded into memory. So that's the meaning. And these variables are stored in a memory partition location. I told you method area. Now let me execute this one. This will also give us the output 0 and 0. So that's about the local variables, instance variables, and static variables meaning. Now let's move on and see the variable naming rules. Variable names can contain alphabets, numbers, underscore, dollar sign. And they can start with alphabet, underscore, and dollar sign. They cannot start with a digit. They cannot contain special characters apart from the dollar sign and underscore. Now let's see the concept of something called as casting and conversion. It is pretty straightforward. Everyone knows this one. Casting means the process of changing the data type of a variable from a wider data type to a narrow data type. Consider these two variables here. Long X is a variable of long data type, which is greater than the int data type, and we are trying to assign X to variable Y. So this is casting and this is explicit. So we are converting, we are changing the data type of X to int before assigning it to Y, which is of int data type. So this process of converting the data type of one variable from bigger data type to lower data type, we call it as casting. Sometimes we call it as downcasting also. So casting is an explicit action, whereas something called as conversion, which is a reverse, it is an implicit automatic action. Conversion is the reverse of casting, which means changing the data type of a variable from narrow type to wider type. So from small type to big type. So let's say this is X, which belongs to int data type. Please ignore the typing mistakes where int I is typed as capital letter there. Now here, this X is being assigned to the variable Y. Once again, we have a typing mistake here. Ignore that. So X is being assigned to the variable Y, which belongs to the long data type. Here we did not make any bracket symbols and change the X data type to long because it is automatic. This is called conversion. Something which is automatic is called conversion. Something which is manual is called as casting. So that's about the casting and conversion. I believe everyone knows this one, whether you are from C, C++ background or Python background, something else. That's about casting and conversion. Now let's understand a point called Java is robust. The meaning of Java is robust is Java is very strict in typecast checks. For example, if you try to see all floating point literals are considered as double data type values by default. In order to use float variables, we have to explicitly suffix the letter F or lowercase f or uppercase f to the floating point variables. You watch here, float, once again typing mistake, sorry about that. Float X, this is of course not a typing mistake. There is a wrapper class concept, this still works. Okay, so here float X is equal to 10.12. This is a compile time error. Why? Because this 10.12 is considered as the data type. The data type of this 10.12 is considered as a double data type. So we cannot assign the value of double to a variable of float. In order to solve this problem, we have to suffix this 10.12 with a small letter f or an uppercase letter f. So this is the second one, it will work. Now let's go ahead and see this one in the command line. I'll show you that. So let me take this one here and cd slash, and then what I do is cd java -program, and then what I do is notepad, let's say float test.java, something like this one, and here I create a class, public class float test, and here what I do is I declare the main method public static void main, and then string args, and then what I want to do here is float x is equal to 10.1 10.1 to some number. Okay, it's not necessarily the same thing that we have seen on the screen. Okay, now this will not compile. You see here I'm saving this file save, and then try to compile this one, java c float test.java. It won't get compiled because as I told you just now, this is considered as the variable of a double data type. So we need to convert this 10.12 into a float data type, in two different approaches. One approach is using the lowercase or uppercase f, file, save. Then if I compile this one, it will compile Java C and then float test.java. So that's the meaning about the float test. You can use the uppercase f also, that doesn't matter. And the next item is similar to this one. All integer literals are considered as int data type values by default. Okay, int data type values by default. In this case, what happens is when you say 10 is okay, now you say byte x equal to 10 and then x equal to x into 2. This particular 2 we call it as integer literal. So this is a compile time error because 2 is considered as of int data type. What happens is x is byte and 2 is int. Byte multiplied by int, the bigger one, the answer is int. So therefore, this will result in a compilation error. And that's the reason this is a solution to this one. Let's go ahead and see this in action. What I do is notepad int test.java, and then let's say public class int test. And what I do here is the main method, public static void main, and then string args. And then what I do here is we usually put the opening curly bracket on the same line of the method or class. Now let's say I say byte x equal to 10 and then x is equal to x multiplied by 2, and this will fail. This will fail, as I told you. This will not compile. Let's go and compile it. Java C int test.java. It won't compile, as I told you. This is considered as an integer. So now let's do the casting and then it works. So what happens here is I want to cast this one to byte data type because the target variable to which we are assigning the result x is a byte data type. So that's the reason we are going for casting. We know the difference, right? Casting versus conversion. Here we are doing casting, which is an explicit action. So that's how it works. Now it should get compiled. We probably want to print it as well. Let's say System.out.println. I think a little slow or little fast it's going on, but that's okay. I think this is a basic concept. It's not a complicated one. Java C int test.java. It is compiled successfully, and then Java C int test. Now it should print the whatever computation it is about 20 is printed. So that's about casting and conversion, and that's about this particular topic. Now let's move on to the next topic. Now, let's understand the concept of arrays in Java. An array is a collection of variables or memory cells which together share a common name. As an example, we have few variables displayed on screen. The name of all these variables is collectively scores. Each variable that belongs to an array is technically called as array element, and each element has an integer associated with it called as array element index. The index starts from 0 and ends with the number of elements minus 1. For example, in the scores array, there are 5 elements and the index of the 5th element is 4. Accessing array elements. In order to store or read data from the array elements, we make use of a syntax, something called as array name followed by the square brackets, and inside the square brackets, we mention the element index. For example, if you look at the code snippet here, scores of 0, scores of 1, 2, 3, and 4. So all these statements store the data such as 10, 15, 5, 22, and 50 into the respective array elements. Arrays in Java. Arrays in Java are considered as objects. Therefore, we need to make use of the new operator to create arrays. Why? Because objects in Java are created using the new operator. In other words, the new operator is used to allocate space to the objects in Java. The syntax to declare an array is something like this one: data type followed by the name of the array and then the square brackets. Please note, these square brackets can be placed before the array name as well. It is optional up to the requirement. As an example, we have few arrays declared here. Scores is an array of integer data type. Names is an array of string data type. Of course, string is not a data type, it is a class name. Areas is an array of the double data type. And one more point to notice here is we have not mentioned the number of elements inside the square brackets that we mentioned during the array creation step using the new operator in Java. However, people from C and C++ background, we have to make a note of this point that we don't mention the size of the array, that is the number of elements of the array in this particular square bracket during the array declaration, which is the case with C and C++. Okay, so now creating arrays in Java means allocating space to the arrays in Java. And the syntax is something like this one: array name equal to new operator followed by the data type to which the array belongs and the number of elements. Watch here. We mentioned the number of elements, that is called as array size here. As an example, we have scores array, which is the array name, equal to new operator. And the data type of this scores array in the previous example is integer. And here we want to store 5 integers, and therefore we have mentioned the 5 as the size of the number of elements to the scores array. Similarly, names is the name of the string array in the previous example code snippet is equal to new operator followed by the string class name, and we want to store 3 strings. Once again, areas equal to new double of 4. All these 3 statements create the arrays such as scores, names, and areas of the respective data types or class types such as integer, string, and double. When these statements are executed, space is allocated to the individual array elements of scores, names, and areas. Declaring and creating arrays in one single statement is possible, and here is the syntax as well as the example. Data type array name square bracket is equal to new data type and then the size, which is the number of elements that we want to store in the array. Example, int scores square brackets is equal to new int of 5. Once again, string names square brackets is equal to new string of 5. Again, double areas equal to new double of 4. This way, we can declare and create the arrays in the single statement instead of declaring and creating in two separate statements. Let's go ahead and see the hands-on code examples of the topic so far understood. First of all, we finish the scores array example followed by names and followed by areas. Now let's go to Eclipse. I will create a new project. File, new Java project. Now I'm typing the project name as arrays project 1, probably arrays project 1. Now inside this arrays project 1, I want to expand this project folder. Right click here and then go to the new option to create a new class. And let me say scores array. And when the class is created, we begin with the main method. I believe you all know how to create a new project and new class in Eclipse. Eclipse is not responding. Yes. New class, let's say the main method. Now we declare the array. If you remember the syntax, what is that? Data type and then array name square brackets is equal to new data type and then size. So declaring and creating array in the single statement is what we are currently using, the syntax. As an example, we are working with the scores array. Integer scores empty square brackets is equal to new integer of, let's say, 5 elements, and that's all. So this is declaring. Now let's say we want to work with this one, and now let's say we declared all these arrays. Now let's print all these things. System.out.println scores of 0 plus space and then scores of 1 plus space and so on, scores of 2 plus space. However, we don't usually type the code in such manner. We use the loops in order to access and process the array, all array elements in one go. Okay, this is the beginning part of the example, and that's the reason I'm going for a manually accessing each and every element. I know some people are already familiar with arrays and the loops which are used to access the array elements. So this is for beginner level. If you're already comfortable with the arrays concept, you can skip this section and jump to the next topic wherever you want to learn from. So in this way, we have declared the array, we have created the array, and we have printed each and every element. By default, the values of the array elements belong to the data type of the array. For example, for byte, short, int, and long, the default value in each array element is 0. In our case, the array data type is integer. Therefore, this will be this will print 0, this will print 0, and so on. Now, let me go ahead and let's say run this example Java application. Eclipse is not responding. Yeah, we have this one printed, all these things. Now let's go ahead and see the similar code example for strings, which is a names array, which is a string data type. However, string is not a data type. It is the built-in class in Java. I'm repeating once again, we will use the loops in order to access each and every array element. As I told you just now, this is the basic fundamental example of array. In the next few minutes, we'll see how do we access each and every element using the loops such as do loop or do while loop or while loop or for loop. Okay, so now let me go ahead and create one more class called as names. I'm creating a new class here. The class name, let's say names array. Now inside the names array, I'm maximizing the screen. Then main method I'm generating here. Now inside the main method, I want to declare string names equal to new string of, let's say, 3 things I'm taking here. And then I want to, print that you see, I will get a copy of the previous program print statement. I repeat one more time, please do not get confused that why I am using the manual access of each and every array element. So I will demonstrate the array access using the loops such as for loop in the next few minutes. Okay, names of 1, 2, 3. This is in consideration to the first timers to arrays, please. Okay, that's it. We are done with this one. Now let me right click this one and then run as. We get all NULL. We'll talk about this concept later. Of course, if you remember the object creation process in the previous videos, by default, all object references, they point to null. If you have not already watched the previous video, you can please go and watch and you'll understand the meaning of the reason why this one is displayed as null. We are done with the names array. Now let's go ahead to areas array example. Now let me come back here and create a new class. Now new class, and then what I say, let's say areas array. And once again, almost the same program, just the data type is different. The main method. Now inside the main method, let's declare double areas square bracket equal to new double of, let's say we want to store 3 areas. And then I want to paste the previous one. I say areas of 0, now areas of 1, and then areas of 2, and we have printed the 3 elements as so far. Now let me run this code and we get the output 0.0 in all the 3 cases, because as I told you, they have the default values according to the data type of the array. For byte, short, int, and long, the default values are zeros, and for float and double, the default values are 0.0, and for class types, the default values are null, and for Boolean, it is something called as false, and for character data type, the default value is something called as /u followed by 4 zeros, which is nothing but this null. Now let's say we have executed this one, we got all these things. Okay, so before exiting these programs, let's add the data into these ones. Let me store the data. Now you can see here, by default, we are printing all these values. Now scores of 0 equals, so let's say some 12. I'm adding storing the data into each array element. Scores of 0, scores of 1, scores of 2, and so on. So this is scores of 1, scores of 2, scores of 3, scores of 4, and I'm taking random data, some 45, and then some 56, and then some 67, and then some 78. And after storing the data, I'm printing the values once again after storing the data. You can watch it here. I have copied and pasted the above displayed the print statement. So here we get all zeros by default, and here after these statements are executed, what happens is the data is stored into the respective elements. Now we are printing the data after they have been updated. Now let me right click and run as this one. We get the data printed like so. This is the before adding the data into the each element, and this is after storing the data into each element. Let's do the same thing for the remaining two programs. Come back here. So what I do here is names of 0 is equal to, let's say I'm giving my name, okay, and names of 1 is equal to, let's say John or someone, let's say some name I'm giving here, and then names of 2, let's say, I don't know, let's say I give learn clearly, okay, something like this one. So after adding the data, after storing the data, let me once again copy and paste this statement here. Now let me right click, and then here we get the null first time, and because we have stored the data in them, we get the latest data printed. Now let's go ahead and execute this program, and there it's working like this. Now let's go and do the same thing for areas. So what we do is areas of 0 is equal to 12.3 or something, and let me copy and paste this one couple of more times, something like this one and something like this one. Areas of 1, areas of 2, and let's say some random data 13.5, and let's say some other random data 15.6, and let me copy and paste this one. If you feel this typing in watching fast, you can please watch it in slow mode, please. Run as Java application, and we got the output before adding the data into and after adding. So that's about that. Now let's see the code snippet that loops across each and every element using the for loop. So we can start with the scores array first. So what I'm doing is I'm commenting all these print statements. I comment this one, I comment this one. And then what I want to do is I want to begin with the for loop for int I equal to 0, and then semicolon I less than 5 I plus plus. Of course, there is a length property for each and every array that is built into arrays in Java. If here we place something like what do you say, array name dot length property. We'll see this in the next few minutes, please. For now, let me give the manual size there. I equal to 0, I less than 5, and I plus plus. And then I want to print System.out.println. Please watch here. I'm not using println. What I want to do is scores of ith element, and then I want to print a space there, and that's it. Now let me run this code example. So it is how it looks like. So let me copy and paste this one to the names array as well as the other one. What is that? The areas array. So I want to comment these two print statements, and after the last one, what I want to do is I less than 3 here, and then this is names array, and then save this one, and then let me save and execute this program. We get the output. So here we are using for loop instead of visiting each and every element manually like names of 0 and so on. And once again, let me copy and paste this one to the areas array as well in the similar model. So I comment the first print command, something like this one, and then I want to paste it here. And this is the array size. Once again, it is 3, and the name of the array is area, something like this one. Now let me right click and then run as Java application, something like this one. So that's about declaring and creating arrays, storing some data into the arrays, and printing each array element manually, as well as using the for loop or something else. Now let's move on and see the next topic called as array length property. Every array in Java is provided with a built-in property called as length, which represents the number of elements or the size of the array. Okay, for example, in our scores array, we have 5 elements, then the length property gives us 5 and so on. Now let's move on and see the same length property applied to these things. For example, so before printing, what I want to do is, for example, window perspective, and then reset perspective will set the windows back to the original places. And now, first of all, we start with this scores array. So what we do is before printing the for loop, let's print the size of the array here. You watch here, System.out.println size of the array, size of scores array is equal to let's say, then give a plus sign, and then scores dot size. Sorry, not size, length. Sorry about that. So scores dot length. You see, we get this one will print the length here. Let me save and execute this program. When I execute this program, we get the what do you say, size of the array is 5, and we can, instead of using 5 here, we can use scores dot length, something like this one. Save this one and then execute this one. And similarly, let me copy and do the same thing for the remaining other two examples. I copy this statement here. I close this program and I go to the names array program. So here, so I'm printing here size of, here I say names, and here I say names dot length, and here I say names dot length in the loop as well. So this is the built-in property. Let me save and execute this one. Here we get 3 in the first output, and here it works something like this. Now, once again, let me make the required changes in the other program. So what I do here is the size of areas array, and here it is areas dot length, and here also it is instead of 3 areas dot length. So this is how it works. Once again, when we execute this program, we get the output 3 for the first statement, and the remaining statement goes as it is. So that's about the length property of arrays in Java. Let's move on and see something called as array initialization. Initialization means assigning the values to the individual array elements during the declaration itself. Instead of manually visiting each and every element, we can do something like that. So as an example, syntax you see here, data type followed by the name of the array and then the square brackets, and equal sign followed by the new operator and then the data type square brackets. After the data type and square brackets, here we don't mention the size if you look here. And in the floor brackets or curly brackets, we keep on providing the values such as 1, 2, 3, 4 on. And the number of values that we provide here becomes the size of the array. If I declare 3 values here, the array size becomes 3, something like that one. And one more point to notice here is this portion from the new operator to the square brackets is optional. We can directly use the curly brackets. Okay, now this is the example you see here. So we are declaring arrays, and at the same time we are initializing array elements with the values whatever we want with. So, and if you notice here, we have not mentioned the size such as 5 or 3 something like that one. We have taken the values directly in the floor brackets. To remind once again, as I told you, this portion that is new operator followed by the data type in the square brackets is optional when working with the array initialization syntax. Let's go ahead and apply the syntax of array initialization to the previous examples. This time we add a couple of more examples to our learning structure. Now, first of all, let's go ahead to this arrays example. I will create a fresh project, maybe arrays project 2 here, file, new, Java project, and then arrays hyphen project 2. This is the second project in array. Now, what I want to do is create the new class here, right click, and then go to the new class option. And let's say scores array 2, for example, I say scores array 2. And inside this class, I want to create the main method as usual. And after creating the main method, I want to go for the syntax. If you remember, data type followed by the name of the array, data type followed by the array name square bracket is equal to new data type, if you remember that, and square brackets, and then value 1 comma value 2, and so on. This is how we do that. Now let's do the apply this syntax that what we have learned just now to the code example of this course. Scores is equal square brackets is equal to new int of square brackets, and then let's say 10, 23, 35, whatever values we want. Okay, we can give some random values. As I told you, this is optional to put something like this one. Let's do that optional step in the next 2 examples. As a first example, I'm using that syntax of mentioning the new operator followed by the data type in the square brackets. Right now, the scores array is declared. Now, let me use the for loop for int I equals to 0, I less than scores dot length, and then I plus plus, and then let's print that scores of 0th element. Let's say what is that, scores of ith element, and then I give a space, and instead of print ln, I'm taking print here. Please watch here. If you use the print ln command, what happens is the output is pushed to the next line every time it prints. So that's all. Now let me execute this program. Right, so Java application. I'm going little fast, probably I said many times, so you can slow down the watch time, watch speed. And let me go ahead and create one more class for the names array. Okay, names array 2, and here I want to create the main method again, and the main method followed by the declaration. If you remember the syntax once again, data type array name data type array name square bracket is equal to new data type and then square bracket empty and then value 1 comma value 2 and so on, something like this one. This time I'm not using the new operator data type syntax after the equal sign. So let's do this one first. String data type array string names empty square brackets is equal to, please watch here, we are not using new operator, it's directly we are giving the curly brackets and then the values, let's say Ravi and then Reshant and then I say learn clearly, okay, whatever we want, we can give as many names. And then what I do is for int I equal to 0, I less than names dot length and then I plus plus, and then I want to print the value something like this one. So I don't want the println. Then what I do is names of ith element followed by plus sign and one space there. That's it, right? So save this file, and then I want to give as many examples as possible in the shortest possible time, and that's the reason I'm typing and explaining the programs little faster than usual. Okay, because if I keep teaching slow, what happens is the length of the video duration increases, and if the video duration increases, the number of programs will come down because there is a limit to the length of the full video. Now let me go to the next example, new class, and then let's say areas array 2, areas array 2. What is the example we want to do here? Let's go to the main method. Now inside the main method, as usual, declare the variables like let's say float or something. We'll take double. If you take float, if you remember, we have to use suffix f. Float areas is equal to, and curly brackets 10.2f. We have to use this suffix. I explained in the previous lectures. Okay, comma, and then 23.45. We can use capital letter F also, as I told you in the previous lessons, and then 56.7f, and that's it. And then what we can do is use the loop in order to do that. For int I equal to 0, I less than or equivalent to, sorry, not less than or equal to, like I less than areas dot length. If you're already familiar with arrays, you can skip this part, please. And if you're a complete beginner to programming fundamentals, you have to watch this tutorial, programming fundamental onwards. And if you already know few topics, you can just jump to the respective topic you want to learn from. However, I recommend you watch each and every point of my tutorial, because a lot of concept is explained very clearly in depth with real world hands-on examples that you will rarely find when you search for. So System.out.println areas of ith element and then space, and then that's it. Now let me run this program. Once again, we get the values printed. So that's how it works. So that is about the length property and the example, sorry, initialization and the length properties, scores array, names array, and areas array. Now let's go ahead and see a few additional examples in this particular topic, finding the maximum of the array elements and the minimum of the array elements, as well as the sum of the array elements. Maybe we can mix these two programs into one single, but I don't want to do that. Okay, I'm doing these two as separate programs. So now what I want to do is create one array program, one class called as new and then class. Now inside this class, what I want to do is the class name as max min array element. I remember I explained the naming conventions. There is a typing mistake. We right click here, go to the refactor and then rename. And here you can make the correction lowercase I and then click finish button. It will changes wherever applicable. Now let me create the main method, the main method. Now inside the main method, what we want to do is declare and initialize an integer array. Integer, let's say scores is equal to, this time I'm not using the data type and new operator here. I'm directly taking some random values, 34, 12, and then 45, and then 10, and then 56, and so on, as many as required. Now we want to take two more additional variables such as max array element. We'll initialize this one with the 0th element. First of all, scores of 0th element. And similarly, we copy and paste this one and take the another element called as min array element. We again initialize this one. Now, if you look at these two statements, max array element will get an initial value of scores of 0th element. That means 34 will be inside this element. And min array element will also get the initial value as scores of 0th element. This is also 34. And we start iterating the loop. Every time we compare the loop, we iterate the loop, we compare the current value of the max array element with the current array element, and we do that. For int I equal to 0, I less than scores dot length, and then I plus plus, and then what I do here is if scores of ith element, if scores of ith element is greater than max array element, then what we want to do is max array element is equal to current element. Okay, current element. And similarly, we copy and paste this one to the min array element. If scores I of element is less than min element, okay, min element, and then we say min array element is equal to scores of ith element. I guess you know the understanding of this logic, how this one works. Every time during the iteration, we are comparing the current element of the array. Ith element may be 0th element, first element, and so on. The current element is compared whether it is greater than the max array element, which already has some certain value. Then we are replacing the max array elements value with the current array elements value. And similarly, we are doing the same task for the min array element. After the for loop, we want to print that. Okay, what is that? Max element is equal to plus max array element, and then I copy and paste this one to the min array element. See, watch here. So sorry, every time I'm repeating, I'm typing, I'm going little fast than usual, but you may want to slow down the speed if you feel it fast. Now let me save and execute this one. Then Java application, we got 56 as the max element and 10 as the min element. Hope that makes sense. Now let's move on and create one more class for working with some of array elements. Okay, so let me close this one, right click, and then go to new, and then class, and then class. What is that? Some array, sum of the array. Let's say the class name as sum array, and then the main method. And when the main method, we'll declare this array element in sum in scores is equal to, let's say, some random values once again, and then any random value, doesn't matter anything. So what we do is we take int sum is equal to 0 initially, and then we start iterating the loop for int I equal to 0, I less than scores dot length, and then I plus plus, and then in here we say sum is equal to sum plus is equal to scores of I, sum plus is equal to scores of I, and outside the for loop we want to print sum of all array elements is equal to plus sum, something like this one. So what we are doing inside the for loop is for every iteration we are adding the current value of I to the already existing value of this sum. So I believe you already know the meaning of the assignment operators. If you're not familiar with the assignment operators, you have to watch the relevant section of the video in my programming fundamentals tutorial part. Right. So this is the assignment operator. To make it more concise, we can more less straightforward. Here also we can do the same thing. We can cut this one here, and then I put a comma here, and then I put it here, and after the for loop I can just put the semicolon, and I can delete these two lines, and this will also work, right? So let me save this one and then run as the Java application. Sorry, something wrong. Exception 5. It is less than scores dot length. Okay, the last one will give the problem here. This logic is not applicable in this particular part because it is applying the last one also. Now this one will work now. Okay. Yes, something like this. Sum of all array elements is 880. The previous problem was due to some small logical of. Now let's understand about the next topic called as array index out of bounds exception. Java is strict in checking array boundary, array index boundary. That means if we use an array index beyond the array size or the negative size, JVM throws an exception called as array index out of bounds exception. There is a special topic in Java, like many other programming languages, that is the exception handling topic, regarding which we'll understand in the respective time. For now, don't bother about the meaning of the word exception. The only point to notice here is if we use an array index beyond the array size or the negative index, JVM throws an exception. This is the problem we encountered in the previous example, that is sum of array elements. So now let's go ahead and see this array elements, array index out of bounds exception hands-on code example, right? So we'll see that before the arrays project 2. Here I say maybe I copy this scores array, copy, and then I paste it here, scores array 3. So this is scores array 3 is here. Let me say, so instead of using this for loop, let's say I have 5 elements, right? 1, 2, 3, 4, 5 elements are there. So let me try to print these index 6 element in the element with the index 6, scores of 6. This will so here the 6 is beyond the size, that is 5, size is 5, and this will compile successfully, but it will throw an exception during the execution time. The problem that occurs during the program execution time is called as array exception. In this example, the name of the exception is array index out of bounds exception. The index that we have used is 6, which is not available in the array, and it has occurred at this particular Java program at the statement number 8, line number 8. So that's about the array index out of bounds exception. Let's move on and start the next topic, array of objects. So far, we have used arrays to store numbers, strings, and floating point values. Now let's understand the concept of array of objects, which means an array contains objects of classes in spite of the numbers such as 10, 20. So that's, let's say we have a bank account class which has 2 variables and methods. Account number, customer name, account balance, and it has few methods as well, couple of methods. Now if we want to create object of this class, such as 5 objects or 10 objects, we have something called as collections available in Java. That is the last topic in this tutorial. Okay, before that we'll talk about arrays and objects in Java. Now I want to create 3 objects of the bank account class and store them in array. And the syntax looks something like this. When you see here, this is the data type, that is the class name, and the name of the array as well as the square bracket is equal to new than the data type, which is the class name, and the size of the array. So altogether, this statement creates an array. The name of the array is accounts, and the data type of this array is a class name. It's not a primitive data type name such as integer. Rather, it is a class name, right? So, and new followed by the data type, once again, it's a class name, and we have 3 array objects stored here. Now, when this statement is executed, what actually happens is we don't get 3 objects of the bank account class created in memory. It creates 3 object references of the bank account class. The references are something like accounts of 0, accounts of 1, and accounts of 2. So all these object references, they point to null, because the new operator used here is not for creating 3 objects of the bank account class, but it is used to create 3 object references of the accounts array. Don't get confused. Now what we have to do is we have to write extra code in order to create 3 objects of the bank account class that need to be stored inside this accounts array. And this is how we do. Let's say we see this example, array of objects null. This demonstration, we'll see this in hands-on example. To see this hands-on example, first of all, we have to create a bank account class. Let me go ahead and close this one. I'm creating arrays project 3, file, new Java project, arrays -project 3, and in this project I want to create a new class. I rather take the bank account class somewhere in the bank account.java. I copy this one and I copy it into the source folder of the project. This project you see here, I have copied and pasted it here. I have the bank account class, right? So something is here. Now what I want to do is I want to create a new class here, and the new class, what I want to do is this bank account array demo, bank account array demo. Now inside this program, I want to create the main method, and after declaring the main method, I want to create this kind of statement. What I do is, if you remember the syntax, bank account accounts square bracket is equal to new bank account of 3, bank account of 3, and if we use a for loop and print the accounts of 0, accounts of 1, and so on, we get null, null, null printed for each. For I equal to 0, I less than, let's say I less than accounts dot length, and then I plus plus, and then I want to print System.out.println accounts of I. Okay, I'm not using print this time, I'm using println. Now we get the output null printed, because as I told you, this new operator in this particular statement, it is not not creating 3 objects of the bank account class, rather it is creating 3 object references of the bank account class. That is, accounts of 0 is reference number 1, accounts of 1 is reference number 2, accounts of 2 is reference number 3. All these 3 references have, they point to nothing in memory. So therefore, when we execute this one, we get null printed on the screen. So that is the meaning of creating declaring what do you say, array of objects. So in order to get the real objects, we have to do the code something like this one. You can see initializing array of objects, and this is how we do that. You see here bank account, and this is the array name followed by the square brackets, and inside the curly brackets we have created 3 objects. So for creating each bank account object, we have used the syntax of the object creation. This is the element number 0, element number 1, and element number 3, the index 0, index 1, and index 3. We can do as many as things, something like this one. So you see here, when this statement is executed, unlike the previous case, now we get accounts of 0, the actual object is created, accounts of 1, the actual object is created, accounts of 2, the actual object is created. So that is the difference between working with arrays of primitive data types such as integer, float, otherwise string class type, and the objects of this specific user defined class. Let's go ahead and see the hands-on code example of this one. So instead of doing this one, what we do is, this time I don't want to do this one. I'm creating the initialization step, if you remember, right? So here what we have to do is new bank account semicolon, and then sorry, not semicolon, it's a comma, and then new bank account, and then a comma. Once again, as many as you want. For the sake of simplicity, I'm taking only 3 items here. So now when we save and execute this program, instead of getting the output null printed, what we get is something called as hashcode that we'll understand later. Hashcode is a separate detailed topic explained in some topic called as object class in Java, right? So we call this one as hashcode in Java. For now, please do not try to bother about the meaning of the hashcode. Okay, if you're watching this video, all topics, you'll get a very clear understanding each and every topic. Okay, we'll understand hashcode and its importance in some topic called as object class, wherein we discuss something called as equals method and hashcode method and their importance in Java. So that's about working with array of objects, hands-on code examples. This is already done. If you want, you can also use the customer class objects arrays. Let's do that. Why should I skip that? The same way we get it. So what I do is I create a new class here, new class, that is customer class. In the customer class, I take a couple of variables such as integer customer ID, and then string customer name. And then what I do is I declare 1 or 2 methods here. Let's say public void print customer details, or some method is there. Okay, some method just for the sake of demonstration of this previous example. Okay, customer details here, customer details here. So I recommend everyone watch each and every minute of the tutorial. It's very important. I'm explaining maximum possible concepts with in-depth hands-on code examples. Now what I do is I create a new class here. The class is customer account array, customer array demo, customer objects array demo. Now inside here I declare the main method, and this is the main method what I'm declaring. And then what is the syntax? Customer few customers square bracket is equal to, what we do here is new customer comma, and again new customer, once again as many objects as we want, as I told you, new customer. So please be patient and keep practicing the programs, not just watching the video. Okay, and if you have any queries, you can mention in the comment box. I can revert to the comment depending upon the time availability. Now for int I equal to 0, I less than a few customers dot length, and then I plus plus, and then I plus plus, and then what we want to do is print the account, that is few customers of ith element, few customers of ith element. Okay, now people who are watching this tutorial from the middle portion, you are supposed to watch wherever applicable, because I'm coming in a proper step-by-step approach. Okay, so a few examples might be related to the topic that has already been explained in the previous parts of the videos. So you can watch the relevant previous part if you're not able to understand any code example that is connected to the previous part explanation. Now that is done with the arrays project 3. Now let's move on and see the enhanced for loop concept. The concept of the enhanced for loop, it was introduced in the Java version 1.5. Okay, the enhanced for loop is the official technical name, but sometimes people call it as for each loop also. Of course, it's not a mistake to call it as enhanced for loop or for each loop. The enhanced for loop provides an alternate syntax to looping across the elements of the array or otherwise collection. And the syntax collection is a separate dedicated topic that we have at the end of this tutorial. Okay, complete tutorial. The last topic is collections. Now you see here the syntax is for keyword in the within the circular brackets of the parentheses. We mention the data type or the class name of the array, and the temporary variable name such as x, y, z, whatever variable name we want, and we use the colon sign and the array name or the collection name, something like this one you see here. In case of the scores array, the data type of the scores array is integer, and the temporary variable can be anything of your choice such as I, j, k. And what happens is this for each loop, what it does is every time it iterates the loop, I plus plus is automatically in the background. We do not have to write I is equal to 0, I less than scores dot length, I plus plus, nothing as such. So the enhanced for each loop, the enhanced for loop is a shortcut syntax to for loop, wherein we use the for loop such as I plus plus to iterate arrays and collections. So this is how it works. Now let's go ahead and see this for each loop with hands-on code examples for all these things. Now let me go to this one, and what I do is here array project 3, we have these three things. Array, I go to arrays project 2. Here I have something like this one. I create a new class, and then for each, actually it is enhanced for loop, doesn't matter. For each scores, for each scores example, what I do is I go to the main method, and the main method, inside the main method, I want to initialize the scores array. Integer scores is equal to, let's say 10, 23, 45, 56, 78, 89. Some numbers are input here. And then for int I colon scores, if you remember the syntax, let me open the slide once again for your convenience sake. You remember the syntax, right? For data type, that is the integer, and the temporary variable name such as I, j, k, and colon sign followed by the array name or collection name. As I told you, collections is a separate topic, and we have this topic dedicatedly explained at the end of the complete Java tutorial, as that is the last topic in the Java standard edition to learn. Now let me go ahead and this is the, from here each element is dumped into this one automatically, and the loop automatically advances to the next element in the array. So what I do is System.out.println, instead of println I take print there, and then scores of ith element, and then give a space, something like, it's actually not I, it's not scores of I, it is simply I. am sorry about that, the current value, it's not scores of I. That's how it works. Now save and execute this program. Okay, this is how it works. It's not scores of I. You can use any variable name, whatever value is there from scores of I will be copied into x, the temporary variable. You want to get an x also here, it works. It's just a temporary variable. You can use any variable of your choice for that, right? So that is done with the for each scores. Now let me go ahead and create one more class, new, and then class, that is for each. I repeat once again, it is actually enhanced for loop. For convenience, many people call it as for each. For each names, and then what I do is I define the main method inside this class. Okay, the main method, and inside the main method, string names is equal to, let's say Ravi, and then my name Ravi, and then Rishan, my son's name, and then learn clearly, my YouTube channel name. Okay, learn clearly, something like this one. and something like this one. And then what I do is we have other approach also. I'll explain that in Java 8 topic. Okay, for what is that? For string as colon names. If you remember the syntax, the first part represents the data type name or the class name, and this is a temporary variable name. So this data type or class name belongs to the name of the class name or data type name to which the array belongs, and this is the array name. This is the array name. From this array, the next element, that is Ravi, is captured and stored here for the first time of the iteration, and the pointer is advanced to the next item, and then that value is stored here, and then the pointer is advanced, the next value is stored in here, and then let's print it. So that's about System.out.println, and I'm just printing. This time I'm printing each and every element in the next line. Now let me save and execute this program. It works well. So that's it. Let's move on to the areas example once again. Maybe you want to make use of the areas or a bank account or whatever you want. We have so many displayed here. Let me take the bank account this time. So instead of areas, now what I do is I create a new class here. The new class name, let's say for each bank account, but I don't know bank account is in this project or not. It's not in this project. Let me close this one. I go here and then right click in array project 3. Watch here, array project 3, right click, and then new class. Inside the new class, what I do is bank, let's say for each bank account. This place, what I want to do is main method. Okay, and then what I want to say, bank account accounts is equal to, then what I want to do is a semicolon here, and then new bank account. Please remember, as a best practice, the flower brackets will, or open flower brackets will always be on the same line, and closing flower brackets will be in the last line, something like this one. That's a best practice. Never put the open curly brackets in the next line of the heading. Okay, that is poor programming practice. Never follow poor programming practices, please. Some people by mistake put it here, which is actually not the best practice that Java developers follow. Please be in good practices list, best practices people's list. Okay, now this is done. I want to do the for each loop here. You watch here. For what is the data type here? That is a class name. For bank account B, and then colon, and then the array name or the collection name. So this is the data type or the class name of this accounts. And now from this array, the next account object is copied into this B, and that is printed here in the for loop. Let's say if System.out.println B, and that's it. So first time the first one is copied here and printed, the second time the second, and so on, something like this one. Run as Java application, and this is how it works. Now let's do the same thing for customer for each. Now create a new class here, that is for each customer. The only thing is you need to have time and patience. I'm explaining in-depth, crystal clear examples, real world examples, please. It's kind of paid course that you're learning it for free almost, right? So let's say customer, few customers, customers is equal to let's say new customer. This course is a wonderful course that I've designed for you people. You can learn each and every point very clearly with real world examples. Okay, you don't have to search it. Almost every piece of Java related topic is explained here with wonderful examples, not just ABC examples, please. Okay, now for customer C colon few customers, and then I take it here and then I print it here, C here. That's it. Now it works well. So hope you're able to understand my teaching speed. If you feel it fast, you can probably, this is the last example in this list. And that's it about the hands-on examples of the about arrays and enhanced for loop. Let's meet in the next part. Thank you. Now let's understand the next topic called as method overloading in Java. Method overloading means declaring more than one method with the same name with one or two rules applied. As an example, we have a shape class which has 3 methods, and the name of all these 3 methods is same: area, area, and area. In order to achieve method overloading, we have to follow one rule. That rule is kind of an either rule or rule. So either the different versions of the methods must have different number of parameters, or otherwise, if they have the same number of parameters, then the data type sequence must be different. So consider the previous example. We have three different methods overloaded. In the first and second case, we have the same number of parameters. So the number of parameters in the first case is 2, and the number of parameters in the second case is also 2. But in case of 1 and 3, otherwise in case of 2 and 3, the number of parameters are different. Method overloading does not restrict that the return type has to be same. Of course, in this particular example, they are same. However, it is not a rule that the return types must be same or that the return types must be different. Nothing as such. Okay, it's only about the number of parameters and the data type sequence of the parameters. Now let's go ahead and see the hands-on code example to the method overloading with respect to these examples. First, let's understand this shape example as displayed on screen. So I'm creating one new Java project, and let's say project name overloading proj1, overloading proj1, project 1, and here I'm creating a new class, and the class name, let's say shape, and inside this class, let me type in the code that is displayed on screen: public void area, integer length and breadth, and inside this one I want to print area of rectangle equal to, and here we type the formula length multiplied by breadth. And let me copy and paste this one to the second item, public void area, double, let's say height and base, height, and here double base, and then area of triangle, let's say half multiplied by base multiplied by height, half multiplied by base multiplied by height. And this is one more copy of the area method. This time let's say integer side, and this can be area of square, and then area of square, as we all know, is side star. And that's it. Now let me create a main method in this one, or else I'll take the main method in a separate class. I create a new class here. Now inside this class, what I say is shape overload main, and inside this class what we do is define the main method. Now inside this method I create an object of the shape class. Shape s1 is equal to new shape, and then I execute the methods one by one. This is the area of square, shape1 dot area of double of 2.2 comma 3.3, and then shape1 dot area of length and breadth, let's say 3 comma 5. And that's about the overloading example for shape. Now let me save it and execute this program. We got the output as expected. Now let's go ahead and see the next example listed in this one, calculate example. I create a new class there, and the class name is calculate, and here I take a couple of methods such as sum or something. Public void add int x comma int y, and here System.out sum of two ints is equal to plus sign x plus y, and here one more copy, public void add of double x comma double y. If you consider this example, there are two versions, add, and the number of parameters are same here and here, but the rule is we should have different versions of the parameters. Like if both are same, then that will be a compilation failure. You watch here, we got a red line, right? So I'm going for undo, and that's all. So this is the print command for this one, and this is the sum of two doubles. So like this, we can give as many as required. Now let me go for a main method for calculate. Right click and then go to new class. Now inside this one, calculate overload. Some typing mistake is there, please ignore that, no problem. of calculate overload main method. Now inside this one, I want to create a new object, new calculate dot add of double, if you say 2.3 and then 3.5. So we can create an object even though we don't have a reference. This is a possible syntax. This will be a temporary object. This object will be created only until the execution of this statement, and it becomes eligible for garbage collection. Similarly, I'm doing the same kind of object creation for the next item, calculate dot int of 2, 3, something like this one. Now, if I execute this program, we get the output something like this. Now, let's see the next example, that is the payment processor example for method overloading. So let me create a new class, payment processor class. So I go here and then create a new class. The class name, let's say payment processor. Now inside this class, let's take process payment method, public void process payment, and here string payment type, something like this one. We'll take one more method, public void process payment, and here System.out.println payment done via credit card, something like this one. And here we take if payment type dot equals of let's say debit, then let's say System.out.println payment done via debit card. Else if what you say payment type dot equals of net, then let's say System.out.println payment done via net banking. Else let's take some default here, payment done cash on delivery. So that's all. And this is the equals method in this string class. If you notice here, payment type is a parameter which is of type string class object. So we'll discuss string class object and its details in the respective topic. For now, one of the methods of the string class is equals method, that is used to check whether the content present in a string object is something like this one, equals. And that's it. Let's go ahead and create the main class for payment processor overload. Right click and then let me create a new class. Let's say payment overload main. Okay, in this case, I want to create the main method. Now inside the main method, I say payment overload, payment processor P1 equal to new payment processor. And here P1 dot process payment, this is the default one that we have chosen for credit card payment. And then payment processor dot this one, let's say debit card, it prints us. This is case sensitive while comparing the text. There is another method for comparing case insensitivity. So let's say payment processor, like let's say net banking or something. And that's how it works. Let's go ahead and run this program. We got the output, payment done via the credit card, debit card, and net banking. So that's about the method overloading. We'll continue with the next topic. Thank you. Now let's understand the next topic, the final keyword. The final keyword has three different uses. The first one is to declare constants, to prevent method overriding, and to prevent inheritance. We shall understand the usage number 2 and 3 when we talk about inheritance. For now, we'll see the first use of the final keyword. The constant is a data member which cannot be changed, whose value cannot be changed after it is assigned for the first time. For example, we declare the constants using the final keyword, something like this one, final double pi equal to some value, final int max underscores is equal to some value. And then later we try to change it, pi equal to 4.1. This won't get compiled because we are trying to change the value after it is assigned for the first time. And generally finals, constants are generally typed in capital case. It's not a rule, it's just a convention. If the constant's name contain more than one word, we separate them using an underscore. Okay, so, and then object references and final. Let's say we have a object reference B1 pointing to an object. We can see in the data here, B1.account number, this works well. We can again change the data of the account number, but we cannot, make this B1 points to a brand new bank account object. So this is not okay. Let's go ahead and see this one in action. Let me create a new class. Right click and then new class. Let's say final demo 1, and in here I say the main method. Now inside the main method, let's declare final double pi equal to 3.141. Let me try to change it now. Pi equal to let's say 4.0. Now you'll get a compilation error if you notice here. So this is the error, we cannot change it. Okay, so that's about this one. For the sake of temporary this one, let's say class, I'm taking one local class here, class employee. In this one, maybe I take a bank account. Let's say I have integer account number, and let's say I create a bank account object. So bank account without final. First of all, let's see without final. Bank account, new bank account, and then B1 dot account number equal to 100. This works well. I again change the value B1 dot account number is equal to 200. Of course, logically speaking, account number should not be modified and cannot be modified. That is another part. Now this is possible. Now if I try to add B1 to point B1 to one more brand new bank account object, this works well. As of now, it works well. But if I start this one as final, this won't work. Control S. I have saved it. Now you can see this is a compilation failure. That means when talking about final and constants with respect to object references, the object reference can change its data, but the object reference itself cannot point to a brand new object. That is the point you need to understand. So that's about final keyword working with constants. As I told you, we can understand preventing method overriding and inheritance in the respective topic that is called inheritance. Now let's stop here and continue with the next topic. Now let's understand the next topic called constructors. A constructor is a special method of a class whose name is the same as its class name and which has no return type. To understand this sentence, let's understand we have a class bank account and a method also bank account. Now, if you look here, the name of this method is same as its class name, and at the same time, it has no return type. So such methods which have the name as their class name and which don't have return type are called constructors. And constructors are executed every time on an object during an object creation time. For example, if we create an object for this bank account, object number 1, it is executed. And if we create object number 2, the constructor is executed, and so on. So that's how constructors are executed. Let's go ahead and see the hands-on example of this bank account constructor. So let me come here and create a new package, new Java project. Let's say constructors underscore project 1. Now here I create a new class bank account, new class, let's say bank account. And here what I do is I type the constructor bank account, something like this one. And here is what is happening. Inside the constructor, something like this one. Now, for the sake of simplicity, I'm running the main method here in the same program. Let's say the main program. Now, bank account B1 equal to new bank account. Bank account B2 equal to new bank account, something like this one. So this way the constructor is executed as many times we create an object. It is executed for an object during its object creation time. Okay, that's case, that's there. Now control S, this is saved. What is this error? We have what is this error? save. Let me close and open this one. Sometimes it doesn't refresh. I think there is no error. Okay, now let me save and execute this one. Now we get the output 3 times inside the constructor, inside the constructor, inside the constructor. That is, it is executed once per each object. That is the meaning of constructor execution. Now constructors are used to provide the custom initial values to the instance variables of an object. If you remember, there are 3 different types of variables in Java: local variables, instance variables, and static variables. Instance variables are those which are declared inside the class, outside the method, without using the static keyword. Go back to that particular part and you can watch my video. I've explained the details there. Now let's understand the use of constructor hands-on code example. Now let's consider this bank account example. What I do is initially I say integer account number is the account number semicolon, and then let's say double account balance semicolon, something like this one. Now what happens is when we create 3 objects here, what happens is the account number gets 0, the account balance gets to 0.0 for object B1, for object B2, as well as for object B3. What I'm trying to explain here is each and every object has the same value, such as 0 and 0.0 for the case of account number and account balance. Let me demonstrate and print them. You watch here. System.out.println B1 details, and then what I'm doing in the next line, you watch here. So I'm not using println there. So what I do is let's say println as well. So here B1 dot account number and then space, and then give B1 dot let's say account balance. So to get a more clarity, let me give account number is equal to, and then plus sign, and then here what I do is account balance, let's say ACT account balance, something like this one. You can watch it here, account balance. Now let me execute this one for B1 and B2, as well as I copy these 2 lines for B2 and B3. You can watch it here. I'm pasting it here. This is for B2, and again I say this is for B3. I'm saying this one for B3. And if you see the output here, what happens is we'll get the same details for all the objects. Now we have to change this one, right? B2, and then this is B3. And then I go here, this is B2, and then this is B3. 3 objects are there. All the objects have the same values by default. So we change them by using the constructor. So let's say run as the Java application. We get the output account number 0, account balance is 0.0 for all the 3 items. So constructors are used to provide custom values. For example, what I do is inside this one, account number is equal to, let's say 1, 2, 3, 4, and then account balance is equal to some 10,000. Now what happens is when the constructor is executed for object B1, its account number is set to 1, 2, 3, 4, and its account balance is set to 10,000. Similarly, when this constructor is executed for object B2, it again gets set to 1, 2, 3, 4, and 10,000. But this is not what we actually want. We want different values for different objects. We'll see that in the next 2-3 minutes. Now let me execute this one. Right click and then execute this one. You see now we got the output as. So this is, we are able to provide custom values to the instance variables with the help of the constructor. So that's the case. But what is happening here is all the objects are getting the same thing. So what we do is we take the constructor parameters here. Watch here. So what is integer? Let's say integer account number, and then let's say double account balance, and then what I do is here account number, and this one is account balance. This is how it works. Now in the constructor, I have defined 2 parameters, if you all notice, and while creating here, I have to pass the custom account number 1234, comma some 5,000. And here what I do is I say 4321, comma some 6,000, and then let's say I give 5678 and then comma some 7,000. So this time what happens is For the bank account object B1, the B1 object, this 1234 goes into this account number. This account number goes into the account number of the bank account object, right? So that's how it works. And this 5000 goes into this account balance, and this account balance goes into the account balance of the object B1. So this is how it works, and it works in a similar way for B2 and B3 as well. So when we give parameters to the constructors, then we call it as parameterized constructor. That we will see the definition in this topic itself. Now let me execute this one. For the sake of clarity, I'm removing this print command. Now let me save and execute this file. Now we get the details, right? So that's how it works. You can see here account number is 1234, balance is equal to 5000, and something like this is displayed. So that said, the constructors are used to initialize the instance variables with custom values. This is what we have seen about this one. Constructors and access specifiers is the next topic. To the constructors, we can declare it as a public constructor or a private constructor, or protected or default. That means before the constructor name, we can use private, public, protected, or nothing. So that is possible. So let me demonstrate that. So this can be public, okay, that works. This can be private, no error. This can be nothing, no error, or this can be protected, no error. Control S. Okay, so there are no errors in the constructors. If you put it public, private, protected, and default, that is possible. Now let's go ahead and see the hands-on code examples. This is just now completed. Constructor overloading. Constructor overloading is similar to method overloading. That means we can have more than one constructor declared inside a class. A constructor with 0 parameters and a constructor is one parameter is demonstrated on screen. However, there can be any number of constructor versions provided as long as they follow the method overloading rules. There can be 0 parameters, 1 parameter, 2 parameter as per the requirement. Now let's take one default constructor. Watch here. I am taking one default constructor, bank account, and then System.out.println. This is the default constructor. I mean 0 parameter. Let's say 0 parameter constructor. There is something called default constructor that we'll understand in the next few minutes. Now there are two constructors available. The first one which has 0 parameters. The second one which has 2 parameters. So depending upon which type of constructor we have used in the object creation time, that is executed. Let me take bank account B4. Now bank account B4 is equal to new bank account. And here I'm using the 0 parameter constructor. 0 parameter constructor, it is called as default constructor. You can learn that in the next few minutes. That's how it works. Now, that's how it works. Now let's go ahead and run this code. Let me save this and run as Java application. That's how it is. That's how it works. Right. So this is the 0 parameter constructor. So that's how it works. Now that is done with the constructor, and constructor overloading is completed. And then we cannot declare a constructor as static. Let's go ahead and see that. If you try to declare a constructor static, you see here it is a compilation error, because the reason is constructor is not common to all objects. It is specific to each object. So if we declare something as static, it is common to all objects. If you are new to static versus non-static, you can go ahead and watch that topic in my tutorial in the same video, right? So that's the reason we cannot put the constructor as this static. And similarly, we cannot use final for the constructors. You can see here final, we cannot use the final. So this is a compilation error. That's how it works. Now the default constructor is something which has 0 parameters. A constructor with 0 parameters is called the default constructor. If we don't write at least one constructor, the compiler automatically adds a default constructor to a class. This is important. If you see here, we have not mentioned any constructor, but what happens is the compiler automatically adds a default constructor to this bank account class. Not just the bank account class, it adds the default constructor to any class in which there is no single constructor defined. So that's the meaning of the default constructor. We'll see this one. That's about parameters constructor. Parameters default constructor, it's already seen, isn't it? So this one is 0 parameter constructor is called the default constructor, right? Now parameters constructor means the one which have already seen. It contains the parameters like account number and account balance, right? So now let's understand the next topic called this pointer, or otherwise this object reference. Internally, JVM maintains a special built-in pointer called as THIS in memory. And this this pointer always points to the currently active object, which means the object upon which the code is currently in execution. To understand this pointer as well as the meaning of this statement, let's consider this pointer is there inside the memory of JVM, and then we have a class something like employee, which has two variables and methods, something like this one. And then we want to execute this code, which has 4 statements. As usual, JVM starts executing the statements one by one. And when JVM executes the statement, that is the first statement, at the time of execution of this first statement, object E1 is the active object. And when JVM completes this E1 and goes to the next statement, E2 is the active object. And when this is completed, when JVM goes to E1, this time E1 becomes the active object. That means the currently active object is not always the same object. It keeps on changes, right? So to understand this statement, let's say JVM started the execution of this code with the first statement, object E1. When JVM executes this statement, until the time this statement is in execution mode by JVM, object E1 is called the currently active object, and therefore this points to the object E1. When JVM finishes the execution of this statement E1 and moves to the next statement, what happens is object E2 becomes the active object and this switches to E2. Once again, when this one is completed, what happens? JVM moves to the next statement. When JVM executes the statement number 3, because the object on which statement number 3 is E1, what happens is this this again moves to E1. So that is where this always points to the currently active object. When this statement is being executed, what happens? You see here inside the set method, we have this. This currently means E1. Right. So that means this 101 goes into this employee number, and here this means E1. E1.employee number is equal to 101. And when this statement is completed, what happens? Currently active object is E2, and then here the this is now E2. That means within the same code, this this is sometimes E1 and sometimes E2. So that is the meaning of the currently active object and the meaning of this pointer. That is the information about the this pointer. Hope you understood. Now let's move on to the next topic. Now let's understand the next topic, encapsulation in Java. Here is the list of topics that we will learn in this particular part. We'll see what is encapsulation and how do we achieve it, followed by the benefit of encapsulation along with the hands-on code example. So let's get started with what is encapsulation. Encapsulation is the process in which the data and code are bound into one single unit. Data means instance variables, code means the methods. To understand these concepts, let's imagine we have a class called employee with two variable names such as emp number and ename. After the employee class is declared, let's imagine we have declared two more classes, employee main1 and employee main2. And in these two classes, we have created an object of the employee class, such as employee E1 is equal to new employee. After creating the object, both the classes are making use of the employee number and ename variables using the object name E1. Now, this way, the program works well and perfectly we get the perfect output. However, at a later time, if you want to go ahead and change the variable names in the original class employee from emp number to emp code and from ename to emp name. So when you make the changes in the original class, then you have to make the changes across the classes such as emp main1 and emp main2. You watch here in this class also we have made changes to emp code, and this one has been changed from ename to emp name. Similarly, in emp main2 also, this is changed from emp number to emp code and from ename to emp name. Let's imagine there are 100 classes such as emp main3, emp main4, and so on. That means every time you make a modification to the variable name in the original class, then you have to make changes to those variables wherever they are used across 100 classes. So that is the trouble if we don't make use of the encapsulation. So how do we solve and how do we achieve encapsulation is something like this one. To achieve encapsulation, we should not allow the target classes such as emp main1 and emp main2 to directly make use of the variable names such as e1.emp code and e1.emp number. To do this, what we do is we declare the variable names using the private keyword in the original class employee. Thereby, when we declare any variable in a class, then when we declare any variable in the original class as private, that variable is not visible and it is not accessible to outside classes. You can see this is error here. Main1 and main2 have no access to these two variables. Then now the question is, how do these classes employee main1 and employee main2 read and set the values of the variables employee code and employee name? The solution is the public getter and setter methods. To every variable in the employee class, such as employee number and ename, we provide one set method and one get method. The set method takes the input of the employee number and the get method returns the value of the employee number. Please watch here, these setters and getters are public methods. So this pair is declared for each variable such as employee number and employee name, ename. So in this case, we have a pair of methods to both employee number and ename, and the target classes such as employee main1 and employee main2, if they want to make modifications to those variables, they use the set methods, or if they want to read those variables data, they use the get methods. So this is how encapsulation is achieved. Okay, now let's see the hands-on code example of the same whatever we learned. Let me create a new Java project in Eclipse. Let's say the project name is encapsulation demo, encapsulation project 1. Now in this class, I want to create a new class. In this project, I want to create a new class. The class name, let's say employee. Okay, employee class. And then what I want to do is I want to declare a variable such as integer emp number without encapsulation. Let's see without encapsulation first, string ename, and then let's say this is a class default. Now let's say we have two more classes, employee main1 and employee main2. So what I'm doing is I'm creating one more class and then emp main1, and inside this emp main1 I want to create the main method, and after creating the main method I want to create the employee class object, employee e1 equal to new employee, and then after that I want to say e1.employee number is equal to 100 or something, e1.ename is equal to Ravi or something. Okay, let's say something like this one. Now let's say we have this program works well. Now what I do is I copy and paste this employee main1 class. I'll get one more class. I copy this one and put my cursor here and then paste it here. I get employee main2. So now both the classes, the program is working well. So employee main1 is there, employee main2 is there. Now the employee main1 and main2 are perfectly working. Now I go ahead to employee Java file and then change employee number to employee code, something like this one, and this one to emp name, something like this one. And when I save this employee class, now the other two programs we get error. You watch here, we got errors here. That means in order for these programs to work well, we have to make the changes here as well. Employee code and employee name, something like this one. Only then this will work. Employee code and this works well, and employee name. So this is the trouble with without encapsulation. If you change the variable names in the original class, you have to make those changes in all the target classes wherever the variable names are used. Okay, so many people learn encapsulation very incorrect. So please learn the things correctly. So let's say this is emp name. Now this is the problem. Now to achieve encapsulation, what we do is we make this as private. When I make this as private, you watch here, private, and this one as private, and save this one. The moment I save this one, what happens? These errors, these variables are not accessible. We got errors in both the classes. You see, this is how it works. So what we do is we provide here a pair of getters and setters. So you position your cursor here and then right click and then go to source menu and then go to generate getters and setters. I repeat once again, position your cursor here, right click here and then go to source and then generate getters and setters. And when you click this button, we get the select all option for employee code and employee name. Eclipse will automatically generate the getters and setters. Now we got the getters and setters which are public, if you notice here, and the variables are private, if you notice here. Now the calling programs such as employee main1 and employee main2, they don't directly use the variable names. Rather they use the this one getters and setters for working with the data. So at that employee name, let's say Ravi or something. So this is how we achieve encapsulation. Hope you understood it. Employee emp1 dot get emp code. If you want it, you can print it. Let's say System.out.println emp employee code, and then System.out.println e1 dot let's say get employee number, we get. So let me copy these 4 lines and put it in other program. Let's say here, I save this one, Control S. Now let me execute this employee main program. We get the data as it is, like employee Ravi and 101. And here also, let me right click and then execute this program. We get something like this one. So that's about the meaning and actual purpose of encapsulation. Many people learn it is incorrectly. Please don't learn things incorrect. So the next thing is, let's understand the benefit of encapsulation. And encapsulation is helps to modify the instance variable names without breaking the calling code. The meaning of the word calling code in our example is employee, the classes employee main 1 and employee main 2. I guess you understood the meaning and purpose of the encapsulation. Thank you for watching. Let's meet in the next part. Now let's understand the next topic, that is inheritance in Java. This is one of the most important topics, and here is the list of topics that we will understand in this particular part of the tutorial. We'll first see what is inheritance and its benefits, followed by the different types of inheritance. We'll then understand the concept of superclass, subclass, super constructor, and super keyword. After that, we'll see what is the meaning of method overriding and why do we use method overriding. And we'll demonstrate the concept of polymorphism that is achieved with the help of the method overriding. Okay, we'll then see the concept of abstract methods, abstract classes, and interfaces, followed by the difference between an abstract class and an interface, along with the difference when to use an abstract class over an interface. And we'll understand the concept of abstraction. So let's begin with the first question. What is inheritance? It is an approach in object-oriented programming in which one class inherits the features of the other class. Let's understand this statement with an example. Here, the permanent employee class and the contract employee class, both classes inherit the features of the employee class. Again, the standard customer class and the premium customer class, both classes inherit the features of the customer class. Similarly, the classes business class ticket and economy class ticket inherit the features of the ticket class. In this entire explanation, the classes which are mentioned below the other classes, these classes, permanent employee, contract employee, standard customer, premium customer, business class ticket, and economy class ticket are called as subclasses, and the classes employee, customer, and ticket are called as the superclasses. So that's the meaning of inheritance, where one class acquires the features of other class. Let's go ahead and see the benefits of inheritance. Inheritance offers 2 benefits. The first one is code reusability, and the second one is polymorphism. Achieving polymorphism is possible only with the help of inheritance. If there is no inheritance, there is no possibility of achieving polymorphism. So this is the most important benefit of inheritance. However, code reusability is another importance of the inheritance. Now let's see the extends keyword. The extends keyword is used to declare a class that wants to inherit the features of other class. For example, consider this structure where we have permanent employee and contract employee subclasses, employee as a superclass. In this case, we declare the employee class as it is something like this one, public class employee. And if you want to achieve inheritance, we declare the contract employee class by using the extends keyword followed by the superclass name. Similarly, the permanent employee class by using the extends keyword followed by the superclass name employee. So this is how we achieve inheritance. This is how we declare a subclass with the help of the extends keyword. Now, types of inheritance. There are different types of inheritances available. First one is called the single inheritance. And in this case, we have only one superclass and only one subclass. Multi-level inheritance. In this kind of inheritance, we have one superclass, the next subclass, and so on. Hierarchical inheritance is something like we have class 1 superclass and 2 subclasses, and this kind of model. Multiple inheritance is something where a subclass has more than one immediate superclass. And please make a note that Java does not support multiple inheritance with classes. However, it supports multiple inheritance with the help of the interfaces. Now let's see the hands-on code examples for all the previously explained inheritance class diagrams such as employee, customer, and ticket. So let's go ahead and start a new Eclipse project here. File, new Java project. Now let's say inheritance project 1. And inside this project, I want to create the class employee for the first example. New class. Here, the class name is employee. And inside this class, let me declare a few variables relevant. Let's say private integer employee number, private string employee name, and then private. You remember, is it? Why do we use private? Private double gross salary. And I hope you also remember the naming conventions that are used for variables, classes, methods, etc. Now what I want to do is generate the getters and setters. Okay, now the getters and setters are generated. Now this is the super class. We are done with this super class, and then I create one more class which is a subclass to the employee super class. This time what I do is the class name as contract employee. Let's say contract employee. Here what we can do is we type in the superclass details, extends employee class, and then let's say the contract employee class has some features such as, let's say, private int contract duration, that is the number of months or the number of days the employee is offered the contract. And let's say private int monthly contract rate, that means the salary for the month on a contract. And then let's say private double, let's say deductions, the deductions from the actually, before paying the contract rate, some kind of income tax deductions, for example. And this is about, let's go ahead and generate the getters and setters for these variables as well. Select all and then select this one. So this is completed. Now let me create one more class. Let's say new class, and this time it will be full-time employee or permanent employee, whatever word you want to use. This is employee. So here we have an option of super class. If you notice here, we can type the super class name. So instead of going and typing the extends keyword manually, and this is possible to us. Now in this case, let me declare few attributes such as private double income tax, and then private double provident fund, and then private double insurance. And these kind of deductions will be there to this permanent employee or full-time employee, whatever. Now getters and setters for these three attributes. Now this is the structure of the employee class, which is a super class, and then you see this is the contract employee subclass, this is the permanent employee subclass. Now let's go ahead and create a class that demonstrates the usage of inheritance. The class name is, let's say, employee inheritance 1. And in this one, let's say I want to say the main method, and here I want to create an object of the classes such as contract employee class and the permanent employee class. Let's say I'm creating a contract employee CE1 equal to new contract employee. And then if I press CE1 dot, we should get the list of methods that are declared both in contract employee class as well as the methods that are listed in the employee class. Okay, when I press something like that, you see here we get contract duration, deductions, employee name, employee number, gross salary. If you remember, the methods such as get employee number, employee name, gross salary, and all of this stuff, these are not declared inside the contract employee class. They are declared inside the employee parent class, that is the super class. However, a child class, the subclass, inherits the most of the members of its class, which are non-private. Now let's see, let's say C1 dot set employee code or employee number as 101. And then let's say C1 dot set employee name as Ravi. Okay, and then let's set something else. C1 dot set gross salary as some 10,000.00, and then C1 dot set contract duration, let's say for 2 months, and then C1 dot set contract, let's say a monthly contract, maybe some, let's say 5,000, something like that. and then ce1 dot set deductions. Let's say the deductions at the rate of 5% or 10%, something like this one. We are not going to the in-depth employee management contract in this particular tutorial. This is just an understanding of how the inheritance is used. Now let's go ahead and print the details of the contract employee. So system.out.println and then contract employee details. Contract employee details are being printed. Now what I do is let's say system.out.println. So instead of using println, let's say I use this println. That's not a big deal. So here what I do is ce1 dot get employee number and then space. Okay, I use all those things there. So let's say copy, and then I use in the same line I use two attributes I print here, then space and then plus sign ce1 dot get employee name, and then system.out.println ce1 dot get gross salary, and then space and then plus ce1 dot or let's say get contract duration, and once again the other details like ce1 dot get monthly contract rate plus space, and then ce1 dot get on a monthly contract rate is already done, and the other one that is deductions, right? So this is how we inherit the details of the employee class into the contract employee class. That is called inheritance. Now let me save and execute this program for the contract employee. Otherwise I will let me type in the code for the permanent employee class as well. So here, and then I display one line there, and then I want to create permanent employee class, permanent employee PE1 equal to new permanent employee, and then I want to set all the details, permanent employee dot set employee number, employee name, and these things will be common to the permanent employee. So what I do is I copy and paste. This is the permanent employee here. Okay, and then for the permanent employee, these things are again inherited. The employee number is 102, and then the employee name is guest, and the salary, let's say 15,000, and then PE1 dot set income tax. This is special to permanent employee, which is not there in contract employee. Set income tax of some 1,500, 1,500, and then PE1 dot set insurance of some 500. That is something there, and PE1 dot let's say some PF of 200, and that's it. We have 6 details. Okay, in both the cases, the first 3 details in both contract employee and permanent employee classes are inherited from the parent class employee, but the remaining 3 details such as income tax, insurance, and PF is special to permanent employee, which is not available to the contract employee. Similarly, the details such as contract duration, monthly contract rate, and deductions, this is special to contract employee, which are not available to the the permanent employee. Okay, so that means the child classes have their own features as well as the features that they inherit from the parent class. Now let me print the details of the permanent employee class. Now what I do is I print a text called permanent employee details, and in here, as usual in the previous case, what I do is I copy let's I better print it here itself. PE1 dot get employee number, then space, and then plus sign PE1 dot get employee name. Okay, and the next 2 lines I print the remaining details. Okay, system.out.println PE1 dot get gross salary, then press space, and then PE1 dot get income tax, and once again system.out.println PE1 dot let's say get insurance, and one space there, and then again PE1 dot get PF provident fund. This is how the inheritance can be demonstrated with the employee, contract employee, and permanent employee class. Now let me go ahead and execute this program. We get the output displayed, right? So somehow it's stuck here. Let me run it again. And this is how it works. You can see the details. Contract employee details are displayed here. Permanent employee details are displayed here. So that is one of the examples that we wanted to demonstrate using the hands-on code example of inheritance. Okay, in the second example, we'll see is the customer example, where we have a customer superclass, standard customer, and premium customer as the subclasses. So let's go ahead and do that. So let's go ahead and do that. Let me create a new class there. Let me close the existing programs, new class, and this time I say this is the customer class. Inside the customer class, I will declare the details which are common to the child classes, such as private integer customer ID. Always the parent class includes the features which are common to the child classes, and the child class includes the features which are uncommon to both the child classes. So let's say private string customer name, and let's say for now this is okay. We'll add any other features if it is required. Now let's go ahead and say otherwise let me add one more variable here, private character customer type. Customer type can be standard customer or a premium customer depending upon the requirement. Now let's go ahead and see here, generate the getters and setters. Now what I'm doing is selecting all the attributes and generating the getters and setters. Now let's go ahead and define the classes such as standard customer and the premium customer as the child classes to the customer class. What I'm doing is creating a new class. In the new class, what I'm doing is the standard customer, and here in place of the super class, if you notice, I'm typing customer here. Okay, what I'm doing in this place of the standard customer, generally, even though the standard customer is not a paid customer, he or she is offered a free trial limit duration. So what I do is private int free trial limit or something else, duration, whatever you want. So let me save and generate the getters and setter for this one. So this is select all and then click OK for this one. And similarly, let's go ahead and create a class for the premium customer, new class, and this time it is a premium customer class, and this class also extends the customer class. You can watch it here. This is the customer class. Once again, the premium customer, let's say we have one attribute, let's say private int additional discount. Apart from the regularly offered discount, the premium customer may be offered additional discount. Let's say let me right click here and generate source getters and setters. Right, so guys, this is little faster than usual, but you can slow down the speed of the playtime. Then as you can control the speed of the you can control the play speed and reduce at your convenience. Now this is done with the premium customer and the standard customer. We have the super class customer. Now let's go ahead and create the main class for this customer inheritance. Let's say customer inherit main one. Inside this one, I want to declare the main method, and inside the main method now I want to create the object of the standard customer, fill its details and print its details. Similarly, I want to create an object of the premium customer, fill its details and print its details. Now let's say the object of the standard customer, let's say standard customer s1 equal to new standard customer, and then I want to fill the details s1 dot set customer ID. If you remember, the set customer ID, get customer ID, customer name, these are not declared inside the standard customer child class. They are declared inside the customer parent class. As you know, in case of inheritance, a subclass inherits the features of its parent class, that is the super class. Now here we are setting the customer ID as 101 and then setting the customer name as Ravi, okay, and then setting the the customer type as standard, let's say standard customer, and then s1 dot let's say a free trial limit, let's say 10 days or 15 days, something like this one. Now I want to print the details of the standard customer, so I'm printing the prompt on the screen, standard customer details or something like this one, standard customer details. And here I want to use all the getter methods, s1 dot get customer ID, get customer ID, a space there, and then s1 dot get customer name, something like this one. Similarly, I want to use the s1 dot get customer type, whether he or she is a standard customer or a premium customer, and s1 dot let's say get get customer free trial limit, how many days we have that. So this is about the standard customer, and let's go ahead and create an object for the let me give print as a line symbol here, so to show the difference between the two customer output. Now let's say I'm creating a premium customer object, premium customer p1 equal to new premium customer. Control space, guys. Every time I'm pressing control space, and that's the reason I'm typing little fast. And then what I want to do is I want to set these three details which are common to this one. Okay, this is not three details. I think there are three details. I paste it here. This is let's say this is premium customer P1, this is premium customer, this is premium customer, and the customer ID, let's say the customer ID as 2, and then let's say guest, and then this is the premium customer capital letter P, and then P1 dot set additional discount of 3%. Apart from the existing discount that is offered to the premium customer, the premium customer is also offered the additional discount. And now let's print the details of the premium customer. Let's say this one is here. I give the details something like this: premium customer details, and then let me print these details such as the first 1 and 2. Okay, the first 1, 2, 3, and here it is premium customer. I want to change this one to P1, and I want to change this one to P1, and I want to change this one to P1, and here is the final one that we need to change it to completely modified P1 dot get additional discount. That's all. And this is how we develop the inheritance program for standard customer, premium customer, and customer superclass. Let me run this program. We'll get the output something like this one. You can double click and see here. And this is the example that demonstrates the premium customer and the details. Now let's go ahead and see one more hands-on code example, that is the ticket example. We'll see this one once again. So I'm creating a brand new class this time. Once again, new class, and let's say instead of saying the class name as just a ticket, I want to say flight ticket or something. I say flight ticket. Okay, and inside the flight ticket class, let's say the flight number, something like that one. Private int flight number, and then private string customer name, private string customer name and flight number. And let's say that's it for now. Let's come back and add the details if required any later. Now let's go ahead and generate the getters and setters. Let's say getters and setters. Now select all, and then this is completed. Now we have generated getters and setters to the flight ticket class. And now let's go ahead and declare the child classes to this flight ticket class, that is the subclasses. Now let me create a new subclass, that is the class. The class name is business class ticket. Okay, business class ticket. Okay, some typing mistake, and here I want to use the extends keyword. What I do is the extends keyword, and then I say this is an extension to the flight ticket class. In the business class ticket, what I want to do is private, let's say integer additional, otherwise I say extra baggage allowance, how much it is offered. Now what I want to do is extra baggage allowance, and then I want to generate getters and setters to this one. Source generate getters and setters. Okay, and this is selected, this is completed. Now let me go ahead and create one more class, that is the economy class ticket. So new class, this time economy class ticket. And the economy class ticket is a child class of which class? If you remember, it is a child class of flight ticket. If you want, you can select it from the browse button adjacent to this one. The browse button is there. The economy class ticket. Now it has been come here. Now let's say private integer free food, free soft drink. Let's say this the soft drink name, free soft drink, free soft drink. And then let me generate the getters and setters to this one. To generate the getters and setters, this is completed. And once we are done with this one, let's go ahead and create the main class to the economy class ticket, business class ticket. Right click and then go ahead and new class. Let's say flight ticket inherit main, flight ticket inherit main 1. And in here, I want to generate the main method. Now inside this main method, as usual, I want to create the tickets or objects. Business class ticket B1 equal to new business class ticket. And to this one, I want to fill the details like flight number is 101. And then let's say customer name as Ravi. Okay, and then I want to say b1 dot set extra baggage allowance, let's say some 20 kgs, something like this one. Now I want to print the details again back. Now let's go to System.out.println business business class ticket details, details, business class ticket details. And then what is the output we have to print there? What is that? b1 dot get flight number and one space, and then again plus sign, b1 dot get customer name and then space, and then plus b1 dot get extra baggage allowance. And this is about the business class ticket. Let's do the same thing for economy class ticket. Economy class ticket E1 equal to new economy class ticket, and here I want to fill these three details. Let's say these two details I want to grab here, and then what I want to do, this is E1, this is E1, and the flight number is 102, and let's say the guest customer name is guest there. And then I want to say E1 dot set free soft drink, let's say cola, Coke or something, right? Something like this one. I want to print these details now to the economy class ticket. Here is the details. Now what I'm doing is, here is the economy class ticket, and then before, in between these two output, I want to print something called a line separation to see the difference. Economy class ticket, I have to change the details here. This is E1 and this is E1. This is E1, and if I go to the other attribute, let's say, let me go to the other attribute. This is E1 dot get soft drink. This is, let's say, E1 dot get free soft drink, and this is the details. As you're able to notice, all the child classes, what they do is they have the common features inherited from the parent class, and they have their own specific features which are different to each other child classes. This is how inheritance is used as a basic example. Of course, we are not done with inheritance. It is a very important and it's an in-depth topic. I'm going to explain you a wonderful concepts throughout this inheritance tutorial. Now let's go ahead and see the next topic in action, that is the super constructor and the super keyword. The super constructor refers to the constructor of an immediate superclass and is used to execute the constructor of a subclass, constructor of a superclass from within the constructor of a subclass. Let's go ahead and see the concept of the super constructor with a hands-on example. Okay, what I'm doing is window perspective and then reset perspective. You click yes button there. Okay, this is all reset. Let's say for the sake of simplicity, I don't want, maybe I use it here itself. Consider the customer class. Inside the customer class, we have a constructor. It is not there. We have a default constructor in every class. If we don't declare a constructor, I don't know whether you remember or not. I have explained very clearly with an example in the constructors topic. So let's say we have a default constructor. What I'm doing is I'm generating, typing a default constructor here, public customer. Even though we don't type, it is there. For the sake of explanation, I'm typing it manually here. So system.order. So customer class constructor, something like this one. Okay, this is the place. And then what I want to do is I want to go to the child class, that is the standard customer or the premium customer. We can choose any one for the sake of this is a small topic. Super class constructor is not a small topic. So what I want to do is I want to create a customer to the standard customer as well, constructor to the standard customer class as well. Inside this class, what I want to do is I say super. So this statement makes a call to the super class constructor and executes. This makes a call to the super class constructor. In our example, the super class is the customer class. Now this is the standard customer. Let's say what I want to do is standard customer, constructor, standard customer constructor, something like this one. I save this one. Let me do the same thing for the premium customer. Let's say I go to the premium customer class. Where is that? It is here. I want to create a constructor to this premium customer class. What is that? Public and then premium customer. And inside this one, I want to write the same code this class makes. And here I want to change this one to premium customer. This is how it looks like. Now, when we execute the customer inheritance program, we should first of all see the output of the customer. What happens is, let's go ahead to the customer inheritance program. It is here, customer inheritance main. What happens is, when this part of the constructor is executed, this will go to this part. What is this part? It comes here, and this part will go to the constructor of the immediate superclass. In our case, the immediate superclass of the standard customer is the customer class. So this portion will take the execution flow to this portion. It will execute this part, and after this one is successfully completed, it will come back to this part and it will continue from here. Similarly, it does the same thing in case of the premium customer example as well. Now let's see the output. Save this program and then save and then run as the Java application, something like this one. You see here, in case of the standard customer, we got the output. In case of the premium customer also, we got the constructor executed. That is, the constructor, the super constructor is used to execute the constructor of an immediate superclass from within the constructor of the subclass. So this is how it works. Let's go ahead and see the concept of something called the super keyword. To demonstrate the super keyword, I just want to take some basic example for now, and when we switch to the correct topic, I'll demonstrate it with some other real-time example. So let's go ahead and let me take some the basic example, such as class names such as ABC. Okay, let me take some class names. Here what I'm doing is creating a class called as test. I'm creating a class called as test1, and inside this one I want to declare a couple of variables, one variable and one method. Private, let's say I say integer I equal to 10, and then let's say public void method1 m1. Then what I do is system.out.println inside method 1 of superclass test1, inside method 1 of superclass of test1. And then what I do is, here itself what I'm doing is class test2, and this one extends a test1 class. And here what I'm doing, so the test2 class inherits the test1 class. The test2 class redeclares the same numbers here. Once again, you watch here, it has declared. Now let me put it as 20, and we have the same declaration, int I10 and int I20. Public void method1, once again it is declared in the child class. Okay, we call this as method overriding, which we'll see in the next few minutes. Inside the method 1 of the subclass test2, what I'm talking here is subclass test2. This is how we work on this. So subclass test2. Now watch here, the child class is redeclaring the variables and methods with the same names of its parent class. The child class is redeclaring the variables and methods with the same name of its parent class. So if you want to execute the superclass members from within the child class, what you can do inside the method, what I'm doing is super.m1. So this portion, this statement will execute the m1 of the superclass. That is the meaning of this one. So you want to change it, you can change it. So now let's say I want to print it. You watch here. After the system.println command, I want to say, let's say I is equal to then plus I, and then one more print command. What I say, let's say super.I is equal to, and then plus super.I. So please watch here, simply mentioning I, this will print this 20, and simply mentioning super.I, this will print this current value of I, that is. So that is the meaning of the super keyword. If you want to look here, the super keyword is used to refer to the superclass members such as variables and methods from within the code of the subclass in case of the duplicate names in both the superclass and the subclass. So that is what we are trying to understand. Now let me create a main method here. Let's say class super main. Let's say super main, and then here I want to say the main method. Inside this one, I want to create an object of the subclass test2 t1 is equal to new test2. If you remember, we need not have an object reference for temporary requirements. New test2.m1 is what I'm saying. So this portion creates an object of the test2, which is a subclass of the test1. and on that object we are making a call to M1. This portion will go ahead and trigger the method execution of this one, and from here this portion will go ahead and execute this part and come back to this, and this will print this method, and after that this prints 20 and this prints 10. And this is the meaning of the super keyword. This is not a special topic, and that's the reason I have chosen these basic examples. Wherever applicable, I will demonstrate you with this particular one. So maybe this is not having the main class. Let's say cut this portion, and I will create one more special class, that is the super main. Let's say a new class, and the class name is super main, and here I select all and then paste it here. Now let me run this program, right click and then run as, and then we get the output something like this one. You see, first of all, inside the method one of the super class test1, and inside the method one of the subclass test2, I equal to 10 and super.I equal to 20. This is how we make use of the super constructor and super keyword. Now let's understand the next topic related to inheritance, that is called method overriding. Method overriding is a context in which a subclass redeclares the method of its superclass with the same signature. Let's understand the meaning of this statement, which means the same syntax means same return type, same method name, same number of parameters, same data type sequence of parameters, everything same. That is called method overriding. So as an example code snippet you can watch here, we have the employee superclass, which has a public void calculate net salary method, and the contract employee, which is a subclass of employee, permanent employee, which is a subclass of employee. Both the child classes, that is contract employee class and the permanent employee class, both of these classes have redeclared the method of the employee parent class with the same syntax. The method name is same, the return type is same, and of course the parameters is 0 in this case. However, if the parameters are also there, they should be same. So that's the reason these two methods are called overriding methods. Now let's see the method overriding hands-on code examples. Let's apply the concept of method overriding to the previously understood inheritance examples: employee, permanent employee, contract employee, customer, standard customer, premium customer, flight ticket, business class ticket, and economy class ticket. So let's apply the method overriding concept to these examples. So let me open the Eclipse environment and go back to the previous class examples. This is the employee parent class, inside which we have something called as employee number, employee name, gross salary. Here what I do is I declare one method. For example, I declare it here. Let's say the method name, let's say public void calculate net salary, public void calculate net salary, and this method has no code inside that. Okay, now let's go ahead to the child classes. Now let's say I go to the permanent employee class. Inside this one, I declare the permanent employee class. I once again declare the same method, that is public void calculate net salary method. The calculate net salary method of the permanent employee class. Here what we do is we calculate the details of the net salary and print them. So what shall I do here? First of all, I say double gross salary is equal to get the gross salary, we make use of the get gross salary of the parent class. This is the parent class. If you remember, from this class we get all the methods inherited into this class. That means it is as if we can call the get gross salary method here as if we have declared in the child class itself. So this method will go and execute the get gross salary method declared in this class. And if you look at the get gross salary method, we have this method is returning the gross salary. Okay, now what we'll do is get gross salary will return and store it here. What we do is we calculate the deductions. For example, double deductions is equal to let's say income tax, let's say income tax plus PF plus insurance. These three are the deductions that we want to deduct. And then double net salary is equal to gross salary minus deductions, gross salary minus deductions. So this is the formula to calculate the gross salary of the permanent employee. This formula is different from the formula that is used to calculate the net salary of the contract employee. We'll see the code example of the contract employee calculate net salary in the next few minutes. Now, after we have calculated the gross salary, deductions, and net salary, let's go ahead and print the details. Now, System.out.println, okay, employee salary details, okay, net salary details of the what is that, permanent employee, net salary details of the permanent employee. This is how we do that. And now after this print command, let's print all the details. What is that? We get the employee code. First we print the employee number, then give a space, and then let's say we print the employee name, and then after that we print the gross salary. Let's say we print the employee number and name, and then System.out.println. So let me improve the output with more quality. Let's say this is employee number is equal to something like this one. And then let me close this print command here, and let me print all the details very clearly one by one. So here what I do is System.out.println employee name equal to get employee name. If you remember, I told you many number of times, these are the methods that are inherited into the permanent employee class from the superclass employee. Okay, that is called inheritance. Now what I'm doing is I'm printing other details like System.out.println, and I say gross salary is equal to, and then plus gross salary. We have the gross salary locally available here. And then what I want to do is I want to print deductions is equal to the deductions that have been computed in the previous statement, that is deductions, something like this one. And again System.out.println, and the next one I want to say is net salary after all the deductions. Okay, net salary that is equal to, and then let's say plus sign, and then net salary. So this is how we calculate the net salary. However, it's not a strict calculation related to the net salary as per the industry standard. It's just blind calculation, just to demonstrate the concept of the method overriding, how it looks like, and how the formula is different from permanent employee to the contract employee. So this is how it works with the contract permanent employee calculate net salary method. Let's go ahead and do the same thing with the full permanent employee contract employee class here. Let's go ahead and then what we do is inside this place, let's declare the same method once again, method overriding. Please don't get confused. Calculate net salary. Once again the same method, please, same method, same spelling, same number of parameters, same return types, everything same. Right, so what I do here is once again I get the gross salary from the this one double gross salary. Okay, double gross salary, let's say double gross salary is equal to, I don't think we use gross salary here, but let me check. If we don't use, just ignore that. Okay, now what we do is let's say double deductions. We don't have so many things here. Double net salary is equal to gross salary minus deductions. Okay, deductions. These deductions can be some percentage. What we do is we calculate some deductions here. What is that? Double deductions is equal to what we say is gross salary minus gross salary minus gross salary into, that is multiplied by, let's say 10 divided by 100. I will again take this one into another parenthesis, and this is how it works. So what we are doing is we are taking the actual gross salary. From this gross salary we are deducting 10%. So what we do is we get the deduction here. So this is a gross salary into 10%. This is how we are doing that one. So maybe a small correction, this one. Okay, this is how it looks like. Okay, so that's where it works, right? Something that, let me some small formula problem here. What I say, gross salary multiplied by 10, okay, divided by 100. This entire thing goes here. That's the correction, right? So we are done now. Now what we do is double net salary is equal to gross salary minus deductions. If you look at the formula difference in calculating the net salary between the permanent employee and the contract employee, the difference is in the formula. The contract employee has just a fixed set of 10% deduction, whereas the permanent employee has various components to be deducted, such as income tax, PF, insurance, gratuity, and much more details. This is how it works. Now let's go ahead and print the details of this one, net salary details of the what do you say, contract employee. Here what I say is net salary details of, here what I do is I copied and pasted it here. What is that? Contract employee. In the contract employee, employee number and employee name will be same, gross salary will be same, deductions will be the local deductions, net salary almost same. That's it. Now that is how this is called method overriding. Method overriding is used to achieve something called as polymorphism, which we will understand in the next few minutes. Okay, and the logic, the idea of the polymorphism is the logic to achieve something is different in both the child classes. This is the concept of the method overriding. Now let's go ahead and create let's go to the inheritance main Java program. Here what I'm doing is I'm going to the last statement here. What I'm doing is System.out.println. I'm just going to this one, and then what I'm doing here is System.out.println net salary. Let's say I'm just directly I can print that object. If you remember, this is C1 dot. This is what is that object name? P1 and standard customer. Sorry for that. It's not a customer program. This is an employee program, right? So where is that employee inherit demo one? This is employee inherit CE1 and this one. So here what I want to do is let's say I print some lines in here, and then what I want to see, CE1 dot calculate net salary. So this is printing the calculate net salary, and again I want to calculate print one more line, and then PE1 dot calculate net salary. If you remember, the gross salary has already been set to the permanent employee and the contract employee in the previous code examples. If you want to re-understand the program, you can go back and then rewatch that particular portion. Now let me save and execute this program. We get the output something like this one. You see here we got the net salary details of the contract employee. We have 101, and then some employee name, the gross salary, the deductions are some 10%, something like 9,000. That's okay. Net salary is equal to 1,000, and this is 102, and we have a guest and 15,000 reductions. So this is so that is to demonstrate the what do you see, the concept of the method overriding. Please try to understand one more time. Method overriding means a method, a child class redeclares the method of its parent class with the same syntax, everything same, method name same, return type same, number of parameters same. However, in case of public, private, protected, there is some rules we need to understand that we will see later. Okay, with respect to method overriding. Now let's go ahead and see the next example of method overriding with respect to customer, standard customer, and premium customer. After finishing this one, we'll see the method overriding example to ticket, business class ticket, and economy class ticket. So let me continue with the standard customer class. Let me open the first of all, I go to the customer class. Inside the customer class, what I want to do is I want to declare a method that has to be overridden by both the standard customer and the premium customer classes. So let's say public void, let's say calculate discount. If you understand the general business logic, business logic of calculating the discount to the an unpaid customer, otherwise the standard customer, is little low than the discount that is given to the what do you say, the premium customer. Okay, let me do that here. So what I do is I'll go to the standard customer class. I copy this method, and then I go to the standard customer class. Inside the standard customer class, I want to add that method here. You watch here, I'm adding it here. Now inside this calculate discount, what I'm doing is I want to get the product price and all that stuff. So what we do is we add few more methods here, a few more details here. What is that? Private integer, private double product price, private double product price, and then let's say this is a product price. Let me generate the getters and setters. You can place the mouse pointer over the variable name and you can locate something called as create getter and setter for the product price. When you click on this one, we are prompted with this screen, and when you click OK here, the getters and setters are added here. So at the now it is added here. So what we are doing is in the standard customer, what we do is we get the product price here. So what do you say? Double product price is equal to get product price. So please do try to understand this get product price is a method that is declared in the parent class customer. That means from here the method is inherited, it is copied into this method. So we are calling this method, this method will go ahead and call this particular get product price method. This return product price will give us the value that is stored inside this product price. Okay, and after getting the product price, we want to apply some discount. So how do you do that? Is something like this one. Discount percent is equal to let's say discount applied discount is equal to, let's say, product price minus, and then what we do is product price multiplied by, let's say, some 5% of discount divided by 100. This will entirely go here, something like this one. So we are applying not this one, sorry about that. Product price, this is product price and this one, and then double, what you say is price after discount is equal to product price minus discount. Okay, we have first of all calculated the discount, and then this is an extra item. That's okay, no problem. We have first of all calculated the discount, and product price is the actual price of the product. Product price minus discount, we get the price after discount. Now let's display the details here. System.out.println, the product details, the price details of standard customer, and what are the details that we want to print here? System.out.println, customer ID is equal to, and then plus get customer ID. Please try to understand these methods such as get customer ID, get product price. These are all the methods which are inherited from the parent class. So we are getting the customer ID details here. Once again, what I'm doing is customer name, let's say customer name is equal to something called as get customer name. Once again, this is the method that is inherited from the parent class, something like this one. And once again, we want to print something like product price is there. Actually, this is product price. This product price is equal to, let's say, plus product price. We have it locally in the variable. And then this product price is nothing but this product price. And then we want to display this one as well as this one. So actual product price, we give it actual product price, something like this one. And then system.out.println, and then discount applied is equal to the discount that we have calculated just now in the previous statement. If you remember, this is the discount that is applied, and then system.out.println, and then price after discount. So after applying the discount, this is the actual price that the customer has to pay the company, to the shopkeeper. That is the price after discount, and this is how it works with here. Now let's go ahead and repeat this one to the what do you say? It is almost same to the premium customer as well, but the difference is the premium customers are given little more discount than the standard customers. So I copy this entire part and I put it in entirely inside the premium customer.java file. Where is the premium customer Java file? It is here. So from here I put it there, copy and paste it here. Now the price details of premium customer, and it is almost, this is 10%, for example, double than the this one. So this is the difference between calculating the discount for this one. If you want, I can add one more example to the customer, standard customer and premium customer. What I do is I will add one more method, that demonstrate method overriding to the same example. Public void, let's say delivery date, delivery speed, and delivery speed is one of the method, and the delivery speed to the standard customer is if is late than that of the delivery speed of the premium customer, we'll do that. So Control C here, and then let's take it to the standard customer here. And then what I do is System.out.println, the product will be delivered. Product will be delivered in 7 days. Okay, so this is a premium customer, standard customer. Copy this one, and then what I do is I paste it here. What I'm doing is the delivery speed, the product will be delivered. This product, this customer is eligible for overnight delivery. So what I do is I type that sentence here. Let's say this customer is eligible for overnight shipping. Okay, and then the product is delivered. The product will be delivered next day itself. The product will be. So that's the difference between the premium customer and the standard customer in the regular business transactions. Now let's go ahead and see the inheritance main program in case of the customer. So what I do is, first of all, I need to set the customer product price or something like S1 dot set product price. So let's say some 250, or let's say some 500, and this, let's say the same product price to the premium customers product as well. Let's say P1 dot set product price, let's say some 500. And after this one, at the bottom of the screen, I want to print the details such as system dot, not this one, what is that? That is premium standard customer dot calculate discount and standard customer dot delivery speed. And once again, I want to print a dash line there, and then I want to do the same thing to the what do you say this is for the premium customer P1 and P1. So this way we can write as many methods, as many classes. This is to I'm trying my best to give you the best possible examples, real world examples that you will hardly find across the internet, right? So let me save this and then execute this one. Now let me run this example, right? Something like this one. You see, we have the these details are available. Customer, the price details of the premium customer are 102. Actual product price is 500. Discount applied is this one, and price after discounts is this one. And now you see we have 5% applied, and the price after discount is 475. That's the difference. And if you see this one, this is a delivery speed of the product. The product will be delivered in 7 days, and here the delivered product will be delivered in the next day itself. So that is the difference between the method overriding logic of two different child classes. Both of them will have different programming logic, different formula to calculate the actual requirement. So that's the actual idea of the method overriding. Now let's go ahead and see the next example of the method overriding, that is ticket, business class ticket and economy class ticket. So let's go ahead to the ticket class example. Now let me take to the flight ticket class here. What I want to do is I want to declare one method that has to be overridden by the child methods, that child classes, public void, let's say show benefits. Inside this one, what I want to do is this is nothing. The parent class has nothing code. In all the examples, if you notice, there is no code in the method of the parent class. We'll see the reason why it has no code and how do we solve this problem in the next few minutes. A topic called as abstract methods. Now I will go and just copy and paste this one in the let's say business class ticket. In the business class ticket, I will paste it here. And then what I do is the business class ticket customers have so many benefits that are not applicable to the economy class ticket. Now let me print all those details. So here, business class ticket benefits, business class ticket benefits is something like this one. I want to print, let's say system priority checking. Check-in type is equal to, boarding check-in type is equal to let's say priority check-in, and then boarding type is equal to priority boarding. Wherever we go, business class has the first priority for check-in, for boarding and all that stuff. Okay, priority boarding. And the seating facility for the seating is equal to luxury seating. So because they pay more, isn't it? So that's the reason they have so many benefits. System.out.println, food is equal to unlimited free food and drinks. This is how the difference between business class ticket and economy class ticket. So I guess you all know the experience, you all have the experience of this one. So let me copy and paste this one into the economy class ticket and just change the output wherever applicable. This is the business class, and then economy class ticket is here. What I do is, I think there is okay, I see here. Now what I do is I paste it here, and then here I want to change it to economy class ticket. Economy class ticket benefits check-in type is equal to standard check-in. It's not priority check-in, it is standard check-in, and it is standard boarding, and this is regular seating, normal seating. Okay, for food is equal to paid food and drinks, so that's how it works. Now let's go ahead and see the main function of this one, that is flight ticket inheritance admin main.java. Here what I do is I just print one empty line here, and now what I do is what is that economy E1 economy class ticket dot show benefits. Once again I copy these two lines and then paste it to, and here what I say, business class B1 dot show benefits. Apart from the previously understood example, this is an added code to the existing code. Now let me run as the Java application, and if you look at the output, you see we got the initial details. Apart from that, we got the economy class ticket benefits and business class ticket benefits. So that is the process how we achieve method overriding. All are 100% real world examples, nothing like animal, bird, okay, a shape, circle, nothing like that. So very real world examples. Please do not miss learning these topics, very important, very clearly explained with a lot of wonderful real world examples. Now let's understand the reason why do we use method overriding. Method overriding is used to achieve polymorphism, and polymorphism is an approach in object-oriented programming using which an object of a class behaves differently at different times. As an example, an object of the employee class behaves as permanent employee at some point of time in execution, and the same employee class object behaves like contract employee at some other point of time in execution. Similarly, an object of the customer class behaves like standard customer at some time, and the same customer class object behaves like premium customer at some other point of time in execution. Now let's go ahead and see the syntax. How do we achieve polymorphism? In order to achieve polymorphism, we make use of a special syntax which contains a statement called as a superclass object reference can point to an object of its subclass. Let's understand this statement with an example. Consider we have a class employee which has a calculate net salary method, and the employee class has two subclasses which are permanent employee and contract employee. Both subclasses permanent employee and contract employee override the calculate net salary method of the superclass employee. Now let's understand there is an object reference to the superclass employee, that is employee E. The object reference E currently points to no object. That means it is null at the moment. But what we are trying to say here is this is an object reference of the superclass which can point to an object of any of its subclass. The subclasses of employee in our example are permanent employee and contract employee, which means this object reference E can point to an object of the permanent employee class as well as an object of the contract employee class. If you look at the diagram, object reference is E, which is a reference that belongs to a superclass, whereas it is pointing to an object that belongs to a subclass. Similarly, the same object reference E can point to another subclass of the same superclass employee, that is the contract employee. That means the same E at some point of time can point to permanent employee, at some other point of time can point to contract employee. This behavior of an object reference that points to different object at different times is called polymorphism. And this. Now let's see the hands-on code examples to understand the polymorphism that has been discussed so far. We'll continue the previously started examples on inheritance and method overriding to demonstrate and include the polymorphism feature as well. To work with these examples, let's go ahead to the previously started project, and let me add one new class to the same project. The class name Currently we are working with employee polymorphism example. So what I want to do is I want to add one class called employee service, and to this employee service class, let's say we declare one method, let's say public void public static void, and then salary service, or otherwise let's say show salary. Show salary method, we give one parameter. That parameter, let's say it's an employee class name, object reference e. Please watch carefully. This show salary is a method of the employee service, which is static method. If you remember, static methods, static variables are called or used by the class name dot method name or variable name syntax. I have explained you in the previous lectures. Now let's go ahead and come back to the employee inherit program. In the employee inherit program, what we are actually doing is we are printing the calculate net salary method by directly making a call to the main method. So instead of directly making a call here, let me comment this code source and then add block comment. I have commented here. What I want to do is I want to let's say call the employee employee service. This is a class name which has a static method show salary. To this object reference e, I want to pass an object of this contract employee, which an example is CE1. And then once again, at some other time, I want to pass an object of the, let's say, permanent employee, which is again an object of the permanent employee class in these examples. Let's say we have the object of the contract employee, this is C1, and the object of the permanent employee, which is P1. So how does this one work? So this is the syntax that we use. For example, let's say we have this one coming here. You watch here. This is the code. Watch here. So employee service dot show salary, this one show salary, and here we are passing this CE1. This CE1 is an object of the contract employee, which is a subclass object. This CE1 goes and it is captured into this superclass object reference E. Okay, and inside this method, what we do is E dot calculate net salary. That means during the time this statement is executed, that is statement number 39, line number 30, the statement at line number 39, when this one is executed, the object that is passed into this E is contract employee. And then this E, because this E points to contract employee, this calculate net salary will execute calculate net salary version of the contract employee class. And after this one is completed, when this one is executed, what happens is during the time this one is executed, this object permanent employee is passed into this E. That means this E sometimes behaves as contract employee until the time the statement number 39 is executed, and some other time this one behaves as permanent employee until the time the statement number 40 is executed. When statement number 39 is executed, this will point and execute the calculate net salary version of the contract employee, and statement number 40 is executed, this will point to the permanent employee and it will execute the calculate net salary version of the permanent employee. And this is called polymorphism. Now let's go ahead and close this file, and then let me run this, save and run this program, and we get the output as expected. Right, so that's the meaning of the polymorphism with the code example. Permanent details, net salary details of the contract employee, and net salary details of the permanent employee. So this is the meaning of polymorphism. Now let's go ahead and see the same example, same concept with the other examples. Calculate discount with the customer class example, and the show benefits with the ticket class example. So let's go ahead and add the new class customer service. What I do is create a new class, and the new class name is customer service. I hope you understood it clearly. Customer service, and inside this one, as usual, we add one static method, public static void, let's say customer, what is the example name? Customer discount, show discount or something, show discount. Inside this one, what should we use? Customer class, the parent class. And then this can point to standard customer, and this can point to the this can point to the premium customer. And this C has to come here, C dot show calculate discount, C dot calculate discount. And what are the changes that we should do? If you remember, what we have to do is we have to go to the customer inherit main method. And then what we have to do is we have to comment these lines of code. then go to source, add block comment. We want, if you want, we can calculate delivery speed also. Here, what shall we do? Customer service dot show discount, something like this one. And here in place of C, we will pass the standard customer, that is S1, at some point of time. And again, to this one more time, what we do is customer service dot show discount, and then we pass in something called as what do you say, P1, a premium customer. I'm not demonstrating delivery speed. You can do it as your practice and assignment. Of course, you will be able to do that by looking at these examples. That makes sense. Now let me save and execute this program. That is, the output is displayed. So we got the output as displayed. Okay, so discounted price and all that. So that is done. Now let's go ahead and do the same process for the next example. That is the flight ticket example. Let's come back here. And then what I want to do is create a new class, and the class name is something called as flight service, FLIGHT, and then flight service. And to the flight service, as usual, let me create a static method, that is public static void, and then show benefits method, the same method name I'm taking here. Let's say something like this one. Inside this one, I'm taking the parent class, that is flight ticket FT, and this FT will sometimes point to premium business class ticket, and then some other times it points to what do you say, economy class ticket. So when this FT points to business class ticket, the benefits that are printed belong to the business class, and when this FT points to what do you say, if this FT points to economy class ticket, the benefits that are printed that belong to the economy class ticket. So let's go ahead and change the inherit method of the, what do you say, flight ticket inherit main, flight ticket inherit main. So here what I'm doing is to just commenting these previously developed code, source, add block comment, and then save here. Now what I want to do is that's a flight service, the flight service, not this one, flight service dot show benefits. And to this one, sometimes we want to pass economy class ticket even, and some other time we want to pass the what do you say, dot show benefits, that is business class ticket B1, something like this one. Now we'll execute this program. We get the output as expected, similar to the previous two examples. That's also economy class ticket details. These are the things we have. And then we have the business class ticket benefits. These are the things we have. Something like this one, we can use polymorphism. I'm trying my best to give you the real world examples to understand the concept. Where should they be exactly used? Okay, that's about polymorphism and how do we achieve polymorphism, and more importantly, the syntax of this statement called as superclass object reference pointing to subclass object. So that's about that. We'll continue with the next topic. Now let's understand the next topic, the instance of operator. The instance of operator is used to check whether an object reference points to a specific class object. Consider this example code snippet. We have the employee class object reference E. This E can point to permanent employee or contract employee object. So in order to execute certain action, certain code, we want to check whether E is currently pointing to permanent employee or contract employee. So in order to check whether E points to permanent employee or contract employee, we make use of the instance of operator. If you notice here, the instance of it is a single word. There is no space in between. So if E instance of space followed by that class name, if E points to the object of the permanent employee, this particular if condition returns to true. And based on the return value, we want to take some action. And similarly is the case with the next example. If E instance of contract employee, we want to execute some action depending upon the return value. That's the meaning of the instance of operator. Let's go ahead and see the instance of operator hands-on example. So what we do is we go to the this one, go to the service class, employee service class. So here what we do is now let's say I want to say if E instance of permanent employee, then I want to say System.out.println now printing net salary details, now printing net salary details of permanent employee, now printing the net salary details of permanent employee. What I do is else if E instance of contract employee, then I want to print the similar text, just the class name different. Now printing the net salary details of contract employee. This is how it works. Let's go ahead and run this inheritance program once again, and then we can see the output here. Now, when this one is executed, we get now printing contract employee. And when this one is executed, we'll see the output now printing permanent employee, right? Something like this one. You can see that now printing net salary details of contract employee, and now printing the net salary details of permanent employee. So that's the way we do it. So let's do the same thing for the remaining two examples. Let me go to the customer inherit main, not this one, customer service. So what we have to do is inside this one, I check if C instance of, let's say, premium customer, and then I say now printing discount details of premium customer. Now printing the discount details of premium customer. Else if C instance of what do you say, standard customer, and then we want to print almost the same print command, now printing the details of discount details of standard customer. And let's go ahead and run the customer inherit main. Here when this one is executed, instance of points to S1, we get true, something like that. Now let me execute this program. We get the details. You can please watch it here. Now printing the discount details of premium customer and standard customer. And similarly, let's do the same thing to the ticket class example, which is the flight service. It is flight services here. Then we want to do that instance of if flight ticket instance of, then let's say economy class ticket, then what we do is System.out.println, now printing benefits of economy class ticket, else if FT instance of business class ticket, then we want to print the similar text. Copy this one and I paste it here, now printing the business class ticket, something like this one. So that is the meaning and purpose of the instance of operator flight ticket inherit. Let's go ahead and run this program, this inheritance program. Let me save and execute this program. So this is done. So that's about the instance of operator that is completed. These are the examples that we have watched. Okay, now let's understand the next topic called as object downcasting, which is very important. To understand this statement, we'll see this sentence. When a superclass object reference points to an object of its subclass, then it cannot access those members of the subclass which are exclusively declared in the subclass. You remember this statement, right? The previous one, polymorphism, superclass object reference points to subclass object. That is important. If you forget that, you can go ahead and watch it again as long as you feel comfort. Now, what you see is to understand this sentence, let's consider this problem statement. To understand the statement, consider we have the employee class and calculate net salary, get base salary, sets base salary, something like this one is there. Now we have the permanent employee class. The permanent employee class inherits the features of the employee parent class, that is calculate base salary, and base salary is the inherited one. Net salary is the overriding method. Okay, this is the overriding method, and here this get PF and set PF, these are the methods which are exclusively declared by the child class, that is the permanent class, permanent employee class. That's the meaning of the exclusive declared members. Now, when a superclass object reference, such as employee class object reference, when it points to an object of the permanent employee class, that object reference E has no access to these exclusively declared members, such as get PF, set PF, or otherwise PF variable, and so on. To understand this one, let's say we have the employee service, and to this employee service we have a show net salary method, and this E it points to the E instance of permanent employee. That means E is superclass object reference pointing to an object of the subclass. Now this E has no access to get PF because get PF is exclusively declared member of the child class. Please watch the sentence again. I'm scrolling up here. When a superclass object reference points to an object of its subclass, then it cannot access those members of the subclass which are exclusively declared in the subclass. So that is the context here. So these members are the exclusively declared members within the subclass. These members such as get PF, set PF, etc. are not accessible by the superclass object reference. So that is the thing we are trying to understand. E is an object reference of the superclass. It is pointing to an object of the subclass. In this situation, object reference E has no access to this E dot get PF, because this get PF is an exclusively declared member of this permanent employee. Okay, so this is the problem. You see here, we are passing employee service dot show net salary. From here, we are passing this one, and this employee, this one belongs to this one. So in this case, this is an error. So to solve this problem, what we have to do is we have to downcast this object reference E to the object reference of permanent employee. We have to downcast this object reference E to the object reference of the permanent employee class. And this is how it looks like. Object downcasting syntax and example. The syntax to downcast an object reference is this: superclass object reference, subclass name within the parenthesis in the left hand side, and the equals left hand side of the equals and subclass object reference. And this is the example: permanent employee PE1 equal to E of permanent employee, and this is the superclass object reference, and this is the subclass name. So this object reference E is downcasted into an object reference of the permanent employee, and then we get a PE1 there. And next we have the similar example. E is downcasted into contract employee CE1. Let's go ahead and see the previous example now corrected. In the same example, what is happening is we are downcasting this object reference E, this one. This object reference E, we are downcasting into permanent employee PE1. And this time we are making access to get PF method using PE1, but not using E dot get PF. So that is the important topic that you need to understand about object downcasting. Very important point, please. Now let's see the hands-on code example of object downcasting. We'll continue with the previous examples. Now let's begin with the employee class example. Let's go ahead to the service class, employee service class. We have employee service class here. So let's say we want to print the employee name and all that stuff here. For example, we want to, let's say, I cannot directly print E dot, let's say E dot get EMP name. Okay, this works well, but this specific data that is there in the, let's say, if you go to the contract employee class, it has deductions. This stuff is not accessible to this one. Employee service, this is not possible. We cannot use E dot get contract duration. This is not possible. This is an error. This is an error because this belongs to contract employee exclusive member. So we need to downcast this E, something like this one. Let me demonstrate this one. So let's say I put it here. What I do is, so I'll take one separate method rather. Here, public static void downcast demo employee E, and then here I want to downcast that one to this one. If E instance of permanent employee, then I want to downcast that one. Permanent employee PE1 is equal to permanent employee E, then System.out.println E dot, let's say income tax, something like this one. Sorry, PE1 dot get income tax or insurance or some other details, something like this one. System.out.println PE1 dot get insurance. Like this, we can do that. Else if E instance of contract employee, then we want to downcast E to contract employee. This contract employee CE1 is equal to E, and here we can downcast it there, and then CE1 dot, let's say CE1, let me take it as CE1, and CE1 dot get contract duration, and then let's say CE1 dot get deductions or something. So if you notice here, we are making use of the instance of operator. If it is permanent employee, then we are downcasting this object reference parent class to the child class object reference, something like this one. And then using this one, we are getting the details that are exclusively declared in PE1. If you remember, get income tax and get insurance, these methods are the exclusively declared methods of the permanent employee. They don't belong to the parent class employee. So the parent class object reference cannot access these methods. Similarly here as well. So that's how it works. Let's go ahead and to the employee inherit main and then check the details, something like this one. For now, what I'll do is I'll comment this one as well. Okay. So source and then add block comment. And then what I do is employee service dot let's say downcast demo. I give CE1 there, and similarly, and then employee service. Let's see the output for the CE1 for now, and then we'll see the output later. Okay, let me execute this one. We get the downcast demo. This is the contract employee details. We got it right. So similarly, let's do the same thing to the PE1. I give PE1 there, PE1. Okay, save this one, and then let me close. Something happened. The other file got closed. Employee inherit 1. This has to be PE1 earlier. Yeah, now if I execute this one, it will get the details. Okay, permanent employee details. So that's how the downcasting is used. I think you can use the same thing for the other programs as a practice yourself using the demonstration done. Now let's move on and see the next topic called as method overriding. Method overriding, preventing method overriding. We can prevent a method from being overridden by declaring it as final keyword. Let's say we are declaring the method M1 in the class test as final. When a method is declared as final, a child class cannot override this one. So this is a compilation failure. I'll show you this in Notepad, a command prompt example. Let's say cd/cd java-program. Okay, and then let's say Notepad test. Let's say I will delete anything test star if it is already there. Now I create a Notepad file, Notepad test1.java. Now inside this one, I want to create public class test1. Inside this class, what I want to declare is final void method1, and let's say something like this one, and then System.out.println, and in here I say M1 of test1 class, some text I'm printing here, and that is done. I'm going to the next class, that is class test2, and this test2 extends a test1, and the test1 it is extending, and test2 is trying to override, you remember, right? Declaring the method of the super class with same syntax. The return type is same, everything is same. Now if I compile this one, this won't compile because we cannot override the method M1 of the parent class. Why? Because it is final. That's the meaning of preventing method overriding. Now Java C, what is that? Test1.java. We compile that. It should not get compiled. Method M1 in test2 cannot override M1 in test1. Because overridden method is final, so that is final. That is about the overriding methods, preventing method overriding. The next thing is preventing method. This is done. Preventing inheritance. To prevent a class from being inherited, we use the declare the class as final. There is some typing mistake, forget about that. So public final class. If we declare a class, this cannot be extended. Let's do the same thing for the existing example. So I put it here as final, and then if you declare a class as final, that cannot be extended. Now let me compile this one. I have saved that file, Java C test1.java. Now I'm compiling that. It is okay. it cannot inherit from a final test one. So that's the meaning of the preventing method overriding and preventing inheritance. Now let's understand the next topic in Java, that is abstract method, abstract class, both which are declared using the abstract keyword. If a method has just method declaration but no code implementation, then it is called as an abstract method. And a class which contains at least one abstract method inside it is called an abstract class. We use the abstract keyword to declare abstract methods and abstract classes. You can see the example code snippet here. The welcome class has two methods, greet and the show full name method. The show full name method has some code inside, but the greet method has no code. It just has declaration, and therefore we have declared it abstract using the abstract keyword. And the welcome class has at least one abstract method, therefore we have declared the class as abstract. Now let's go ahead and see the hands-on code example for this welcome class. So let me create a new project. In the new project, let's say abstract basic project 1. And in this one, I want to create a new class. The class name, let's say welcome. And in this one, I want to declare something called abstract method, public abstract void greet. So you can see the example string message is there, string message. And then if you see here, the moment we add abstract keyword, there is one abstract method and there is an error. We can place the mouse there, make type welcome as abstract. Now this has become abstract. So the second method is optional. If you want, I will type it. Okay, public void show full name. This is the basic example, please. Real world examples we'll see after this example. The show full name, let's take string f name and string last name, and then let's say System.out.println hello plus space, and then f name, then space, and then l name. Okay, something like this one. Now this is the declaration part. In order to use this abstract class, we cannot create an object to this abstract class. What I'm trying to say here is we cannot create object to the welcome class. That means, for example, we have a main method here. We have the main method, which if you try to create an object to an abstract class, it gives us an error. Welcome, let's say object 1 is equal to new welcome. The reason that we cannot create object to an abstract class is the abstract class is not complete. This is, it does not have complete functionality. It has only partial functionality. So then that's the reason there is no point in creating an object which has a partial functionality. So that's the reason we cannot create it. So then how do we make use of this method, which is non-abstract? In that case, what we do is we create a child class to an abstract class, and then override this abstract method with full code functionality, and then create object of that class. What I'm trying to say here is we create a child class welcome child, some names, class welcome child, extends welcome. Then inside this welcome child, we override the method, this greeting method you see here. You place the mouse there, add unimplemented methods, and then we get the override. You all remember, right? Overriding method, overriding, same method, everything same. But this time it is not abstract. We are having method code inside the greet. Okay, we have curly brackets open and close here. Here is what we have to type the code. Let's say I type some greeting, hello or something, hello or something here, something like this when I do this. Right, so hello from greet method, something from greet method. I remind you people once again, this is a basic example. Once you understand the concept of abstract class and the child class of an abstract class, then we can switch the previously discussed examples such as customer, employee, and flight ticket examples. So this is how it works. We will now create a welcome child object and then execute that. So now the main method, now inside the main method, see the welcome child class has now two methods. One method that it has overridden, and the second method that this one is copied and pasted into this class from this class, that is inherited as it is. So what we do is create an object of the welcome class. Welcome w is equal to new welcome child. If you remember, superclass object reference can point to an object of the child class, right? So this is the superclass object, this is the superclass, this is the superclass object reference, and this is pointing to object of the child class. So therefore we can execute the methods. Now what I say is w dot greet, and then greet is taking some message. Okay, hello, I say so here. Let's say this hello I remove here. What I do is let's say message plus space. So w dot greet, and then after that w dot show full name, let's say Rabi, and my last name I type in here, Rabi Tatikunda. And that's all. We can execute this one. Probably I'll cut and paste this one in a separate class file, Java file. I'll cut it here. And then what I do is I create a new class here, the new class name, let's say welcome child, and then I will paste it here, Control S. Now I can execute this program. Right click and then run as Java application. And that's how we create an abstract class, and we declare a child class to an abstract class, and then override the abstract methods with concrete implementation, something like this one. And after that, we create an object of the concrete implementation class and then use the method, something like this one. Now let's go ahead and work with our existing inheritance examples to demonstrate the concept of what does abstract class mean in that particular point. So abstract class, abstract method and class, real world examples, which are nothing but the inheritance examples that we have been following since the last few minutes. If you remember, the parent classes employee, customer, and ticket, these classes have a single method which has no code inside them. If you remember, let me open the inheritance program, and if I open the employee class example for the first time, now if you see here, at first, if I open this one, the calculate net salary method has nothing to do with inside. There is no code inside this method. Okay, when there is no code inside method, what I can do is I can make it as an abstract class, abstract method, semicolon, and then what I do is abstract, right? Now Control S. Now, if this class has at least one abstract method, this class has to be declared as an abstract class, and then that's it. We are done with this one. However, we have already, in order to use the employee class, we need to extend the employee class. We already did that with the help of the full-time employee, that is the permanent employee, as well as the contract employee. So we don't need to do any extra coding here. Just the existing code, we are making changes so that the methods are declared abstract and so on. What is that? We have this one as an abstract method, public, and then abstract, and we have no code in the parent class to place it. So therefore, since we don't have any code in the parent class, I made it as an abstract class. So therefore, this one has to be made abstract. So, and then that's it, done. No changes in the output, no changes in the code, just making a let's say flight ticket as an abstract class and abstract method. The show benefits, let's make it as an abstract method because it has nothing to place inside. So therefore, we just make it as a semicolon, and then we make this class as an abstract class. Okay, please try to understand. I'm repeating, in order to make use of an abstract class, we need to have two steps. Declare one extra class that extends the abstract class, and then override the methods, abstract methods concretely, and then create an object of that class and use it as an example we have used here, right? So what is that? We have declared one extra class that is extending the abstract class. And the step number 2, we have overridden the abstract methods concretely. And then we create an object of that one and then started using those methods. That is how we do that. So that's about abstract class and abstract methods. Let's go ahead and see the next thing, concrete methods and concrete classes. The methods which have implementation are called as concrete methods. And the methods, the classes which have zero abstract methods are called concrete classes. Okay. And more points about abstract class and methods. We cannot create an object of an abstract class. An abstract class can extend other class also, and it can also implement 0 or more interfaces at the same time. We talk about interfaces in the next few minutes, and an abstract class can contain both concrete and abstract methods. An abstract class or an abstract method cannot be declared as final. We cannot declare them as final. Okay, in order to use an abstract class, we have to declare a concrete subclass of an abstract class and override all abstract methods in it. This is the one that we have seen in the welcome abstract class example. This point point number 1, 2, 3, 4, 5. The fifth point is what about how to use an abstract class. And there can be an abstract class with 0 abstract methods inside it. Now let's understand the next topic in Java, that is interfaces. An interface is a collection of abstract methods and constants. And if you notice the second statement, Java version 8 onwards, interfaces can contain special kind of methods called as default methods and static methods. However, the second statement and its explanation is beyond the scope of this particular video. Depending upon the situation, I will possibly upload another video on this topic. Now let's go ahead and see the interface declaration example. We use the interface keyword to declare an interface, public interface, interface name. In our example, checkout is the name of the interface and employee DAO is the interface name. Okay, so and it has one single abstract method, that is the process payment, which takes one parameter of string type, that is the payment mode. Okay, when it comes to employee DAO, the word DAO stands for data access object, and few people pronounce this one as DAO. So altogether, we can pronounce this one as employee DAO. Okay, so the DAO interface is generally used when working with database access such as Oracle or MySQL to store the data, to retrieve the data, etc. However, we are not going to learn database related programming in this particular video. If you're interested, you can watch the JDBC tutorial in Java. In which I explained how to connect with the database and everything in crystal clear example, as well as one project is also explained. Right now, let's go ahead and see the hands-on code example for declaring an interface of the so-called examples list: circle interface, checkout interface, and employee DAO interface. Now, let me create a brand new project. Let me say new Java project, and in here I create interface hyphen project 1. And then I want to declare 3 interfaces as we are trying to understand there. The first interface is control, and this time it is an interface, not a class. The interface name is circle. Let's say for the sake of simplicity, this is the basic example, and the process payment and the DAO are the real world examples. Public abstract void draw circle, public abstract void draw circle. And then this is completed. An interface can have any number of abstract methods. Please, it is not restricted only to single abstract method. Depending upon your requirement, you can add as many abstract methods as required. However, you can also add constants like this one. For example, public static final double pi equal to 3.141, something like this one. This is a static constant. Okay, so interface can contain abstract methods and constants. In this particular example, we are not making use of any constants, and that is the reason I did not add any constant. Now let me create one more interface as per our examples list. The second interface, let's say checkout interface. Okay, the checkout interface is there, and now let me add a method there. What is the method? Public abstract void process payment or process checkout. What is the method we have chosen in our example? Process payment or process account. We can use whatever applicable. Process payment, and then string payment mode, whether the payment is done using the debit card or credit card or internet banking or something else. Now let me create one more interface, that is the employee DAO. Okay, as I told you just now, we are not dealing database programming in this tutorial. If you're interested, you can watch my JDBC tutorial in Java in 45 minutes, followed by another video which demonstrates the real world project case study of database access in Java and Oracle MySQL. So that is done. I want to add one more method here, that is public abstract void add record. Okay, so more strictly speaking, we will add generally we add one object inside this parameter that has to get added to the database. For the sake of simplicity in this example, since we don't have employee class, I'm not using that. Right, so that is completed. We have declared 3 interfaces. Let's go ahead and understand the next topic, that is interface declaration. Hands-on code example has been completed. Now working with interfaces, the implements keyword. Since the interfaces are interfaces contain the abstract methods, we cannot create objects to them. So therefore we cannot use them directly. So in order to work with interfaces, we have to declare a class that implements the interface by using the implements keyword. So to use an interface, we need to declare a class that overrides the methods of that interface. And then we use the implements keyword to do this. As an example syntax you see here, public class name, implements keyword followed by the interface name. One class can implement more than one interface. You can see here public class name implements interface name 1, 2, 3, and so on. And this is the syntax. And if you look at this one, public class credit card checkout implements checkout interface. You watch the implements keyword here. Please watch the statement once again. To use an interface, we need to declare a class. We have declared a class credit card checkout, and that overrides the methods of that interface. So the class credit card checkout has to override the method here. Okay, and that's the example snippet. Okay, now the implements keyword is done. We're working with interfaces, hands-on code examples. Now let's go ahead and implement the 3 interfaces that we have defined above. So first of all, let's go with the circle interface. Now what I'm doing is I'm creating a class. Okay, the class implements what? Circle interface. So I say filled circle. I say filled circle. This is a class, and this class implements which interface, please? It implements the circle interface. Okay, and please remember, when I start saving this one, it shows us the complaint. Thus, this has a compilation error. If a class implements an interface, that class has 2 options to do with. Okay, either this class has to override all the abstract methods that are declared in this interface, or this class has to be declared itself as an abstract class. Either of the 2 options this class has to do. Otherwise, the compiler shows us a compilation error, and that is what we are seeing now. And if I hover the mouse pointer on this error, we'll get the 2 options that I have explained just now. You see here, okay, add unimplemented methods, or otherwise make type filled circle as an abstract. So we want to go for unimplemented methods. When we click on this one, we get the draw circle. And please try to understand, this class which is implementing this interface should definitely override the method. If not, it has to declare itself as an abstract class, public abstract, something like that one. Okay, now it cannot use whatever method name. Let's say draw sir. Okay, this is not a method that is there in the circle interface. Okay, so this class is declaring one method, but this method is not a part of this interface. This class should definitely use the same method. You remember, right? Overriding means everything same, method name same, return type same, everything same. That is the rule you have to follow, right? Now let's say I say some print command in here, System.out.println. Let's say filled circle. Let's say filled circle. Now I close this one. Now let me create one more class that implements the circle interface. That the class name is, let's say, hollow circle. I say there is a hollow circle, and this hollow circle class once again implements what? The circle interface. Implements the circle interface. Again, it has to override the methods. What I do is add unimplemented methods. Here what I'm doing is adding some print command. This is hollow circle. This is hollow circle, something like this one. That's okay. We can keep on adding as many classes, circle classes as required. Now let me go ahead and add one more class to the checkout interface, new class, and the class name is debit card checkout. See how the naming convention is followed here. First we use the class name, and then later we use the interface name, right? So that someone who reads this class name will understand that this is a class that implements this interface. Please always follow the best practices at your best possible. Okay, so public class debit card checkout implements checkout. Public class debit card checkout implements checkout. These are all the best practices that I'm following, and you should also follow in order to learn correctly, right? So add unimplemented methods. For process payment, I want to check whether this payment mode is debit card or something. For now, I'm not checking here. I'm just printing something like this one. Let's say System.out.println payment processed via debit card. Maybe payment done via the debit card. Of course, we can use the if condition and do some additional processing. I'm ignoring that for now. Similarly, what I'm doing is I'm copy pasting this checkout debit card checkout one, copy, and then I'm pasting it here, and then I want to change it to credit card checkout. Credit card Okay, checkout. And here the print command will now be changed to credit card checkout. Payment done via the credit card. So this way we can do as many implementations as required. Now I'm adding one more thing. Let's say net banking checkout, internet banking checkout, net banking checkout. So everywhere you see the suffix checkout is there in all the class names. Okay, the suffix checkout is there, which represents that these classes are implementing this interface. That is best practice I am telling you. Okay, via internet banking. Okay, so as many possible payment modes, you can create as many classes as required. Now let's go ahead and create the implementation classes to the DAO interface. New class, that is the, let's say, memory in-memory employee in-memory employee DAO, and this one implements what? This implements which interface, please? Employee DAO interface, employee DAO interface, if you remember. And in-memory means we are not using any database. We are storing the data temporarily in memory until the program is live. The data will be available. Once the data program is shut down, the data will be erased. That's the reason in-memory employee DAO. Right. So once again, I'm not adding any data here, just a print command. Okay, now here what I'm doing is data stored in memory, something like this one. Now, once again, I want to create one more copy of this one and change the file name to MySQL DAO. Let's say this is MySQL employee DAO, MySQL employee DAO. That means this time we want to store the data in the MySQL database, not in the memory. So actually we are not using database programming here, right? So that's the reason I'm just using the print command. As I told you a couple of times, if you want to learn JDBC programming and how do you store data, access data using database and JDBC Java programming, you can watch the relevant video from my channel. So that is done. Now let's go ahead and create the main classes for each of the topics, such as circle and checkout, as well as the DAO classes. Now let me create a new class. I'll close all the classes for now, right click and then create a new class. The class name for, let's say, circle interface main1. Let's say circle interface main1. Please remember, we cannot create objects to an interface. We can create object references. Let's say circle is an interface, C1 equals to new circle. We cannot create objects of an interface, but we can declare object reference. Please watch, there is a difference between declaration of object reference versus object creation itself. So this statement will not create any object. It is only a declaration object reference. Okay, but when we use the new operator, then its purpose is to create an object. So this portion means creating object. This particular portion means creating object. So that's the difference between object declaration and object creation. We can declare object references, but not object creation for interfaces. But an object reference of an interface can point to an implementation class of that interface. For example, I type it here, an object reference of an interface can point to an object of its implementation class. Something like this is something like super class object reference can point to its subclass, something like that one. So I say circle C1 is equal to new filled circle. Circle C1 is equal to new filled circle. Then I can say C1 dot draw circle, something like this one. So this is currently pointing to filled circle, and therefore the draw circle method fills the output, prints the output filled circle. And then C1 is equal to new hollow circle. You remember, right? Polymorphism. And then C1 dot draw circle. Once again, we have to make use of the service layer of class that we previously understood. We'll do that in the next few minutes. That is about the circle interface main. Let me save and execute this program. We see the output printed follow circle and hollow circle and filled circle. Similarly, let's do the same thing for checkout interfaces. New class, and let's say checkout main, and then inside this main method, inside this class, let's create a main method. Now inside the main method, what we need to do is let's say checkout ck is equal to new credit card checkout, and then ck dot let's say process payment, let's say checkout of a credit card. Of course, we have not used this string internally in the logic of the credit process payment method. That's okay for now, not a problem. And then ck is equal to new debit card checkout and ck dot process payment of debit card. So I mean, we usually give the debit card details for processing, credit card details for processing, and that's how we do that. So now let me execute this program. We get the output printed. So payment done via debit card and check credit card. And similarly, we do the same kind of program to the DAO class. Let's say create and then employee DAO interface, interface main. And inside this one, I create a main method again. The main method now contains what's that, employee DAO interface. DAO is equal to new in-memory interface implementation, and then DAO dot add record. And once again, polymorphism, please. DAO is equal to new MySQL DAO, and then DAO dot add record. Okay, so that's how it works. As I told you, you can watch JDBC video separately there in my channel. And that's how it works. That is the steps to create and declare interfaces, implementing classes, and creating objects of the implementation classes pointed by the object references of the interfaces, and then calling the methods. So let's go ahead and see the next topic. One interface, many implementation classes. We have already seen that, right? When to use implementations, we'll understand this. When do we use interfaces? Okay, now that we have understood what is an interface and how to use an interface, now let's see what is the reason behind using interface. Why should we use interfaces? So to understand that one, let's understand the problem statement that interfaces solve. Let's imagine we have this interface checkout and process payment is there, and we have two classes, credit card checkout and debit card checkout. Both the classes are there. Now let's say we have three classes: checkout main 1, checkout main 2, checkout main 3. All these three classes currently want to make use of the payment processor using checkout, credit card checkout. Okay, now this code, this program works well. The program in main 1, main 2, main 3, main 4, main 5, whatever, right? So these programs give the correct output and it works well. A few days later, we want to switch from credit card checkout and we want to switch to debit card checkout mode. So in that case, what we need to do is we have to visit each and every main class, main 1 class, main 2 class, main 3 class, erase all of them, and then add debit card checkout in those places. Imagine you have 100 main classes or 1000 main classes. Then what we have to do is you have to visit each and every class in 1000 main classes and delete all of them, and then add the debit card credit card as applicable. Now once again, after a few days, you want to come back to the credit card, you delete all the debit card and again put the. So this kind of trouble is called tight coupling. There is a tight coupling between the main classes which are using the credit card or debit card checkout classes. So to overcome this problem, what we do is we introduce one intermediate class, one proxy class in between the main classes and these checkout classes, something like this one. We have something like this one, checkout service and then process payment. So this class is introduced in between these two classes and these three main classes. And then what happens is this checkout service class will make use of the credit card or otherwise debit card or whatever is required. As an example, the checkout service makes use of the credit card service. And then we use this checkout service class in all these main classes you see here. We are using the checkout service, and the checkout service is internally making use of what? It is using credit card checkout. And if at all we want to make changes from credit card to debit card, we don't have to visit each and every main 1, main 2, main 3 classes. Simply what we have to do is we have to make changes in the checkout service, and that will take care of internal changes to that one. So in this case, what is happening is there is no tight coupling between the main 1, main 2, main 3 classes and the credit card checkout as well as the debit card checkout classes. Whatever change is required, we simply make the changes in the intermediate class, that is the service class. Okay, and these classes main 1, main 2, main 3, they only know the details about the checkout service class. They don't know what exactly checkout service class per process payment method is internally making use of. That means they don't know whether checkout service, whether it is making use of the debit card or credit card checkout. They simply know that they have to use the process payment. So this feature of not exposing what exactly the checkout service class is using to the main classes is called abstraction. The main classes just know the process payment method of the checkout service, but the main classes don't know what exactly internally the process payment method is using. Is the process payment of the checkout service using debit card, or is the process payment of the checkout service using the credit card? So they don't, this information is hidden from the main classes main 1 and main 2 and main 3. So this feature is called abstraction. Many people by mistake learn or misunderstand that abstraction and encapsulation both are one and the same. They are 100% different, please. This is the difference. Okay, hiding an unwanted functionality from the client classes is called abstraction. I guess by now you should understood the concept of abstraction. I have already explained the meaning of encapsulation in the relevant part of this video. If you have not already watched it, please go back onto that particular part and watch it. The difference between encapsulation and abstraction is a lot. Both are not same, please. And encapsulation is not for data hiding. It's not for data hiding to achieve security, nothing as such. And whereas abstraction is to achieve loose coupling. Loose coupling means there is no link between the main classes and these checkout classes. The link is only between the checkout service and these main classes. If you want to make changes to these main classes, you don't have to visit all three main classes. You can simply make the changes in the intermediate class. That is called the loose coupling. Abstraction helps in achieving loose coupling. Loose coupling helps in achieving easy code changes. What do you mean by easy code changes? If you want to switch from debit card to credit card, or if you want to switch from credit card to debit card, you don't have to change these three classes. Simply you can change it in one place. That is called easy code changes. In this entire explanation, where did we use the checkout? In this entire explanation, where did we use the interface? Did I use the interface checkout interface here? Did I use the checkout interface? Nowhere we have used checkout interface here. The checkout interface is implemented by these two classes, such as credit card checkout class as well as the debit card checkout class. So what happens if these two classes don't implement this interface? What is the use of interface at all in this complete explanation? The problem is, if we don't use this checkout interface, these two classes, that is credit card checkout and debit card checkout, these two classes can use any name of their choice to this process payment method. For example, this can use process credit card payment, or this can use process debit card payment. That means if the names are different here, what happens is the difference in the naming of these methods will break the code that we use inside the checkout service class. So that is the reason we have to force that the debit card checkout class and the credit card checkout class, we have to force these two classes should definitely make use of the same method name. Then how do you force that? We have to force them by implementing these by these classes letting implement the checkout interface. We already know that if a class implements an interface, it has to definitely make use of the same method names, and that's the reason we have to use interface in this particular context. Hope that helps. Thank you for learning, and let's move on to the next topic. Now let's see the code example to the previously understood checkout service explanation. Let's go ahead to the interfaces example, and let me create the checkout service. This is interface project. Now here what I do is I create a new class, and this class name, let's say checkout service. Now inside this checkout service, we declare a reference to an interface that is checkout, and then checkout. Let's say this is private. That should not be a trouble then. And then this is the interface. This is the interface name. This is the object reference name. Don't get confused, please. This can be C1 also. But as a best practice, we generally use certain standards. Right. So that is done. And in this checkout service class, we define the same method, public void payment. Let's say payment process payment, right? It's not payment processor. Let me copy in the name to prevent any incorrect names. Where is the checkout interface? It is here. I'll just copy this one. I'll copy this one, process payment method, and then I paste it here. I remove the abstract method here, and then this will be something like this one. Now here what we do is inside the constructor, or otherwise here itself, you can say new initially, let's say we want to go for a credit card credit card checkout. Please try to understand and remember, object reference of an interface can point to object of its implementation class. So this is the implementation class, and this one new operator creates object, and this is object reference that points to the implementation class object. And this one points to this one, and we call the method here, that is checkout dot process payment, maybe payment mode that comes from the main method. So this payment mode comes to the main from the main method, something like this one. Now let's go ahead and see the main method, checkout main, this one, right? So here, instead of creating checkout objects, now what we do is abstraction. If you remember, this time we call the service class, that is checkout service. Checkout service service is equal to new checkout service, and then service dot process payment, and here you say credit card, or whatever we want, credit card, something like this one. Now in this place, what is happening is the main method always connects with the checkout service. The main method doesn't know what exactly the process payment method of the service class service object is internally using. That means this main class does not know whether the process payment method of this service class is it internally making use of the credit card or debit card checkout. So it doesn't know that. That's the abstraction, right? We previously understood in the slide representation with a clear example. That's how whenever we want to change it, whenever we want to change from this one, we just go ahead and change this credit card checkout to the debit card checkout. So that is called the loose coupling and abstraction. Abstraction helps in achieving loose coupling. Loose coupling helps in achieving easy code maintenance, and that's it. So let me run this program, and then we get the output payment done. So if you want to go ahead and change it here, we can just change one simple change. So that we are not changing multiple main classes. Of course, in this case, we just have one main class. Considering the reality, if you have multiple main classes, we have to make those changes multiple places. So that's the reason. So that's done. So now we are done with the checkout service, this one. Now let's go ahead and see the points about interfaces. One interface can extend one or more other interfaces, and then we cannot create objects for an interface. All data members in an interface are public, static, final by default. Okay, and all methods of an interface are public, abstract by default, right? So that's about the interfaces. Now let's see the difference between when to use an abstract class or interface. Abstract classes should be used in a situation where some common functionality need to be shared across the child classes by the superclass. At the same time, the specific functionality need to be delegated to the subclasses, and interfaces should be used when we want to when we want the same functionality to be solved in different ways. For example, payment. The payment can be done using different modes, right? Different ways. So interfaces are used to achieve abstraction. Abstraction helps in achieving loose coupling. Loose coupling helps in easy code maintenance. So that's it about the inheritance, abstract class, abstract methods, overriding, polymorphism, when to use interface, when to use abstract classes. So many topics here. This is a very important topic. If you're strong in the object-oriented programming concepts, you can learn any object-oriented programming language very easily. So that's it. Let's go ahead and move on to the next topic. Thank you. Now let's understand the next topic in Java, that is packages. We'll see what is the meaning of a package, as well as creating and importing the package content, followed by the built-in packages list, a few names that Java offers. A package is a collection of related classes and interfaces which are together placed in one single folder. As an example, you see we have an employee package which contains all the classes and interfaces related to employee management system placed into one single folder. Similarly, the bank package contains all the bank account banking related classes and interfaces. Once again, the customer package contains all the customer related classes and interfaces. That's the meaning of this one. The package statement and the package keyword is used to create a package. You see here, package is a keyword, and the first statement we call it as package statement. After the package keyword, we mention the name of the package that we want to get created. As an example, com.employee. So this statement package com.employee creates a folder, employee creates a folder named com, under which it again creates one more folder called employee. And inside the employee folder, the dot class file that is generated when we compile this employee Java file is placed. So similarly, package com.banking creates another folder for banking, and this one creates another folder for customer. That means in order to store our classes and interfaces in a separate package, what we have to do is in that particular Java file, we have to declare the package statement at the top, okay, and the first statement. Now let's see the import statement, which is actually used to import the classes and interface from one package into a particular Java file. So that means before we want to make use a class or an interface in any Java program, we have to first of all import that. Consider we have two packages, com.employee and com.customer, and the employee package has the employee class and the customer class has the customer package has the customer class. And in the third package, com.banking, we have a class called bank account. Inside this bank account class, we want to make use of the object declaration of the employee class. This is from this package, and the object declaration of the customer class, which is from this package. So before using these two classes here, we have to import them. Import com.employee. And then employee. First, we mentioned the full package name followed by the class name or the interface name that we want to import. Similarly, we have imported com.customer.customer. That's about the import statement. Now let's see the few built-in packages in Java. The Java Standard Edition comes with so many built-in packages. A few built-in packages which are more commonly used are java.lang package, and a few classes and interfaces that it contains are object class, string class, StringBuffer class, integer class, system class, and many more. Similarly, the java.util package contains the collections framework, which is a very important topic. That is the last topic of this video tutorial. And this contains so many classes and interfaces related to collections management. We'll see the detailed concepts about collections as a last part. Now we have the collection interface, set interface, list interface, linked list interface, arraylist class, treeset class, and so on. The java.io package contains the classes related to reading and writing from keyboard, files, network, etc. The class names such as file reader, file writer, IO exceptions, file not found exceptions, all of them belong to the java.io package. The java.sql package contains the classes and interfaces which are used to connect and retrieve the data from the database, store the data in the database. This part related to JDBC. If you want to learn JDBC, I have a video uploaded into my YouTube channel. You can watch that. So that's about the few built-in packages in Java. Let's go ahead and see the concept of creating and importing package content, the hands-on example. We'll create these three packages and we'll see the importing stuff as well. So let me go to this Eclipse, and then I want to create a brand new project. Let's say the project name is packages-project1. Now inside this one, what we do is here, right click here and then go to new package. When you say package, we can type the package name com.employee. Inside this com.employee package, what we do is right click on the package name and then go to the class. And here I say employee. So that's all. It is as simple as that. So we have imported. Now similarly, right click on the source and again create another package. Then let's say com.customer, and then on the customer package, right click here and then go to create new class. Let's say customer class. Similarly, we create another package, banking. We can create as many packages as we want. Let's say banking. Now inside this banking package, right click here and then go to class and then let's say banking. So every time you create a new package and every time you create a new class in that package, the package statement is automatically generated. There is a small correction. Let me say right click and then go to refactor and then go to rename and then let's say com.banking. Usually package names are typed in complete lowercase. Let me correct this one also. Let's say rename com.customer and then that is done. So when we create a package using Eclipse, built-in options, it automatically generates the package statement for us. We don't have to separately, do that. So for example, I want to create one main package. Let's say new package. Let's say the package name com.main, which contains the main class. Now here, if I say right click and then new class, then what I do is main class 1 or something. Now inside this one, the main method is generated. For example, I will add the main method. Now here I want to use employee object. Employee P1 is equal to new employee, right? So when I say this one, it has to import the statement. So here it is not automatically imported by default. For example, I type this one, it is not there. So what I'm doing is, you watch here, I'm pressing control space there, and then I'm typing employee, okay, control space, and then you press enter there, it will automatically import. On the other hand, you can manually import, of course, and the keyboard shortcut is also available. Control plus shift plus O will import that. So that's how we create packages and import the packages. Okay, it's a simple topic. Now let's proceed with the next topic. Thank you. Now let's understand the next topic, that is access specifiers in Java. Access specifiers are the keywords which are used to define the visibility or the scope of the members of a class or an interface. There are 4 access levels for which we have 3 keywords, and the 4th one, there is no keyword. The keywords are public, private, protected, and default. For the 4th option, there is no keyword like default. If you don't use any of these 3, then the access is called as default access, right? Now let's understand these points very clearly. The public members are accessible in any package, any class, anywhere. Consider we have class A in package P1, com.p1. We have public variables such as public int I and public void test. These 2 members, I and test, are accessible. You see here in package P1 in a subclass. Okay, here it is accessible. Okay, and within the same package with B is a non-subclass, it is accessible. Within the same class package, C is a subclass of A, it is accessible. And then within a different package, you see com.p2, this is a separate package, and D is a subclass of A, it is still accessible. Public means accessible everywhere. And within a separate package, class E, it is a non-subclass of class A, but still accessible. That is the meaning of public. It is accessible everywhere. Private is just accessible only in the place where it is declared. Okay, it is not accessible anywhere. You see here. And protected means it is accessible within the class, within the same package, non-subclass, within the same package, subclass. You see here, B is a non-subclass, C is a subclass of A. It is no error here, and they are accessible in subclass of a different package, even though class D is in a different package. But if it is a subclass of A, then protected members are accessible there. That's the meaning. And then you see here, it is different package, non-subclass, protected is not accessible. So that is protected. Default means we have not mentioned any keyword with the variable declaration, method declaration, then we call them as default access. They are accessible within the same package, non-subclass, within the same package, subclass. Okay, and that's it. It's not accessible in a different package, subclass. It's not accessible in a different package, non-subclass. That is the meaning of the access specifiers, and this is the catalog of access specifiers. Hope that helps. This is a simple topic. Thank you. We'll continue with the next topic. Now let's understand the next topic, that is exception handling in Java. And here is the list of points that we will understand in this particular part of the tutorial. First of all, we'll see the meaning of what is an exception, followed by exceptions in Java. We will then see Java exception class hierarchy. After that, we will understand the meaning of what is exception handling, followed by the meaning of exception handling keywords along with their syntax and usage. Later, we'll see the meaning of user-defined exception along with the hands-on code example of creating and using a user-defined exception. After that, we will see the meaning of checked exception and unchecked exception, followed by the differences between checked and unchecked exception along with the hands-on code example. Now let's move on and see the first question, what is an exception? An exception is a runtime problem. The meaning of the runtime problem is a problem that occurs during the execution time of the program rather than during the compile time of the program. In more technical terms, an exception is an event that is raised by the Java virtual machine. Let's understand this statement with an example. Consider we have this program which contains 3 statements inside the main method. And when JVM starts executing this program, it starts with the first statement and prints the output of the first statement Java on the screen successfully. But when JVM tries to execute the second statement, that is the division by 0, 10 division by 0, it stops the program execution by throwing an exception called as arithmetic exception, by throwing a problem which is technically called as exception. And the name of that problem in this particular example is arithmetic exception. That means JVM cannot execute this statement successfully. When JVM cannot execute a particular statement successfully, it stops the program execution by throwing that problem in terms of something called as exceptions. But we can solve this problem by using some mechanism called as exception handling mechanism that is offered by Java. And of course, this facility is available in many programming languages. Now let's move on and see the exceptions meaning in Java. Exceptions in Java are the objects of special category of classes called as exception classes. And here is the list of few example exception classes. Java has many exception classes, and this is only a few names, list of only a few names. The first one is the arithmetic exception class. The second one, array index out of bounds exception class. Next one is class not found exception class, null pointer exception class, and many more are also available in Java. Now let's understand the meaning of these exceptions one by one. The arithmetic exception is occurred when the divisor is 0, such as 10 division by 0. The array index out of bounds exception occurs when an array element with an index beyond the array size is used. The class not found exception occurs if a required .class file is not found on the class path. The null pointer exception occurs if we access an instance variable or a method on an object reference which is null. And there are so many exceptions like this. Now let's go ahead and see the hands-on code example of all these exception classes. How do they occur and when do they occur? So let me create a new Java project. And let's say the project name as exception project 1. And inside this project, I want to create a new package because we have already learned packages. Package name, let's say the package name com.exc1. And inside this one, I want to create a new class. The class name, let's say arithmetic demo. Let's say arithmetic demo 1. And inside this class, I want to create a main method. So as you all know, the keyboard shortcuts, which were already explained in the beginning of the tutorial. So I've generated the main method. Now I want to create add the print statements. Let's say I want to print hello, and then I want to print something called 10 division by 0, and then I want to print something called as hello world. Now when we try to execute this one, if you notice, there are no compilation mistakes or compilation errors in this program. But when we execute this program, as we previously understood, as JVM starts executing all these statements step by step, it executes the first statement successfully, but JVM encounters a trouble when it tries to execute this particular statement, that is 10 division by 0. When JVM encounters such kind of statements, it causes an exception of the relevant problem, and then it stops the execution of the program. Now let me save and execute this program to see the output. The remaining part of the program is not executed. We'll just get the output hello followed by the problem described. Now, if you notice here, we have seen the first output, that is hello, and then the second statement caused the java.lang.arithmetic exception division by 0, and it has clearly mentioned at which package and at which class and at which method and the line number at which the problem is there. If you click on this one, it will show us the problem where it is available. So that is the arithmetic exception. Let's go ahead and see the next problem. That is the what is their list in that array index out of bounds exception. Let me create a new class here. The class name, let's say array index exe1, array index. Okay, no problem. Some typing mistakes, it doesn't matter. And then I want to create a main method inside this one. Now I want to create a number array and initialize it with some values. Let's say 10, 23, 45, and then 56. Then what I want to do is I want to use the print commands such as print number of 0, the 0th element, that is the first element exists. And then I want to print the few more statements. And then what I want to do is I want to use the 7th index, which does not exist. and I want to print the second index which exists. So JVM successfully executes this statement and prints the value 10, and it fails the execution at this particular statement because the array element with an index 7 does not exist. There it encounters the problem and stops the program execution by throwing an exception named as array index out of bounds exception. Let me start and execute this program. When I execute this program, I got the output something like this one. You can see the meaning here. The first statement is printed successfully, and the second statement caused array index out of bounds exception. And the index that is invalid is 7 here, and it is at array index.java program. Still, line number 7 is the problem. It is there. Now let's go ahead and see another example. Window perspective and then reset perspective. Let's go ahead and see another example in our list, that is class not found exception. Let me create one more class, new class, and then let's say class not found demo, class not found demo. Actually, this requires an understanding of something called as throws keyword, try catch keyword, and much more. For now, please ignore, just watch the example. After the completion of the exception handling, you will understand the meaning of this program. However, let me show you that class dot for name, and then let's say hello, and then I say this one. Please do not try to understand the meaning of what I'm doing currently. After the completion of this exception handling mechanism topic, you will understand the meaning of this try keyword, catch keyword, and this entire code snippet. For now, just see the problem. Let's say I run this program, you see class not found exception. So the class not found exception is raised when a particular class name that is being loaded is not available on the class path. As I told you, do not bother about the meaning of this one until the time you finish this part of the exception tutorial, the exception handling tutorial completely. Now let's see the next example, that is the null pointer exception. Now let me go ahead and create a new class here. Let's say new class, let's say null pointer demo. The null pointer exception occurs, as I told you, let's say class product, some product class. I'm taking a temporary product class inside which I'm taking a product ID or product number, and then string product name, and then let's say public void print product, and in here I say the details printed. What are the details? Let's say I want to print the product name, or else I want to give a space and then product number. Now the product class has two variables and one method. Inside the null pointer demo class, what I'm doing is creating a main method, and inside the main method I'm declaring a product class object. Product p1 is equal to null. Product p1 is equal to null. And this product object is not created. P1 does not point to any object. That is, P1 is currently null. If we try to make use of any variable or a method on an object reference which is null, then it causes null pointer exception. P1 dot product number is equal to 100. Now save this one. This particular statement causes null pointer exception. Line number 14, you remember? I explained the reason, because this is null. This does not point to any object in memory. Object does not exist in memory. Therefore, it causes a null pointer exception. Let me save this one and execute this program. This is the null pointer exception. 14 line number, null pointer exception, java.lang.null pointer exception. And this is the meaning of exception. The JVM throws exception and stops the execution of the program whenever it encounters some problem that is not rectified. Okay, now let's move on and try to understand the next topics. Java's built-in exception class hierarchy. The topmost superclass of the exception classes in Java is something called throwable. It has two child classes, that is exception and error. The problems related to application fall into the category of the exception, and the problems related to the environment such as Java runtime environment fall into the category of error. And exception class has so many subclasses. Similarly, error class has so many other subclasses. So a few subclasses of the exception classes are runtime exception, IO exception, SQL exception, class not found exception. And a few subclasses of the error class are stack overflow error, out of memory error. A few subclasses of the runtime exception class are arithmetic exception, array index out of bounds exception, null pointer exception. Altogether, this is the Java built-in exception class hierarchy. The top-level superclass of all exceptions in Java is throwable, which has two immediate child classes, exception and error. Now let's see the meaning of user-defined exceptions. User-defined exceptions are those which are defined by the programmer or the so-called user. A few examples of the user-defined exception classes are account not found exception, insufficient funds exception, invalid employee number exception, and many others. That's the meaning. Now let's understand the next topic, that is what is exception handling. Exception handling is a mechanism of catching the exceptions thrown by the JVM so that the program execution is not stopped when an exception occurs. Exception handling is achieved by the use of 5 keywords such as try, catch, finally, throw, and throws. Now let's understand the meaning and usage of all these keywords step by step. First of all, let's understand the meaning and purpose of the try and catch blocks. The try block is used to enclose the code that possibly causes the exceptions. For example, consider this code snippet. In this code snippet, the statement int k equal to I divided by j causes an exception, that is arithmetic exception. When a statement causes arithmetic exception, JVM creates an object of the arithmetic exception and throws that object. And if an object is thrown and if there is no exception handling mechanism, the program is terminated. However, if we enclose the statement that possibly causes exception inside a try block, the object is thrown outside the try block by the JVM. And when an object is thrown from the try block, there should be some piece of code to catch that block, and that block is called as the catch block. The catch block is used to catch the exception object thrown from a try block. So the catch block is placed immediately after the try block. The catch block takes one single parameter which represents any exception class name. However, the class name mentioned in the catch block and the exception object thrown from the try block has to be matched. Just in case the exception thrown from the try block is arithmetic exception, and if the catch block contains null pointer exception, the exception will not be received and handled by the catch block. So altogether, the try and catch blocks are used to handle the exception. Whenever a statement inside the try block causes an exception, JVM creates an object of that particular exception class, and that object is thrown. And if the catch block contains a matching exception class name, which is thrown by the try block, then the catch block receives it and the exception is handled. The program will start continuing from the next part of the program. So that is exception handling done using the try and catch blocks. Exception handling, try catch blocks, hands-on code examples. Now let's see these examples in action using the try and catch blocks. Let me go to the previous examples. So first I'll go to the arithmetic demo one, and inside this one what I do is I take these 3 to 4 statements and then right click here, then go to surround with try catch block. When I say surround with try catch block, it encloses the entire code block into the surround try block and catch block. So here we mention the arithmetic exception as our example case. Arithmetic exception as an example case. So instead of printing this statement e.print stack trace, what I do is I use a print command to print it. So exception occurred and handled in catch block. And then I give the next statement. What I do is in the next statement, System.out.println, I give e there. Okay, and then that's the case. Now let me save this program. When execute this one, this one is executed. This one causes arithmetic exception. Object of the arithmetic exception class is thrown from here, and the catch block receives that, and this statement will be continued. However, please be noted that after the catch block is executed, the execution flow will not go back to the try block and continue with the next statement. JVM jumps after the catch block, jumps to the flow after the catch block. Therefore, we'll cut this one and put it here. Okay, something like this one. So we should play smart in order to do the correct programming. Now let me save and execute this program. We get the output as expected. You see here the program is executed, hello is executed, and then exception statement inside these two catch blocks, and this is after the catch block. So this is how we handle the exceptions. Let's proceed with the remaining two programs. Let's say what I do is I right click this one and then go to surround with, and then try catch block, and in here I mention what null pointer exception. If you notice, everywhere surround with automatic generation, there is a superclass exception instead of arithmetic exception, null pointer exception, because a superclass object reference can point to an object of any of its subclasses, if you all remember. So this is the catch block. I just say this statement, delete it here, and then print what I say, exception caught, and then some pointer space there, plus E. And then when I execute this one, it will catch the exception. So that is exception caught, java.nullPointer exception. So this is how we catch the exceptions. Let me go to the another exception. What is that one? So I take these three things. I take these two things, then surround with, and then go to try catch block. And here what I do is array index out of bounds exception, and that's it. Here I use my own print command. What is that? Exception caught, then plus E, something like this one. Now let me execute this. We'll get all three outputs printed. Exception caught, we got the second element, second index, that is 45 printed. That is completed. Let's do the same thing for, I will copy this one. What is that? Exception caught statement, not this one. I'll go here, and then what I do is I copy this statement and put it here also, class not found exception. Now this is already there, is it? So this is a different topic that we will understand in the next few minutes. Now something like this one. So by now you should understand the try block and catch block meaning of the class not found exception demo program. So that is completed. Now let's move on to the next topic. The finally block. It is used to contain the resource cleanup code. Let's understand the meaning of resource cleanup code. Consider we have a code that closes the database connection, or the code that closes the file connection. The piece of code that closes the connection of any resource is called resource cleanup code. To understand this statement, let's look at some code example snippet. Connection cn equal to null, and then cn equal to driver manager.get connection. It takes three parameters, URL, username, and password. And this statement opens up a connection with the database server. And once the database server connection is established here, and after the database server connection is established, using the code here, we read the database records. While reading the records from the database, if some exception occurs, what happens is exception occurs, the program terminates. If the program terminates, the connection statement, the connection close statement will not be executed. I repeat once again, the first statement, connection cn equal to null. Second statement, cn is equal to driver manager.get connection. This particular piece of code, it is related to JDBC program. So don't bother about the meaning of the program. When this statement is successfully executed, it establishes a connection with the database server. After the connection is established with the database server, using some part of the JDBC program, we use the code to read the records from the database. While reading the records from the database, if some exception occurs, the program terminates. And if the program terminates due to the exception, what happens is this statement which tries to close the connection will not be executed, and therefore the connection remains open. If anyone else tries to open the connection, they will be in trouble. So that means the conclusion is the connection will not be closed if an exception occurs just before closing the exception. So such kind of statements which close the database connection or which close a file or a network connection, we call this type of code as resource cleanup code. Okay, in order to ensure that this kind of code is definitely executed in spite of whether or not the exception occurs, we make use of a special block called as finally block. Okay, however, this is database related problem statement. We are not going to demonstrate the finally block with this one because this is JDBC program. If you want to understand or learn JDBC program, you can watch the same example in my JDBC tutorial in my YouTube channel. Now let's go ahead and see the finally block basic code, basic example, hands-on code example. Now you see here we have integer I equal to 10, j equal to 20, and k equal to I divided by j. And then what is happening is the exception that is thrown from the try block, if you notice, is arithmetic exception. But the catch block has no matching class name. It has null pointer exception. That means if the exception thrown is of arithmetic exception, but there is no matching catch block, what happens? The program terminates. The program continues its execution if the catch block contains only a matching class name. In this case, it is not. So therefore, the exception is thrown here. The catch block skips the exception. It cannot catch it. And therefore, the program terminates. Before the program terminates, the finally block will definitely execute. That means this statement will definitely execute and this statement will not execute because this statement is not inside the finally block. Let's go ahead and see the example of this finally block. Now let me go to the first example, that is arithmetic exception demo. And inside here, what I do is, I put something called as null pointer exception. Null pointer exception. Please try to understand the object thrown by this statement is of arithmetic exception, but the catch block is containing what? Null pointer exception. So this cannot receive arithmetic exception, isn't it? So therefore, this will not be executed, and as a result, this will not be executed. If we want this statement or any other code to definitely get executed in spite of an exception is not handled, we should put that inside the finally block. What I'm doing is I'm placing a finally block in here, and then what I'm doing is finally block some statement I'm printing. That means in place of this print command, we make use of the resource cleanup code such as connection.close or file.close and similar. So finally block is what I'm typing here. Please watch. We get the output in the finally block printed, but we don't get the output of the world printed. So that is the meaning and purpose of the finally block. Let me save and execute this program. You see this one. Hello is printed, finally block is printed, but the world output is not printed. The text world is not printed in the output. That means this is not executed. So in order to ensure certain piece of code is definitely executed when an exception occurs before the program exits, we want to put that kind of code inside the finally block, and that code we technically call it as cleanup code. That's up the finally block. Let's move on to the next topic. User-defined exception is an exception that is defined by the user, that is the programmer. We define exceptions due to the business requirements. Okay, in order to define an exception, in order to create a user-defined exception, we declare a class that extends any exception class. Consider a few examples here. Public class insufficient balance exception. This is the class name. Extends exception. Exception is a built-in class. Please watch the definition. To create a user-defined exception, we need to define a class that extends any exception class. So here exception is an exception class which is built in. Right. So here public class insufficient balance exception extends exception. This is a user-defined exception. Similarly, public class payment failed exception extends exception. This is also user-defined exception. The toString method defined in both the classes is used to display when this exception occurs. When insufficient balance exception occurs, this message is displayed to the end user. Similarly, when the payment failed exception occurs, this message is displayed to the end user. So that is the purpose of the toString method. What are the steps to develop a user-defined exception? We define a class and then override the toString method with some reasonable text message. Now let's go ahead and see the next topic of creating user-defined exceptions with hands-on code examples. We'll see 3 examples: insufficient balance exception, account not found exception, employee number not found exception. Just plain classes. Let's go ahead and do that. So within the same project, I'm creating a new package. The package name is com.userDefined. Okay, new package. Inside this one, what I'm doing is com.userDefined. This is simple. Now here, what I'm doing is creating a new class. The class name is insufficient funds exception, insufficient funds or insufficient balance or some reasonable name, insufficient funds exception. And here what I do is extends an exception class name. Usually it can be any exception class name, but more generally we put the exception as the class name. And here we override the toString method, public string toString, and then here what I say, this I will return something, funds not available. Funds not available, some message that describes the problem, right? So this is completed. So this is the insufficient funds exception. We'll see the usage of this exception in the next few minutes in the next topic. Similarly, let's create another class. I copy this one and I paste it here. And this time I change it to account number not found exception, account not found exception. And when I press enter, the file is renamed. Inside the file also the class is renamed, account not found exception, extends exception. So here the message, some reasonable message, what I do is account not found, account not found. Working with user defined exception is a two-step process. Step number one is we define a class something like this one and override the method something like this one. Later, we apply this exception with the reasonable code, with the suitable code. Applying this exception, causing this exception, the suitable code, we will understand in the next few minutes. Just like account not found exception, we will create one more exception class, copy this one and paste it here. And then I say employee number not found, employee number not found exception. Okay, something like this one. When I open this one, we got this one. You see here exception. And then what I do is employee number not found, employee number not found, something like this one. So that's it. We are done with declaring user defined exceptions. We'll use the code snippet in order to demonstrate these exception classes in the next few minutes. Now let's go ahead to the next topic, the throw keyword. The throw keyword is used to deliberately throw an exception. We want to wantedly throw an exception. We can make use of the throw keyword. To throw an exception using the throw keyword, the syntax we use the throw keyword followed by an object of exception related class. Please remember, please try to understand, after the throw keyword, we cannot use any object. We can use only that object that belongs to any of the exception class names. So that is the syntax. As an example, you see here, throw new null pointer exception. This creates an object of the null pointer exception class, and then that object is thrown here. Okay, now if we have a question, what is the use of throwing an exception wantedly? Throwing an exception wantedly is more general in case of the user-defined exceptions. Consider we have a bank account class which has a withdraw method. Before withdrawing the amount that we have receiving in the parameter, before withdrawing amount, we want to check whether this amount is greater than or less than the available account balance. If the withdrawing amount is greater than the available balance, we want to throw an exception here. To throw an exception here, first of all, we have to declare the user-defined exception. It's an insufficient funds exception or insufficient balance exception or whatever applicable. And once we define this one and we throw here using the throw keyword, throw new insufficient balance exception. So that is the meaning and purpose of the throw keyword. The throw keyword is used to wantedly throw an exception. Throwing an exception wantedly is more general in user-defined exception in the situations as explained now. Okay, so that's about the throw keyword. Now let's go ahead and see the example of the throw null pointer exception with some basic example. However, we'll see the hands-on code example of throwing insufficient balance exception when we understand the next topic called as checked exception, right? So let's go ahead and see this example of throwing null pointer exception. So I go here and create a new class test throw or something. Here I'm creating in exe1 package. What I'm doing is creating a new class. The class name, let's say throw demo1. Please try to understand throw keyword is applicable for only user business exceptions called as checked exceptions that we will understand later. However, we are seeing the throw keyword is the basic example such as null pointer exception in this code snippet. Throw new null pointer exception. That's all. This will throw an exception. You want to print a statement before that? Okay, we can do that. But let me demonstrate this one. Right click here and then run as and then Java application. So this has thrown an exception. If you see it, java.lang.null pointer exception, right? So that is how the throw keyword is used to throw the user-defined exceptions. More generally, it is applicable to business exceptions called as checked exception. Okay, now let's go ahead and see the meaning of the throws keyword. If a method's code causes an exception that is not handled, then the method has to declare that exception name in its heading using the throws keyword. Please read this sentence twice or thrice until you get a clarity. If a method's code causes an exception that is not handled, then the method has to declare that exception name in its heading, right? So please also watch something called as throws keyword is applicable only to the checked exceptions. Throws keyword is applicable, this correction is applicable only for the checked exceptions. Now let's go ahead and see the meaning of this statement with an example. Consider we have the bank account class with a withdraw method, and this withdraw method is causing an exception called as insufficient balance exception. This method is causing insufficient balance exception, but it is not surrounding this statement which is causing the exception using the try and catch block. It is not surrounding this statement with using the try and catch block. So in such case, what happens is this information of not handling this statement inside the try and catch block has to be declared in the withdraw methods heading line after the closing parenthesis. You watch here, something like this one. Public void withdraw int amount after closing parenthesis. Here we have to mention the name of the exception that is not being enclosed inside the try and catch block. So that is the importance of the throws keyword. Okay, so that the callers of this withdraw method are informed about this problem's existence in this method. Right, now let's move on and see if this is not declared here. At least let's move on and see the example of this particular one. So here the throws keyword hands-on code example, we'll see this one here. So let me create a bank account class for now. Okay, what I do is I create one more package, new package com.throws. I've created the invalid throws is built-in one, sorry, com.throws demo. Here I'm creating a new class, let's say bank account. In the bank account class, let's say we declare one double variable, let's say account balance, and then public void withdraw, and here I take double amount, and in here what I do is if amount is greater than account balance, then I want to throw new insufficient funds exception. If you remember previously we defined it, insufficient funds exception. Okay, the moment we do this one, we'll get a compilation. It is throw here, not throws, throw, and this one it has to be declared here. So what I do is I put a mouse here and then add throws declaration. So this is the meaning of this one. When any method causes an exception which is not enclosed in the try catch block, then that exception name has to be declared in the methods heading. Okay, if this one is not declared here, there is one more option that we will understand in the next few minutes. Let's do the similar kind of thing with the other account not found exception. Let me create one more class, public class accounts or something, new class, and then account details or something. Okay, inside this method, what I do is I define one method. Inside this class, I define one method, public void find account, and then integer account number. However, we are not dealing a full-fledged example of accounts here. If you want to understand something related project, you can watch my channel's video relevant. Now what I'm doing here is if account number equal to 0 or then throw new account not found exception, something like this one. Then we have to declare, because this statement is not surrounded using the try and catch block, we have to declare this account number in this particular place. So what I do is add throws declaration. This will throw here, something like this one. You need not type it here. You place your mouse there and you will get two options. The first option you select it. The meaning of the second option will be explained in the next few minutes. And then this is how it works. Similarly, I recommend you do this by yourself as a hands-on practice. Now let's go ahead to the next topic, calling a method that declares exceptions using throws keyword. So this is an important topic. If a method is declaring an exception in the throws keyword, and if we want to execute this method, if we want to call this method, for example, I have a main method here. For example, I have a main method in this particular case. Okay, and the main method wants to make a call to this one. I'll put it as static for now. And the main method wants to make use of this method. It wants to call this method here. If the main method wants to call this method which declares an exception in its throws keyword, in its throws clause, what is that we need to done is this topic about. Say, for example, calling a method that declares. So consider the withdraw method has throws and the main method wants to make a call to this withdraw method here, b1.withdraw. So in this case, the main method, in order to make a call to the withdraw method that throws insufficient balance exception, the main method has two options that it has to pick from in order to make a call to the withdraw method. Option number one is use a try catch surrounding this withdraw method, with the withdraw method, and inside the catch block use the insufficient balance exception. This is option number one. If the main method is not interested in using the surrounding try catch block, the option number two that main method can use is redeclare the insufficient balance exception in its heading, something like this one. Main method's heading, it is redeclared. If we don't do either of these two options, then this statement will be a compile time error. So that is the meaning of the statement, calling the method calling a method that declares exception using throws keyword. It has two options. Option number one, try and catch, and then call the method inside the try block with a sufficient matching catch block. And the next option is to use the throws keyword if it is not interested to enclose this call in a try catch block. That is important to understand. Right now, let's see the hands-on code example of these two. I have not demonstrated this one. You can work it on yourself. And these two things we'll see right now. So for example, we are in the main method. Now I want to find, I want to call the find account method. So here I say 100 or something. Now, if you watch here, now this is a compilation failure because we have not used any one of the two options. Why? Because if you don't use any one of the two options, I told you it will be a compilation error. So I put the mouse over there. I have two options. Option number one, I select it as surround try catch. I got it. Now I'm going for an undo option. Then option number two is declare with the throws keyword. This is the case. Similarly, in the main method, you can do it here. For example, main method. Let's say the main method. Now inside this main method, I want to create a new, I'll create a bank account object first. Bank account BA1 is equal to new bank account. And in here I say BA1 dot withdraw of some blindly, I'm giving some data there. And this statement is now a compilation error because it is not following one of the two options. At least one option has to be selected. So I go to this one and then I go to the surround with try catch block. So that is the meaning of the throws keyword. Now let's understand the next topic, that is checked exceptions and unchecked exceptions. Checked exceptions means any subclass of exception class except runtime exception class and its subclasses is called a checked exception. And these are the examples of checked exceptions: IO exception, SQL exception, class not found exception, and many other similar. Now let's go ahead and see the reason why checked exceptions are called by that name. Checked exceptions represent the problems which cannot be solved by making changes to the code. Let's understand this sentence with some example. Consider we have this statement file reader fr is equal to new file reader, which tries to open the file hello.txt. When JVM executes this statement, and by the time JVM executes this statement, the file may or may not exist during the execution time. JVM throws an exception called file not found exception if the file does not exist. The problem to understand here is we cannot make changes to this line of code so that those changes that we make will not turn the situation of file not existing into a situation that the file exists. So such problems, we are calling it as problems which are not solved by making changes to the code. And the points about the checked exceptions are: the compiler checks whether the developer has surrounded these kind of statements with relevant try-catch block. And if not surrounded, then the compiler triggers a compilation error, because the compiler don't want such code to be in trouble if the file does not exist. If the developer has not surrounded such code with relevant try-catch block, the compiler demands to at least declare the exception name in the method setting using the throws keyword so that the callers of the method are warned about it. And finally, the conclusion is because the compiler checks for the existence of the try-catch block or otherwise the declaration in the method's heading, these exceptions are called as the checked exception. Now let's understand the next one, that is unchecked exceptions. Any subclass of runtime exception class, including runtime exception, is called unchecked exception. Example, runtime exception class, arithmetic exception, array index out of bounds exception, null points exception. These are all unchecked exceptions. Now let's go ahead and see the reason why unchecked exceptions are called by that name. Unchecked exceptions represent the problems which can be solved by making changes to the code. To understand this statement, let's consider we have a code snippet int I equal to 10 divided by 0. When JVM executes the above statement, it throws an exception named arithmetic exception. However, we can solve this problem by making 0 to non-zero, and therefore the compiler does not check whether the developer has surrounded these kind of statements with relevant try-catch block and does not trigger a compilation error for such kind of problems, which can be solved by making changes to the code because they are in the control of the programmer. We can change 0 to non-zero and the problem is solved. But in the previous case of a file example, if the file does not exist, we cannot make changes to the code so that the file becomes into existence. So that's the difference. The conclusion is because the compiler does not check whether we use the try-catch block or the throws keyword for problems of this kind. These exceptions are called as unchecked exceptions. Now let's understand the next topic, that is wrapper classes in Java. And here is the list of points that we will understand in this particular part of the tutorial. The first point what we'll understand is what are wrapper classes, followed by where are they used. We'll then see a few methods of wrapper classes along with the hands-on code examples. So let's go ahead and see the first point, what are wrapper classes. Wrapper classes are those classes which wrap the primitive data type variables inside objects. Just like we have primitive data types such as byte, short, int, long, float, double, char, and boolean, there are classes that match these data type names such as byte, short, integer, long, float, double, character, and boolean. All these 8 are the class names, and these class names are called as wrapper classes. If you notice, the class name of a primitive data type is almost same as the data type name except for int and character. For int data type, the wrapper class name is integer, and for char data type, the wrapper class name is the complete spelling character. Now, let's understand what is the meaning of this statement, wrapping primitive data type variables inside object. Let's say we want to create two variables such as I and d, which are of integer data type and double data type. Now, these two are called as primitive variables here, primitive data type variables here. However, we can work with object versions of this I and d using some code, something like this one. We can type integer I equal to new integer of 10, and we can type double d equal to new double of 20.35. In this case, integer and double are the wrapper class names which are from java.lang package. As discussed, we have 8 wrapper classes in Java which are used to work with wrapper versions of the primitive data type variables. Now let's move on and see the point, what is the use of wrapper classes. They are used to store object equivalents of primitive data values in collections. In Java, there is a topic called as collection framework. The collection framework is some topic which is used to create and manage a group of objects. When working with collections, if we want to store primitive data values, the collections do not support storage of primitive data values into the collections. We need to store only objects. Collections support only objects to be stored inside them. So if at all we want to store the values such as 10, 20, we want to convert the 10 and 20 into an object of the respective wrapper class and then store that object inside the. Now let's understand few constructors and methods of the most frequently used class, that is the integer class. There are so many overloaded versions available. A couple of them are displayed here. Integer, and it takes an int variable, and integer and it takes a string variable, something like this one. As an example, you can see we can create integer something like this one. Integer I equal to new integer of 10. We pass the direct int value there. And in the second case, we pass a string which is converted to an integer. And the passing is a static method. If you remember, we make use of the static methods by using the syntax class name dot method name, static method name, and therefore it is static method. We call it as integer dot parseInt, and here we pass some string that is converted to an integer. The equals method is used to compare whether two given objects contain the same data or not. We will learn more about the details of the equals method in a separate topic called as object class and its equals method. Okay, now let's move on to the next topic, next method, that is the compare to method. The compare to method is used to compare the two given objects against their natural ordering. That means the compare to method takes the source object and the target object, and it returns a negative number if the source object is less than the target object, and it returns a positive number if the source object is greater than the target object, and it returns 0 if the source object is same as the target object. Now let's go ahead and see the hands-on code examples of all these things. Now let me create a new Java project, and let me name the project name as wrapper proj1 project1. And inside this one, I want to create a package, new package. New package, it's a com.wrappers, and in here I'm creating a new class of integer demo. We are seeing the demo class for integers, however the concept is same for almost every class. Now here I want to generate the main method. Now inside the main method, I want to create an object of the integer class. What I want to do is integer I equal to new integer of 10, the first version of the constructor. This is Java version 8. Java 9 onwards, this construct is deprecated, please. Equal to new integer of, let's say, some 20, please. This is a string this time, and that is done. So let's say System.out.println, you want to print I plus j, something like this one. So here, what we run this program, we get the same output as we get in case of primitive data type variables. Okay, we got the output displayed. Just in case we have a space here, this constructor causes an exception called as number format exception. Not necessarily space, anything which is non-digit. Let's say run as Java application, you can watch it here. You got the number format exception. Okay, so this is the number format exception that we got here. Now it occurs even though there is a non-digit, not necessarily space. Right click and then run this one as Java application, that is. Okay, now when we store the data inside objects, we are able to use them directly, just like I and J. In the background, it applies a topic called as auto unboxing. We'll see the meaning of auto unboxing in the next 2 minutes. So that's about the constructors. Now let's see the pass int. Let's say int x is equal to integer dot pass int of let's say some 2. And this one also causes throws the number format exception if it contains a space or something. Okay, now let's print x square. Now let's print x star 2, and we'll get the output 4 as usual. Right, so this is a number format exception in the first case. Let me save this one, correct it, and save this one. Now I will execute it. Now this is the wrapper class, how it works. Now equals method. Let's say I want to print System.out.println I dot equals of j, and then we have the same data there, right? Different data, right? We get false printed, so that is false printed. Now the next method, compare to method. Let's print System.out.println I dot compare to of j, something like this one. So let me do the execution, and we get the output printed. So this is -1 because this is less than this one. We get a negative integer. Negative integer is not restricted to -1. It can be any negative number. Please remember that. Now that's done. Let's go ahead and see something called as auto boxing and auto unboxing. Auto boxing means the primitive variable is automatically wrapped into an object of the respective wrapper class. Instead of writing this one integer I equal to new integer of 10 and 20 as we did just now in the code example, we can directly say something like this one, integer I equal to 10 and 20. This way, just like we use the normal variables, we can do this one. So this syntax is applicable from Java version 5 onwards. And let's go ahead and change our code snippet. So let me not use the new keyword, just straight away. Now 20, that's all. This is auto boxing. And auto unboxing means extracting the data from these variables directly, we can use that. So without auto unboxing, it will automatically extract the values from the object into primitives. So what we can do is we normally have to write a int i.int value plus j.int value. We can write this one integer k equal to I plus j. This is unboxing. So without unboxing facility, we have to make use of this syntax. However, this is an outdated syntax, and this is the latest syntax that we use. That's about wrapper classes. Now let's go ahead to the next topic. Thank you. Now let's understand the next topic, that is the string class, StringBuffer class, and StringBuilder classes. And here is the list of points that we will understand in this particular point of video. We'll see the string class and its methods, string pool, the string immutability concept, the StringBuffer class and its methods, the StringBuffer versus StringBuilder class, along with the hands-on code examples. Now let's move on and start with what is a string. Anything enclosed in double quotations is called a string, and it belongs to an object of the string class. Example, we have Java as a string, programming as a string, React.js string, Angular, which is a string, Spring Boot. They're all strings. Okay, now the java.lang.string class, it provides the constructors and methods to create and manipulate the strings. There are so many versions of the constructors. There are so many methods available in the string class to manipulate that. So the string constant pool. String constant pool is that partition in the object heap in which only objects of the string class are stored. For example, this is the object heap, and in this object heap, one partition is allocated to a separate, one partition is allocated to strings, which is called as string pool. Okay, whatever object string class you create using this string literal syntax, that will be stored inside the string pool. Other objects such as customer, employee, bank account, etc. are all stored outside the string pool inside the object heap. That is the meaning of the word string constant pool. Now let's see the concept of creating string class objects. There are two possible ways we can create the string class objects, using the new operator as well as using the string literal. Objects of the string class created using the new operator are stored in heap, and objects of the string class which are created using the string literal, something like this one, without using the new operator, are stored inside the pool. Now let's understand the next topic, that is string literals and string pool. Every time JVM encounters a string literal, that is anything enclosed inside the double quotations, JVM automatically creates an object of the string class object and places it inside the string pool. Now let's move on and understand next point called as string immutability. Objects of string class are called immutable, which means their content cannot be modified once they are created using the string literal object. Now let's go ahead and see the explanation of string immutability, string literals, and string pool. Consider we have the object heap which contains the string pool, and then what we do is we want to execute these lines of code. When the first statement is executed, what happens is the string class object hello go and sits inside the pool, and then s1 points into that points to that hello string object. And when we try to change s1 with the next statement, such as s1 equal to s1 plus world, the existing object is not modified. Rather, one more brand new object is created, and s1 will then point to the final object, that is hello world. However, the previously created hello object is still available in the string pool, and that is used by the JVM at the next time some other object is created using the hello content. For example, we create string s2 equal to hello, then what happens is JVM will now point the s2 directly to the existing hello object instead of again creating a brand new object. That is the meaning of immutability. If you try to modify, it is not modified, rather a brand new object is created. That's about the string immutability, string literals, and string pool. Now let's understand a few constructors of the string class. An empty constructor is there, that is the default constructor, which takes a string and which takes an array of bytes and an array of characters. Okay, now here are the few methods of the string class. There are so many methods in string class: equals method as well as equals ignore case, to uppercase, to lowercase, length, substring, starts with, ends with, index of, last index of, and character. Let's go ahead and see the hands-on code example of all these methods, or at least a few methods, because there are so many methods. Let me try to cover maximum. Okay, let me create a brand new project, file, new Java project. Now let's say the project name string proj1. string project 1, and here I want to create a new package. The package name com.strings, and inside this one, what I want to do is create a new class, and the class name, let's say string demo1, and here I want to go for the main method. Now in the main method, I want to create a string class object using a string literal or something. Let's say string s1 is equal to hello world. And then let's say I want to uh, print the methods one by one. I will demonstrate one by one. Equals and equals ignore case. I will take one more string object, please. S2 equal to hello space world, and then two dots and then semicolon. So first of all, I want to demonstrate s1 dot equals of s2, something like this one. Now let me save and execute this one, run as this one. So we got two true there, and equals ignore case. Let's say this is in capital letters. I create one more object, s3 is equal to the same content but with different keys, that is a capital keys. Now if I go and use s3 in place of s1, we'll get it as false. Even though the content is same, but the case is different, we get the output as false. Now let me execute this one. So this is completed, we get false. And equals ignore case will ignore the case just in case the content is same. Ignore case equals ignore case, control S, I've saved it. Now I am executing this one. Let's say Java application, I got the true. And let's go to the two uppercase and two lowercase methods. What I'm doing is I delete the statement, and then what I do is System.out.println s1.to uppercase. I'm converting this uppercase, and then System.out.println s3.to lowercase. We can convert to uppercase into lowercase. Then let's say save and execute. We got these things printed, and length substring starts with and ends with. Let's say I go to something called as these two statements I'm deleting there. And then what I want to demonstrate is System.out.println s1.length, and then we want to see the substring s1.substring, substring of the beginning index. Let's say from fifth index, I want it will extract everything. The substring method starts extraction from the fifth index. That is the index is 5, but the position is 6. Okay, it starts from 0, 1, 0, 1, 2, 3, 4, and then 5. From here it starts, and it extracts the entire remaining string. That is a substring. And another version of the substring, we want to extract the s1.substring. Let's say from 0, I want to extract some 6. It does not extract 6, it extracts up to 6 minus 1, because the index counts from 0, and therefore it extracts. So this will print as world, and this will print as hello. Let's see if it works well. And this will print as the length. Okay, now let's say run as Java application. We got 13, this one length is 13, and we got world, and we got this as hello. That's how we work with the length and the substring. Let's go ahead and see. Starts with and ends with. They return true or false, indicating whether a given string starts with something that is mentioned. Let's say string dot. This is pretty simple to learn the strings. S1 dot starts with let's say Ravi. It doesn't start with Ravi. And similarly, S1 dot ends with let's say Java. It doesn't end with Java. We should get false there. Now let me save and execute this one, and then we got false. Now let me change this Ravi and this one to hello. I change this one to hello, and this one does not end with hello, right? It ends with two dots. Let's say both of them should now return as true, and that's about true. And starts with index of, last index of, and character at. Okay, let's see these examples. Let's say, let me delete these things. What I want to do is System.out.println s1.index of. This method is used to find the position of a specific character such as h, and it will return the index of the first occurrence. If we return the index of the first occurrence, let's say I want to run this program. We got the first occurrence is 0, and let's say if I give L, then and save this one, we have two copies of L. 2 times, it will get 0, 1, 2 this time. We get 2 there, and we have last index of here. Let's say last index of, we'll get the index of this one now. Okay, now let me save and execute this program. You get this one, sorry, L is there, and that is completed. And last index of character, it will give you, let's say index of, I give some X there. If it is not there, it will return -1, indicating that it is not available. It gives us -1. So that is completed. Now character, it will give you the character at a specific index that we mentioned. Let's say character at, and let's say the index, I give some 5 is a space. Let me give 6 there, and then let me execute this program. We get the output 6. And if we give something which is not the index, which is some 90 or which is not there, we get an exception, string index out of bounds exception. However, the version, depending upon the version, this will change sometimes. So that's about the few methods of the string class. Now let's go ahead and see one. We can also see everything enclosed in double quotes is a string. If you remember, I told you we can directly make use of the methods on the string literals. Let's say like this, hello dot length. We need not definitely have object reference like s1, s2. Directly we can use the method something like this one. Let me save and execute this one. We get 5 output there. So that's about the methods, a few methods of the string class. There are so many methods available. You can browse the documentation. Now let's move on to the next topic, StringBuffer and StringBuilder classes. The StringBuffer and Builder classes are used to work with mutable versions of strings. Mutable versions means we can modify the content, and brand new content, brand new object is not created if you modify the StringBuffer object or the StringBuilder object. Okay, the difference between StringBuffer and StringBuilder class is something called a StringBuffer is called thread safe class, whereas StringBuilder is not thread safe. In order to understand the meaning of the word thread safe, please learn the topic called as multi-threading, regarding which there is one video in my YouTube channel. Then you will understand the meaning of the thread safe. Now let's move on and see the few methods of the StringBuffer class: insert, delete, update, and reverse. Now let me go ahead and create one more class, that is StringBuffer, new class, and then let's say new, it's coming new package, new class, and then StringBuffer1, and the methods in StringBuffer and StringBuilder are same, 100% same method names. The difference is something called as thread safety. All the method names are same, please. Now I'm creating a new StringBuffer object. StringBuffer sb1 equal to new StringBuffer, and let's say Java programming. Let's say Java programming, and then I want to say sb1.insert. sb1.insert, I want to insert at 0, and then I say hello. At the 0th index, I'm inserting a hello. I put a space there, and then what I do is sb1. If you print sb1, let me save this one. Now let me execute this one. You watch. Hello Java programming. The initial one is Java programming. We have inserted a space. I'll insert another space here. I'll execute this one more time. We get insert. Now we want to delete something. We can delete that. You can see sb1 dot delete, sb1 dot delete from 0, and then let's say I say 5, and then it's deletes from 0 to 5. Now let me what do you say, we get the output programming, and because 0, 1, 2, 3, and then 4, the space is also deleted. 5 is this one, right? So it's from start from 0, and that's the reason. So then append, you want to append something at the end. Let's say append, and then we have something called as append hello, hello, and then I run this program. We get the output something like this one. Java programming. Reverse, as you know, it reverses it, sb1 dot reverse, and then save this one, and then right click, and then run as Java application. We get this one reversed. That's about the string class, StringBuffer class, and StringBuilder classes. Let's learn next topic. Thank you. Now let's understand the next topic, that is the object class in Java, and we'll see this, what is object class, followed by its most frequently used methods such as toString, equals, and hashcode. So let's begin with what is object class first. It is the implicit parent class of all Java classes, which includes both user-defined classes as well as the built-in classes, and this class is from java.lang package. Example you see here, the object class is the parent class of the built-in classes such as string, integer, linked list, arraylist, throwable, and at the same time it is also the parent class of the user-defined classes such as customer, bank account, and so on. In other words, what we type is this one. If you see here, if we type something like this public class product, which has no extends keyword after the declaration of the class name, and similarly public class customer, which also has no extends keyword after the class name, the compiler will automatically attach this statement extends java.lang.object. And this way, the built-in classes or otherwise user-defined classes, all of them are the subclasses of the object class. And the most frequently used methods of the object class are toString, equals, and hashcode method. The toString methods, the toString method returns a string description of an object. It is pretty simple method. Now let's go ahead and see the toString method hands-on code example with respect to the product class and the bank account class. So let me create a new Java project and let me name the project name as object object project 1. And inside this class, I want to create a package, let's say a new package, and the package name, let's say com.object demo. And here I'm going to create a new class. The class name is product. And to the product class, I want to declare a few attributes or few instance variables, whatever you want to call it as. Private int product ID, and then string product name, private string product name. And I want to generate all this stuff such as constructors, other stuff. Go to the source menu. You have so many options here: generate getters and setters, delegate methods, hashcode, equals, toString method, constructor using fields, constructor from superclass. We'll generate the constructors from superclass, and then we'll generate the constructors using fields, and then we'll generate the getters and setters. Source, generate the getters and setters, select all, and then select this one. Now this is selected. Now let's override the toString method. So if you remember in the examples, the methods list, this is one of the built-in methods of the object class, but inside the product class example, we want to redeclare the method. If a child class redeclares the method of its superclass, then with the same syntax, then we call it as method overriding. Of course, I have explained that in the method overriding concept. If you're not familiar with method overriding, you can please go back to that part and watch it. Now I'm talking about method overriding. That is, we want to override the toString method. So we can manually type the toString method something like this one, or otherwise we can use Eclipse facility, public, and the return type is string, and the method name is toString. The toString method does not take any parameters, and this is overriding return some string here. Okay, we want to return some string here. So this is called method overriding, in which a subclass redeclares the method of its superclass with the same syntax. We have overridden this one. However, we need not manually type this overriding version. We can make use of Eclipse automatic facilities. Right click and then go to source, and then go to generate toString method. When you generate toString method, it asks to select the fields which need to be included as a part of the toString method return value. So we have selected, by default, it has selected product ID and product name, which are the two attributes of the product class. When we click this one, it frames a return statement. You see here, it has overridden here. It frames a return statement in such a way, it prints the details product and the product ID as well, the text product ID followed by the actual product ID, and similarly product name is equal to followed by the actual product name. This entire stuff of the output is enclosed inside the square brackets. However, it's up to you. You want to return whatever string you want. This is just a convention to return the description of the object in any toString method of any class. So that's about the toString method that we have overridden inside the product class. Let me go ahead and create the main method class for the product object. So I'm creating a new class, and then product toString main. And here what I want to do is create the main method. The main method I create, and then I want to create a new object of the product class, product p1 equal to new product. And inside the constructor, I want to pass some data. Let's say some mobile phone or something, and then I want to copy and paste to make the second product, that is product P2. Now inside this one, I want to give the product number as 20, and let's say this as charger. Okay. And then I want to use the print command, System.out.println p1.toString. The toString method returns this string. If you remember the syntax, the return value of the toString method is string. Please watch here. So this returns a string, and therefore this print command gets the string output that is returned by the result of the execution of this toString method. That means when this entire block of the code which I have highlighted, when this one is executed, this is replaced with this statement that is returned by this toString method. Okay, and to make you informed that we need not definitely use the toString method inside this print command. Wherever we use the object name inside the print commands, the print statement such as System.out.println, the toString is automatically attached to that. For example, I will demonstrate that with the P2 object. Okay, System.out. Now P2. So this will automatically become P2.toString. We need not mention something like this explicitly. However, let's see the both possibilities, and let me execute this program. We get some output, something like this one. Right. So that's executed. We got the output that is written. And similarly, let's do the same thing for the bank account class. I'm creating a new Java class that is the bank account, and then new class, let's say bank account, and inside the bank account class I want to declare a couple of attributes like account number and all, private or integer account number, and then private string, the customer name to which this account belongs, and generate the other stuff that we previously discussed, objects, constructor from superclass, and then constructor using fields, and then generate getters and setters. Okay, and then select all getters and setters, and then generate the toString method as well. We have the toString method as well. Now that is done, we go to the main class, that's new class, and the class name is bank account toString main. And inside this class, once again, we want to do the similar kind of code that we did for the product main class. Now, what I'm doing is bank account B1 equals to new bank account of the account number, let's say 1234, the customer name, let's say Ravi, and then I want to copy and paste this one. On the second one, I want to copy and paste this one guest, and this number be 4321, and then let's say this is B2, and let me print those things, System.out.println, and then maybe I want to use toString in one statement for the demonstration purpose, and without toString the B2 for the demonstration purpose. That's done. Let me save and execute this program. This works well. So that is completed. We got the output of the toString. Now let's move on and see the next step, that is the equals method. The equals method is used to check whether two objects of the same class have same data. Let's understand the equals method clearly. Let's say we have two objects of the string class. So these two objects have the same data, that is Java and Java. So therefore, these two objects of the string class which have the same data are said to be equal. And we have another set of these string class objects which now contain Java and .NET. These two are unequal objects because their data is different. And similarly, two equal product objects which contain the same data such as 101 and mobile. In both the data of both objects is same, and the data of both objects is different here, two unequal product objects. Now, provided these objects are available for us, if we want to check whether these two objects are same or not, whether these two objects are same or not according to the data, we make use of the equals method. That means we write the statement in such a way that we want to check whether the data is correct or the objects are same or incorrect. Right. So now let's see the default functionality that is provided by the equals method. By default, the equals method that is available and that comes with the object class checks whether two object references point to the same object. Now let's understand this statement. That means this equals method that is automatically available with the object class. It does not check us the functionality. It does not provide us the functionality that compares the data of two different objects. Rather, it compares the whether two object references point to the same physical object. That means we consider we have these two objects of the string class which are pointed by the object references S1 and S2. And when we say S1 dot equals of S2, and we consider this is the built-in equals method of the object class. Of course, the string class has its own overridden version of the equals method. Now, just for the sake of understanding, let's say this is the built-in functionality of the equals method that is offered by the object class. When we write something like this one, the equals method translates that statement internally something like this one. The meaning of S1 double equals to S2 is to check whether S1 and S2 are pointing to the same object. But however, in this particular case, if you notice, this is pointing to a different object and this one is pointing to a different object. That means this answer will result to false. But what we actually want is we want the equals method to compare the data of these two objects and return true if they are same, otherwise return false if they have different data. Okay, now let's go ahead and see the equals method default functionality hands-on code example with respect to product class and bank account class. Now let me go to, I have not overridden any equals method. If you remember, in this bank account class, as of now, there is no equals method. If there is no equals method, please remember guys, we have extends object here. We have extends object class here. That means whatever method is there in this object class is automatically inherited into this one. That means equals method is already there in the bank account class, and that equals method is that version which has the functionality something like which checks the double equality operator kind of functionality. Now we are going to see and demonstrate that double equality functionality. Please watch carefully. There is no equals method as of now. Now what I want to do is I want to create go to the bank account toString main. For example, I will show here what I do is System.out.println b1 dot equals of b2. Now what is happening? The data of b1 and b2 in this particular example is different. That means we should get the false for this output. Let me comment these two print commands for some time. Okay, now for this statement, we should get false. However, we'll get it false because the default functionality compares the object references. Now let me change this data to same. I copy this one and then I paste it in here and then save the program and I again execute this one. We will get the output false again. Actually, we have to get true, but we are still getting it false. Why? Because for the explained reason, this equals method internally is translated into a statement something like this one, b1 double equals to b2. But actually b1 is a different object and b2 is a different object. Now, what we have to do is, in order to get the expected output true in this particular situation, such as the data of b1 is same as the data of the b2, we should get true. In order to get the expected output, we have to explicitly override the equals method inside the bank account class, such that if the data of these two objects are same, it returns true. And if the data of these two objects are different, it returns false. Okay, we have to override that. But during the overriding process, we have to keep in mind certain rules, and the rules are mentioned here. The default functionality we have done with this bank account, right? Let me demonstrate with the product also. Let me demonstrate this product main as well. The product main, I say this is B2 and this is P1. And let me comment these two statements for some time. Now let me save and execute this program. This is now we got false again. Again, we have to override that same thing. We don't have the equals method inside the product class. So we need to override the equals method in such a way that returns true or false depending upon the object contains different object contain the same data or not. And while overriding the equals method, we have to follow certain rules which are technically together called as equals method contract. Now let's go ahead and see that. we have P1 which matches the data, the data of the P1 matches with the data of the P2. These two are same. And if we use P1 dot equals of P2, we should get true. And similarly, if P1 dot equals of P3, the data is different and it should return false. And let's go ahead and see the rules. We should override the equals method in such a way that it checks the data of two objects instead of two object references. Example, if you write P1 dot equals of P2, as per this sample data, this function should return as true. That's how it works. Now let's go ahead and see the rules. The rule number one is, if both source object and the target object are same, then we should return true. That means if this is the source object and this is the target object, P1 dot equals of P2, if both objects are same, then we should return true in the method functionality that we are about to override. And similarly, the next point, if the target object is null, then we should return false. For example, we have these three objects available, and if we say P1 dot equals of null, which is the target object, there is no meaning in comparing something which is not in existence with something that exists. So P1 dot equals of null should return false. Okay, we should write our code in such a way. Now the next step is, if the target object belongs to a different class, then we should return false. Consider we have P1, P2, P3, S1 and S2. These are all string objects. These are all product class objects. And if you write a statement something like P1 dot equals of S1, then we should return false, because there is no point in comparing objects of two different classes for their equality against the data. So in this case also we should return false. This is rule number 3. And the rule number 4, if the data of the source object is different from the data of the target object, then we should return false. In this case, we have three objects, product objects P1, P2, P3. And if we look at this one, P1 and P3 both belong to the product objects. That means it makes sense for us to compare the data of these two classes. But if the data of this one is different from the data of this one, then the functionality should return false, something like this one. So the data of P1 and P3 are different here, we should return false. The next rule, if all the above conditions fail, then we should return true. For example, we have something like this one. I compare P1 dot equals of P2. This data is same as this data, then we should return true. This entire rule set, we technically call it as equals method contract. Okay, and by fortunate, Eclipse provides the facility for us to automatically generate the equals method. We don't have to separately keep these rules in mind, except for the interview purpose. Otherwise, we don't have to memorize these points. Okay, Eclipse will automatically generate the equals method. While generating the equals method, Eclipse will automatically follow all these 5 rules. Let's go ahead and see the examples of equals method that we ordered the equals method for the product class example and bank account class example, such that it works in a way that we expect. Now let me go to the bank account or product class, whichever first. Now let me go to the product class, for example. Now inside the product class, what I want to do is I want to right click here and then go to source menu and then go to generate hashcode and equals method. We understand the hashcode method in the next few minutes. Here Eclipse is prompting us whether we want the object to be compared based on the data of all the fields. So I want to take yes there. And you see here the first one, if this object is equal to target object, then both are same, the return true. And if object is equal to null, that means this is the target object. If this one is null, then there is no point in, so we return false. And if both class names are same, if both class names are different, then return false. Get class means it returns the class name of the source object. Object.get class means it returns the class name of the target object. This is rule number 3. This returns false. Okay, rule number 1, rule number 2, rule number 3. And then rule number 4, both belong to the same class, but their product ID is different. That is rule number 4. This is rule number 4. Otherwise, this is the rule number 5. And this is how it works. Now let me save this one. What I want to do is I want to go to the product main, and then you see product to string main. Here, this time the data is different. Now it returns as false. However, if the data is same, it returns as true. Okay, now the data is different. Now what I want to do is I copy this one and then paste it here. And then paste it here. This time it should return true, right? So because we have overridden, this has written as true. And similarly, let's do the same thing for the bank account example. This is here. Now let me come here and go to the bottom of the code, generate the source code, and that is equals and hashcode method. Now based on the 2 attributes we want to compare. Now save and then go to the bank account main class, and then we can run it here. This time it gives us the result as expected. Let's say both are same. Now this one returns as true, right? Say true. And let's say I want to change this one to some other. Now I'll right click and then run as. This will return as false. This will return as false. So that is about the importance of the equals method to be overridden. The equals method is very important. Accordingly, the hashcode method is also very important. Okay, now let's go ahead and see the next topic, that is the hashcode method. The hashcode method returns an integer technically called as hashcode of an object that is used by the hash table data structures such as hashset, hashtable, and hashmap. This is a part of the collections framework that we will understand at the end of this tutorial part. Collections is the last topic in the Java Standard Edition to learn. Now, the default method of the hashcode, it returns the memory location of an object. However, we have to override the hashcode in such a way that it returns us by following certain best practices. Overriding hashcode. We should override the hashcode method against its default functionality in such a way that it can be correctly used by the hash table data structures in the aforementioned slide. Now, rules to override the hashcode method correctly. If two objects are equal according to their equals method, that means if p1.equals of p2 returns true, then p1.hashcode and p2.hashcode must return the same integer. This one should, if this one returns 10, this one should also return 10. So this is the rule. Then the hashcode method should return the same integer with this one. However, the usage of the hashcode method and equals method is best understood in the collections topic. Until then, just learn the syntax and the rules, and then override the equals and hashcode methods accordingly in those respective classes, and they can be used in the collections framework. Now let's go ahead and IDEs such as Eclipse and others provide the facility for auto-generating the code of equals and hashcode method according to the above discussed rules. Now let's see the hashcode example. This is already overridden. Just we need to print them and see. Now B1 and B2 are different, right? Now if we print the hashcode of B1 as well as the hashcode of B2. Now B1 dot hashcode, and then let me print B2 dot hashcode. B2 dot hashcode. Now let me comment this because this is false for now. Now let me comment this one. I say both are different, then the hashcode different, then the hashcode is different. Now let me make this same data here, copy and then paste it here. Now the data is same. Both the objects are same according to the equals method. If both objects are same according to the equals method, then their hashcode has to be same. Now we get the same hashcode. You watch here. This is the rule we have to remember. And let's do the same thing for product class. I copy this one here, and then I copy it here and then paste it here. Now this is P1 and this is P2. This is P1 and this is P2. And let me comment this equals method for some time. Both objects are same according to the equals method. Right click and then save as. We should get the same hash code. We got the same hash code. Just in case if this is different, let's say 101, and now I save this one, we get the different hash code because both of them are different. However, if two objects are unequal according to their equals method, it is not compulsory that the hashcode method should return different values. That's a tricky point to notice. And that's about the importance of the equals method. Functionality of the equals and hashcode method. Their importance is best understood in the collections framework topic. Now let's move on and see the list of few other methods that belong to the object class. Finalize, get class, clone, wait, notify, notify all. These three methods, wait, notify, notify all, they are used in multi-threaded applications. Finalize method is currently deprecated, and get class method returns the name of the class to which an object belongs. The clone method is used to create a duplicate copy of a given object, and that's about the importance of the object class methods. Thank you. Now let's understand the next topic, that is the comparable interface. We'll see this, what is comparable interface and what is the compare to method, along with the code examples. The comparable interface is from java.lang package, and one of its methods is the compare to method, which is used to compare two objects of the same class against their natural order. For example, 10.compareTo of 5, we are using the compare to method to compare whether 10 comes first or 5 comes first against natural sequence. And similarly, Java comes first or Angular comes first against the natural sequence, and product 1 comes first or product 2 comes first against the natural sequence. So the compare to method, if the source object such as 10 is greater than the target object such as 5, the return value of this compare to method is a positive number. And similarly, if the source value is negative than the target value, if the source value is less than the target value against the natural sequence, then the return value is a negative number. And if the source is equal to target, then the return value of this compare to method is 0. So let's go ahead and see this code example. Let me create a new project, file, new Java project. Let's say comparable project one. Now here I want to create a new package. Now the package is let's say comparable demo, and in this package I want to create a new class comparable int demo, and inside this one I want to create a main method. Now inside the main method I want to just say new, in let's say I want to take two integer classes, integer I equal to 10, integer j equal to 20, and then I want to say I dot compare to of j, and that's it. So if this is less than this one, we'll get a negative number returned. If this is greater than this one, we'll get a positive number returned. And if this is equal to this one, we'll get 0 returned. Now let me run this program, something like this one. Maybe that is, now let me see the change the values reverse. I'll say it as 30. Now Control S. Now let me save and execute this one. We get some 1. Let me change the values to same, then Control S, then save it as new Java application. We get the 0. Now similarly, I want to copy this one and then paste this one, comparable, let's say string demo. And then inside this comparable string demo, this time I want to take two strings such as Java, Angular. Let's say string, I even don't need an object. If you remember, I explained, let's say string Java dot compare to of let's say Angular, something like this one. Now save and then execute that. If the source is this one, this is greater than, so if you see here Java comes after Angular. Now let me reverse these two, Angulars dot compare to of Java, Control S, and then save and execute. This will give minus number, and let me give both of them the same. Then this will give us 0. We are trying to understand the compare to methods return value. After this one is completed, we'll see various comparable interface used. Now let me create a new product class. Let's say product, and inside this one I want to declare a couple of variables, private int, let's say product ID, and then private string product name. Then I want to say something like getters, setters, and constructors from fields, and then constructors from superclass, and constructors from fields, and then getters and setters. Let's say getters and setters. This is all done. Once we are done with the getters and setters, we have to go for implements comparable here. Implements comparable of product type. This represents that we want to use compare to product class objects. Now here this comparable has a method, as we know, compare to method. Place the mouse here, add unimplemented methods, and then scroll down, you see the compare to method. So here what we need to return, we develop the logics in such a way that if this dot product ID is greater than arg0 dot product ID, and then we want to return 1, else if this dot, we are comparing two products based on the product ID, arg0 dot product ID, then we say return -1, and then else return 0, something like this one. This entire statement can be developed in one single statement. If you want to say comment this one, source add block comment, what I want to do is return this dot product ID minus arg0 dot product ID. So this is the arg0, the T2 in our example. You watch here, this is P1 and P2. So this means P1 in our, this means P1, and P2 means this arg0. We are comparing and then returning our value. Now let's say I want to go for a new class, then comparable product demo 1. Inside this one, I want to create a main method, and then I want to create a System.out.println new prod. See, we can use the object names or not, that's up to the requirement. So product p1 equal to new product of, let's say, new product of 10 comma a, and then product p2 is equal to new product of, let's say, 20 comma b. This is second product, and then System.out.println compare to of p2, and then now let's see the output. Say this is something like this one, or we got 10. Okay, something like this one, some logic. Yeah, that's how it works. Right, so now let me reverse this too. This is p1 is less than p2, right? This 10 is less than this one, so I reverse this too. Then p1, now we get a positive number. This time we got a positive number. Let me say both of the same, p2 and p2, both values are same, and then I get 0. And you want to change this one to 20 and b also, you get the same values. Save p1 and p2, two different objects I want to compare with the same data, you get the same 0. So that's about the compare to method, how it works. And the compare to method is actually used by special collection classes called as tree set, tree map, and something similar to them. For example, let's understand how tree set classes uses compare to internally. Tree set is a topic that belongs to Java collections. Please, once you once we reach the Java collections, then you'll come back and understand this point one more time to understand that logic. Let's say we want to store 5 strings in some class called tree set. Tree set is a class that stores all the objects given to that in sorted manner. Let's say the input that we give inside the tree set is first Java, .NET, Angular, Oracle. But after we give these set of objects in this particular sequence, such as Java first, .NET second, and so on, tree set, what it does is it automatically sorts all these elements. In order to sort all these elements, it internally makes use of the compare to method. Okay, so somehow it does java.compare to of .NET. So if this written, depending upon the written value, in this particular example, Java is greater than .NET, then what happens is tree set does a shuffling of Java and .NET. You see here, and after these two are done, it will again compare Java compare to of Angular, and then it will again .NET, Angular, and Java, and keeps on something like this one. This way, it will sort all the data. So that means tree set internally makes use of the comparable interface. So this is important to remember, that in order to store any object, the class of that object, any object in tree set, the class of that object should implement the comparable interface as per our example that we did now. For example, if we store the object of the product class inside this tree set or tree map or something, we have to do some code, something like this, implements comparable, something like this one. Otherwise, the compilation fails. However, we'll understand this problem statement when we talk about the Java collections framework tutorial during the tree map and tree set. Thanks for watching. Let's continue with the next topic. Now, let's understand the next topic, that is the Java collection framework. In order to learn Java collection framework, we should already know the concepts of data structure programming. At least the basic familiarity of the data structures will help to learn the collection framework easily and clearly. Therefore, I am going to explain the overview of the data structures concepts in this particular part of the tutorial. However, this is not an in-depth data structure tutorial. If you are already familiar with data structure programming, you can skip this part and start from collections onwards. And here is the list of points that we will understand in this data structure model. What are data structures and what are they used for, followed by the different types of data structures. And then we will see the functionality of and the working of arrays, linked lists, trees, and hash tables in this particular part of the tutorial. So let's begin with the definition. What is a data structure? A data structure defines a solution to efficiently store and retrieve data from memory. And the data structures are used to improve the performance of a program in terms of memory usage and time. There are two categories of data structures: linear data structures and non-linear data structures. Linear data structures store data sequentially arrays, linked lists, and hash tables are examples of linear data structures. Non-linear data structures store data randomly. Trees and graphs are non-linear data structures examples. Now let's understand the working model of arrays, linked lists, hash table, and binary tree data structures, which are the main topics to learn Java collection framework. Let's begin with the concept of arrays data structures. Arrays data structures store data as continuous collection of memory cells. The retrieval operation of an element in an array is faster because it is index based. For example, if you want to find or search the fifth element, that is the element with index 4, we can directly hit the index 4 and retrieve the element. However, the insertion and deletion operation in arrays data structures are time taking and they are called costly operations in arrays data structures. For example, if we want to insert the element 4 in between 34 and the 5 elements, then what we need to do is we need to shuffle the places of 67, 56, and 5. That means we need to push these elements to the next place, something like this one. We need to push 67, 56, 5, and then make a place for the element 4 and then insert it there. Once again, if you want to delete the element 4, we need to reshuffle the data structure, something like this one, back to its original place. So this shuffling of elements is costly operation, and therefore deletion and insertion operations in arrays data structures are called as costly operations, whereas retrieval operation is fast because it is index based retrieval. Directly we can jump to the specific element and retrieve that particular element. Now let's understand the next data structure model, that is the linked list. Linked list data structures store the data in terms of something called as nodes. Each node contains data as well as the memory cell address of the next node and the memory cell of the address of the previous node. Just in case if a particular node is the first node, as a part of the memory cell address of the previous node, it contains the address of a special node called as start, which does not contain data. Just in case the particular node is the last node in the list, the memory cell address of the next node contains something called as null, which does not point to the next node. And this is the example of the linked list. We have the start pointing located at the cell number 10, and we have various nodes such as Java, Angular, React.js, and Python. And if you notice, the memory cell address for the previous case of the Java is 10, which is the start, and the memory cell address of the next node in case of Python is null, which represents that there are no more elements available. Right. So if at all we want to insert the data new node into the list, for example, in between Java and Angular, we need to detach the link between Angular and Java and then insert the .NET node in between. However, inserting or deleting operations in linked list is cheaper because they don't need shuffling of elements as in the case of the arrays. Let's understand how the insertion operator works. We insert the data something like this one, and these are detached and reconnected. Once again, if you want to remove this one, we can connect Angular and Java, and then the operation is little cheaper when comparing to the insertion operation or deletion operation of the arrays. And the retrieval process of elements in linked list is linear to the number of elements that are available, the number of nodes that are available in the list. And that's about the doubly linked list. Now let's move on to the next topic called as binary trees. A binary tree data structure stores data nodes in terms of a two-branched tree, and therefore it is called as binary tree. The first element in the tree is called the root node, and the remaining branches are called as the remaining nodes are called as branches, and this is the right hand side branch and this is the left hand side branch. The insertion or retrieval process or deletion process in a binary tree is something like, if at all we want to insert an element, given element such as 33, we compare the 33 element, the data of the 33 with an already existing node's data. If the data of 33 is greater than the existing node's data, then we drop that new data onto the right branch of the existing data. Else we drop it on 33 onto the left branch. In this particular example, 33 is greater than 27. Therefore, we drop 33 to the right hand side, and right hand side there is already some other element. Again, we compare 33 with 35, and then we drop it to the left side in this particular example. Again, we compare 33 with 31, and then we drop it to the right hand side, something like this one. That means insertion and deletion operations in trees is only 50% of time that is taken to insert, to delete, or to search. We are not going to search the entire tree, right? So that's about the trees concept. Now let's understand the next data structure model, that is the hash table data structure. The hash table data structure stores the data in a 2-column array, where in the first column it maintains the index of the data that is stored and retrieved, and in the second column it stores the actual data. In order to store and retrieve the data, hash table data structure uses a special technique called as hashcode. Hashcode is an integer that is calculated by the hash table data structure on a given piece of data in order to store it or in order to retrieve it. For example, in order to store this text elbow or below, the hash table data structure computes the special integer called as hashcode on the data such as elbow. The formula to calculate the hashcode can be user defined or any custom formula. However, the more efficient the hashcode formula, the more efficient the storage and retrieval of the data will happen. For example, as a basic level understanding, in order to store the data such as elbow and below, let's say we want to calculate the hashcode of the elbow by summing up the alphabetical indices of the alphabets which are a part of the word elbow, such as E plus 5, E plus I plus B plus O plus W is equal to 57, in which 5, 12, 2, 15, and 23 represent the alphabetical indices of the letters in the word elbow. Once we get the hash code computed, we perform a modulo operation of this hash code with the number of elements that are available in the hash table. For example, we have the 7 elements, 7 indices available, and then we perform the modulo operation 57 with the 7, and then we get 1. And then this is the one which is the index at which the elbow is stored, something like this one. And this process continues to store and retrieve all the pieces of data in hash code. To store the data, we need to calculate the hash code. And again, to retrieve the data, we need to use the hash code. So for example, below also goes to the same thing, to the same data, to the same index, because both the elements have the same data, so same hash code. Similarly, state goes into same thing, and then taste, both of them have the same alphabets, both of them go there. And once again, night and thing, all of them go into the same index. So that is the hash table data structure model, and this is the overview of the data structures. Now let's understand the next topic, the Java collections framework, as we previously understood the overview of the data structures. If you don't have the knowledge on data structures, please go back to the overview of the data structures prior to this part of the tutorial. Finish that and come back and start learning this one, please. So let's see what are the topics that we will understand in this particular part. We'll see the meaning of what is a collection, followed by the concept of generic collections and non-generic collections. What are collections used for, followed by the meaning of the Java collection framework, the collection interface, list interface, set interface, followed by ArrayList class, LinkedList class, treeset, and hashset classes. After that, we'll see the map interface, treemap class, hashmap class, hashtable class. We'll then see the meaning of fail-fast collections and fail-safe collections, followed by the collections class as well as the arrays class. So let's begin with what is a collection. A collection is a group of objects, example, a group of string class objects, a group of employee class objects, a group of string class objects, employee class objects, and number objects, and so on. Collections are of two types, generics and non-generics. Generics collections are those which contain the same type of objects. Non-generics are those collections which contain different types of objects inside the collection. Example of non-generics include employee class object, string class object, integer class objects, and this is non-generics. Generics means collections which contain similar objects such as string class objects or otherwise employee class objects or otherwise bank account and so on. Now let's see the reason for using the collections. Collections are used to efficiently store, retrieve, update, and delete a group of objects in memory. They help in transferring a set of objects collectively from one part of the application to the other. To understand this statement, let's consider we have the records in the database. Using some Java programs such as JDBC program, we fetch the records from the database and stored in the collections, and all those records are put inside the collections, record 1, record 2, record 3, and that collection as a bunch is transferred to some other programs such as a servlet or a controller program such as Spring MVC controller. And from here, that collection is again transferred to the browser. So in this model, what is happening is we are able to transfer a bunch of records in as one single packet from one part of the application to the other part of the application. So these are the two different use case examples of collections, of working with collections. Now let's move on and see the topic of Java collections framework. Java collections framework is a set of Java interfaces and the classes which implement these interfaces. Okay, and these interfaces and classes are available in a package called as java.util, as well as other related package of similar. And this is the hierarchy of the Java collection framework. At the top contains something called as iterable interface. Next to the iterable interface, there is a child interface that is called collection interface, which again has two interfaces, list interface and set interface. Okay, and there are so many implementation classes available to the list and set interfaces. A few examples of the classes that implement the list interface are ArrayList, Vector, and LinkedList. And a few example classes that implement the set interface are TreeSet, HashSet, and linked HashSet. Now, let's understand the concept of the ArrayList class, why it is used and how it is used. The ArrayList class implements the functionality of the arrays data structures, as we previously understood in the overview of the data structures concept. And this is the example of dynamic arrays concept. Next thing is linked list class. This implements the functionality of the linked list data structure, and that looks something like this one. Similarly, the tree set class implements the functionality of the tree data structure that looks something like this one. I repeat once again, if you are not familiar with data structures, please go back and complete the overview of the data structures part in this tutorial, which is immediately previous to this part of the tutorial. And the next one is the hash set class. This class implements the functionality of the hash table data structure, something like this one. We had clearly understood in the previous part of the tutorial. Now let's move on and see the few methods of the java.util.collection interface. This interface is the top level interface. Of course, on top of this one, there is one more interface called iterable interface. The most commonly used methods of this collection interface are add, remove, contains, is empty, clear, size, and iterator method. The add method and remove method are used to store an object inside the collection, and the contains method is used to check whether a collection contains a specific object. It returns true or false. The isEmpty method returns true or false, indicating a specific collection is empty. And similarly, if we want to remove all elements from the collection, we make use of the clear method. The size method returns us the number of elements available in the collection. The iterator method returns us a pointer to the collection's start pointer, using which we can visit each and every element and then iterate it. Now let's see the hands-on code examples such as ArrayList, linked list, HashSet, and TreeSet. We can store the data, we can retrieve the data. We'll see the examples step by step. So we'll see the examples for integers, strings, and product class objects for all these classes. So let's begin with the creation of the new project. I'm creating a new Java project, and let's say the project name collection project 1. Now inside this collection project 1, I'm creating a new package. Let's say com.collection1, and here I'm creating a new class. The class name, let's say ArrayList demo, maybe ArrayList string, ArrayList string, something like this one. Now here I want to create add a main method. Now inside the main method, I want to create first of all, we need to import something like this one. Please watch. Import java.util.ArrayList. something like this. However, this is only to demonstrate to you. We can automatically get the import statement. Please watch here. What I do is list, and then the syntax to work with generics is something like this one. We give the class name of the object that we want to store inside the list. Usually, more technically, class name is considered as a type name. So we type the something like this one, type name, something like this one. Okay, list type. See, for example, here if you want to store strings in the array list, we give a string there. If you want to store employees in the array list, we want to give employee there, and so on. And this list is from the java.util package. We need to import that. You see, if I press control, if I first of all, let me declare this statement, and then let me give a string. I want to store all the strings in the array list. Let's say string list is equal to new array list. Okay, new array list, something like this one. Okay, so the moment I have used the control space, so it has automatically imported the array list. However, this has to be imported. We have a couple of options. We can place the mouse pointer over there, and then we can choose this one, import java.util.list. There is one more list. If you notice, there is something called as java.awt that is used for Java graphical user interface. So we are using this one, please. Something like this one. Now, this is how we create an object of the collection. Please watch. Maybe if you want the interface name, let's say the syntax is interface name followed by collection name equal to new implementation class name, and then square bracket, something like this one. So here we, after the interface name, we provide the type of the collection object that we want to store in the collection. As an example, this one. If you want to use array list here, the class name, you will get the output well, but that is not a recommended choice because of the best practices. We always use the interface name. To understand and to get experience about the best practices, you need to learn the Java and gain some experience and follow certain design practices or best practices. Then you will understand the reason why do we use something like this one. Right. So now this is done. We have created a brand new array list object. That means we currently get something like this one. Let's say when that statement is executed, we get an array list, something like this one. We get, this is a string list. And once the array list is created, what we want to do is we want to add into that string list dot add, and let's say Java, and then I want to copy and paste a few items there, and then Java, Python, Angular, React.js, whatever. Okay, Angular, and then React.js, and so on. Now, once we add the things into the list, we can straight away print them. Okay, this is creating collections. Now let's move on and copy and paste this one to something else. Maybe I finish this printing concept. You see, now System.out.println, I use the string list, and then save and then execute this one. Now we got the output, something like this one. So this works well for strings because strings are simple objects. So we get the actual data of the strings stored inside the collections printed. Now, however, if it is an employee class object, we get the hash code of the employee or hash code of the bank account, whatever we have used inside the collection. And please try to understand the syntax. This is the syntax that we use to work with generic collections. As I explained you, there are two models of collections, generics and non-generics. In case of non-generics, this bracket syntax won't be there, and that is the old style of programming which is currently not used. Please do not use that at all, please. So let's say interface name, and then no bracket symbol, nothing, and the collection name, variable name, whatever you want, and then new implementation class, no brackets once again, please, something like this one. So this also works, but it is not recommended to use this syntax. Please always use this syntax. Now that we are done with the array list string example, let me copy and paste this file, copy this one, and I paste it here. And then what I do is linked list string, linked list string. The entire program is same place, only the class name gets changed here. Then what is the difference? If you have a question, you have to answer it yourself, of course. The answer I'll tell you in the next 2 minutes. So linked list, then linked list. That's all. Control Shift O will import the generate the import statement. Please watch here, undo. I'm pressing the key combination Control plus Shift plus O. When I come here, Control plus Shift plus O, this will automatically add the import statement here. And you see this is the red line is removed. Now the difference when you run this program, we'll still get the same output. Now the difference is, I think you already know the difference. The difference is in the internal functionality of the linked list. Okay, so when you use the linked list internally, it implements the data structure, that is the linked list data structure. And when you make of the array list internally, it uses the arrays data structure internally. So that is the difference. Programming wise, you don't have any difference. You have the same method names polymorphism. If you have learned my tutorial from beginning to this part, I have clearly explained this is polymorphism. Polymorphism is a feature in which a given object behaves differently as a different times. Now let's move on and see the next topic, that is I'll copy, and then what I do is copy this one and then paste this one. Let's say this time I want to use tree set string list, something like this one. And once again, no changes, please, just one single change. See how easily we are able to switch from one data structure to other data structure because of the polymorphism and other stuff. All these methods belong to the collection interface because they are there from the collection interface. From the collection interface, they inherit to the list interface. From the list interface, they inherit to the I'm sorry, this is not lists. I'm so sorry for that. This is set interface. There are two different roots of collections, list and set. We'll see that in the next few minutes. And this is string set. I'm so sorry. Is it set we are talking about? Hash set, yes, hash set and tree set. And once again, this is let's say set. Okay, I made a mistake. Of course, we can change it in one place. That gets changed there. That to teach that, I have to teach you one step for that. Okay, now this is completed. Now let me run as, and this is how. If you notice the output in these tree set program, Angular, Java, Python, and React.js. And if you notice the output in the addition sequence, the add statement sequence is Java. We have added first Python, Angular, and React.js. This is the add statement sequence. And the add statement sequence is same in almost every program that we have copied and pasted. Now Java, Python, Angular, and JS. When I execute the ArrayList and linked list program, you see the output. We are getting the output displayed, and the output contains the sequence of the strings which are added to the list as per the add statement sequence. But when we execute it in case of the tree set, we are getting the output in alphabetical order, that is in the dictionary order. Why? Because tree set internally uses something called as sorting technique, and it implements some interface called as sorted interface. And therefore, tree set sorts the data, whatever we add it to that. And once the data is added, the sorted, it will print us. Okay, so the sorting happens dynamically, not during the compile time of the program, but it is done during the execution time of the program. In order to get the successful sorting of this data, we need to make use of the comparable interface and its compare to method. So that's about the tree set. Now let's move on and copy and paste the tree set to the hash set. I copy it in here and then paste it. Let's say this is hash set. Okay, hash set string list, and this is a set interface. We have two models, I told you, set and list, and then currently we are working with hash set. On the previous two cases, we worked with tree set, linked list, and array list data structures. Now this is imported, Control Shift O, hash typing mistake. Okay, and then Control Shift O. This is imported. Now let me run this program. We get the output something like this one, and then we are done. So that's about the working with string class objects. We can use the integer in the similar model. Let me demonstrate that one as well. Okay. Now let me create one more class to demonstrate the integers. So let's say new class, and let's say the class name array list integer, and then same again. What we do is we generate the main method, and here what we do is a list of integer, and then let's say integer int collection is equal to new array list. And then, if you remember, it's almost the same code. Control Shift O for this one, the java.util.list. Now I want to add int collection.add, and here new integer of 10. And instead of writing new integer of 10, we can directly mention something like directly 20, the number directly. If you remember, I explained you the concept of auto boxing and boxing unboxing when I talked about the Java wrapper classes. This is auto boxed. Okay, this is manually creating an object. I also explained you the reason, the need of the wrapper classes. Why should we use the wrapper classes if we already have primitive data type variables? Because collections, they don't accept the primitive data type variables. Here it looks like this is accepting direct value, but it is automatically boxed into an object of the integer class. Okay, now let's say copy and paste a couple of times, or let's say 10, 20, 30, 40, and 50. And then I want to print the int collection, and then this is printed. We'll see all the operations. The moment we start adding the writing the add operation, now what happens is when these statements are executed, the data is stored into this collection. Let's say this is array list or tree set or whatever it is. Let's say it adds, it keeps adding something like this one at 10, 20, something like this one. At the moment we perform the add, it adds the data, and internally it maintains the data structure implementation of whatever class that we make use of. If we are using ArrayList, it maintains a sequential collection of memory cells. If we are using the linked list class, it uses the doubly linked list data structure model, as we learned in the data structures overview and so on, right? Something like that one. So we added, and then let me save and execute this one. Let's say this one, that is done. So to save time, I want to just change the class name here itself. I'm not taking one more class, please. Linked list, and then save, Control Shift O, and again we get the same output. Right click, and then we get the same output. Now this time I want to make use of the tree set. On the left hand side also I have to make it as set interface, Control Shift O. If you remember, an interface reference, this is the interface reference. An interface reference can point to an object of its implementation class. I have clearly explained every point for which the syntax I'm currently using. If you're not familiar with interfaces, and if you're not familiar with this interface name on the left hand side and the class name on the right hand side, please go back to my interfaces tutorial in this part in the same tutorial, and you will understand it clearly there. Okay, so and then that's it. We can now execute that, run as Java application. This is, maybe I'll put this 50 in the middle or somewhere. I want to demonstrate the tree set sorts the data. Okay, I cut it and I'll put it randomly. So 50, 30, and so on. We get the data like 10, 20, 30, and so on, because tree set makes use of something called as comparable interface. That's about the tree set. And if I use the hash set, okay, hash set, Control Shift O, and then this is done. Let's see, we get the hash set, something like this one. So that is done with the integer example and string class example. Add statement is done. We are learning all the methods one by one. We are done with the add method for integer and string class. Let's see the other methods step by step right now. Before that, I want to go for the product objects example. As of now, we have used the integer and string, but let's create one product class. I'm creating a new class, and let's say the class name is product. And inside the product class, I want to declare a few attributes. Instance variables are called with different names: attributes, properties, instance variables, and so on. Private int product ID, private string product name, and then we want to generate everything. Right click and then go to source, and then constructors using superclass and fields and so on. Everything, constructors from fields and all that stuff. Then source, getters and setters. What is that? Getters and setters. I have clearly explained you all the topics which I'm currently using in this one. And then right click and then source, equals and hashcode. Pretty important methods. I have explained you when I was talking about the object class. Very important, please. And this is completed as of now. and we need to add something called as comparable interface in this particular one. So I'm doing that. Please implements comparable, and here I want to say product, and then I want to add unimplemented methods. This is for the sake of a tree set class, please, for the usage of tree set class. Then we have to go and implement this comparable. Let's say I want to say this one as let's say return this dot product ID minus arg0 dot product ID, and that it's done. So we are comparing the values, the products based on the product ID. If you want to compare based on product name, you can do that. Okay, so that is done with the product class defined. Now I want to go ahead and create a new class, and the class name, let's say product collection or product list. I say, let's say product list or demo1, or else I say product list demo1. That's okay. Now here I want to let's say I create a main method. Now inside the main method, what I want to do is I want to declare a list, and then this time this is product. Please watch here, I'm using the class type as product, very important point. And then prod list is equal to new array list. First of all, let's use array list, and then we change that to linked list. Of course, we get the same output wise, but the difference is in the underlying implementation. As I told you, Control Shift O util, and this is completed. Now I want to add the item product list dot add method. To the add method here, I want to add the product class object. So new product, and the product method has two constructor parameters, that is product number 1 or 2, and then let's say product name as mobile, and then let me copy and paste, and then 1 2 3 4 5, and then I want to say this as charger, and then I want to say this one as Bluetooth, and then I want to say this one as earphones, and then I say this as cable, and then this one be 105, 103, and this is 101, this is 104. Randomly I have placed all these things here, right? So that's it. Now let me print this one. If I print this one, we get the hash codes. However, I'll demonstrate you how do we loop each and every element and then print them in the next few minutes. So when I print this one, let's say System.out.println, I see product list. We don't get the data as it is, we get the hash codes printed. Right click, and then let me run this program. We get the hash codes printed. Now we want to print the actual data, not the hash code, something like this one, please. We'll see that in the next few minutes, as I'm saying. Okay, this is done with the array list, and then you want to see the same output for linked list. Almost we get the same output, linked list. Okay, linked list, Control S save, and then import, and then right click, and then run as Java application. This is now completed. Now let's say I copy and paste this program, maybe not this one, I say this one as set, and this one I say as product set. I'm sorry, let me not disturb this code. I copy and paste this program. Okay, copy this and then paste it here. This is product set. This is product set demo1, and here I want to use preset and hash set this time instead of list here. Let's say set, and this one is product set, and this one is preset. Okay, this one is preset. Okay, so many topics to learn. Please hold on and watch and complete all the tutorials, all the parts of the tutorial, very important. And this one is okay, this is I can actually change it in one place. Control find and replace and other options are available, such as refactoring. I did not explain you that point, that's the reason I'm not using that place. Okay, let's say save, and then if I run this one, we again get the similar hash code kind of output, but we'll see the details very soon. And this is product. Now you see I have used the tree set here. Inside the tree set, I have stored the objects of the product classes and product objects inside the tree set. But if I don't implement the tree set, comparable interface inside the product.java file, and if I execute this one, watch here, this implements keyword inside the product.java file, I'm deleting for some time, Control X, Control S. I've deleted that. And if you watch here, inside the tree set, product set is a tree set. Don't get confused, please. Product set dot add, this is a tree set. inside the set, what is happening? The tree set internally sorts all these product objects according to some order it want to store on. But how does the tree set know whether it has to sort the product objects based on the number or based on the name or something else? So therefore, it doesn't know that information. Therefore, it won't be able to sort it, and thereby it will raise an exception. Please watch here, class cast exception. Some error. Where is that error? Let me see. Even then again, run as Java application. Collection project 1 errors exist. Which place? Maybe some other place. Forget about that. So we got this one, class cast exception. Watch it here. So this is the it has no comparable. You see here, product cannot be cast to java.lang.comparable. Now if I put that comparable back to this product.java, then it works well. Control V, Control S. Then I come here, reset. Internally, when I use this one, internally reset makes use of this comparable method, and it takes the two consecutive product numbers, this one and this one first. It compares and sorts these two elements, and again it makes this one and this one first, and again compares and sorts this one. If you are not familiar with the comparable, please go back to the comparable topic of my tutorial, and then you can come back here. This you will understand that clearly. So let me put some print statement inside the compare to method to demonstrate that works. Okay, compare to. Okay, Control S. I've saved this one. Let me come back here and let me execute this one. So and then it works. Isn't it working or not? Compare to, has it not used or not? So that's the reason behind using the comparable interface inside inside the product class, in order to store the product class object inside the this one tree set. Now let's say we want to use the hash set instead of the tree set. This is product set demo. And if you remember, I explained you the functionality of the hash table in the data structures overview. And here it internally makes use of the hash set. Okay, so the hash set internally makes use of the hashcode method. Please watch here. I'm going to the product.java. Okay, I explained you the reason of the hashcode concept as well as equals concept. Hash table uses both equals and hashcode. So equals as well as, let's say I go to the hashcode. If you remember, I explained you the meaning of hashcode, how it is used and where it is used. Hashcode method. Now when we execute this product set program, the hash set object, in order to store the product class object inside the hash table, it first of all computes the hash code. In order to compute the hash code on the given object, what it internally does is it does something like this one, dot hash code, something like this one. So it computes the hash code, and once the hash code is calculated, it makes use of the modulo operator, as I explained you in the data structures overview hash table example explanation. Okay, so that's the reason, even though you don't use it internally, it is used, please. So now when you execute this program, we see the output of hash set. So this one, hash code, this output. You please watch here. When I run this program, run as Java application, you get the hash code, right? Something like this one. Now, if you want to search some element internally, hash code after computing the after computing the hash code, since more than one object can have the same hash code, therefore, in order to find the right element, what it does is it performs the search operation based on the equals method. Okay, so once it hits the particular index, it performs the equals method across the, it executes a loop and checks the equals method across the list of elements that have the same hash code. We'll see that in the next few minutes. Now that we are done with the adding of data into the adding of the data such as integer, string, and product into ArrayList, linked list, hash set, and preset. Now let's move on and see the next few methods. Let's say I'm here. I go to the let's say the product list one. Let's say I want to search first of all, let's see for the strings, for example, ArrayList string here, and I demonstrate it for string, and then it's same for everything, please. Now I'm checking whether this string list contains Java or not. So I'm checking that. You see here, string list dot contains, and then I'm saying Java. The contains method returns true or false, and if it is there or not, what I'm doing is System.out.println. I'm cutting it, and then I want to print it here. So we have Java there, and then run as Java application. So we go to true there. So this way we can use it for integers as well and something else as well. Let's say I give hello, and then Let me right click and then run as this Java application. This is done. So we understood the contains method. We understood the add method. Let me use the remove method, please. Come back here. I say, first of all, I remove that. Okay, system.out.println. Sorry, I'm sorry. It's not system.out.println. String list dot remove of I want to remove Java, and then I want to print contains of Java. So if you notice, first of all, we are removing. If it is removed, means the next statement should return false. Now save and then execute this one. Run as Java application, false. So we are done with the contains method for the string objects. Now we'll see the collection is empty or not. System.out.println, and then string list dot is empty, control S. I have saved this one. Now right click and then run as Java application. Okay, it's not empty, therefore we got it false. And then clear, it removes everything. So let me clear that string list dot clear, and then this won't remove there and this won't remove there. Now it's a clear, it clears everything, and then is empty returns as true because it was cleared prior to this check, is empty check. And size, we want to see that. How do you want, before clear itself, let me see the size. Let's say system.out.println string list dot size and something like this one. Now let me save and execute this one. Something like this one, you got the 4. Okay, we have 4 items there. So we have seen almost every method with respect to strings, and iterator method is pending. We'll understand in the next few minutes, please. Now let's go ahead and see the contains method functionality with product list or product set example. So come here in the product list demo 1, and then I want to comment this print command. Now I want to use this product list dot contains method first. Inside the contains method, I need to supply the product class object, product class object I need to supply here. So therefore, what I'm doing is creating an object here, product, and then 102, comma, mobile. I rather say 103, and then that is Bluetooth, right? Something like this one. I use this one. So this entire thing, I want to put the print command. I cut it here, and then inside the print command, I want to put it. And then that's done. So this product list, in order to decide, in order to confirm whether this object is available inside this list, what does the linked list do is it runs a loop, and in every iteration of the loop, it applies the equals method on this object and this object. First, it applies the equals method on this object and then this object. In this case, what happens? The equals method returns false. So therefore, in the loop, it goes to the next item and then compares the equals method and then this object. It fails, and then again it goes here. Then it gets the output here. So it prints the output true here. So let me save and execute this program. And you see here, we got equals has been run for the first time. It did not match the first case. Equals is run for the second time. It did not match the second time. It run the third time, and then it found a match, and then it printed something like this one. For example, let's say the object is there, but if we have not overridden the equals method, what I'm trying to say here, you watch here, I'm commenting this equals method. I'm selecting this entire equals method, and then I'm commenting that one, add block comment. I save the product.java file. I come back here, and then when I save and then execute this one, since the equals method is not overridden inside the product.java, if you remember, the superclass object class is there. The product class gets the functionality of the equals method, inherited the functionality of that equals method that is there inside the object class. Okay, so we have already learned the default functionality, the default behavior of the equals method that is declared inside the object class in that particular tutorial part. Okay, now so let's see how it works. We don't get the expected output true because equals method is not working as expected. We get false. Even though the search object is available, we still get false because the equals method that is there as a part of the object class does check the double equal symbols, as I explained you in that particular part. Okay, so that's about the importance of the equals method as well as the hash code method I told you. Let me this one, uncomment this one. So this is done. Let's say source and remove block comment, save this one. So now we are done with the contains method, and remove method also, it also requires the equals method. Maybe you watch here, I first of all say 109, which is not there, control S, and then this time, even though the equals method is defined, since the object is not available, it gives you false, and it keeps on checking all the objects. You see equals 1 2 3 4 5, it checked this object, the equals method checked this object with all 5, and it did not find the match, and therefore it has printed false. That's the match is not found, something like that one. Now what we're trying to do is, let's say we want to remove that. Let me comment this one. Okay, why should I comment? I directly put it here, and I say this object is 103 and then Bluetooth, and then I want to remove it first. Okay, so removal operation also does the same logic. You watch here, product list dot remove, and inside this one I want to provide new product of 103 and then Bluetooth, and this, so it works. Now I give a print command. Okay, after remove, right, something that's one. What you do is here it prints the equals method again, and here it prints the equals method again. You watch the difference. You see here it has printed the equals method. To remove also, it need to check whether it is there or not. So that's the reason equals method has that importance, right? So that's about the remove method, and we are done with the remove method. Of course, is empty, clear, and all are same. And now let's move on to the next topic, that is the iterate traversing through the collection. As of now, we have demonstrated the basic operations such as add, remove, find, and all that stuff. Now let's move on to the topic called traversing to the through the collection. And in order to traverse through a collection, we have different options available. The first one is called as enhanced for loop, which I already explained in the concept of arrays. And now the second option is using something called as java.util.iterator, and the third one is called as the for each from Java 8. However, I'm not going to demonstrate this for each in this part because this is totally different topic. I will possibly upload the video on this particular part separately. Right, so let's see the for each loop, enhanced for loop examples, and we'll see the iterator later. So let's go ahead and see the iteration process of the previous examples. Previously, when we printed the array list or string list, it straight away printed the output in the what do you say, in the square brackets. Now let me comment this entire code. I comment this entire code. Okay, after commenting this, here I want to use the for each syntax of enhanced for loop. If you remember the syntax, you can understand it. If you don't remember it, please go ahead and watch the for each syntax in my arrays part, tutorial part. What we do is, for string colon s, and then we say string list, and then string list, and that's all. System.out.println s, that's all. So the for each loop, or otherwise called as enhanced for loop, it extracts the next item from this collection and copies it here, and that is what we are working on here inside the loop. That's all. It's pretty simple. Now let me run this one. We got the output. Now let me copy this and put it in the, of course, this is simple. We can apply the same thing wherever we want. In the product list also, what I do is I comment all these lines, save, add block comment, and here copy and paste. And here what we need to do is product, and the current object is product, and this is prod list. So from this product list, we get the next product every time the loop is executed. We get the next product. The next product is copied into this one, and here I want to do product p dot get product ID, and then space, and then colon, and then p dot get product name, save, and then execute. This is the enhanced for loop, easy to traverse through the loop. So that is completed. Now that is done. Enhanced for loop is done. Of course, it's same everywhere. It's same everywhere, please. And let's go ahead to the next one. Understanding the java.util.iterator. This is one of the ways that we can use to traverse the collection using a loop. The previous one is called as enhanced for loop, and this is a different model. Okay, now let's do this one. The iterator is an interface. Point number one, it provides methods to iterate each element in a collection. So before working with hands-on code example, let's understand this concept. Iterator has a few methods available. A few of them are the next method. This next method returns the pointer to the next available node, and the hash next returns whether there is a next element or not, and remove method removes the current element. We'll see all these concepts very clearly in the next 2 to 3 minutes. Now let's go ahead. Now consider, to understand the iterator interface, consider we have a linked list created something like this, which contains strings. Then what happens? This one is created as a linked list. If you remember, we get something like this, isn't it? So as a part of this execution, we get something like this one. So in order to iterate from first element to the last element, the very first step is we need to get a pointer to this start. Okay, step number one, we need to get a pointer to the start position. And once we get in order to get a pointer to the start position on this list object, what we do is we execute the iterator method, list.iterator method. The return type of this iterator method is a reference to the iterator interface. Don't get confused, please. The method name is iterator, as well as the interface name is also iterator. So don't get confused, please. Right. So that is how it works. So when this one is executed, it returns an iterator, ITR. So this one returns an ITR. So what we need to do is this ITR, when this statement is executed, this ITR points to start. You see here, this ITR points to start. And once we get a pointer to start, using the hasNext method of this iterator, ITR, we check whether there is a next element from the start position. How do we do that? See here, is there any next element available from the location currently pointed by ITR? ITR is currently pointing to start, and we need to check whether there is a next element, something like this one, ITR dot hasNext. Okay, this method returns true or false if there is a next element. If yes, then move ITR from current element to the next available element. So there is a method ITR dot next method. So we do this one. This ITR will now switch from a start to this one. Again, we check ITR dot hasNext, next. Again, something like this one, and so on. This is how we make use of the iterator. Now let's go ahead and see the examples. So what I do is I go to the this time I go to the linked list, and then I apply the iterator concept here. Watch here. What are the steps? First of all, iterator of string I want to take, and then ITR is equal to string list dot iterator, string list dot iterator, and then I need to import this one. This one I need to import java.util, and once it is imported, I have to run a loop while itr dot hasNext, and then what I need to do is I need to get the next element, itr dot next element. The next method returns us the pointer to the next element. Let's say string temp is equal to something like this one. This temp contains the next object that is written by the itr dot next method. So we can print or whatever you want to do here, something like this one. Okay, so temp, that's it. We are done with that. Now let me save and execute this one. This is completed. So that's how it works. Right, so let me apply the same thing to the product. Right, so product list, let's say I go to the product set this time. So instead of product list, I go here, and then I comment this print command, and then I paste it here, and then I say this is a product set, and then this is product, this is product. See, the coding is same everywhere. Okay, maybe itr dot, this is product. Okay, that's all. And then this is temp will print the object. We want to get the product ID, and then a space, and then temp dot get product name, and this is how it works. Right, and save this one. This is how it works. So this way you can apply the same formula to all these programs that we have demonstrated in the previous cases. So in order to prevent the time constraint, I'm not typing the same, since if it is a different program, I can type it. Right, so that's done. Now let's move on to the next topic called as list iterator interface. it is a child interface to the iterator interface, and it provides the methods to iterate in backward direction and is applicable only to lists. Please watch here. List iterator is applicable only to list, please. A few additional methods it has previous method and has previous method. Now let's see the list here. Let's go to the product list or something. We have it here. We don't have. So let me comment this one, source, and then add block comment. What I do is I go for the list iterator, and then what I need to do here, list iterator product list iterator product of iterator is equal to product list dot list iterator method, product list dot list. It's the same model. We need to import this one, please. I have imported this, and then what I need to do is I need to first of all iterate forward and then forward reverse itr dot has next, and then what I to do is product temp is equal to itr dot next. And once this one is completed, then what I need to do is while itr dot has previous from. So then see, first of all, when this loop is executed, what happens is this list iterator points to the last item, and from here I'm talking about has previous. So what I do is product temp is equal to, this time itr dot has previous but not has next, please. Next, it's not previous method dot not next method. And then from here we need to print the details of the temp object, temp dot, let's say what is that, get product ID, and then put a space, and then temp dot get product name. This way you can apply the logic to every program that we did until. So let me save and execute, right? So we have got the output from cable 101. You see, first of all, we have pointed itr to the last element. From there we started reverse traversal. That's about the list iterator, which is applicable only to lists, please. Now let's move and see the list iterator. This is all completed now. Now let's understand the interface provides, the list interface provides additional methods which support index based operations. Please watch here. This is applicable only to lists, not but set. Okay, we can add, we can get, we can set, and we can find an index of an object and so on. Okay, you can see this one. You see add method. We can add at a specific index. We can get an object from a specific index. We can replace an object at a specific index. We can find the index of an existing object. Okay, let's see these methods in action for the string objects or product object, whatever example. Now let me go to the close all programs, and I create a brand new program, new class, let's say list operations demo, and here I grab the you say this list, these things, copy here, and then main method, and I put it here. I want to check one by one, please. The first method is adding at a specific index. Now let me add one object. After this is completed, string list dot add, you see index and string element. So I want to add somewhere after Python. This is 0, this is 1, this is 2, let's say 2 comma, let's say Oracle, and then I want to print the list, system.out. So I use the for loop for string s colon string list, and then what we do is print s there, and that's it. So we should get 2 Oracle at the expected position. Now you can see it here. We got Oracle as the second position. Now let's do the same program for product, new class, let's say list operations product, and then here I want to generate the main method. Now inside the main method, what I want to do is grab that products list data. Where is that product list? It is here. What I do is I get this one, copy, and put it here inside the main method. Now what I do is I want to add one more product list dot add at a specific index, please. Let's say the third index. I want to add a new product object. I want to add a new product object. Let's say 107, and then let's say or keyboard or whatever. Okay, keyboard, whatever, something like this one. Now I want to use the for each loop, okay, enhance for loop, or this one. I copy this and then I come here. Now we see 107 in the third index. So that is, you see here, right click and then run as Java application. This is 0, 1, 2, 3. This is the third place, right? So that's added. Now you want to remove at a specific, you can do that. Remove option is also available, not listed here. You want to get a specific object. Now you see here, after this, I will comment this loop source add block comment. What I want to do is product temp is equal to product list dot get at the third index. Now we should get the this one, product 7 printed. Now what we do is, let me get this one and then print it here. This is, I'll change this one to product P. So we are getting the product at the third index and we are getting that pointer into P, and I'm printing it here, right? Save, then run as, we get 107. That is index based retrieval. You want to replace it, a new object, you watch here. So what I want to do is, so product list dot set at the third one, I want to replace product of 108, and then let's say charger, let's say wireless charger, and then I want to get it. I have set it, okay, I have set it there. Then okay, this is from 3 it was set to keyboard. I'm setting it there. Then I want to get it again back. Okay, this is not here, sorry. First of all, I have set it. First of all, I have added there and then replaced, and then I want to get it the replaced item. Product P equal to product list dot get of the third index. Now this time this will print as 108 and then what is a wireless charger. Now right click and then run as Java application. So that is replacing. So this way we can do whatever you want. We can use the object and we'll get the index. Probably you want to see that one. It's not a big problem. So let's say int x is equal to product list dot index of new product of 108 comma wireless charger, and then I say print x there. Okay, index is equal to plus x, something like this one. Save and then execute. Index is equal to 3. If this is not there, that will give us -1. Save and then run. If it is not there, representing that it is not available. That's about the index. So this is the list based operations. Now let's move on to the next topic. This is all completed. Fail fast versus fail safe collections. Collections that do not allow structural modifications are called as fail fast collections, and those that allow the structural modifications, fail safe collections. Fail fast collections throw concurrent modification exception if they are structurally modified. Now let's see an example of this meaning. Let's say we take the string objects example. I go to the what do you say, this one, ArrayList string. I come here and then do we have an iterator? I'll take a brand new one, copy this one. I'll create one more class, new class, and this is the fail fast demo. And inside this one, I create a linked list object. I create a linked list object and then store the data. Now I will iterate here. You watch here. First of all, I'll get an iterator of string. I'll get an iterator of string. Let's say string list dot iterator, and then I need to import the iterator, and after that I need to iterate across itr dot hashnext, and then itr, let's say inside this one, let's say string temp is equal to itr dot hashnext, and then inside this one I'm trying to add one extra data. This is not hashnext, sorry, it is next. I want to add one extra item. Maybe watch here, string list dot add, and then hello. something is being added here, and this statement will cause concurrent modification exception, and therefore list is called fail fast collection. While iterating, if you try to modify that, concurrent modification exception. Now let's see the next topic, that is map. A map is an object which stores the data in terms of key and value. Key is an object of any class and value is an object of any class. In this particular basic example, key is an object of the string class and value is also as an object of the string class. As an advanced example, key is an object of the customer class or bank account class, something like this one, or we can use this product class or a vendor class or something like this one. Now the map.entry interface represents a combination of key and value together as one single object. Map.entry is a nested interface inside the map interface. Now the map hierarchy is something like this one. Map interface and a few classes are displayed here, such as tree-map, hashmap, and hashtable. Apart from these, we have something more additional, such as linked hashmap, concurrent hashmap, etc. Of course, these are the basic ones, and we are going to see these examples. Now, let's say the map interface has many methods. A few methods of the map interface are put. It takes two parameters, key as well as value, which is used to store the key and value combination inside the map object. And the get method takes one parameter that represents the key. We supply the key, and then we get the the value associated with this key. And then the key set gives us all keys as one single set. Map.entry set gives us all entries as one set. Contains key will take a key and return as true or false, indicating whether that specific key is there or not. And similarly, the contains value. Let's go ahead and see the example of these map methods. First of all, we'll see the basic string example, and then we'll see the product and vendor example. So let me go ahead and create a new package. Let's say new package inside that com.maps. First of all, I want to create a new class. The new class I want to say string map, and the string map I want to create a main method. Inside the main method, I want to create an object of the map interface. I want the key. This is the key that belongs to the string class, and this is the value that belongs to the string class. And then string map is equal to new tree map or hash map or whatever we want, something like this one. Then we need to import Control Shift O, that's imported. Then I want to say string map dot put method. If you remember, key and value. Key is, let's say, A, value is, let's say, Java. And then let me copy and paste this one. And then let's say B, C, D, and let's say Angular. This is Python. And then let's say this is React.js. And that's the put method has stored everything, and we get a map something like this one, please. Something like this one. Then we need to perform with the get method. You see, we have worked with this put method, key and value. We apply the get method. What we do is, let's say string temp is equal to string map dot, sorry, it's not str, string map dot get, and to this one we give A, and the value associated with this key is this Java, and we get temp as Java printed. Now let's say System.out.println, let's say temp, and that's how it works. Now let me save and execute this one. We get the output Java printed. Whether you use tree map or hash map, etc., or you get the same output. Control save and then import. Internally, all keys use the respective data structures. If you use tree map here, all trees are maintained in a binary tree kind of thing. If you use hash map here, all things are maintained in a hash table kind of data structure, right? So if you can also maintain something called as hash table here. Control S, Control Shift O, and we still get the same output. Please be noted, P is lowercase. There is a built-in lowercase. This is also same thing. There is a difference between hash map and hash table. Hash table is synchronized and hash map is not synchronized. To understand the concept of synchronized and unsynchronized, you please watch the multi-threading tutorial video in my YouTube channel that will explain you the meaning of synchronized concept. So that is completed. We are done with the string example of these. Now let's go this is completed. We go to product and vendor and apply the same thing here. So we already have product class. Let me get it from the previous examples. Copy this one and I take it here. Of course, I can import it just for the sake of clarity, especially for the beginners. I'm just copying and pasting here as well. Now I have the product. This is comparable. And let's say I want to create a new class prod map, prod vend map, and then I create the main method here. Inside the main method, I want to create a map of, now the key is, what is our case? Key is product, value is vendor. So what I do is I create, first of all, we need to create a vendor class also. Product is key. I'm creating one more class. The class name is vendor, the vendor who sells the product. Now let's say I want to declare a couple of variables, private int vendor ID, private string, vendor name, getters and setters. For now, I'm taking only getters and setters to save time because I have to fit all content in one single video. I'm trying for that. Not sure whether it works. Now this is completed. We have product and vendor. Here, what I want to do is, let's say product and then vendor and then prod map is equal to new tree map, something like this one, Control Shift O. Now I want to put product as a key and vendor as an object, as a value. Let's say this is something like this one. Now what I do is prod map dot put inside here new product of 1 comma, let's say mobile here, mobile, and this is the second object, new vendor of, vendor is 10 comma vendor A, someone who sells that product. Copy this one, some correction, what happened, this is put and then comma new vendor and then something like this one. Right, now it has worked. Now 10 comma, let's say vendor A. What is that? We don't have a constructor, it seems. Let me go to the vendor class. I will generate the parameterized constructor and parameter constructor here. Right click, source constructor from super class, and then here right click, source constructor using fields, and then we are done. Save it here, come back here, and then this works. Now I copy this one and then paste it 1 2 3. So product 1, product 3, product 2, let's see charger, let's say Bluetooth, and then I say this is where the says sold by product vendor ID 20 and 30, and this is vendor name B and then vendor name C. So this way you can use a hash map or a tree map or whatever you want. Let me do for some time for the tree map. And then now let's say I want to get the vendor associated, the vendor who sells this product. So what do I do for that? Product P is equal to product map dot get of let's say new vendor of 10 comma A. So I want to new product of, let's say I want to supply a product and get the vendor, sorry about that. So vendor V equal to this way, right? So now what I'm doing is to this product map, I'm supplying the get method. To the get method, I'm supplying this product object. This is the key. This is what do you say? 1 and mobile. Sorry for the confusion. It's this mobile. This 1 and mobile is a product which is sold by this vendor. Now that means this V should now contain this one. So let me say that How does it work? So System.out.println v.get vendor ID, and then a space, and then plus v.get vendor name. Okay, so that's it. Now let me save and execute this one, run as Java application. We get the same thing. It internally uses the compare to method. We got that. Now let's say we want to use the hashmap. You can use it, please. Hashmap, Control-Shift-O. We still get the output, right? So save and then run as Java application. Internally, it uses hashcode and equals method, as I told you. And then you can even use the hash table. Save, Control-S again, save, and then again save and execute. Okay, so that's about the complete Java tutorial. I hope you liked it. Please leave your comments and suggestions. Thank you so much for watching the full course.